Hello, and welcome to the Certified Ethical Hacker Complete video course. My name is Bo.
And I'm Nick.
This video course is designed to get you prepared for the EC Council CEH exam. This exam is challenging. You'll have to be familiar with a wide variety of tools and techniques. Throughout these videos, we'll cover the topics of the CEH blueprint, including footprinting, enumeration, offensive network security, both system and web application, and wireless hacking.
We'll be supplementing these topics with live demonstrations to help you understand the techniques covered in the lecture. A few words about Bo and I, since we're going to be spending so much time with you throughout this course.
I'm William Bo Rothwell. I'm a technical trainer and courseware developer. During my 25-year career, I have focused on developing and delivering courses that are focused on security, Unix, Linux, and scripting languages such as Perl, Python, and shell scripting. My experiences have allowed me to discover methods that give learners the best chance of learning complex topics and passing certification exams.
And my name is Nick Garner. I'm a solutions integration architect with Cisco's Advanced Services Group, focusing on enterprise network architecture and design. I've been with Cisco for 10 years, and I've been in this industry since the late 90s. I'm a technical editor for Cisco Press, as well as a Cisco Live speaker. I have 2 CCIEs in routing and switching and security, as well as the CISSP and CEH certifications. Bo and I will be tag teaming the videos in this course, with each of us presenting different lessons. Let's go ahead and get started.
Welcome to our first lesson, Course Overview. This lesson provides a general overview of the CEH exam, as well as the areas of focus. We'll also discuss what this course is and what it is not, to ensure the viewer knows what to expect from studying for the CEH exam.
We're going to get started by looking at areas of focus, as well as information regarding the CEH exam. This is areas of focus for this course here. These are the areas that we're going to be digging into. There's quite a few, so let me run through the animation here and touch on each one. We're going to start out with ethical hacking, what it is and what it is not. Footprinting, where we gather information about our target. Scanning, this is mostly around network scanning, port scanning, things like that. Enumeration, where we'll be gathering information on users as well as network shares. And then system hacking, where we actually get into a system. Following that, we'll be talking about malware threats, Trojans, things like that. Sniffing, and this is where we're actually going to grab the traffic off the wire or the air and take a look at the data that's inside it. Social engineering, this is manipulating a person in order to achieve a goal. Denial of service, where we're going to restrict access to a service by either attacking the actual application or the pipe that leads to that application, filling up bandwidth to access a resource. Session hijacking, Bo will be getting into, where we're going to actually insert ourselves in the middle of an active TCP session. Hacking web servers, we'll take a look at getting into web servers such as Apache or Microsoft Internet Information Server, IIS. Hacking web applications, we'll be looking at injecting code, say through cross-site scripting or SQL injection, in order to manipulate that application to do something it wasn't intended to do. And I just touched on SQL injection there. As far as evading IDS firewalls and honeypots, we'll be looking at fragmenting traffic in order to bypass those things. Cloud computing, we're going to be not necessarily looking at attacking cloud computing, but providing a general overview of what cloud computing is, as well as detecting whether or not a service is being served from a cloud provider. We'll also be touching on using the cloud as an attack source. So hosting our servers in the cloud and using them as the source of the attack. In the cryptography section, we'll be looking at algorithms that are commonly used when encrypting data, as well as some of the attacks that we can use to break that encryption. The CEH exam is offered from EC Council, and there's 2 routes to actually get your CEH or Certified Ethical Hacker certification. The first being the official training route. This is where you pay money to EC Council, you attend their training, it's a 1-week session, and then you're allowed to take the test. The alternative is If you have experience in the industry, 2 years of information security experience, then you can apply to get a pass, basically, to take the test without attending the training. As you can see on the screen here, the left side, the official training route, there is an instructor there. They walk you through each section of the CEH blueprint, and then you sit down to take the test. With the no official training route, you have that previous work experience. You have an educational background that shows a specialization. They do reach out to your manager of wherever you're currently employed in order to validate your work experience. You buy the exam voucher and you can sit down and take the test. It's 125 questions and you are allowed 4 hours to take the test. Whenever you take it, it's an online proctored exam. You don't have to go to a testing center. You just sit somewhere that's quiet, there's no interruptions, and you work through an online proctoring service, which will have you on your webcam the entire time and watching what you're doing on your computer. It is a multiple choice test, several options to choose from, so best guess. The exam prefix you see listed here is 312-50. That's the ECC exam. When I took the test, I went through ECC, so I did the online proctoring. You have to achieve 70% correct in order to pass, and you can get more information from eccouncil.org. URL is there on the bottom of the screen.
So next, let's talk about what this course is and is not. So this course is an EC Council's CEH track overview. What it is not is a security analysis class, one that maps with the EC Council's ECSA certification. It's also not the forensic investigator course, which matches up with the EC Council's CHFI certification. And it's also not the network defense certification course, which matches up with the EC Council's CNDA certification. What it is focused on offense and not defense. The focus being on offense so you can understand what it is an attacker is going to try to do to get access to your system. And by learning that, you're going to learn how to defend those types of attacks. So the attacker thought process and methodology is going to be the primary focus of this course. Next, let's talk about author introductions. There are 2 authors to this course, myself, William Bo Rothwell, and Nick Gardner. I'm a technical trainer with 25 years of experience. I've authored over 30 courses on security, Linux, and programming languages. I'm also the author of the LPIC2 certification guide that comes from Pearson. Nick is a Cisco Advanced Services employee with 9 years of experience. Prior to Cisco, he had 10 years of experience in financial and military verticals. He is also a network designer and security architecture and a Cisco Press technical editor. And Nick is also a CCIE for routing and switching and for security.
Welcome to Lesson 2, Introduction to Ethical Hacking. This lesson explores several general concepts with respect to ethical hacking. We'll begin with an overview of InfoSec, discuss attack concepts, phases and types, and wrap it up with InfoSec policies. Let's have a quick overview of information security, or InfoSec as it's commonly shortened to. So what if this was your company? This is a screen grab from CNET showing an attack on Yahoo. This was in September of 2016, where, as Yahoo claims, a state-sponsored actor was able to compromise names, email addresses, telephone numbers, dates of birth of 500 million accounts. Pretty significant information disclosure here. So information security is extremely important. Now, what are the pillars of information security? You can see here on the screen confidentiality, integrity, availability, authenticity, as well as non-repudiation. We're going to be mentioning these terms quite a bit through this course. Let's start with confidentiality. What is confidentiality? That is that the data is only readable by those that are authorized to read it. So if we have Joe and Alice, Joe says Alice is allowed to read this, it is confidential in the fact that only Alice can read it. With respect to integrity, that is that you can validate that the contents of the data, the actual data itself, has not been changed while in transit or at rest. Availability, this particular pillar deals with the accessibility of the data when it's needed. So when we talk about denial of service, that would be an impact to availability. Authenticity, this is validating that the source is who it says it's from. And non-repudiation is that the source of this data, say an email, cannot say that it did not create it. It's a bit confusing to understand, but if I send an email to Alice, then non-repudiation would say that I cannot deny that I sent that email to Alice. The information security triad, this triangle you'll probably only ever see in courses, but it's basically security, functionality, and ease of use are tied together. And as you become more secure, that means things will become harder to use and less functionality. So if you imagine a ball in the middle of this triangle, as you move it closer to security, then of course you are more secure. However, your functionality is going to be impacted as well as ease of use.
In this next lesson, we're going to talk about threats and attack vectors. Let's first talk about threats. One of the things you may want to think about is the fact that threats come from many different directions and not always the areas that you might consider. For example, there are physical-based threats, which include theft, intrusion, and sabotage. Natural-based threats, which includes things like earthquakes and weather-related natural disasters. Humans are obviously going to be a threat, not only hackers, but also social engineering folks, security training, and insider threats as well. Network-based attacks. This is the one that a lot of people focus on. This could include things like spoofing attacks, sniffing, denial of service, man-in-the-middle attacks. Host-based attacks, when the software itself on your operating system is being attacked. That could include things like malware, password attacks, backdoor attempts, and then also application-based attacks. Things like input validation attacks for web forms, authentication attacks, buffer overflows, other types like that. Next, let's talk about attack vectors. The idea behind an attack vector is the path by which the hacker is going to gain access to your system. And once they gain that access, they're going to deliver some kind of malicious payload. This could be a cloud-based attack, some kind of cybercrime attack, could be an insider threat, someone within your organization trying to attack your system, botnets, a collection of different types of network-based machines working together to try to access your system. Could include problems with security policies, network-based applications. Even your mobile devices might be a vector of attack. Audits and compliance might be an issue. Another problem might be insufficient security funding. Social networking is more and more often becoming a vector of attack. Unpatched software and malware.
All right, now we're going to get into concepts of attackers or attacking concepts, if you will. So there's a difference we need to be aware of between hacking and ethical hacking. And within hacking, there's the different mindsets. So if you talk to someone who grew up through the 70s, 80s, and early 90s, and you talk to them about hacking, then it's all about digging into systems and understanding how they work. Nowadays, here in the tens of the 2000s, hacking has taken on a different meaning, and that is exploiting vulnerabilities to gather information, the compromise of security controls to gather information. For whatever reason, it's the illegal access of information. When we contrast that with ethical hacking, the term hacking usually has a nefarious side to it. You know, if someone's a hacker, they're a bad guy. So what is ethical hacking? That is using tools and techniques, these same tools and techniques that the bad hacker would use in order to validate a system's security. So we are attacking our systems on purpose in order to verify that they are as secure as we think they are. We take that information, we report it to the appropriate people. These would be the administrators of those systems so that they can further secure their system. So there's a pretty big difference between hacking and ethical hacking. One is bad, one is good, basically. There's several different types of hackers out there, and the ethical hacker sort of falls in the top right side of the screen here. Black hat, these are your malicious folks that are out to do harm. They want to gather that information for whatever reason, however, usually illegal. So whether it's a ransomware, which is popping up in the news quite a bit these days, where you're holding data hostage for financial purposes. Gray hat. These are folks that could be considered a black hat hacker. However, they do focus both on offense and defense. network security professionals could occasionally fall into this gray hat area. White hat, those are folks who have those black hat skills, but their purpose is to defend the network. So we know how the attackers are going to attack, and our job as a white hat hacker is to defend against those attacks. Script kiddie, these are folks that know the tools exist. They go download those tools, they run the tools, they impact the system, they get access to some data, but they don't really understand how it works. Whereas the black hat in the upper left, they're the ones that are writing these tools. Script kiddies are, just downloading and using them. Cyber terrorist, this is sort of the really bad side of the spectrum. These are the folks that possess those skills, but use them to further an ideology. It could be very dangerous. State-sponsored, these are, the folks that work for governments, and their purpose is to attack other governments for whatever reason, both offense as well as protecting their government from attack by other governments. Now, what is a hacktivist? Dictionary.com defines it as a computer hacker whose activity is aimed at promoting a social or political cause. So these are people who, just as an example, maybe attack the ASPCA because they don't agree with not harming animals. Maybe it's a meat eater. We have on the screen here Jeremy Hammond, who pled guilty to gathering information on law enforcement agencies and government contractors, actually attacking those systems and getting access to data. He's a very famous hacktivist.
In this next lesson, we're going to talk about attack phases. So attack phases normally follow the following process. First of all, there's the recon phase, where we're seeking out information about a system. Then there's a scanning phase where we do more in-depth probing of the system. Then we try to access the system, i.e. hack into it. Then we want to try to maintain that access. One of the problems with attackers is they are concerned about getting discovered, and if they're discovered, obviously they might get kicked off the system. And last thing we want to focus on is covering our tracks. So let's look at the recon phase in more detail. This includes information gathering. It could include things like finding out what kind of operating system we're trying to connect to, what services are running on that operating system. Passive recon includes gathering intel without any type of target interaction. So we may probe information about the target by using tools that are available on the internet, but not directly interact with that target. And active recon is when we're actively trying to get information directly from the target. Scanning is when we use tools to automatically scan devices, so we can probe for network ports and open services, for example. We may also want to look for live hosts, those open ports again, and what kind of operating system details we have. Specifically, what type of operating system is Microsoft Windows, what version of Linux it might be, things like that. Next, we try to exploit any kind of vulnerability that we discovered through the last two phases to gain access to the system. Part of that process will also be something called privilege escalation. The idea with this being that normally when you access a system, you can't get access as a privileged user account, like an admin or the root user on Linux, but normally as a regular user account. That regular user doesn't provide you enough access to do what you want to do on that system. So the next step during the access process is to escalate your privilege to an admin or a root user. This technique could include password cracking, making use of buffer overflows, and something called session hijacking that we'll talk about later in class. Once we have that access, we want to maintain it. We can use techniques like backdoors, so we can get back into the system using a different technique. Tools like rootkits, which provide many different ways of getting back into the system and also are used for the next step, which is going to be hiding our tracks. We might also use binary executable replacement, where we replace key binary files with files that will allow us access back into the system again. We can also use the system to launch further attacks on other systems as well. And the last phase here is to cover our tracks. So we want to make sure that any evidence of a breach has been removed. The reason why it's important is because to maintain access, we want to make sure that no one even knows we're there in the first place. So if we can cover our tracks, then it's less likely someone's going to discover that we've accessed that machine and block that access. So this will include things like modifying log files or possibly even deleting them. Also, any type of history, like for example, in a Linux environment, when you type in commands on the command line, a history is made inside of the bash shell. So any type of history, we want to remove those sessions.
Attack types. So if we need to classify attacks into various buckets. These are the buckets we'd put them into: operating system, application, shrink-wrap code, and misconfiguration. So when it comes to operating system attacks, the purpose here is to get access to the system by exploiting a flaw in the operating system itself. So not an application that you've installed subsequent to actually installing the operating system, but getting access to the operating system itself through a flaw. What are our attack vectors for operating system attacks? You can see here buffer overflows, software defects. Again, these are software defects in the operating system itself. The patches that have been applied or not applied, implementations of protocols. So when an operating system vendor creates the operating system and they need to code in, say, TCP as an example, how they implement that based on RFC standards, it should conform. However, they might unintentionally introduce a vulnerability in their actual application of the code. And the last one here for attack vectors, authentication scheme. So this is the methods used to actually authenticate a user. Next bucket, application attacks. So this is gaining access to the system by attacking an application that system is running. As an example, say Apache running on Linux. If we exploit Apache and gain access to the system, then that's an application attack. Methods of attack here, buffer overflows, software defects, as they say professionally, and bugs to the rest of the world. SQL injection, cross-site scripting, denial of service, man in the middle. So all of these different methods here that you see for application attacks, we're actually going to be looking at in the other lessons in this course. Shrink-wrap code. So this one is somewhat unique in that it's an attack on an operating system or application directly after it's been installed. So this is a defect that exists in code as shipped and maybe subsequently patched, but maybe those patches hadn't been applied. I touched on the first bullet there of examples, software defect in the first shipped version. Some more examples here. Say a web server ships with some default CGI scripts that you can use to just test functionality. If those aren't removed, then that's a possible method of exploitation. Also, default passwords could be a way to get in if those passwords hadn't been changed after the application had been installed. And finally, misconfiguration, gaining access to a system by exploiting a misconfiguration. And this usually just comes down to administrator education. As an example here, improper permissions on SQL users. If I'm an SQL database administrator and some application developer comes to me and says, I need to write data to this table. And let's say I go and create that user, but I don't apply the permissions I should, then perhaps they can access other tables. Another example of common implemented access list, that being permit all, doesn't really enforce security if you just allow everything.
In this next lesson, we're going to talk about info security policies. So info security policies often will share some common traits. They'll include the policy itself, procedures, and guidelines. If you want to learn more about policies and procedures, the ISC2 CBK provides a good in-depth overview of not only info security best practices, but also how to implement them. So let's break this down a little bit here. The first thing we have is the idea of policies. Those are going to be high-level statements about protecting information on your system. They include business rules as well. That differs from procedures. Procedures will be the step-by-step operation of how to accomplish a goal. So we have the instructions on how to implement the policies that we decided we have to have in our company. The last thing is going to have guidelines. Guidelines are going to be advice on a given situation. A good example of guideline would be if I want to tell my users what kind of passwords they should create, that would be a guideline. The policy would be exactly what type of passwords they have to have, like the minimum number of characters, and if they have to have special characters. And guidelines would be things like making more complex passwords by using capital and lowercase letters, special characters, numbers, and things like that. So they're recommended, but they're not mandatory like a policy or procedure would be. So let's talk about some common security policies. First of all, you don't want to try to fit everything into one document. Like, for example, you might have a policy just for your systems, a separate partner policy, a network policy, a user policy, and a provider policy. One of the things you may want to consider also is this idea of defense in depth. What that means is instead of having just one layer of security, have multiple layers of security control. The good thing about this is it provides some redundancy in the event there's some kind of control failure at one of the depths. For example, I might have on my host a host space intrusion prevention policy. And then on my local area network, I'd have another policy. Outside of that, this next layer of defense would include an intrusion prevention system. And then maybe the top level or the first level is going to be my firewall. The benefit of a defense in depth is, again, the redundancy, but it also does make the security policy more complex as well. For instance, let's say currently I'm blocking a specific user or a specific IP address from accessing that host. In order to be able to allow that user or that system to access the host, I'd have to make rule changes at all 4 levels: the firewall, the IPS, the LAN security, and the host space as well. That makes it more complicated to try to allow access, but again, it provides more security in case one of those layers doesn't work properly. Next, let's talk about incident management. We want to have a comprehensive plan before we are attacked to handle an incident. So we want to develop the process during the prepare phase, select people and assign roles, and define tools to handle the incident. Not only that, but also make sure the people we've selected know how to use those tools. So in the identify and detect phase, you want to determine if an incident has occurred, and you want to make use of several different types of components. IDS, which is the intrusion detection system, SIEM, which is a security information and event management, and any kind of antivirus program that you can use. Lastly, you want to go through the contain phase. Once you determine that we've had some kind of breach, we want to limit the damage, contact the system owners, and also isolate those hosts so they don't affect other systems. Next step will be to eradicate that problem, remove the cause of the problem, and if necessary, patch our system as well. Then recover the system by getting it back into production, and also make sure that we monitor the system after the fact. We want to make sure there's no additional security holes that we were not aware of. Then after that, always make sure that you perform a follow-up, so check that system on a regular basis from that point on. Document what's happened and why. That way, hopefully, you can avoid this problem in the future, and also transfer any kind of knowledge to other departments in the company as well.
Welcome to Lesson 3, Footprinting and Recon. This lesson begins our dive into the actual hacking. Footprinting is one of the most important steps when evaluating a target, as it helps you focus your attack on resources that might be vulnerable. Footprinting isn't just about finding open ports. It also includes gathering intel about the company or person through search engines, websites, social networks, and competitive intelligence. Footprinting concepts. Let's talk about what footprinting is. As I mentioned in the introduction, this is, I consider to be one of the most important aspects of a penetration test, and that is understanding what is there to attack, right? So footprinting is a process used to gather that information about your target. If you're hired to conduct a penetration test on XYZ corporation, you want to gather as much information as you can about that corporation. There are several different places that you can gather this information, and it's not only from the company itself. So we take a look at these examples here: web searches, Facebook, DNS, Whois. This is all publicly accessible information, and it's very helpful to understand the company's attack surface. What are we trying to determine through this? That's operating system versions, application versions, and that allows us to find out what vulnerabilities exist in the software and operating systems that they're running. So it's all about gathering information. And what methods of approach are we going to use here? There's 2 different types of information gathering. There's passive and there's active. Passive is hopping on Google, typing in XYZ corporation, and seeing what's available there. Active information gathering, this is where you're actually contacting the company or maybe its competitors in order to gather information about the company. All of this should go into some sort of information database that you're maintaining for whenever you actually launch the attack. A couple different places to do footprinting. One is just pure internet. Hop on search engines. Don't just use a single search engine. Everyone's go-to is Google. However, there are other search engines out there that might rank results differently and allow you to see more information. So try multiple search engines. Private footprinting is gathering information from the organization that you're going to be attacking through, say, a website that they didn't intend to make publicly accessible. or an open directory as an example. And we'll talk later about using certain keywords in Google to find things like open directories. What's the point? Why not just, fire up Nmap and start attacking stuff? Well, I guess you don't attack with Nmap, but you get my point. Why not just launch an attack on the company? And the point here is that if we were to just, start up Nessus, say as an example, and point it at the company's website, they're going to see it, most likely. So we want to gather this information so that, one, we can assess the posture of the network. We want to know what types of devices are there. Do they have a firewall in front of their web servers? Or, like some companies do they just put the web servers and secure the web servers directly on the internet? Gathering this information will let us know, do we need to fragment our traffic to sidestep an IDS, as an example? It allows us to focus, right? If we know what devices are there, we know what operating systems they're running and what applications and what versions of operating systems and applications, then we can see what vulnerabilities exist and we can just target those vulnerabilities. I mentioned a database of information just a moment ago, and I want to touch on it here. We want to keep all of this information that we're gathering. Don't just try to keep it in your head. Write it down, put it in Notepad or TextEdit, whatever your chosen text editor is, so that whenever you need to put together your plan of attack, you know what operating systems and applications are in use, so that you can, create a step-by-step guide for what you're actually going to do when the time comes. The final note here, time invested up front will save time later. If we were to just fire up Nessus and start attacking, one, they're probably going to see us, and two, you're going to waste time. There's no reason to attack Apache if they're not using it. So what are our objectives when footprinting? What information are we trying to gather? Well, we break it down into three different areas: network, organization, and hosts. You can see I got a whole bunch of text on the slide here. I'm not going to read through it all, but some of the highlights. When we look at the network, we want to get information from the DNS. The DNS, the domain name system, is required for, say, a browser to know the IP address of the website so it can go and make that request to get data. So it has to be publicly available, as well as the networks the company is using. Those have to be publicly available so that the systems can operate the way they should. So gathering this information, again, from publicly available sources, provides a whole bunch of information on what you can actually go after when you're planning your attack. From the organization side of things, you want to know the people, as well as the organization structure, what websites do they have available, phone numbers. If you need to make a call into this company to gather information, there's a good chance you can find phone numbers on their website. And once you have that first tech support phone call, maybe you can get a phone number for another agent and keep going from there. Something I want to touch on in organization, the last two bullets, they're company history and business association. If you do need to make a phone call into a company to try to get a little bit of information, knowing the history of the company can provide you with some validity. If say you're impersonating an employee of the company, knowing who the CEO is, knowing who the CFO is, and dropping names can definitely give you some credibility when it comes to gathering information. On the host side of things, we want to take a look at what services are running there. If it's listening on port 80, there's probably a web server there. What's the web server version? And we'll dig into enumeration in a subsequent lesson. But all of this information, whether it's network information, organization information, host information, we want to put that all into our information database. Going back to our big, large text document where we're putting all this stuff, it allows us to plan our attack when the time comes. Here's an example of footprinting. And I mentioned in the previous slide, making that phone call in. So here we have our attacker, our black hat. He's calling in and he's saying he's Jim Brown from HR. But how does he know Jim Brown actually works for HR? He probably checked LinkedIn and found a guy named Jim Brown that works in HR. And he just calls in with a quick question. I need to know how to VPN in. I can't remember what it is. Tech support, they maybe know Jim Brown. Maybe they haven't talked to him much, but they've seen his name because he's an important guy. And they let him know, sure, remoteaccess.acme.com. And from that point on, he knows where to focus his attack. He can do this network attack, leads to information loss, maybe they hold that data ransom. And what's the end result for Acme? They lose some credibility, perhaps maybe some market share, some money in the worst case. So where do attackers get information? The most popular go-to is going to be a search engine. When you need information, you go to a search engine, whether it's Google, Bing, Yahoo, DuckDuckGo, whatever the case may be, you type in that company name, you get some information. The first one's probably going to be the company website. Second and third, probably also company websites. But you go to the next page of information, you might find some hidden nuggets in there of good information. When it comes to people, people are usually pretty happy to share information about themselves when it comes to what they do professionally. So take a look at LinkedIn, look for the company, and you'll find a whole bunch of people that work there. Competitive intelligence, if say I want to attack Microsoft, which I don't, but if somebody did, who would they call to get competitive intelligence? That would be Apple, even to a certain extent Google, right? If I want to say, for example, attack Microsoft's cloud platform, that's Azure, their major competitors would be Google Compute as well as Amazon Web Services. So if I call up Amazon and say, hey, why would I use you over Microsoft Azure? What if I wanted to directly peer with you? What would be the benefits to using you over Azure? And when they provide that answer to you, there's going to be certain pieces of information, such as how they're doing the BGP peering, that could be potentially helpful to an attacker. Of course, websites, plenty of information to gather from a company's website, as well as competitors' websites if they actually post competitive analysis of their competitors. Email tracking, we're going to dig into this in an upcoming slide. However, it's a method by which you can inject hidden HTML into emails to where whenever they're viewed and the HTML rendering occurs, it calls a hidden image and you can track emails. Pretty cool technology that attackers as well as legitimate uses such as salespeople are using this stuff to see who's opening the emails. Network discovery, either through public information or scanning. DNS, who is information, who is a publicly accessible database of who has actually registered the domain name, and it includes addresses, phone numbers, email addresses, a lot of good information there. Social engineering, this is just calling the company up and asking them questions. Not just competitive questions, but you impersonate Jim Brown from the previous example, you get some potentially useful information. Employee online activities. Once I have a name of someone that works for this company, let's say I found them on LinkedIn, and then I search for them on Facebook or Twitter, there's a good chance they're putting some information out there that could be helpful to an attacker, such as their spouse's name, right? It gives you credibility if you know information about somebody. So I mentioned in the previous section that search engines are a popular place to go to gather information as a first step. So what are we looking for when we hop on Google and search for, say, Apple? You can see in this screenshot here, I'm using a keyword. That's the site operator for Google. This is finding all results that are served from apple.com. But if we're not using a keyword and we just search for Apple as an example, what information are we looking for? We want to know the names of the web servers, the actual DNS name to get to those web servers. Resolving those to an IP will tell us where to actually go when, say, launching an attack. And I'm not advocating attacking Apple here, just using it as an example. We can also get information on subdomains. So we see that first result, www.apple.com, www being the subdomain, very common subdomain for a web server. However, you might see other subdomains like database.company.com as an example. And we also want to look at cached versions. What if by accident a web developer or website administrator posted some information, they saw it, they removed it, but in that period of time when it was publicly available, it had been cached, not just in Google, but in the Wayback Machine available at archive.org, where they occasionally go and crawl websites to store cached versions. So take a look at those cached versions. You might find some information that they didn't intend to release. Also take a look at their Wikipedia page. You're going to find names there, say the name of the CEO, the name of the executive management. There's a lot of good information you can gather from search engines as well as public information repositories such as Wikipedia. Hop on maps as well, not just Google Maps, but Apple Maps, Bing Maps, whatever the case may be. But knowing where these office locations are can be helpful because you call up the technical support. This is Jim from the Sunnyvale location. It gives credibility to who you are. So keep this in your information databases, information on where the offices are located. I mentioned this earlier, these keywords. These are operators that you can use in Google to narrow your search results. some examples here, such as site, which I used earlier. Or if you put site:apple.com, it's going to restrict results to those found at apple.com. You can find some really good information using these keywords, such as open directories or file types. If you search for filetype.txt, then you can find some publicly accessible text documents. There might be some good information in there. And I wanted to make a call out to Johnny Long here of Hackers for Charity. He's got a good database of operators and examples over at hackersforcharity.org/GHDB, or Google Hacking Database. Here's an example of using these keywords. Here we have in title intranet, in URL intranet, or in URL employee. And this can provide, as the screenshot shows here, this is an actual screenshot from Google just taken a couple weeks ago, where I wanted to find the website an employee would go to access an intranet for a company. I'm not necessarily targeting a particular company here, but you could just by tacking their name on at the end there. So we can see there's plenty of information to be gathered as far as where might I focus an attack if I did have a username and password of an employee. So we know our target name. Now let's find some people that work there. Most popular place to go is LinkedIn. This is where people often build themselves up. You tell people what you do, who you work for, things like that. You hop on LinkedIn, when you create a LinkedIn profile and you say, I work at company X, it's going to show up when other users click on company X, they'll see a list of people that work there. It's pretty helpful to know names of people that work there, because when you're making that call to tech support, name dropping, again, gives you credibility. Also, knowing the people that are in executive management. I wouldn't recommend trying to pass yourself off as one of those executive managers. However, mentioning their name, the CFO, Bob, needs some information. He needs it right now. You wouldn't want to make him mad, would you? So give me what I need to know. Once we have a list of names, we want to gather as much information about those people as we can, including their full name, phone numbers, any personal websites they have, their addresses, both home and work. It may be needed. Again, this is going into your information database. It's not necessarily going to be used, but it is good information to have in the event that you need it. And this could be as simple as searching a search engine for the person plus their company. There's a chance you might get the information that you need just from a quick search. Some other resources here that you can use to search, whether it's white pages, Anywho, Intellius, they all provide some information, some better than others. So try as many avenues as you can in order to get the information that you need. Now, social networks, a very common thing to do is pop up on there and say, hey, I'm going to Bermuda for the weekend. Well, now their house is unoccupied for the weekend. They're telling everybody that basically their house is a target. Regardless, people like to share information about themselves. And looking for these people on Facebook, Google, Twitter, any of these popular social network sites can often lead to some good information. A quick note here, there's a good chance that usernames will be reused. jsmith99 over at Facebook is probably jsmith99 over on Twitter. So look for that as a first step for gathering information about these people. Competitive intelligence can give you a view into a company simply by talking to their competitors. Again, I'll go back to the Microsoft Apple example. If I'm attacking Microsoft, there's a good chance that Apple is willing to provide some competitive intelligence on why you would use them over Microsoft. Where can we get this information? Again, search engines are a great place to go simply by searching for, in our current example, Microsoft competitive information. There's a chance we'll find some information there from, say, Apple or Google on why you should not use Microsoft. Also, take a look at what they're showing at conferences and expositions as far as new products. We want to know what they're offering so that we know what we might be able to attack. Press releases will give you a good place to look for new product offerings, because if it's a new product, I'm sure it's gone through some form of QA, but there's a chance there might be some sort of undisclosed vulnerability in there. So take a look at the latest and greatest, going back to our shrink wrap code method of attack. Patents and trademarks, you go search for a patent, you're going to get some insight into how they're doing what they're doing, because you have to disclose in a patent the invention and how it works. Regulatory reports, it's good to know about the finances of a company. And finally, call them. Call and ask, why should I use your product? And how are you doing this? And if you're doing this, how are you doing it better? They'll probably be more than willing to get a new customer, and they're willing to tell you how they're doing things. Some places we can go online to get information about a company as well as its competitors, including the SEC. Owler is me and my friend's favorite place to go, just to gather a bunch of information on our particular target. So if you recall from the beginning of this lesson, footprinting is all about narrowing our attack, right? So what should we attack? Doing an analysis on the publicly accessible website will very easily narrow down what we want to attack. As an example, we take our target, in this case apple.com, and we want to know what web server software they're using. Then doing this website analysis would be able to tell us what versions of software should I look for vulnerabilities in, right? If this was Microsoft.com, they're probably running Microsoft IIS, and maybe the version number will be disclosed. So how do we get to that information? There's a couple different ways to do it. First one listed here is Packet Sniffer. We'll take a look at how to do that with a Packet Sniffer. As well, the majority of browsers these days include developer tools to where you can see the actual header that's returned from the website whenever you surf to it. In this screenshot example here with Chrome Developer Tools in the upper right, click on the little hash marks, go to More Tools and Developer Tools. This is what you're going to see. The important tab here to look at is the Network tab, which I have highlighted with the red arrow up top. Once we click on Network, we refresh the page and it's going to show us the actual response headers, which is going to include the server information, which I've highlighted with the red arrow on the bottom there. In this case, Microsoft.com is using IIS version 8.5. So it's very helpful information. Now I know if I were to attack Microsoft.com, I want to focus my attack at IIS version 8.5 if I'm trying to exploit some vulnerability running on the web server itself. Some other tools that are available for you to analyze a website, I've already touched on Chrome. Firebug, Burp Suite, and ZA Proxy or ZA Proxy can provide that information. But what information do we care about? Content types are helpful. Is it using, say, for example, JSON as the return type, or HTML being the most popular one? What is the actual server software and version? The cookies that they provide back, maybe there's some information in there that if we were to get a hold of someone else's cookie, we could use that information in order to impersonate them. Powered by is also a helpful header to show you maybe what application they're using in order to provide the content. Same information you can get from a sniffer. In this example here, we're using Wireshark. When you run that GET with HTTP, you'll see the same response header. It's in the data of the response. Here I have highlighted Microsoft.com, again running IIS 8.5. Another example, just using raw telnet. So in this case, we don't have to have a browser. We don't even have to have a desktop user interface. You're running Linux here, you run telnet, hostname, port 80, type in get/HTTP 1.1, give it a host name, hit enter twice, and voila, you got the information that you need, and then you can quit. This information can be gathered through several different means, and that end being what is the server application and what version is it using. Also on this screen here, you can see the X powered by header. So we know that now they're using ASP.NET. It's another avenue or vector to look for vulnerabilities that exist. Another thing we want to look at when analyzing websites is the source of the website, because you can occasionally get good information, such as developer comments, what frameworks they're using for laying out the web page, what JavaScript libraries they're using. And we have an example here. Just by looking at the source, we can see that they're using typo3. I'm not familiar with typo3. However, now that I know that they're using typo3, I can go and look for vulnerabilities associated with typo3. So it's a good place to look for avenues of attack just in the raw HTML source. Another helpful thing you can do is to actually save the website contents for later analysis. A very popular Linux-based tool is wget or website git, which will allow you to crawl a website and save the source of the pages. You can even do it recursively to a certain depth to where it will follow links and save the pages that are being linked to. We have some more examples of tools here on this slide: WebRipper, HTTrack, WinWSD. all provide these mirroring capabilities to where you end up with a directory of files that is the website for later analysis. So email tracking is a method with which we can send an email to someone and know if they've opened it or read it. How do we accomplish this? The common method is to send an HTML formatted email, and the content of that message contains elements that are hidden. As an example, a 1-pixel image that is set to CSS display none. The browser that's built into the email client is going to render that, and because CSS is set to none, you're not going to be able to see it. However, when the call is made to retrieve that image, all of a sudden you know that the email has been viewed. So there's a couple different ways this can be done, either hidden images or link redirection, where if a user clicks on a link, it actually goes somewhere else and then redirects them to what they're expecting. Several different tools out there to do that, and these tools do have a valid purpose, and they're primarily for lead tracking in sales. So if I work for a company and we're selling widgets and I send an email to a potential customer saying, hey, check out our widgets, I'd like to know if they read that email, and I'd like to know if they clicked on the links in that email. Because if they read it and didn't click, they might not be interested, but if they read it and clicked, they are interested, and I should give them a call. So several different tools to use for this. Yesware is a pretty popular one, as well as HubSpot, and then others listed on the screen here. The Social Engineering Toolkit, which we'll touch on in the social engineering section, actually has built-in tools for crafting emails and embedding hidden images in order to determine if they've been opened, as well as link redirection capabilities. Network discovery is an extremely important step when doing footprinting, because if we don't know where to send traffic, how can we attack it, right? So what do we want to look for? We want to look for what IP subnets are in use and or assigned to our target, what operating systems they're using, and how the traffic goes across the internet to get to that destination. In order for a company to offer services on the publicly accessible internet, they need to have a publicly routable IP address. And in order to get those, if they are true provider independent addresses, so there's PI addresses, provider independent, and non-provider independent. Provider independent addresses are actually owned by the company they're assigned to. So if it's a large company, they can go to one of these regional internet registrars to get a block of IP addresses that they can use on the public internet. We have listed on the screen here 5 different entities. These are the regional registrars, and these names are important. So make sure you understand which region is responsible for which area. Here in North America, we have ARIN, the American Registry for Internet Numbers. Africa has the AFRINIC. Asia Pacific, covering Australia as well as Asia, is the APNIC. Down south, South America, we have LACNIC, and over in Europe, we have RIPE. Each of these registrars has a place you can go to gather information. We can take a look at an example here. Here on the left, I've run hostapple.com just because I wanted to get an IP address that resolves to apple.com. Once I have that IP address, I can go to ARIN. This is the North America registrar. Go search who is, plug in the IP, and they're going to tell me the network block that has been assigned to this particular company. In this case, Apple has an entire 8-bit subnet. The whole 17 network is assigned to Apple. So they've been doing this for quite a while. You can see the registration date there, 1990. They've had this block for quite a while, and it's an extremely large block, pretty valuable block. But you can also get information such as who the person is that registered the name, an email address that's associated with it. There's usually an abuse email listed here that you can use to send email to the company if you're being attacked from one of their IPs. Knowing the operating system, again, helps us narrow in what we're trying to attack. These 2 different websites here, Netcraft and Shodan, provide information on operating systems in use. These services are constantly, scanning the internet, looking for information on websites and IP addresses to get the operating system version that's actually being run. So searching these as a first step. Second step is search for it yourself. Using, as an example, Nmap has built-in operating system detection capabilities In this example, I'm using the -A switch, which detects not just operating system, but services, versions of those services. You can try to gather this information yourself. We can see here in this example that it's an Ubuntu system, Ubuntu Linux, running a whole bunch of different services. Scanme.nmap.org in this example is a host accessible on the internet provided by the team that created Nmap for you to test Nmap against. So they welcome the scan. This is what the output looks like when you scan. Routing path analysis, having an understanding of how traffic gets from you to the destination is helpful, because you can find out who their service providers are, as an example. There's two different types of traceroute. There's UDP and ICMP. UDP traceroute is very common on Unix, Linux systems, as well as Cisco routers will use UDP traceroute. And then ICMP traceroute is used by Windows systems. There's a pretty distinct difference in how they operate. Let's start with UDP traceroute on the left. What's going to happen in UDP traceroute is it's going to send packets towards the destination and increment the TTL with each subsequent group of packets. So we can see in the example here, the very first, this is on the UDP traceroute side, very first packet that gets sent is to destination UDP port 33434 with a time to live of 1. And it will send 3 of those and then report the responses. Because the time to live is 1, when it hits the first routed hop where TTL is decremented, once TTL hits 0, it's the job of that device to send back an ICMP time exceeded message. With each subsequent TTL, it's going to increment the port number used. So there's a range of ports needed for UDP traceroute, and it's going to increment that destination port each time. On the Windows side of things, or the ICMP traceroute side of things, it's going to send an ICMP echo. It's still going to use the time to live method. It's just the underlying protocol in use is ICMP instead of UDP. And this is for the packets being sent towards the destination. They're both still doing time to live and incrementing time to live in order to find out the IP address of the hops in the middle. Once that TTL hits 0 and the ICMP time exceeded message is sent back to the source, then the source IP of that time exceeded message is going to be the hop that hit 0 TTL. So as it's running through and sending all these packets, we can build a list of hops along the way. Now, even though Linux systems use UDP traceroute as a default, you can force it with the -I switch on Linux if you want to use ICMP over UDP. Why might you want to do that? Oftentimes, firewall administrators will block ICMP, but maybe not block UDP. So keep in mind that there's 2 ways to do a traceroute, and one might get through when the other doesn't. There are also graphical applications for doing path analysis. The one on the left here, Open Visual Trace, it's available for its cross-platform because it's written in Java. Then over on the right, Visual Route has clients for Mac and Windows, where you give it an IP and it will show you the steps taken along the path. As well, it'll do some reverse resolution on the name so you can find out the name of the provider and other useful information. Going with the command line option for path analysis on Windows, it's traceRT. Give it an IP address and it will run through the hops. Again, this is ICMP-based traceroute. On Linux, Mac, you have the UDP-based version with the traceroute command. Take a look at the help pages as well, because by default, they're going to resolve IPs to names, and that can take some time if an IP doesn't have a name associated with it. So there's usually a switch to disable DNS resolution. Also, you can change the number of packets that are sent. So when we look at the output in the black box on the right, you recall that it sends 3 packets per TTL. There's a couple of reasons for that. One is to see differences in the response time, and the other is to see different paths. So if there's equal cost paths back to the source, then you can see multiple sources that hit TTL of 0. So that's why it uses multiple packets. You can see in the example on the bottom here that you can get rid of the 3. So in this example, we have tries 1, so it'll send 1 packet per TTL, and then wait is 1. That means timeout after 1 second, rather than the default, which could be much longer and make your traceroute take a lot longer. DNS and Whois provide a database of information for mapping of IP addresses to names in the case of DNS, and whois provides administrative contact information for an entity. So let's take a look at DNS first. The domain name system, like I said, it maps IP addresses to names, so it's much easier to type in google.com rather than the actual IP address of the web server that's serving google.com. So DNS runs through a standard process of it talks to the root server. The root server can respond with the .com top-level domain server. This is all called recursive querying. So when you make that initial request, what is the IP address for google.com? Your DNS server goes and asks the root. The root responds with go talk to .com. .com responds with go talk to the authoritative name server for google.com. And then google.com authoritative name server will respond with an IP address. I have a small black box in the bottom left here. NMCLI, device list, iFace, Ethernet 0, grep, IPv4, DNS. The purpose of this example is to let you know an easy way to find your IP address on a system. In the old days, you could look at a file called resolve.conf. With newer Linux systems that are using Network Manager, that method is gone. So this example here tells us that the system that I am currently using is using 8.8.8.8 as the DNS server. This is Google's publicly accessible DNS server. Dig and NSLOOKUP are the two tools that are commonly used to gather information from DNS servers. Dig is a Linux and Mac application, and then NSLOOKUP on Windows. In this example here, I'm using dig on an Ubuntu Linux system. You see the command up top, dig any google.com. Any tells dig to give me all records you can find from google.com. So we run the query and it's going to return a bunch of results. Those results have record types. You can see in the fourth column there, the record type. So the A record is the IP address record. This tells us the IP address of the host we're trying to get to. So whenever you type in google.com to your browser, this process happens under the covers. It goes to your DNS server, which does a recursive lookup for google.com and returns to the browser the IP address that it needs to go to. And then it goes and makes that HTTP GET request to that IP address. So that A record is the host entry, that's the IP address. The quad A record, the 4 A's that you see there, would be an IPv6 host address. The mail exchanger record, the MX record, is pretty important if you need to know where to send email directly. If, say, you wanted to spoof a message through SMTP, that could be done through the MX records. The NS records are the authoritative name server records where you would go to ask for information about google.com. SOA is start of authority, which includes things like the amount of time you should hold this information before considering it invalid and going to ask for it again. So there's a lot of good information there, including things like subdomains. So it could be possible to get information on subdomains from a query to their name server. Whois is an actual protocol. Most people just go to Whois website and type it in, but there is an actual protocol that can be used with the Whois command on Linux systems. It runs on TCP port 43. If you hop on, say, Ubuntu and you type in whoistwitter.com, it's going to provide you with several pages of information from the Whois database. And there's a couple pieces that we really care about. One is what name servers are they using? These aren't versions, but these are the host names to get to the authoritative name servers for, in this case, twitter.com. Some more helpful information. You're going to find the name of the company that registered it. You're going to find their address, their phone numbers. So there's some good information to be gathered for your information database in Whois results. Another common method for footprinting is social engineering. Social engineering really is an art in interacting with people, either physically or just talking to them to get information. The reason we do social engineering is because people want to be helpful, right? They want to feel like they've done a good job. And if you were to, say, call up someone with a problem, they want to help you. And so asking them those questions to get the information that you need, there's a good chance you're going to get what you want. And it's not just calling someone, it's walking in the front door, you're holding a ladder. I've been called to fix the air conditioner in the conference room. I could really use your help here. My boss is on my back. Can you get me in so I can work on this thing and just get out of here? That's what social engineering is all about. It's all about talking to people, interacting with people in order to get what you need. And what kind of information are they looking for? Usernames and passwords. For example, you call somebody up and say, I'm with the IT department. We have a problem with your email. I need to log into your account to take a look at it. Can you tell me the password for your account? Oh, by the way, what's your username? I think I have a typo here. Credit card numbers, of course, very helpful. Not so helpful in the penetration test because you're not going to do anything nefarious as an ethical hacker. However, as part of a penetration test, gathering this information can be included in that report back to management saying, I was able to extract a credit card number from one of your employees. You might need to beef up your security education within the company. URLs, in the previous example, I showed a little guy there calling up tech support. I need the host name for the VPN. So getting that information out of, say, IT help desk employees can be very helpful. Full names, it's usually pretty easy to get someone's full name. If you know a piece of information, you know their last name. Hey, I forgot, Mr. Brown's first name. What is it? Operating system information. Just through a vague question, you can usually gather this information. Calling someone up and saying, hey, can you open Internet Explorer? Oh, I don't have Internet Explorer. Oh, okay, how about Safari? Now you know that they're using Mac. If they're using Mac, there's a good chance the rest of the company is using Mac. So there's a lot of good information you can get just by making a phone call or walking into the lobby and asking, vague, easy to answer questions. Some methods here: eavesdropping, sitting on the airplane, looking over the shoulder, coffee shop conversation, things like that. Dumpster diving, I've never done it personally. However, some good information you can get from the trash. Shoulder surfing, I already touched on. Social network interaction, so it doesn't have to be a spoken phone call. You create an account on Twitter, Facebook, become friends with that person, and just start having, a conversation. Phishing is the act of sending an email to get a response from someone. So I send an email saying, hey, I need this information from you. They maybe click on a website, type in a password, and there's a good chance that's the same password they're using for other stuff. So there's a lot of good information you can get from social engineering. You might notice your heart rate go up a little bit because you're actually talking to a real person and there's a chance of getting caught. But there's a good chance you'll be successful, and it's quite a rush. Touched a couple times in this footprinting section on online activities. There's a lot of great information you can get just by people wanting to overshare about their life. I have a nice quote here from Mr. Huddleston from Fortune. Americans lament loss of privacy, but still share freely online. It's very common for someone to post, pictures to Instagram, Snapchat, Facebook, whatever the case may be, as well as, textual updates of what's going on in their life. So you can get a lot of good information about people just by what they share online. Common social networks here: Facebook, Twitter, LinkedIn, YouTube, all great places to go. And recall from a previous slide where I said usernames are often reused. There's a good chance jsmith99 at Facebook is jsmith99 at Twitter. Keep that in mind. What information are we trying to get? Contact information. Sometimes people will put their cell phone number up on their Facebook profile, if not just for friends, but maybe publicly. Where are they located? What city? Or even closer, what area of a city, if not their address. Are they home or not? I touched on this earlier, but people, posting vacation plans, that they're home. If they're not home, then there's a good chance that they could become a victim. Appearance, this is how they look. If you know that Jim has a mustache and you're calling in to somebody to say, hey, that guy Jim, the one with the mustache, what's his last name again? You can get some good information there. As well as family members. You know that Jim has a daughter named Sue. It gives you some credibility. You know this person because you know his kid's name. And there's a good chance that maybe Jim has posted about Sue's piano recital. Not just users, but companies are creating social network profiles these days. So what can we get from a business and their social interactions on, say, Twitter and Facebook? We can find out who is a user of their product. If they've liked this product's page, there's a good chance that they're using it. We can see what products they make, what services they offer, how to get support. Companies want their customers to be happy, so they're going to tell their customers how to get support before they leave that bad review, As well, open positions, which is a pretty important point, because if I know that my target is hiring a systems administrator. There's a good chance in that job posting they're going to tell me what operating systems they use. So just another piece of information for that information database so that you can narrow your attack. Also make note that most social networking sites will have a default permission of putting your information out there. Facebook, of course, has gotten much better about this recently, but other social networks might not. And users care more about getting that information out there than restricting who can actually see it. So just take a look at whatever social networks you can find that these users might be using to gather as much information as you can. All right, I'm going to throw a bunch of names at you of tools that you can use when doing your footprinting phase. Starting with Maltego. I'm not going to explain what each one of these does, but you can go hop online and take a look. I have included the URLs here so that you can very quickly get to them. So we have Maltego, Domain Name Analyzer Pro, Web Extractor. These are all good tools for gathering information on websites. I spoke about Dig earlier for gathering information from domain name servers that are out there. TC Trace here is a pretty interesting tool. It's a traceroute tool, however, it uses TCP send packets rather than UDP or ICMP. So it's just another method to maybe get through a firewall to do a trace route to get information on the hosts that are in the path. Some more tools here. These are mostly online tools where you can go and enter a query and it will return information, like DNS Digger. Very similar to Dig, but an online version of that. The Autonomous System Scanner. So Autonomous System is a concept within the BGP protocol for internet routing. So the Autonomous System Scanner provides information. You give it an AS number, and it provides you information on the prefixes being advertised by that autonomous system. Dig Web Interface, another interface to Dig to get information on DNS. Some URLs to get whois information here from, let's say, prefix whois, active whois. Zaba Search will give you information on people. Finally, GeoTrace, PingProbe are online network trace utilities. So what can we do to protect ourselves from footprinting? And I would say the answer is not much, because the majority of footprinting is accessing public information, right? We have to put our web server out there so that people can get to the data that they need to use our service or buy our product. But there are some best practices we can follow to restrict some of those areas of footprinting that such as traceroute, right? That's one of the areas that we can actually have some sort of control over. With respect to network level protection, we have appliances on our network, whether they're firewalls, intrusion detection systems, or intrusion prevention systems. There are some best practices we can follow in order to secure those things. Infrastructure ACLs or IACLs are access control lists that are deployed on a system to protect the system itself. So this is restricting traffic destined to that particular system. So an IACL on a router that blocks ICMP would stop you from pinging the router itself. The alternative to IACLs is transit ACLs, and these are access lists that are applied to traffic that is flowing through a device. So if we wanted to stop traceroute, we could use IACLs to stop the traffic from being responded to by the device, or transit ACLs to stop the traffic as it's flowing through the device. So there's an important distinction to keep in mind between infrastructure and transit access lists. When it comes to defining access, always follow a least privilege model. You start with your access link being deny IP any, and then add above that line just the most restrictive possible policy that can be deployed to accomplish the goal. If all you're doing is offering web services and there's a firewall in front of it, then your access list should be permit TCP 80 and deny everything else, or permit SSL, deny everything else. AAA, in the third bullet there, is authentication, authorization, and accounting. It's a common method of both authenticating users, authorizing them to do things, and then keeping an accounting log of what they've done. So deploy AAA so you know who's logging into your devices, you know what commands they're executing, and you are permitting them to execute those commands. Disable insecure protocols. This is, use SSH instead of Telnet as an example. Keep software up to date. Pay attention to security advisories from your vendors. Most vendors out there when it comes to network appliances, whether it's Cisco, Juniper, F5, are going to offer some sort of white paper on how to properly secure their devices. From out of the box to in production, what settings or configurations should you make in order to secure those devices? When it comes to antivirus and intrusion prevention or intrusion detection systems, keep them up to date, download those new signatures, and as well, keep them tuned to the environment. If you know that, for example, there's going to be a whole bunch of traffic with incrementing port numbers, you're going to want to tune your IDS in order to avoid false positives, because if you have a whole bunch of false positives, you're going to miss the actual attack. So keep your IDS systems tuned to the place that they're running. I touched on the first one here already. Keep your IDS, IPS systems up to date. Also use something called split horizon or split brain DNS. This is where you have a DNS that's publicly accessible with publicly routed internet addresses, and then one internal for your private address space. Your clients will use that internal DNS, which may recurse to the external DNS, which would then provide the actual result. So what you're doing here is you are restricting your internal systems from having their IP addresses revealed to external entities. For example, if you have a database server running inside your network that shouldn't be known to the outside world, you wouldn't want to have a single DNS that hosts both internal and external zones. Use two DNSs to accomplish that job. And then on the external DNS, you're not going to tell people that the database server even exists. When it comes to protecting hosts from footprinting, disable those unnecessary services. The more services that are running on a host, the larger the footprint is for me to attack. If it's a web server, the only listening port should be 80 or 443. There's no reason to have Telnet there. There's probably a reason to have SSH enabled, but you get my point. Approach your systems as if you were the attacker, right? So the whole idea of being an ethical hacker is all about performing penetration tests to determine what is vulnerable so that a real attacker doesn't come and exploit those vulnerabilities. So put on your black hat while keeping the white hat underneath, so that you can expose those vulnerabilities before an attacker actually does. Consider using HIPS software, that's Host Intrusion Prevention System. So it's very much like a network level IDS or IPS, but it's running on the system itself and analyzing the traffic before it is received by the application itself. Of course, if you are accessing internal resources, then highly recommended to use IPsec and for remote access into your network. Policy. Often overlooked, but having a sound, well-defined security policy that is endorsed as well as championed by executive management is extremely helpful. If the upper levels of management are not only complying with the security policy, but making sure others do, it will definitely protect information and data. Audit yourself. Go hire a CEH to take a look at what's accessible from outside the network as well as inside the network. Keep in mind that rogue employees can be an attacker as well. So it's not just coming from the internet. You need to take a look at what's accessible on the inside as well. And the final bullet point here, educate your employees. You want them to know what the policy is as well as steps to take to ensure that they are not the source of the compromise. There should be no reason that anyone is ever calling them, asking them for their password. So make sure that they know this, and don't just do it once. Have a yearly true up on information security best practices with your employees. So at the end of every lesson in this course, we have what we're calling a real-world application of the topic covered in that lesson. And the way Bo and I are doing it is a bit different. In my lessons, I'm going to have an overview of the steps you would take during a penetration test to accomplish that particular phase of the pen test. Bo is going to be doing demonstrations of the topics he's covered in his lessons. So the first one we'll be looking at here is using footprinting in an actual penetration test. So let's go ahead and get into that. The whole purpose here of footprinting during a penetration test is to assess the footprint of your organization. So let's take a look at the steps that you're going to do to accomplish this footprinting task of a penetration test. First step is always going to be get approval. There's a good chance that if you're working for an organization that has an actual network security team, that they're going to be watching the IDS systems. And if you go and start scanning systems, you're going to fire off some alarms. So get approval from management, not just your management, but the people that are watching the network, to let them know what you're going to be doing. Also, define the scope. If you're going to be attacking, say, this one subnet or this one host, then you can let those people know that this is what you're going to be attacking. And if they see an attack on another system, that's not you. And that's something they should actually worry about. So defining the scope is pretty important whenever you're conducting a pen test. And then kick it off with the steps that we've discussed during this presentation, starting with search engines. See what information your organization has out there publicly, and use those Google operators we were talking about to find files that are available or open directories. Whatever public information is out there is helpful to an attacker. Those public websites that you do find, take a look at them. Mirror them, look at the source code. There's a good chance that if it's your organization, you already know what the web server is, but you know the method with which to get that information. Use email tracking. If you were to send that email and you want to know if it's possible for your employees to click on a link and say a phishing attack, you can use these email trackers like Yesware to find out which employees are actually willing to click on an enticing link. And it won't do anything malicious. You'll just know that they opened your link because of that link redirection that's in there. Look at your competitors and what information they're willing to give out on your company. It's good information to have. Touched on the operators. Again, use those operators to find information that's publicly accessible. Google is crawling all over the place. There's a possibility that there's an open directory of files that you might not want to be publicly accessible, and Google may know about it. DNS and Whois, again, good information available from DNS as well as Whois. DNS will give you those IP addresses and host names, subdomains, information like that. Whois will, addresses, phone numbers, authoritative name server information, all good stuff. When it comes to the network, take a look at those regional registrars for what IP blocks are assigned to the organization. And then go to the registrar and do the Whois, right? See what information you can gather as far as autonomous system numbers, administrative contacts. And then with that information, their block, go to, say, Netcraft, put the block in there and find out what systems are up and running, what operating systems are being used, and other information like that. Social engineering, cold call your own company or whoever your target might be and try to gather some information. Keep in mind that you want to have some credibility. So knowing the names of the employees and dropping those names during conversations can be helpful. With social media, I would recommend always starting with LinkedIn and a company name search on LinkedIn, because you get the names of the employees, and it can be helpful when doing, say, social engineering, dropping those names to give yourself credibility. And finally, as always, document your findings in some form of report. There's not much point to doing an authorized pen test if you're not going to fix the problems that you find. So document in that same document where you define the scope. You paste in your results at the end there, so you can have a document that you can provide to management with, here's what I did, here's what I found, and here's what to do to fix it. Welcome to Lesson 4, Scanning Networks. Now that we have a good view of our target's footprint, we can begin to find hosts that we should focus on. This involves scanning their networks and hosts to find services available for possible exploit. In addition to general TCP and UDP scanning, we'll be discussing diagramming, tunneling, banners, and several other topics related to scanning networks. Okay, so welcome to 4.1. We're going to be talking about scanning networks. So after we've footprint, we know what we want to gather more information on. The next step would be scanning. So what is network scanning? Network scanning is using a computer, most likely the laptop that's sitting right in front of you, to send probes towards a target. Those probes are either TCP segments, UDP datagrams, or IP packets towards the target in order to gather information about that system. And what information are we gathering? First off, is it alive? So if we send a ping packet, an ICMP echo request to that host, will it respond? Is it alive? What services it's offering? And we can figure this out by basically asking it with TCP segments, what operating system is it running, and or what vulnerabilities exist. So port scanning versus vulnerability scanning are a little bit different in that with port scanning, we're just seeing what services are available. And with vulnerability scanning, we're checking to see if the service that's being offered is actually vulnerable to a known vulnerability. The methods we're going to employ for this scanning are checking for live systems. This is just a general ICMP or ping packet. Checking for listening ports using common tools like Nmap, Network Mapper. Grab banners. We are also going to touch on avoiding IDS detection. That's intrusion detection system detection. We'll look at vulnerability scanners as well as diagramming. So sending all these packets to determine what services are available is fine, but it's good to know what the network looks like as well. So as we're scanning for available systems, creating a diagram to go into that information database I keep talking about is helpful. And we're also going to touch on using proxies to anonymize the source of the traffic. And now we're going to get into techniques used in network scanning. It can sort of be divided into two common themes. The first being discovery of live systems through ICMP scanning, as well as the tools that can do ICMP scanning, and discovering open ports. So is the system alive? If it is, what service is it offering? And tools we have there, Nmap and HPing. There's also some techniques for discovering open ports that we're going to dig in at the packet level to see what's actually occurring. Those being the full open scan, idle, stealth, ICMP echo, UDP. We're going to take a look at all these different scanning methods and how they work. So let's get right to it. ICMP scanning. I have a, right at the top of the slide here, a quick overview of what ICMP is, Internet Control Message Protocol. It's an IP protocol used for signaling between hosts on a network. It's not just for ping. It's not just for echo request and echo reply. It's also there for destination host unreachable, destination port unreachable, time to live expired. It's used for messaging between systems to let them know what's going on in the network. I can't say it's usually solicited, meaning that you send a ping, you get a reply. It's often unsolicited as well, such as TTL expired. However, the most common use of ICMP, the one that users actually see the most often, is echo request and echo reply. ICMP messages have a type value and a code value. For the echo request, when you type in ping 10111, your computer is going to generate an IP packet that uses the ICMP protocol, and within the header for ICMP is type 8 code 0. When the destination receives that, it's going to generate an echo reply, provided it's allowed to, meaning that the administrator of host B has not stopped the generation of those echo replies. The echo reply would be type 0 code 0 as it comes back. Now, knowing types and codes for the CEH exam is valid. It is possible that you might be quizzed on what is, say, type 13, and you would need to know that. So while we won't be digging into all of the types and codes here, that information is available. It's documented by the Internet Assigned Numbers Authority, IANA, and you can go grab the ICMP type code document and take a look at those for further study. That's iana.org, IANA.org. Here's an example of just using ping to check if a system is alive. Very simply ping and the IP address. In this example, I'm using -C3, and that is count. So I'm telling the system to generate 3 ping packets to 8888 and get the responses. The default operation of ping on Linux systems is to just continue pinging. It's very similar to the ping -T or ping/T, whatever it is on Windows that keeps generating ICMP rather than the default of 4 on Windows. You can also get some useful information with the round trip time down there at the bottom. It tells us the minimum value for RTT, the average, as well as the maximum. Ping sweep, it's sort of an expansion of ICMP where with ping, you ping one host, get a response, you know it's alive. With ping sweep, you ping an entire network. So understanding subnetting is pretty important, not necessarily for the CEH exam. However, you may get a question on, say, for example, how many valid hosts are there in a 24-bit subnet? So understanding subnetting may be important. And when it comes to ping sweeping or network scanning, I would say it's very much important, because if we want to say, do a ping sweep of an entire block of addresses, and we know that the size of the subnet is 24 bits, then we know that we're going to be pinging about 254 hosts on that network. So ping sweeping is sort of an expansion of ICMP scanning in that rather than pinging a single host, we are pinging all of the hosts on the subnet. And tools such as Nmap have the capability to ping an entire subnet. And when we get into the demo later on in this lesson, I'll give an example of that. Here I have an example of using Nmap to do a ping sweep. You'll see that you have the command Nmap, and then -S is the scan type. There's several different options. The capital P here is the ping scan type. In the CEH exam, it is possible for them to ask you what is the Nmap switch for, say, just as an example, a ping sweep. And here I'm showing that S capital P. So they might ask you what the switches are for different types of scan. And Nmap's very full featured, so there's a whole bunch of different options. In this example with ping sweep, you can see that I'm giving it to /28. So we have 14 valid hosts that could be responding. So it's going to send that many ICMP echo requests and look for replies to the network specified. In the results output down there, we see we have valid hosts at 1, 2, 5, 10, and 15. It sent pings to all, it says 16 addresses there. One of them is the broadcast. I don't believe Nmap actually sends a ping to the broadcast address, but I might be mistaken. And it is very quick. So you can see there that it scanned all 16 addresses, 14 possible hosts in 1.3 seconds. So very quick. It does it parallel. Take a look at Sniffer while it just fills up real quick. Here's some tools that can be used for ping sweep. I highly recommend Nmap, but there are some other tools that provide graphical interface if needed, such as Angry IP Scanner or Colosoft. SolarWinds has a very full-featured tool set, includes ping sweep. All right, so we had the first bucket of discovering live systems. Now we want to talk about discovering open ports. There's two routed protocols that are most common on the internet, TCP and UDP. While they accomplish the same goal, that is transferring data between two systems, the way they do it is very different. The primary difference being one is connection-oriented and the other is connectionless. TCP, connection-oriented, UDP, connectionless. So with TCP, there's an established session there, meaning I reach out to that host replies and says, okay, I want to talk to you, or I'm willing to talk to you, and then you send data back and forth and then close the connection. So there's session management going on there at that fourth layer of the OSI model. UDP is very much fire and forget. UDP datagram is created, put on the wire, and it's forgotten about. You can have responses with UDP, such as the case with DNS. DNS uses UDP for data exchange. I send a DNS query, I get a response back. But there is no connection state with that. Since it's connectionless or fire and forget, it's unreliable. It's possible for that datagram to be lost in transit and you wouldn't know. But with TCP, because it's got that established session, it's possible for you to know that data is lost. Data needs to be resent. So TCP, we're going to look at TCP because that's usually where network scanning occurs. And in order for a session to be established, there has to be something called a three-way handshake. So host A wants to talk to host B. In this case, it's 10.1.1.10 wants to talk to 8.8.8.8, which just so happens to be the Google publicly available DNS server. But let's not think about that for a moment. A wants to talk to B, and in order to do that, they need to establish a TCP session. The three-way handshake is referred to as SYN, SYN-ACK, ACK. Those are the flags that are used during session establishment. In the first segment that is put on the wire, it's called a SYN packet or synchronize, and it's for synchronizing sequence numbers between the two hosts. So I send a SYN, or host A sends a SYN to host B with sequence 100. The response that comes back is SYN-ACK, meaning I acknowledge your SYN and here's my SYN. So please synchronize with me. He'll send his initial sequence number of 200 and ACK at 101, which is the previous sequence number plus 1. And then finally, host A will acknowledge that SYN from host B. So you can see how that would be SYN, SYN-ACK, ACK. From this point forward, we have an established TCP session. So if you think about how you might discover open ports on a system, if I say have a web server that's listening on TCP port 80, and I want to know if it's listening on TCP port 80. If I send a SYN packet to port 80 and the host responds with SYN ACK, I know it's available. It's listening on port 80. And that's the same method that these scanners use. They try to open a session. If they're able to open it or they get some sort of response, then the port is available. Now, it's not necessarily the case with certain scan types, such as a Christmas scan, which we'll talk about in a bit, but that's the general concept. It's trying to generate a response from the host that's being scanned to let you know that it's actually listening on that service or providing some sort of service on that port. There's 6 different flags. So SYN and ACK are 2 of the flags that are part of the 3-way handshake, SYN, SYN, ACK, ACK. And there are 4 other ones that are important to be aware of. SYN, as I mentioned, was synchronized. It's used to synchronize the sequence numbers between the 2 hosts. ACK is acknowledge. It's used not just for acknowledging the sequence number that was sent previously, but to acknowledge any segment of data, meaning you've sent 10 bytes, I acknowledge the fact that I have received those 10 bytes. You don't need to resend them. Fin is finish, and it's a method for each host to tell each other that they're done. Push is a unique flag that tells the system that receives this segment to immediately pass the data to the application. Urgent, somewhat similar, but it tells the receiving system that it needs to urgently process this information. And reset is used for either host to tell the other host that they're done. We're done talking, I'm not going to talk to you any longer. So the normal flow for a TCP session would be SYN, SYN, ACK, ACK, and then a whole bunch of ACKs, and then fin, ACK, fin, ACK. So push, urgent, reset are used in special cases. It's usually just SYNs, ACKs, and fins. Nmap, I've mentioned, it's a very popular command line application for both live system discovery as well as service discovery. Is the port available? But it also provides operating system detection as well as the versioning. So it can grab banners from services to let you know that this system's running OpenSSH version 2.3, whatever the case may be. So that during that footprinting process, you can narrow in where you want to attack. Maybe a vulnerability is there in 2.3 of OpenSSH that you can target. We'll touch on packet crafting. So this is a method with which you manually define all of the parameters of a packet from layer 2 on. So layer 2 is where MAC addresses come into play, and the MAC addresses change at every routed hop in the network, right? Packet crafting is defining the parameters for an entire packet, starting with source and destination MAC address, subsequent protocol numbers, IP headers, TCP headers, whatever the case may be. And the goal here is to analyze how a device behaves when it receives a packet that it might not be expecting, as well as auditing firewall rules. If we have a stateful firewall running, and stateful firewalls should only allow packets that are either belong to a session or are the start of a session. So if you send an ACK in that doesn't belong to an existing session, you would expect the firewall to drop it. So that's how you could use packet crafting to test firewall rules and ensuring operation of security devices. HPing and Colosoft Packet Builder are 2 common tools used for defining packets. HPing is a command line tool. It's extremely full-featured where you can define every bit of a packet before it gets sent down to the network interface card for transmission. All right, let's take a look at the Connect scan, TCP Connect. This is the most common form of port scanning, and it basically will attempt to create a full TCP session. It will send a SYN, receive a SYN ACK, and then reset the connection to close it. It's a little bit more friendly to the host being scanned in that it's not tying up resources. It lets the destination system know that, my mistake, you can close that and free up those resources. In this slide, as well as the following slides, I'm going to show you what it looks like when the port is open and what it looks like when it's closed. So in a TCP Connect scan, we send the SYN, receive SYN ACK, and then reset the connection. We know that the port is open because we received that acknowledgement from our target. If the port was closed, then the system should send a reset back. And this, when I say should, it's RFC defined that if a system receives a segment destined for a port that the system is not listening on, it should generate a reset. segment. So that means that the reset flag would be set in the TCP flags. There could be something stopping this. In the example of firewalls, they will most often not send reset packets if you were to scan them. And that's a security feature. And you could disable generation of resets in hosts too if you wanted to, just to protect yourself a little bit there. Next up, we have a half-open scan, similar to the connect scan, except we sort of stop in the middle. So we're not going to acknowledge the SYN that we receive from our target. So port open on the left, we send a SYN, we get a SYN ACK back, we send a reset. Now in TCP connect, we'll acknowledge and then reset. In this scenario here, we're not going to acknowledge. And the reason we do that is that because we don't finish the three-way handshake, meaning that the target does not receive that acknowledgement, there's a chance that it won't log it as an open connection. So there could be some evasion from going into logs with the half-open scan. Now there is another type of half-open scan where we don't send that final reset. We just sort of go silent. And that's also a method that's used in denial of service for applications. If you send a SYN, receive a SYN ACK, that application is sitting there waiting for the final ACK to complete the three-way handshake. So it's reserving resources. So if you send a bunch of SYNs, then you could tie up resources on that system. So it's kind of one of the fundamentals for denial of service. Same concept is used here in the half-open scan. For port closed, same as the connect scan. If we get a reset back in response to our SYN, port's closed, move on to the next one. The Christmas scan, or Christmas tree packet, it's a unique take on the way TCP operates on certain operating systems. So what it'll do is it'll send a segment with the fin, push, and urgent flags set. You'll notice that there's no SYN, there's no ACK, there's no reset. So this is a packet that should not exist on the network. It violates the RFC, or the protocol specification for TCP. Whenever a system receives this packet, what does it do? And that's how you can determine if a port is open or not. So on the left with port open, we send the Christmas tree packet. If we don't get a response, then that means that it did make it past that first check of, is it listening, right? Am I listening on that port? If I receive it on that port, strip off the IP header and take a look at the flags, it's an invalid packet and I drop it. So if I don't get a response from the destination, we can assume that it's listening on that port. And the reason we can assume that, because if it was not listening, we would have received a reset, as we see on the right. Fin scan is very much like Christmas tree. If we send a fin to a destination that doesn't already have that established session, it should just drop it. That's the way it should operate. If the port's closed, we'll get a reset back. It's just like Christmas tree, but we're using fins instead of fin, push, and urgent. Null scan is another type of segment that violates the specifications. We send a TCP segment with no flags. If we get no response, the port is open and listening. If we get a reset, then the port's closed. Idle scan is a bit interesting in that we require a third host in order to participate in this. It takes advantage of the fact that every IP packet that is sent from a system should increment its identification number. There have been advances to operating systems that will randomize IP IDs, but it is still common in certain scenarios where you can rely on the IP identification number to know whether or not a packet has left the system. All right, so if I send 3 packets, I should see IP IDs increment one by one. So with the idle scan, what we do is we send a SYN ACK to a zombie, right? This zombie host should not be talking on the network. Its purpose should just be sitting there listening. So we wouldn't recommend Windows to be the zombie because it talks NetBIOS every now and then. Similarly, Mac can occasionally talk multicast DNS, and that'll increment IP ID. But if you get a truly silent system, say like a Linux system, you send a SYN ACK to that zombie. You should get a reset back. When you get that reset back, in the IP header will be the identification number. You store that, and then you send a SYN packet to the target, but spoof the source address. That spoofed source address would be your zombie host. The response from your target is going to go back to your zombie. The zombie is going to do something with it, and it's going to either increment the IP ID or not. And then we go and then requery the IP ID from the zombie, If it has incremented by 2, we know that the port is open. So it's kind of complicated, but it does work. And the actual scanning host is completely anonymous to the target, because the only thing the target knows is that it received a SYN from the zombie host and it sent back its response, whether it was reset or SYNAC. And the IP ID is going to reveal whether or not the end target system is actually listening on that port. So here's an example of the idle scan in action. We have 3 hosts on the screen here. We have our source, this is our attacker. We have our zombie host up top and our destination on the right. First step is to determine the initial IP identifier that Z is going to send. So we send a SYNAC to Z. Step 2, it will respond with a reset. In the header of that reset, we can determine the current IP ID that Z is using. We store that information. Step 3, we're going to send a spoofed TCP segment, so a spoofed source address. You'll notice in step 3 that the source IP is the zombie, and we're sending a TCP segment with the SYN flag set. The destination, upon receipt of this SYN, because the port is closed, in this scenario, it's going to send a reset. That reset, because we spoofed the source IP from step 3, is going to go back to the zombie host. The zombie host is going to ignore it because it doesn't already have a session there. And then in step 5, we requery the IP ID by sending a SYNAC to the zombie. The zombie will again respond with a reset. Because the IP ID only incremented by 1, meaning that the zombie had only sent 2 IP packets, we know that the port is closed. So again, it's sort of convoluted and complicated, but I think seeing it in a picture kind of clears things up. So here's an example of an idle scan with a open port. So the previous example, the port was closed. Here, the destination target is actually listening on that port. And the differences here are that the IP ID gets incremented by 2 because the zombie has to send that reset. If I move my mouse up here, this reset that gets sent from zombie to destination will increment by 1. And then when we go requery the IP ID in step 5, we'll see that the IP ID is now incremented by 2. So the port is open. So gathering all this information and sending all these packets, we can determine which ports are open, which are closed, without the actual target knowing who is actually doing the scanning. As far as the target is concerned, the zombie is the one doing the scanning. Inverse TCP flag scan is just sort of another alteration of unique flags. So with inverse TCP flags, we're using a combination of flag settings, whether it's null, fin, or the Christmas tree. Very similar to those scans. If it results in no response, the port is open. If the port is closed, then we'll get the reset back. The RFC defines that in the event of a combination of flags that should not be sent, you simply ignore it. So we can determine the state of a port just by looking at that. Another scanning technique is the ACK flag scan. Now, unlike the previous scanning methods, this isn't going to tell us if a port is open or closed. And the reason that it can't do that is because if you send a segment with the ACK flag only set, you're going to get a reset if the port is open, and you're going to get a reset if it's closed. So the purpose for the ACK flag scan is going to let you know whether it is filtered or unfiltered, just based on whether or not you receive a response. It will be labeled as unfiltered in map output if it receives a response. That means that in case there was a firewall there, it made it through that firewall and the destination sent the response back, that response being a reset. If there was no response received, then there was probably a firewall in the way that prevented the response to an unestablished session. So here's a quick summary of all the different scanning methods we've touched on. Connect is going to create a full session. Half open will just sort of stop in the middle. Christmas is fin, push, and urgent are sent. And remember that if you get no response, then the port is open. Fin, same as Christmas, but with different flags. Null, again, same, but no flags. Idle uses that zombie host and checks the IP ID numbers to see if the zombie has sent any packets. If it has, then the IP ID will increment more than you expect it to. Inverse is a combination of Christmas, null, and fin. Similarly, you will have no response for open or a reset for closed. ACK will give you filtered and unfiltered and let you know if there's a firewall in the way. Some tools for scanning here. Nmap would be my favorite. Network Tools Pro, NetInfera, and some other scanners here to check out if you prefer graphical user interface scanning. There is also GUI front ends for Nmap available. I don't know any off the top of my head, but there are some out there you can take a look for if you prefer that method for tools. So what can we do about network scanning? What countermeasures can we take to try to prevent scanning? Now, if you think of a web server, right, that you want to provide content from, the scan, you have to open a firewall to allow that traffic into the web server, and the web server needs to be able to respond. So there's not much you can do about stopping a scan to, say, TCP port 80 on the web server. You have to permit that. But for hosts that might not be as secured as they should be, maybe there's some extra services there, then stateful firewalls will protect us, provided, of course, that the firewalls have that least privilege model of access applied. Stateful firewalls will also analyze the flags of segments that are flowing through it so that it can drop segments that have bad flags, flags that shouldn't exist. So you can get some protection there as well. Intrusion detection as well as intrusion prevention systems have signatures that can be used to detect scanning, not just through signatures, but also through behavior. So if it sees a whole bunch of incrementing ports coming in, then it can sort of consolidate, trigger the port scanning rule and let you know that it's occurring so that maybe you can block that source from accessing your network. To put on your ethical hacker hat, proactively scan your assets both from the inside and the outside. So even though there's a firewall stopping it from the outside, what about malicious employees on the inside? If there's a service on that host that might be blocked from the internet but open from the inside, what could possibly be exploited there? Filter ICMP. You'll get two sides of the fence on this argument. When you talk to the network engineers, they're going to say, don't filter my ICMP. I need to know what's alive and what's not. And then the security folks will have the mindset that I don't want people to find out if it's alive or not. That's why I make this point here, at least to and from the internet. At your firewall, filter the ICMP. For general web traffic, surfing the internet, you shouldn't expect to see ICMP unless there's some form of outage, which you should be monitoring with something else anyway. And again, host intrusion prevention can be used to monitor behavior and proactively detect and block scanning if it should occur. I call out this risk here, I've touched on it, but securing the end host should be the ultimate goal, and shutting down services that aren't needed is very important. Okay, let's take a look at Nmap on the command line. This is the first demo that you'll see from Bo and I. In this demo, or at least the demos that I present, I'm going to be using virtual machines running in VMware ESXi. So I only have two virtual machines that are of importance to us here. First one being a Windows 10 virtual machine. That's the one that you're seeing right here. And this is a fresh install of Windows 10 straight from Microsoft. I haven't done any updates on it. And then the other virtual machine is Kali Linux, which is a very popular penetration testing distribution of Linux. So this is the Windows machine. It's straight from Microsoft. Log in here. Looks like resolution is a little bit off, but that's okay because we're not going to do anything here other than determine the IP address of the system. 10.1.1.36. Here's our Kali Linux system, and its IP address is 10.1.1.37. So they're directly adjacent. The Windows system is 10.1.1.36, and this system is 10.1.1.37. And the whole purpose here is to just run a few Nmap commands so we can get an idea of what it looks like when they're executed. So based on our information right here, we see that the local host's IP address is .37 and the subnet mask is 24-bit subnet mask. As far as discovering live systems, if we run a ping scan, that's nmap -s capital P and 10.1.1.0/24. So we have a 24-bit subnet mask. I can scan my entire local subnet with this one command here. It should be fairly quick. So we have finished scanning all the IP addresses in the subnet, and we can see that there's quite a few that are available. You'll see host is up, and you can see 248, 249, 250, 251, quite a few that are available that could be potential attack targets. So now we have a list of hosts that are available. However, we're going to target our Windows system and just see what it looks like. We want to determine what services are available on that system. We know that its IP address is 10.1.1.36. So the first scan type was TCP Connect. The S-T option is the TCP Connect option. 10.1.1.36 and set it free. It came back in 2 seconds and told us that we have NetBIOS there, SMB, and WSD API. I'm not familiar with that one, but based on the fact that NetBIOS is there as well as Microsoft Directory Services, we can assume that this is a Windows host. In this demonstration, we know it's a Windows host, but if you were scanning some system that you weren't sure what it was, if we see NetBIOS there, we can make a safe assumption that it's Windows. Now, keep in mind, though, that Samba, which is a Linux application that provides those same file sharing services, could report these ports as being available as well. All right, let's sort of narrow it down a little bit with some of the options here. So you can specify to Nmap that you want to scan a certain number of ports. By default, it looks at a list of ports that come bundled with Nmap as far as what to scan. But if we say wanted to scan all possible ports, so it's a 2-byte value in the TCP header for destination port. So that gives us a possible 65,000 ports to scan, which we can do with Nmap if we want to wait for it. So we do our TCP Connect scan. With the P option, we say we'll go 1 to 2000. So this will scan TCP ports 1 through 2000. P0 here, we'll say don't ping it. So by default, Nmap will try to ping the system first. We can do P0 in the event that the system doesn't respond to ICMP, but it is up and alive. So let's say we know it's alive. We can give it the P0 to avoid that, and we'll point it at our Windows system again. And this is running in parallel. So it sent those 2000 segments, got the responses, generated the output, and presented it to you in 3.7 seconds. I mentioned earlier the host that the Nmap creators host in order for you to run scans against. Let's take a look at that. It's scanme.nmap.org. And this is just the default Nmap scan. So it's trying to ping as well as running through the list of ports that it's going to check. So we see that it's listening on port 80. It's got Sun Answer Book, nping echo. Now for OS detection, there's a couple different switches. There's A and O. But let's take a look at the documentation, and we will search with the /-A. So we can see that A enables OS and version detection, as well as script scanning and trace route. So let's go ahead and run it. And we'll make it verbose. Because I turned on verbose, it's giving us feedback as it runs through the various pieces. You can see it just started OS detection, retrying. It's going to do a trace route. DNS resolution. NSE is the Nmap script engine. It's a very powerful feature where you can script out things to do in Nmap. Here's our result. We have our OS detection. It's a guess of Linux 3.11. Then it gives you a probability score. So there's a 96% chance that it's Linux kernel version 3.1 to 4.1. And then it gives you some more probable OS detection guesses. It tells you how far away it is. It's 15 routed hops away. Very difficult to guess the sequence number. IP ID sequence generation was all zeros, which is interesting, as you would expect that to increment. Here's our trace route result. So you can see this is 10.1.1.33 is a routed hop between this virtual machine and the network. 10.1.1.1 is the router, and then internet access coming out of Santa Clara, going through Comcast, Cogent to get to nmap.org. So that's a few examples of using Nmap to discover open ports on a system. The most important thing to remember is the man nmap command, because it provides all the information you need as far as different scan types. By simply searching for / or -s, then you'll find the various scan types right here. Ping, Christmas tree, whatever the case may be. So play around with it. Again, the CEH exam can quiz you on scan types. So knowing these switches to make Nmap do that particular scan is helpful. So we can scan our our hosts are our targets, right? But there might be an intrusion detection system that is passively monitoring traffic as it's flowing towards that target. So what can we do about avoiding detection from those IDS systems? First, what is an IDS system? It's a network device. It's plugged into the network. It can see the traffic that's flowing across the network, and based on signature or behavior can alert you to in-progress attacks or exploits. So in the event of a network scan, there might be a signature in there that says, if you see the port number increment by ones, in subsequent packets, then alert me that there is a port scan occurring. So that's what IDS is all about. The intrusion prevention system, the IPS, is an evolution of IDS in that rather than just detecting and alerting, it can actually prevent. It's usually inserted in the traffic path. So traffic would flow through an IPS, a prevention appliance, whereas with intrusion detection, the IDS would be sitting off on the side, just watching traffic as it goes by. So that's an important distinction between IDS and IPS. So how would we avoid detection by an IDS? There's a few things we can do, the most common being packet fragmentation. It's a feature of IP, feature of Internet Protocol, that if a chunk of data is too large to flow across the link, it can be fragmented. And it uses fragment offsets to reassemble the data at the other end. If you purposefully fragment your data as it's flowing by the IDS, it's possible you could avoid detection. And this is, of course, assuming that the IDS is not monitoring fragments and storing them for reassembly and then later analysis. There are some tools that will allow you to manually fragment packets as they're being sent. Spoofing, just like we did with the idle scan, if you're using a zombie and you're spoofing that source address, the IDS will see the scan and alert. However, it's going to alert to the zombie. It conceals your identity a bit there. Proxy servers we'll be talking about later, but it is a method to basically anonymize yourself. It's still detected. There still will be an alert generated that a scan is occurring. However, the use of a proxy server will conceal the true source of the traffic. Source routing is another method. However, it's usually blocked on the internet today, but it is a feature of IP that allows you to specify within the IP header the intermediate hops that a packet should flow through. So provided there's another path into the network that bypasses the IDS, the use of source routing could allow you to avoid the IDS. Again, on today's internet, it's rare that this would work, but from a conceptual standpoint, it is a possibility. So I touched on fragmentation earlier, and it's the most common method of avoiding detection from an IDS. Scanning while using fragments is to take that actual piece of data that contains the scan, meaning the one single probe, and break it up into several fragments. So it'll be reassembled at the destination system, but hopefully not at the IDS system. So you can avoid detection from an IDS by breaking the actual single probe packet into multiple fragments. Now, today's IDS systems can reassemble, so it's not guaranteed that you're going to avoid detection from the IDS. However, it is a possibility. I've previously touched on the benefit of grabbing the banners from applications that are offering services such as web servers. So let's take a look at how we can grab those banners from running systems. There's a couple ways to do it. One is active and the other is passive. With active banner grabbing, we are sending traffic to the target and taking a look at the response that comes back. In the case of a web server, we send that HTTP GET, and the header of the response tells us the server type version. And it tells us the server application that's running and possibly the version. With passive banner grabbing, it's not that we're actively probing the system to try to elicit a response. It's normally done with packet captures. So if we can get access to traffic as it's flowing to and from the system, then we can dig into the data in that packet capture and see what the version is. Again, this relies on us being able to access the traffic as it's flowing. And we're going to talk about sniffing. We have an entire lesson devoted to sniffing. here in just a bit. So just keep that in mind, but we will take a look at it here. Going back to footprinting, the banner lets us know where to target our attack. If we know it's running IIS, we look for vulnerabilities in IIS. Active banner grabbing, and remember this is where we actually probe the system to gather the banner, can be used to deduce both the operating system. As we see here, this is Nmap output showing us that it's most likely Microsoft Windows Phone Vista 2008, Windows 7, or it could be FreeBSD version 6. It's making those guesses based on several different inputs, one of those inputs being the existence of Microsoft Directory services. So while we can deduce operating system, we can also determine application version by doing banner grabbing. In this example here, you see that I'm telnetting to port 22, which is the common port for SSH. When you connect to port 22, that banner will pop up there for you. In this case, we see that this system is running OpenSSH 661 and just so happens to be running on Ubuntu. We can determine that as well. Here's an example of grabbing a web server banner using telnet. Very simple. You just run telnet hostname port 80, and everything that's in red here at the top is manually typed by you. The get/http/1.1 carriage return host, provided some host name, doesn't matter what, and then you'll get the HTTP header coming back at you. And I have highlighted in red here, Microsoft IIS 8.5. So it's very easy to grab banners using telnet. You can also do it with netcat. Netcat is very similar to the cat tool on Linux, except it pumps it out over the network. Here we're running netcat to Microsoft.com on port 80. We type in our get command, provide it with a host, and we get back our HTTP header. There's also GUI tools for banner grabbing, such as IDserve and Netcraft. Netcraft is an online database, so for passive banner grabbing, while it's not you actually going out and querying for the banner, Netcraft is going out and querying for the banner. So you can go to Netcraft, type in Microsoft.com, and look at software and versions there. Another method to determine the application running on a system is to look at file extensions. When I surf to Microsoft.com in this example, and I use Chrome Developer Tools to look at the actual header of the request, I can see that it redirected me to this home.aspx. So based on this, I can deduce that they're running IIS and they're using active server pages. It helps me narrow what I'm going to attack by determining this information. What can we do to protect ourselves from banner grabbing? Is it really that important? It's up for discussion. However, it is possible to turn off the divulgence of that information in the various web servers that are out there. In Apache, it's just these two commands here of server signature, turn it off, set tokens to prod. There's also mod headers. It's a module that you can insert into Apache to change the server name. In this example, we're changing it to Cheetos 1.2. IIS has options as well. There's a lockdown tool offered by Microsoft, and then server mask is another application that can be run to mask the banner being served by IIS. And again, I've said it several times, but disable unnecessary services. There's no reason to hand out that banner on a service that shouldn't even be used. So just turn them off, and that will protect you a little bit. So in network scanning, we're not just looking for open services, open ports. We also want to check for the existence of vulnerabilities. There's several tools out there that will automate the process of vulnerability scanning for you. Now, remember, one of the first portions of this course, we talked about the differences between the colors of the hats, if you recall that. So the certified ethical hacker it's not about creating or finding the vulnerabilities. It's all about penetration testing and using the tools that are out there for discovering vulnerabilities and reporting on vulnerabilities that exist in the network. So we wanted to touch on some of the tools that are out there for you to use. Some of these are commercial tools, meaning that they have to be bought to be used, and we have some free ones as well. But when scanning for vulnerabilities, there's several different areas that we want to focus on: network topology, OS vulnerabilities, application vulnerabilities, service vulnerabilities, and configuration errors. And the tools that we're going to look at over the next few slides accomplish these various tasks to some level. First one we'll take a look at is Saint. Commercially available vulnerability scanner. Used to be free, but it is now commercial, something you have to purchase. Runs on Linux and Mac, and it scans pretty much everything that's out there, whether it be a router, switch, firewall, IDS, desktop. If there's an open service, open port, it's going to throw some traffic at it and try to discover a vulnerability. The way these vulnerability scanners work is they contain a database of known vulnerabilities. And when you execute a scan, they actually run through those vulnerabilities one by one with some intelligence to determine if a vulnerability exists. And if it does, it reports it to you so you can go fix it. Another important feature of vulnerability scanners is compliance auditing. So if you happen to be in an industry that requires some regulatory compliance, whether it's payment card industry or NERC-CIP for power systems, these scanners will scan for compliance to those regulations so that you can report back to the auditors that you are or are not in compliance. Fix the stuff you need to get back into compliance. Next one we'll look at is Nessus. Again, used to be free, now it's commercial. It's a very popular vulnerability scanner, very quick. I've used it quite a bit and it gets the job done. You can grab a copy. I do believe they have a demo these days at tenable.com. The URL's in the bottom right. And they do have an off-premise deployment option, so you can run it in the cloud to scan your assets from outside the network. And it does do the regulatory compliance auditing as well. GFI LandGuard, again, it's another vulnerability scanner to be aware of. Regulatory compliance, monitor your inventory. So it does have some form of inventory management or asset database built in. Can be used for patch management as well as its core focus of network vulnerability assessment. You can get more information at gfi.com. And here's some more scanners, some free, some not. Qualys is a very popular vulnerability scanner. Can be a distributed vulnerability scanner that provides very nice reports. A lot of large enterprise customers use Qualys. And I've even seen some customers that require Qualys scan to be completed prior to an application going into production. It is highly trusted out there in the industry. I have URLs on here for the rest of these. Take a look at them. In the exam, you don't have to know how to use any of these tools, but you have to be aware that they exist and the name. So just read up on them at the URLs provided. Another important step to take when scanning a network or discovering footprinting is the creation of a network diagram. If you know that there's a firewall in front of the systems, it's good to put it on paper or e-paper so that you know what's in the way so you can prepare your attack based on that information. Computer network diagram, as its name implies, is simply a diagram of a computer network. All of the nodes that you've discovered, the connections between those nodes, I would consider it a crucial step in understanding your target. This goes back to that most important step when you're actually going through a pen test is gathering as much information as you can so you can focus your attacks. There's a couple different diagrams you'll encounter out there, whether it's physical or logical. Networks these days are moving towards the logical side where it's consolidation of multiple networks on common gear. There's a lot of talk of overlay networks, underlay networks. So having a logical depiction of the network, while harder to get that information, can provide quite a bit more understanding of how a network operates. Here's an example of a network diagram. This is, I would assume, a retailer based on the fact that it's got a PCI server down there at the bottom. I can see a couple Cisco firewalls in the middle, those 5550s. Switches on either side, a bunch of servers, core switches and routers up top. They're connecting to a layer 3 VPN provider through Verizon. We have remote store at the top, again, leading us to believe that it's a retailer. Some VPN concentrators on the upper left. So this is an example of what a diagram could look like. We also have IP addresses documented down there. So get as much information into the diagram as you can. Now we'll talk about some tools very similar to vulnerability scanning tools that we covered in the last section. These are some tools for automated diagramming. This one here, Land Surveyor from SolarWinds. SolarWinds provides a whole bunch of different applications for network engineers. This one, Land Surveyor, will go out, auto-discover the network, create a diagram for you, and it also exports to Visio. Visio being the most popular format for diagrams these days. As well, it can gather information from SNMP, ICMP, Windows Management, as well as the APIs that are provided by VMware ESXi servers that are out there. We also have Op Manager, which you can take a look at from Manage Engine. As an example diagram here in the bottom right. It does a lot of similar stuff that SolarWinds tools do. including IP address management, which is pretty helpful when you have a large enterprise and you need to know where IP addresses are. The Dude, it's another auto discovery tool. However, it's free. The previous two being commercial options. This one is free. You can take a look at it from microtik.com. It does discovery, creates pictures. You can overlay it on a map. It does monitor links in real time through SNMP and ICMP, so you can know on your picture there if a link is down. So it's pretty helpful and it's free. So go take a look at that. Some more tools for you. NetBrain, I've used quite a bit, and I'm a pretty big fan of that, as well as one that's not necessarily on the list here, but good for getting a view into the network is Live Action. We also have some big names on here like HP, provides Network Node Manager. OpNet gives you NetMapper, SpiceWorks, LandState, IP Sonar. All good tools to be aware of for network diagramming. I touched on using proxies in the IDS evasion section and mentioned that we would be covering it later. And here we are about to cover it. So a proxy server is a server that runs software that allows you to send data to it, and then it will send the original request to the original destination. So they're kind of men in the middle, if you will. And we have an example here where I show the source and destination, not using IPs, but just logical names. So in this example, A wants to talk to C, but it's going to use a proxy to get the job done. So we have source A, destination proxy. The proxy receives the request, analyzes it, sends it to the correct destination, and proxies the response. So as far as destination C is concerned, it only knows about the proxy. So when we talk about using proxies for evasion, I mentioned that the attack will still be detected. However, the source will be anonymized. So that's what using proxies is all about. It's all about hiding the source, which I mentioned here. So it appears to originate from the proxy server, right? But what about the logs on that proxy server? So I wouldn't say that using a proxy server is a way to ensure that you're not going to be threatened with legal action based on this, because it is possible to, say, subpoena the logs of a proxy server. Be careful, a proxy server isn't going to completely anonymize you as the attacker. Another benefit of proxy servers is filtering, in that we can have the proxy server filter malicious or dangerous traffic prior to it being sent out. So a lot of enterprises these days will use outbound proxy servers. They serve other purposes other than just anonymizing the source of traffic. In the example of a web proxy server, it can actually cache content and deliver it faster than the intended destination. So they do have valid purposes other than just sending attacks through proxies. They can also be used to filter traffic to protect internal users. Proxy servers can alter data. Because proxy servers receive the original request as well as proxy the response back to the requester, it's possible for a proxy server to manipulate that data. And if you think about an attack where you are, say, a man in the middle and you run a proxy server with some intelligence that you have developed to where you can, say, change the name of a bank, just as an example, as it's flowing through the proxy server, you can deceive if you wanted to. Source address overload is another benefit of proxy servers, in that you can have multiple clients going through one single proxy server, allowing you to conserve addresses if you needed to. Back in the 90s, proxy firewalls were a big thing. Not so much anymore, but there was a firewall product in the 90s called Gauntlet that used the proxy model, and it would run proxies on all of the different services that you wanted to provide, and traffic would basically be intercepted by the firewall and then proxied out to the destination without client configuration. These aren't used very much anymore, but they do exist. Another benefit, which may not be a benefit if you actually dig into it, if I've compromised a host, because I'm on this host, I have access to the internal network. I can proxy an attack through a proxy server that has access to other internal hosts and then hide the fact that I have access to this compromised host. As far as the logs on those destinations would be concerned, it was the proxy server attacking them. So that is something to keep in mind. It can be used as a jumping off point for an attack. Chaining or proxy chaining is actually using multiple proxy servers in order to further obfuscate traffic. If you take a look at a picture like this, we have our source down in South America, proxies through Australia, Japan, looks like Russia up there, maybe Spain, to get to the eventual destination in the United States. And since these proxy servers are located in different countries which have different laws, correlating the logs on all of the chained proxy servers can be quite difficult. So if you do see an attack coming from a proxy server, there's a good chance it came through a different proxy server before that. So we're going to look at some tools that provide proxy services. This one, it's an old tool, but it gets the job done. It's called Proxy Workbench. You basically would point your clients to this server running on a host somewhere, and it will proxy. You can get a real-time view of the traffic that's flowing through, as you see in the bottom right. So if you were to get this inserted into a network and you're able to configure those clients to point to it, you could sniff the traffic. There are other tools to do the same thing, such as Ettercap on Linux. However, this is a Windows tool that will provide proxy services. Another one, Proxyfire. It's an updated UI. Again, it's been around for a long time. It provides proxy services and it does support chaining. So you can run Proxyfire on multiple hosts around the world and chain the traffic through them. Proxy Switcher isn't a proxy server per se. It's simply a method to configure your browser to use an open proxy. So what it does is it's got a database of open proxies that are up and online, and you basically come in here and select the proxy you want to use, and it will reconfigure your browser to use that proxy. So it serves other purposes other than masking source. It could be used for testing, say, localization of a web page from Russia. If you're serving content and you want it to be in Russian language, you could go through a proxy server in Russia and verify that it's actually showing Russian characters. Tor project, this is the Onion router. It's a pretty neat project that provides anonymization of sources. And it has a very legitimate use, and that is the protection of content creators that may exist in countries that filter internet access. By connecting to Tor, you go through several proxies before you eventually get to your destination. And at each point, it's encrypted, and the logs are not shared between the nodes of the Onion router. So it provides true anonymization of traffic as it flows to its eventual destination. Some more tools for you to play around with: Burp Suite, Fiddler, Widecap, Fast Proxy Switch, UltraSurf, and ProxyCap. All provide some form of proxy service that could be useful when performing a pen test. Another method of evading intrusion detection systems is to tunnel your traffic. There's a couple protocols that make this pretty easy. One is HTTP and the other is SSH. So we're going to take a look at tunneling with those two protocols now. First one, HTTP. In this method, what you're doing is you're taking your original data and encapsulating it in a packet that looks like HTTP traffic. And the reason you might want to do this is because firewalls will often permit TCP port 80 to pass through the firewall because it looks like normal user traffic. When you're doing HTTP tunneling, you have to have something on the other end to receive that traffic, decapsulate it, and send it to its original destination. So in this example, what we're doing here is we have our VNC client that's pointing to some unique software that is an HTTP tunnel client. That tunnel client will receive the data, package it up to look like HTTP, send it out to your destination decapsulation server. That's the HTTP tunnel server on the right. It'll be decapsulated, meaning that the HTTP wrapper will be removed and then sent off to the VNC server. The inverse, when the VNC server sends that, a response back to the client, then it will send it to that HTTP tunnel server, which will send back what appears to be an HTTP response. So it's maintaining that session state using port 80, but wrapping and unwrapping it to get through the firewall. Here's a tool you can use for HTTP tunneling, Super Network Tunnel. You can find more information at networktunnel.net. It's a full-featured application that allows you to do both client and server HTTP tunneling. Another example here, HTTP Tunnel at http-tunnel.com accomplishes the same mission of packaging data inside HTTP packets. With SSH tunneling, it's my preferred method of getting traffic through firewalls because usually SSH will be permitted out I'm not sure why, but many organizations seem to permit their internal users to SSH to the internet. So for example, if I'm behind some sort of device that's not letting me get to a device on my home network, then I can SSH into my home network and tunnel traffic through. In this example I'm showing here, I'm also using VNC and I'm tunneling it through SSH. This is built into SSH. OpenSSH provides this functionality, so if you have a Mac sitting in front of you and a Linux server at home, then you could tunnel whatever traffic you want from your Mac to that server at home. So I have a VNC client here. Whenever you run SSH minus capital L, there's several parameters you need to give it. The first is the local listener. This is the local port that your system is going to listen on. And then after the first colon, that's the destination IP the traffic will be sent to and the destination port. So you can actually modify port numbers as it's going into the local listener and coming out the other end. And it's completely encrypted. So most VNC packages out there require licensing in order to get encryption functionality. You can use SSH to encrypt the VNC traffic so that your credentials aren't exposed to anybody that might be listening. And then finally, username @host. With Windows, there's options for that as well. Bitvice provides an SSH server and clients. If you don't have Linux running in your home network, you could run Bitvice server, SSH server on that Windows host at home, and then connect from any SSH client. This also offers tunneling capabilities. So I'm going to give you a demonstration of using PuTTY on Windows to tunnel traffic through SSH. So this is PuTTY. As you first start the application, I'm not going to use any of my saved sessions where I do have some tunnels already created. I'm going to create one from scratch here. First thing we'll do is we'll type in the host that we're going to connect to. And I'm using a unique port on the other end that I'll be SSHing to. Normally this would be port 22. Next thing we want to do is take a look at connection SSH tunnels. And this is where we create a tunnel. I'll go ahead and create this and then explain it. So I mentioned that you can modify port numbers whenever you're doing SSH tunneling. In this configuration here, what it's going to do is create a local listener on port 5905. And when that traffic is received at the SSH server, it's going to send it to 10.1.1.253 on port 5900. So I'm listening locally on 5905 and it's going to send it to port 5900. Make sure you hit the add button. So I'll go ahead and hit open here and we'll bring the window up here so you can see it. Come back over to our command prompt just to verify. So we can see that we have a local listener created. It's listening on localhost port 5905. And we see the listening keyword there. So if I were to actually telnet to localhost on port 5905, we'll get the common VNC banner that we would see. So if I were to connect to myself with a VNC client on port 5905, it would be sent to that destination system on the other end, which is a Linux server running inside my home network. Another method of evading intrusion detection systems is to tunnel your traffic. There's a couple protocols that make this pretty easy. One is HTTP and the other is SSH. So we're going to take a look at tunneling with those two protocols now. First one, HTTP. In this method, what you're doing is you're taking your original data and encapsulating it in a packet that looks like HTTP traffic. And the reason you might want to do this is because firewalls will often permit TCP port 80 to pass through the firewall because it looks like normal user traffic. When you're doing HTTP tunneling, you have to have something on the other end to receive that traffic, decapsulate it, and send it to its original destination. So in this example, what we're doing here is we have our VNC client that's pointing to some unique software that is an HTTP tunnel client. That tunnel client will receive the data, package it up to look like HTTP, send it out to your destination decapsulation server. That's the HTTP tunnel server on the right. It'll be decapsulated, meaning that the HTTP wrapper will be removed and then sent off to the VNC server. The inverse, when the VNC server sends that, a response back to the client, then it will send it to that HTTP tunnel server, which will send back what appears to be an HTTP response. So it's maintaining that session state using port 80, but wrapping and unwrapping it to get through the firewall. Here's a tool you can use for HTTP tunneling, Super Network Tunnel. You can find more information at networktunnel.net. It's a full-featured application that allows you to do both client and server HTTP tunneling. Another example here, HTTP Tunnel at http-tunnel.com accomplishes the same mission of packaging data inside HTTP packets. With SSH tunneling, it's my preferred method of getting traffic through firewalls because usually SSH will be permitted out. I'm not sure why, but many organizations seem to permit their internal users to SSH to the internet. So for example, if I'm behind some sort of device that's not letting me get to a device on my home network, then I can SSH into my home network and tunnel traffic through. In this example I'm showing here, I'm also using VNC and I'm tunneling it through SSH. This is built into SSH. OpenSSH provides this functionality, so if you have a Mac sitting in front of you and a Linux server at home, then you could tunnel whatever traffic you want from your Mac to that server at home. So I have a VNC client here. Whenever you run SSH minus capital L, there's several parameters you need to give it. The first is the local listener. This is the local port that your system is going to listen on. And then after the first colon, that's the destination IP the traffic will be sent to and the destination port. So you can actually modify port numbers as it's going into the local listener and coming out the other end. And it's completely encrypted. So most VNC packages out there require licensing in order to get encryption functionality. You can use SSH to encrypt the VNC traffic so that your credentials aren't exposed to anybody that might be listening. And then finally, username @host. With Windows, there's options for that as well. Bitvice provides an SSH server and clients. If you don't have Linux running in your home network, you could run Bitvice server, SSH server on that Windows host at home, and then connect from any SSH client. This also offers tunneling capabilities. So I'm going to give you a demonstration of using PuTTY on Windows to tunnel traffic through SSH. So this is PuTTY. As you first start the application, I'm not going to use any of my saved sessions where I do have some tunnels already created. I'm going to create one from scratch here. First thing we'll do is we'll type in the host that we're going to connect to. And I'm using a unique port on the other end that I'll be SSHing to. Normally this would be port 22. Next thing we want to do is take a look at connection SSH tunnels. And this is where we create a tunnel. I'll go ahead and create this and then explain it. So I mentioned that you can modify port numbers whenever you're doing SSH tunneling. In this configuration here, what it's going to do is create a local listener on port 5905. And when that traffic is received at the SSH server, it's going to send it to 10.1.1.253 on port 5900. So I'm listening locally on 5905, and it's going to send it to port 5900. Make sure you hit the add button. So I'll go ahead and hit open here, and we'll bring the window up here so you can see it. Come back over to our command prompt just to verify. So we can see that we have a local listener created. It's listening on localhost port 5905, and we see the listening keyword there. So if I were to actually telnet to localhost on port 5905, we'll get the common VNC banner that we would see. So if I were to connect to myself with a VNC client on port 5905, it would be sent to that destination system on the other end, which is a Linux server running inside my home network. Next, we're going to take a look at some tools that can be used to anonymize the source of traffic. What is the purpose of an anonymizer? The stated goal is to protect privacy. So if an individual happens to be in a country that filters internet access, that's really what anonymizers were created for, so that these individuals that are creating content that might go against or violate some government censorship laws, so they can get that content out to the rest of the world. This example tool here, Siphon, as I say here, it acts as a secure proxy. So what it does is when you boot it up and hit connect, it creates a local proxy server basically, and then tunnels the traffic encrypted through SSL to a destination server, which decapsulates it or unencrypts it and sends it off to its destination. There's quite a few clients available, such as Windows and Android, and can be used to bypass firewalls, IDS, as well as content filters. Another example, it works in the same method, but uses socks, but it still does connect to a server on the SSL port. So frequently, because SSL and HTTP are so commonly used, it's very difficult to block them on a firewall, because then you are restricting a user from surfing the internet, which would perhaps cause some unrest. So by tunneling the traffic through SSL, it'll bypass that firewall and allow you to surf. There's, again, quite a few clients available, Windows, Android, and because the Java version is available, you have some cross-platform support. A few more tools. I mentioned the Onion Router earlier. It's extremely popular for individuals that need to get around those content filtering devices in certain areas of the world. Some more tools to be aware of: Privacy Pro, Anonymizer Universal, ZenMate, I2P. Take a look at those, be familiar with them. You don't necessarily have to know how to use them, just be aware that they exist. Now we're going to take a quick look at IP spoofing and what you can do to protect against it. But first, what is spoofing? So spoofing an IP address is purposefully changing the source IP address of a packet and then putting it on the wire. Why might you do this? One is to protect yourself from being detected. So if you send, as an example, 100 ping packets to victim B here, but spoof the source address to be IPC, victim B would never know that you were the one that actually sent those packets unless something was actually monitoring the wire and taking a look at some unique fields within the packets to determine if they are spoofed. Make note here, spoofing source IPs is easy, but getting a response is hard. If you take, for example, TCP requires an established session to operate. If I send a send packet to the victim here, IPB, but spoof the source, victim B is going to respond to that spoofed source. So attacker A over there on the left would never see the send ACK. It's near impossible to establish a TCP session using a spoofed address because you have to complete that three-way handshake. Some methods to detect IP spoofing, provided you have a copy of the packet. You can compare the time to live in the header of the packet with a valid conversation with that host that you believe is being spoofed. There's some caveats here. If there's an asymmetrically routed path, then it's possible for the TTL to differ. As well, the packets need to be routed, so they have to go through some layer 3 hops to decrement that TTL value. Another method is to look at the IP ID. If you're spoofing a packet and you are randomizing the IP ID, then you can send a packet to the spoofed or the suspect spoofed host and compare the IP ID. It should be near or greater than the suspect packet. If it's not, there's a good chance it's spoofed. Another method is to, and this actually takes pre-work, in that you have to modify the destination host to advertise a window size of 0 in the SYN-ACK packets. The reason you would do this is if you see data in that third ACK that's part of the three-way handshake, but yet you advertised a window size of 0, then it's a good chance that it was spoofed. There's a good paper I list here over from the folks at UC Davis that talks about detecting spoofing. And they cover these 3 methods in depth with charts and a bunch of cool stuff. So take a look at this if you want to get some more information on how to detect IP spoofing. So here's that document titled Detecting Spoofed Packets from the folks at UC Davis. The interesting stuff, not that it's not all interesting, but the stuff that I covered is down here around page 5, where we talk about IP identification, flow control, and specific methods with respect to TCP. And finally, how can we protect ourselves against spoofing? First off, filter ICMP. We talked about this earlier. There's a bit of a culture war as to whether or not you should filter ICMP. It's an organization decision. Maybe just filter from the internet. Use random sequence numbers. This is to avoid somebody guessing a sequence number to inject themselves in the middle of a conversation. Block bogons. So blocking bogons is considered an internet best practice. What you're doing here is blocking traffic on ingress. Meaning if your, say, IP block is 11.0.0.0/8, right? At 16 million hosts, you should not see a source IP that belongs to you coming in from the internet, right? So you're filtering on ingress. As well, you'd be filtering the RFC 1918 addresses such as 192.168 or 172.16 or any of the 10net. Next, we have reduce initial time to live. This is just to keep traffic from routing the normal 30 hops across the internet. So if you reduce that initial TTL, it's possible that traffic could be dropped closer to the destinations. Filter inbound traffic from your subnets. This goes back to the bogon conversation. You don't want traffic coming from the internet that is sourced from one of your networks. That shouldn't happen. Also, with access lists, filter traffic leaving your network that is destined for your network. And 2 final bullets. Do not base authentication on the IP address. You shouldn't be checking the source IP to say, this is who I think it is, because it could be spoofed. And finally, use encryption as often as possible. We'll now take a look at our real-world application section, where we talk about using scanning networks as part of a penetration test. So again, I will keep saying this in every lesson, get approval from management, let them know what you're going to be doing, make sure it's in the scope of that document that you're creating, and then get started. Do some host discovery with Nmap, as well as port scanning. I would also again recommend Nmap, but be aware that these other tools exist, such as Angry IP and Colasoft or NetScan tools. Follow that up with grabbing of banners. You can also use Nmap for that, or go old school and just connect with Telnet to grab the banner that's presented to you. Run a vulnerability scanner. Here I'm recommending Nessus. There's several of them out there. Nessus, again, is a commercial tool. However, it's very full-featured. Make a diagram for that information database we've been talking about, either manually. You could even draw it on paper if you want to, but Visio is a great tool to do that, or in an automated fashion with something like Op Manager. If you can, take a look at what you can use to hide the source of your traffic using some sort of proxy solution. And finally, document your findings, report back to management, get it all in that document so that management knows what to do with it and provide some recommendations on how to fix it. Welcome to Lesson 5, Enumeration. This lesson covers the fundamentals of enumeration, that is, the gathering of usernames, machine names, shares, and other important information from hosts. So let's take a quick look at what is enumeration. That is querying a system to gather information such as usernames, group names, information from SNMP, which could include things like IP addresses, load on the interfaces, shares that are provided by a host, services that are provided by a host, DNS names, machine names, routing tables, banners. There's all kinds of good information we can get, particularly with users, because if you know a username, then perhaps you can try to guess the password through brute force or other methods. Some techniques for enumeration. My favorite on the list is SNMP walking, but we can also try default passwords, extracting users and groups through tools that are available on Windows systems, grabbing usernames from email addresses. There's a good chance that nick@company.com, Nick is probably my username to log into the domain. As well, DNS zone transfer, which is pretty difficult these days with advances in DNS security, but it is still an option for gathering information for enumeration. So what services on a host do we want to take a look at to try to gather information? Starting off with DNS, it's a good place to send some queries and try to maybe do a zone transfer or do some directed queries to get IP addresses or guess some names and get the IP addresses for those names. Server message block on port 445 of Microsoft systems can provide some information. And again, my favorite, SNMP on UDP 161. If the community strings haven't been changed, then we can get a lot of good information there. LDAP, RPC, NetBIOS name services, as well as the session services with NetBIOS can provide us with a lot of good information such as usernames and network shares. When it comes to NetBIOS, which is commonly running on Windows systems, there's quite a bit of information we can get from them, including machine names, usernames, and shares. NetBIOS stands for Network Basic Input Output System, and it's been around for a long time, since 1987. Those are the original RFCs there, 1001 and 1002. Several different port numbers involved with NetBIOS, starting with port 137, UDP, and TCP for name registration and resolution. The datagram distribution service is on 138 UDP, and session service for connection-oriented communications is using TCP because of its connection establishment concept. NetBIOS names, so every NetBIOS computer on the network will have a name, and it is 15 ASCII bytes with a 1-byte suffix. That 1-byte suffix can give you information on what the name is. So several different options here for suffix, whether it's a workstation or a master browser for a domain, file server. You can gather information just by looking at that single byte of the NetBIOS name. I have a link here, support.microsoft.com, which goes in depth into NetBIOS names and how they're organized and how the protocol works on Windows. There's several tools available for NetBIOS enumeration. The first one, NBTstat, is actually built into Windows. If you run NBTstat/?, then it will give you all of the available options. You can give it an IP address and try to gather information from that host that's at that IP address. And then we have some third-party tools as well, such as Hyena, NetBIOS Enumerator, Superscan, and Nmap can provide some NetBIOS information. Again, the CEH exam, they may quiz you on tool names, so be aware of the tools that are available for NetBIOS enumeration. Users and default passwords. Let's first take a look at some tools that are provided by a package from Microsoft. This used to be provided or was originally created by a third party called sysinternals. Microsoft is now offering it for download. It contains several different tools that can be used to gather a lot of information from Windows hosts, starting with psexec, which can list the running applications on a remote system. Going back to our footprinting, if we were to say psexec on another Windows system and see what applications are running, we might be able to find one of those applications is vulnerable to something. It's a good method to gather information from remote hosts. Several other commands here. pslist will show you statistics for processes. psfile is another helpful one in that it can show you a list of files on a system that are opened remotely. So if somebody is connecting to this Windows host and accessing a file over the network, then psfile can let us know about that. Logged on will show us who's logged on both locally and remotely. So if they have, say, a share mapped, then ps logged on can get us that information. psgetsid will get us the security identifier for a machine on the network as well as users. And then log list can be used to show the event log on both local and remote users. You simply run the command with the IP address of the host that you want to connect to and gather that information. Also with default passwords, it's good to know that a lot of devices on the network, small office, home office routers, will usually come shipped with some sort of default password that is often unchanged. So if you do have access to the network and you try to, say, surf to the default gateway for that local area network, you might be prompted with a username password. Let's say you grab the MAC address for that device just by looking at the ARP cache on the local machine. Then you can go and determine the manufacturer and maybe find that there's a default password. Here's an example of a site you can go to on the internet, routerpasswords.com, to get a list of all of the known default usernames and passwords for the device that you're trying to access. Let's take a look at my favorite protocol for enumeration, that is SNMP. Now, you won't usually find SNMP agents on end hosts, such as Windows or Mac. However, most network devices are running some form of SNMP, and it serves a great purpose in that you can gather statistics about interfaces as well as configuration, and you can even change configuration in certain scenarios. SNMP stands for Simple Network Management Protocol. As I mentioned, it's used to manage and monitor devices on the network. There's a couple different pieces to it. There's a manager and an agent. So the agent is what's on the device, and the manager is the server or computer that is polling those devices to gather information, as well as receive traps from the SNMP agents. So SNMP agents can proactively send a message back to the manager to let them know that something has occurred, and those are called traps. There's two common passwords that are used with SNMP, as well there's two different types of access. There's read-only and read-write. Normally out of the box, you'll see public used for the read-only community string, And I put passwords in quotes there because when referring to SNMP, that password is called a community string. So there's read-only, which is commonly public, and the read-write community string is usually private. Several different versions, V1, V2C, and V3. V2 did exist, it was created, and it added security. However, the community didn't really like the methods that they were using for security, so V2C was created. They removed the security, but they kept the rest of V2. With V3, they put true encryption and authentication. So it's usually considered best practice with SNMP to use V3 because of that encryption, but you'll usually see V2C used most common on the network. SNMP has a concept of a management information base, or MIB, and all the MIB is it's a database of entity information that is defined using abstract syntax notation 1, ASN 1. And the object identifiers, as you can see on the right, so the string of text next to the green things would be the object identifiers. So when you know that object identifier, take a look in some sort of catalog of MIBs out there to find out what that number actually refers to. And the SNMP managers out there today, the commercial ones, will provide this information for you as they keep a local database of MIBs. There are also online repositories of MIBs that you can go take a look at. You take the object ID, you plug it in, search, and find out what you're looking for. SNMP walk is a command that is often provided with SNMP packages on various systems out there. In this example here, I'm running SNMP walk against a Cisco router. And you can see it's giving us a lot of information, such as the version of iOS that's running on this Cisco device. So I know it's running 15.14.M3. Maybe I go and look for vulnerabilities that are associated with 15.14.M3. oputils is a software package provided by Manage Engine, very full-featured SNMP manager. Also, SolarWinds provides a nice SNMP management package that does polling as well as trap reception, network discovery, topology mapping, and it is a commercial solution just like the previous example. Some more SNMP enumeration tools to be familiar with: NetSNMP, SNMP Scanner, Spiceworks. They all get the job done, but keep in mind that you need to know what that community string is. And if they're not using version 3, it's possible you could sniff that information and then go and send your SNMP polls to gather information. Here's an example of using SNMP walk. I'm logged into my Ubuntu system running in my home network, and in front of this system, or the router managing the local LAN, is a Cisco 1841 model router. I have pre-configured the SNMP community string so that I can walk it. So it's as simple as running SNMP walk, give it the protocol version that you're using as well as the community string and the IP address. In this example, I'm going to filter the output so I don't divulge my public IP address at home. But if I were to leave the pipe off of here, then it's several pages of text with a lot of good information such as interface names, IP addresses, version of software running on the router. So let's go ahead and search here for version just as an example. So we can see that same example I showed in the slide. This router is running Cisco iOS version 15.14.M3. Another example here, just so you can sort of see how it's working. Take a look for interfaces. You can see that there's several interfaces available in the router itself. Again, if you run this and get rid of the filtering using the grep command, then you get several pages of text that you can dig through and find some good information. The tools that we are going to cover in this lesson were created quite a while ago when security wasn't necessarily as important. There was a little bit more trust on the systems that were running. And these days, Linux systems aren't going to allow you to do what we're going to be talking about here, but it is good to be aware that these tools exist so you can try them, and you just might be surprised what information you can get. Starting off with finger, you can point finger at another host to gather information. That's using the @ qualifier there. Finger at localhost in this case is going to connect to the finger service running on the system itself, which is, finger is an actual protocol. It's TCP port 79. So the finger service would need to be running, and then you could get a list of usernames. RPC info, again, you can point it at a system. In this case, you could replace localhost with the valid IP address of another host and gather information on RPC endpoints that are offered by that system. Similarly, RPC client will allow you to get a list of shares that are offered from a host. And show mount will show you network file system shares that are offered by another host. In all of these examples, I'm showing you how to gather information from localhost. However, you can point it somewhere else to gather that information. enum for Linux is a script that was created. You can take a look at it at labs.portcullis.co.uk. It's basically running through the previous commands and trying to gather as much information as it can to provide you at least a little bit of information that you can use to try to get into that system, whether it's a username or a share that's available. Maybe you can get to a file running on that system. Here's an example of running enum for Linux. It's a Perl script. The -v there is verbose mode, so it tells you what it's doing. Then you give it an IP address to query, and it runs through and it executes several commands to try to gather information. We can see in this example that the SMB client command actually returned some information. So SMB is Samba. In this case, because it's running Linux, this is Samba. That's the server message block client that's part of the Samba package. So it tries to gather some information. We can see that it's trying to enumerate the workgroup and or domain information from that host. We see that the workgroup name is workgroup. It tries to get security identifiers, looks for null session possibilities, and provides you that information back. So it's a pretty neat script put together by these folks at Portcullis. Now we're going to take a look at enumeration for some of the other protocols that I touched on at the beginning of this lesson, starting with LDAP. LDAP is Lightweight Directory Access Protocol, and it's used for maintaining a directory of information, most often used for users of an organization. So you can see in the example on the right, that top line distinguished name, and then it combines a bunch of information. So this is John Doe as part of example.com. You can see how they break down information into individual chunks. We see telephone numbers, email addresses, the manager of that person. The manager is actually a reference to the distinguished name of this person's manager. So LDAP is most commonly offered, meaning available for consumption on TCP port 389. There is a secure option for LDAP called LDAP-S on TCP 636. And it is an open protocol, so the protocol is defined in a specification. It's not a proprietary thing. This example application here, again, be aware of applications, not necessarily how to use them. Softera LDAP Administrator, available there from ldapadministrator.com, can be used, provided you can actually get to the data, can be used to query an LDAP server to gather information. So if you find a system that's listening or offering information on the ports I mentioned previously, take a look and see what kind of information you can gather from them. Here's a few more LDAP enumeration tools, such as LDAP Admin, LDAP Search, LDAP Admin Tool, AD Explorer. A couple of these are from Microsoft themselves. So it'd probably be a good place to start to look at the tools that Microsoft offers. Next up is Network Time Protocol. NTP is used for synchronizing time on systems. And one good example of why you might want to do this is if you have, say, firewalls that are geographically distributed. You have one in New York, one in San Francisco, one in China. Using NTP and setting the local time zone to the common standard of GMT will ensure that the time on all of those systems is synchronized, so that if you need to do correlation of log files, it's very easy to see that what happened at 3 a.m. in New York occurred at midnight in San Francisco, because they will both say the exact same time of, what would that be, about 8 a.m. GMT. It is a very highly accurate time source. At the very top of the tree, so NTP is kind of a triangle, and at the top of that triangle are GPS satellites, usually. And they provide extremely accurate time, which goes down to that first level or stratum 0 NTP server, and it gets filtered down from there. It's offered on UDP port 123, so NTP, even though it is a I'm going to ask you for information and you provide a response back type of communication, it's not connection oriented. So if I send an NTP time request to an NTP server, there's no verification or session establishment. There's no guarantee that I'm going to get a response back. So I touched on synchronizing time from New York, San Francisco, and China. In the event that you might need to go to court and provide evidence in the form of firewall logs, it's usually required that those logs have synchronized time and same time zone. That's why most people target GMT for their logs and use NTP. What information from an NTP server might an attacker be looking to get? The host connected to that server. So there's built into NTP is this concept of peers. And just by querying the NTP server, you can find out who else is talking to it. Also, you can find out the internal client IP address space by looking at those peers. If there's an NTP server that's available on the internet and there's an internal peer, meaning an NTP server inside the organization that is querying that server or synchronizing its time to that server, then you can find out, well, I know it's internal IP that's probably sitting on this subnet. Maybe it's a /24. This is the private address space they're using, information like that. Several command line tools available. These are on Linux. NTP Trace can show you where an NTP server gets its time. As I mentioned, it's a triangle, and usually at the top of the triangle is a GPS satellite. So as you move up the triangle that's going through these different levels of stratum, you get closer to that true time source. NTP DC will ask a local NTP daemon about its state. As well, you can use it to manipulate that state. NTPQ is a command line interactive utility with several options available. Here I'm showing an example of running the lpeers command, which will show you the peers that this NTP server is talking to. In this case, I'm running it locally, so I'm asking the local host who its peers are. And finally, NTP date will simply synchronize the local system's time to an NTP server. SMTP is Simple Mail Transport Protocol, and it's used to send email on the internet. It's a very common protocol in use, if not the most highly used protocol on the internet just after HTTP. SMTP has this concept of verbs, which are commands that are used to do an action. And there's a couple different verbs that you can use to enumerate: expand, verify, as well as setting the receipt of an email header. If you telnet to a mail server on port 25, you can actually type commands to it and ask it questions, such as if you do expn or expand and provide it with an email address, it will let you know if that's a valid email address, just like verify will do. However, the majority of mail servers today, out of the box, meaning as soon as you install them, will disable those verbs expand and verify. Receipt 2 is not going to be disabled because that's a required header value when sending an email. The difference being that new mail servers that are installed will most likely not give you an error if you type in an invalid email address. Back in the day, if you were to type in receipt to jane@company.com and that user didn't exist, it would let you know. So it would be possible to enumerate users simply by brute forcing the receipt to header of SNMP. So if you do come across an older SMTP server, it's possible that these commands will be available and work for you. So try it out. This command, NetScan Tools Pro, provides some SMTP enumeration functions that can help you gather information in an automated fashion. Next up, domain name system used for resolving names to IP addresses around the internet. Runs on UDP port 53. DNS zone transfer is a concept of synchronizing a DNS zone file amongst DNS peers, if you will. However, it can be used to gather information about a target, provided the DNS server will allow you to do a zone transfer. Just like SMTP, most DNS servers deny zone transfer unless explicitly permitted. Here's an example of me attempting a zone transfer. Like I said, most modern DNS server packages are going to deny a zone transfer straight out of the box until you go in and say, I want to allow a zone transfer from host X. So here's me trying to do a zone transfer on asdf.com. The ls-d command followed by the domain on older DNS servers will dump the entire zone file out to you. This is running on Windows. Here's an example of doing it on Linux with dig. You can run dig, axfr, and the @inserver2.apple.com is the name server or the authoritative name server for apple.com. So I'm sending my zone transfer request directly to Apple's authoritative name server, and you can see that they denied my request. So what can we do about protecting ourselves against enumeration or from enumeration? When it comes to email, I touched on the fact that modern email servers will silently ignore unknown recipients. If you are running some older software, take a look at configuration options to silently ignore, as well as disable those verbs that can reveal information, such as verify or expand. Disable relay for other domains. Again, newer software packages won't do this out of the box, but older software would, in that you could send a message to an SMTP server and say, deliver this message to this other SMTP server. Open relays, if you search Google for open SMTP relay, you'll find quite a few hits of directories, and those are the hosts that are accepting and relaying spam from the spammers that are out there. When it comes to LDAP, authenticate queries to only domain users. So if a query is coming in, it should be from a known, valid, authenticated user. Use secure LDAP and disable file and printer sharing. Newer versions of Windows have this concept of network locations, home, public, and you can change based on network location whether or not file and printer sharing is enabled. So take a look at if you're in an enterprise and have some control over group policy, see what you can do about enabling, disabling file and printer sharing using group policy when at work or not. For DNS, disable zone transfer if it's not already done. Just make sure that it is. Use split DNS. I touched on this in a previous lesson, but the concept here is you have a DNS server that's available to the public internet and then one on the inside. The internal DNS is for resolving internal names to internal IP addresses, and the external is for resolving your publicly accessible information. When you go to, say, GoDaddy and you register your famous.com, don't use a personal name in there, because that's just another method of getting information for footprinting. Use some sort of support email address, such as abuse@famous.com. For SNMP, just like ICMP, there could be arguments on both sides of the fence as to whether or not SNMP use should be allowed. I'm on the side of the fence that says absolutely, simply because the amount of information that it provides. However, some recommendations: use version 3 with encryption and authentication, change from public and private community strings. Whatever you've installed, if it doesn't need to run SNMP and it is, then turn it off. So wrapping up our enumeration lesson, we'll take a look at real-world application and using enumeration in pen testing. Again, I'm going to keep saying it, get approval before you do any of this stuff. Get the IP address range of your target through one of those regional registrars such as ARIN or LACNIC. Scan the host using ping, make sure they're alive. Do a port scan to find out which ports are listening, and then try to do some enumeration. In the case of DNS, try to do a zone transfer. With NetBIOS, there's several different tools available such as SuperScan, HyenaScan. Also, you need to be aware that if there's a firewall in front of these Windows hosts, or there's no way to directly access these Windows hosts, then it's going to be pretty difficult to enumerate NetBIOS. So having a host on the inside that's already compromised to jump off from to try to gather NetBIOS information is extremely helpful. So you might need to do a little bit of work to get into the network before you try to enumerate NetBIOS. SNMP, that protocol that's available on the majority of routers and switches in the network, can provide a lot of good information, so try to walk the devices. And there's a possibility that they haven't restricted the SNMP polling from the internet. So give it a shot and see what kind of information you can get. When it comes to enumerating Linux hosts, take a look at enum for Linux. It'll run through those commands. It'll try to get access to Samba servers and get network shares as well as security identifiers. With LDAP, we have Softera LDAP Administrator. If you can get access to the entire directory, then you have a whole bunch of information you can use. You have all the names, email addresses, phone numbers of the entire organization. A lot of good information in LDAP. With NTP, it really just comes down to, can you get the time? Which you could look at your phone for that, but it can also be used to find out which peers are connected, which could possibly tell you an IP address of an internal host. With SMTP, going back to what I said a few slides ago, it's kind of difficult to get information from SMTP these days because they disable those verbs. However, give it a shot, you might be surprised. And finally, put it all in a document, make some recommendations, and provide that back to management.
Welcome to Lesson 6, System Hacking. With the information gathered in the enumeration phase, we can actually attack the system. We'll be covering password cracking, Microsoft authentication, privilege escalation, alternate data streams, rootkits, and much more. In this next section, we'll discuss hacking methodology. And this will be the process in which someone will attack your system to gain access to it, as well as what happens after they attack the system, what type of actions they're going to take. So the first step to hacking methodologies is called footprinting. Footprinting is a process of getting some basic information about a system. This will include what type of machines are available on the system, the IP address of the machine, some basic information about what the systems have on them as well. The next process goes a little bit more in detail, and this is where we do some scanning processes. Scanning will include things like determining specifically what ports are open on the system, what types of services are running, possibly finding out what kind of operating system is available as well. Once that's done, we'll go through a process called enumeration. With enumeration, we'll get more information about specifically the types of programs that are running on the system. We may get some information about user account data and information like that as well. And the next step after that is when we gain access to the system. The idea behind this is now that we've gathered all this information, we should have a good idea what types of vulnerabilities are on that system and how we can gain access. After we've gained access to the system, the next thing we want to do is escalate privileges. Now, the purpose behind this is typically when an attacker gains access to a system, they don't gain access to a system using an account that has a lot of power or features or capabilities. So what they want to do is escalate to a higher level account. This would be something like the root account on Linux or Unix, or Microsoft Windows, the admin account, or any type of account that has some administrative privileges. After this, they want to execute applications. This is when we take the different types of programs that we want to put on the system that will provide us more access, or maybe possibly delete data on the system, or whatever type of action we want to take now that we have full access to that system. In the next step, we want to hide files. Now, the point behind this is that once the system's been compromised, there'll be sensitive data that has been gained. Might be something like user account information, passwords, other things like that. And we want to be able to take that information and store it somewhere. There are several different techniques we can use to hide that data, either within files or other techniques. So that would be the next step that we take. And the last step in hacking methodology is to cover the tracks. Now, this may sound a lot like hiding files, but remember, the idea behind hiding files is to take the sensitive data and just make it so it's hidden where no one else can see it, and we can go back and see it later on. But covering tracks is the process of making it appear as though the system was never compromised in the first place. So we'll use techniques to do things like deleting log files and other things like that in order to make it appear that the system hasn't been compromised. And that's an example of how we do hacking methodology.
Hi, this is Nick. I'm going to give a demonstration of using oafcrack to crack Windows passwords. Here I have VirtualBox running with 3 Windows virtual machines, Windows XP, Windows 7, and Windows 10. I'm going to do XP and 7 at the same time, and then we'll talk about Windows 10. So let me go ahead and start up Windows XP as well as Windows 7. So this is a fresh install of Windows XP and a fresh install of Windows 7. You go ahead and log into Windows XP and Windows 7. Let's take a look at the users on each of them. There's only one account created in XP, that's the Nick account, And XP has an administrator account as well that you configure whenever you install the operating system. And over here on Windows 7, I have the same Nick account, who's an administrator of the local machine. So oafcrack is an application that can be used to grab the hashes from the SAM database on the system and then try to brute force them. Oafcrack has an option to run as a live CD, and that's what I'm going to be demonstrating here. It also comes installed with Kali Linux. So if you boot up a Kali Linux live CD on a Windows machine, then you can get access to those files. So let's take a look at cracking the XP password first. I'm going to go ahead and shut this machine down. And I'll shut down Windows 7 while I'm at it. Now I'm going to configure the Windows XP virtual machine to boot from a CD. This is the oafcrack live CD. Turn that back on. And we will do automatic boot. That's where it will probe for hardware devices and load the appropriate drivers. Now while this is booting up, let me discuss the tables. So oafcrack relies on tables to do its brute force attack on those password hashes. The oafcrack live CD does not come with those tables. So I have a web server running on this computer that's serving the two tables. There's several tables for Windows XP and several tables for Windows Vista. If you hop on Google, then you can search for oafcrack tables. And here you can download the various tables. You'll need to get these files into the machine, and you can do that with USB. That's the traditional method. Here I'm going to be copying them over the network. So I have the two table files here, and we're starting with Windows XP. So we can see that oafcrack is booted up, and it went ahead and mounted the Windows disk and pulled in the information from the SAM database. First thing I'm going to do is delete the accounts I don't care about. I care about administrator and Nick. And when it first started up, it actually did try to brute force these with some built-in algorithms, but it failed to find the password. So I'm going to install the tables and then run it again. First thing I need to do is get those tables. On the correct port. My web server is running on port 8080. So this file is 353.7 megabytes. Have it downloaded. There it is. Let's unzip it. Several files are included, and the oafcrack application is able to read these files. Come back to the application, go to Tables, click on Install, open the directory where we put those files, and select Choose. Now we see that the table is green rather than red, and we can use that table. And then we hit crack, and it begins. So it found the Nick account as capital P password, and the administrator account is the same with a 0 instead of an O. So you can see it was very quick to get the job done. So these are the passwords for those two accounts. Then I could remove the disk, reboot, and log in as administrator and have access to the entire machine. Let's take a look at the same process on Windows 7. We will modify it to boot up from the CD. And we're up and running. I'll go ahead and delete the disabled accounts. It was executing its attack. All right. So Nick is the account that I care about. I need to load the tables first. Get a shell. Come back to oafcrack, click Install, open the directory where those files are, select Choose, hit OK, and then crack. The password here is the same, capital P password. It should pop up here in a second. There it is. So now we have this user Nick password, his password. So it works just great for XP and Windows 7. Like I said, this is also installed with Kali Linux. And let's take a look at Windows 10. For Windows 10, same situation, I have the Nick account. And I'm going to modify this to boot Kali. Actually, I already have it. So let's go ahead and boot this up. If you were to do it in Kali Linux, you would need to mount the disk. So this was a live Kali situation. you need to mount the disk where Windows is installed so that you can get access to those files. And I'll show you that here. Just going to change the resolution of the display so we can see more of it. Okay, so now we have Kali running here. From looking at the kernel boot messages, we can see that there's a disk available at SDA 1 and 2. If I run fdisk dev SDA and P for print, we can see that there's 2 NTFS partitions available, and one of them is very large. There's a good chance this is where Windows is installed. So let's go ahead and quit that, and we're going to mount dev SDA2 in the mount folder and go into mount, and here we see our files. So let's go into Windows System 32 config. So this is where the important files are. We have system and SAM, so system hive and SAM database. Now normally what you would do is run something like SAM dump to system and SAM and get some hashes. However, this isn't going to work. If you'll notice, all of the SIDs are the same for all of these accounts, and all of the hashes are the same. And what Windows 10 did was they switched to AES encryption for the passwords. So oafcrack doesn't work on Windows 10, but this would be the process to do it on Windows 7 or Windows XP. So if you run oafcrack, you can also point it directly to the location. So here is load encrypted SAM, and we will point it to that same location, Windows System 32 config, and hit open, and you'll see that same information. So the account names are there, but it's not going to be able to crack these because it doesn't actually know what the hash is. And the next step would be to load the table and then hit crack, but it doesn't work on Windows 10. So that's the process for Kali and the process for the oafcrack live CD to crack a Windows password.
In this next section, we'll talk about keyloggers and anti-keyloggers. So in this next part, we're going to talk about how keystroke logging works. And to begin with, we have our user, and the user is going to obviously want to put some input into the operating system, and they do so through a keyboard. And of course, the keyboard sends the information to the operating system. And there are 2 different types of keystroke logging that could take place. One is a hardware-based keystroke logging, and that would be something that was in between the keyboard and the operating system. And the other thing would be some kind of software-based keystroke logger. That would actually be on the operating system itself. So now let's talk about hardware keystroke loggers. There are 3 basic types of hardware keystroke loggers. One of those is a PC or BIOS hardware keystroke logger. So this is one that we have some type of device that's physically connected to or physically in the machine itself on the PC or in the BIOS itself. The second one is some kind of external keystroke logger. And the concept behind this is that in between the keyboard and the machine will have some type of device that will be plugged into that will actually log keystrokes. And the third type is actually a keyboard that is designed to log keystrokes. So let's just talk about in more specific types of keystroke loggers that are hardware-based keystroke loggers. The different types of interfaces you might have for a keyboard include a PS2 keyboard, also a USB keyboard. One that's a little bit more interesting is called an acoustic technique. In this case, basically what happens is the keystrokes themselves make a certain noise whenever they're pressed on the keyboard, and someone who's really in tune with how different keystrokes sound can listen to those and determine what types of keys were pressed. Another popular technique of keystroke logging is to use a camera. So the camera will be placed right on the keyboard, probably hidden somewhere, and the viewer can actually see what keys are struck on the keyboard. 2 more techniques, a Bluetooth method where the keystrokes are captured through a Bluetooth keyboard, or if we have a wireless keyboard, then it's going to be connected through the Wi-Fi. Now, as far as defending against key loggers that are hardware-based, first thing you want to do is make sure the machines are physically secure. The idea behind this is that if someone can't get to your machine, then they can't install a hardware keystroke logger. They can't put a video in the room. They can't put a device in between the keyboard and the machine itself, and they can't physically open up the machine and add a keystroke logger in there. Also, you want to make sure you regularly check your hardware. So maybe you're not able to physically secure your system 100%. So make sure you look at that interface between the keyboard and the system on a regular basis. On systems where security is really important, you may want to occasionally open up the system, make sure there's been no additional hardware added internally as well. You can also encrypt keyboard input. So that way, if you do have a hardware keyboard logger, that won't record the information properly. And you can also use anti-logger programs as well. Now, software keystroke loggers can be used too. The idea behind this is some type of thing on the system, like an application is going to log keystrokes. In addition to application keyloggers, we can also have API-based keyloggers. They're more specific to a specific program. API stands for Application Programming Interface. And so this might be something for like a web browser, for instance, that is a program that's used by the web browser, and that can be used to log keystrokes as well. One of the more tricky ones to deal with is a kernel-based keystroke logger. So this is when the kernel itself has some type of software that's been added to it, like a kernel module or a kernel library, and it performs the keystroke logging. The reason why it's challenging to determine whether or not it's been used or not is it's not a separate program that's running, it's something that's embedded in the kernel itself. And that's very difficult to actually recognize. There's also memory injection keystroke loggers, where the keystroke loggers reside within RAM itself. Hypervisor keystroke loggers are anything that you have for virtual machines. So for example, let's say you have a virtual machine like Oracle VirtualBox. There may be something that Oracle VirtualBox's hypervisor, and that's a software program that interacts with the host OS and the virtual machine. That hypervisor may actually have a keystroke logger embedded into it. So it wouldn't necessarily recognize all the keystrokes that are typed on the system, like the host keystrokes, but anything that's done inside the hypervisor could be recognized and stored. Next, we have something called packet analyzers. The idea behind packet analyzers is that whenever you go to a website and you do a post request, so for example, maybe you type in a username and a password, packet analyzers can trap that information and capture the keystrokes of what you typed. And very similar to that, we have something called form grabbing keystroke loggers. The idea behind this is that whenever you go to a website and there's a form to fill out, whether it's a post request or not, it can actually capture whatever you type inside the form itself. If you want to defend yourself against software-based keystroke loggers, you may want to consider some type of scanning utility that scans inbound data. You also might want to make use of on-screen keyboards, because on-screen keyboards wouldn't use necessarily the software type of techniques to grab keyboard data that's coming from the keyboard itself. In addition to that, you may also want to use other techniques to input data in the system. Some good examples are any type of speech recognition program. In addition to that, you may want to use something that's like a macro-driven program. So when you type one key on your keyboard, it actually expands to multiple keys. And there's also things like handwriting recognition programs as well. Another technique we can use is keystroke interference software. Now, the idea behind this is that when you type in keys on your keyboard, the software program will add some additional random keys. So that's designed to obfuscate or to confuse someone that's trying to read the data that's been provided. And that might be good things for things like confusing what type of password's been typed, but all it really does is add more data. The software is still logging the keystrokes. It's just adding some additional data in between the keys as well. So someone that's actually looking at that data may be able to figure out things like usernames or other data as well. You can also install an intrusion detection software program. Use autofill programs. You may have seen these before when you go to a website. Instead of actually typing your information, like your username and password, you can have your web browser autofill that information. Therefore, there's no keystrokes being typed, and there's no way that a keystroke logger can grab that information. And last thing to point out here is be careful with any kind of email that you utilize. Email is really a common way for attackers to send you keystroke logging software that would be installed on your system. The last thing we'll talk about are anti-key loggers. These are software programs that are designed to prevent software key logging from occurring. They don't really help out so much for hardware key logging. That's actually going to require you to actually make sure that there's no additional hardware added to your system. But these are good for software key logging techniques. One thing I like to point out whenever I go through the different programs that you can utilize throughout these video training course is that there's more than what I present. So just keep in mind that you may want to do some research and find out additional software programs. The ones I show you are the ones that I consider to be the most popular and most useful, but definitely for the Certified Ethical Hacker exam, make sure you explore and find some other ones that are available as well. You don't necessarily have to know how to use each one of them, but you should be aware which ones exist. So some examples are Co-Defender, Guardian ID, Privacy Keyboard, Key Scrambler, Anti-Keylogger, and Spy Shelter. So that concludes our discussion on keyloggers. In this next lesson, we'll talk about Microsoft authentication. So we're going to focus on how the authentication process works and where there might be some security holes as well. So the first thing to point out here is for local authentication, the credentials are stored in something called the SAM. That's the Security Account Manager. For network-based authentication, they're stored in the Active Directory database. There are a couple different types of authentication methods. One is called the NTLM. That's the New Technology LAN Manager. There's also an authentication technique called Kerberos. And we'll see both these in more detail throughout the rest of the presentation. So let's first talk about SAM. So SAM uses a local database. It's stored in the Windows/System32/config/SAM directory. It's also available through a registration key, hkey_local_machine/SAM. What's important to understand, though, is that this information, this database, is not available directly when the system's booted up. It means that while the operating system can access that information, you can't view the information, which is really important because if someone can view that data, it might be a way of actually attacking the system and determining what kind of passwords users might have. It's also important to realize that in Microsoft Windows, all the passwords are hashed, which means they've been encrypted. Here's an example of what you might see in that database if you could access it. I should point out that this information is available offline. So for instance, if you boot off of a Linux boot disk and then access the hard drive, you could see this information. You could see what's inside this file. So an example of an entry in the file would include the username, which is the administrator that you see on the line, the user ID number, which is 500 in this case. And there's two sections for passwords. We talked about the fact that there is a LM hash password. That's where you say no password followed by a bunch of asterisks. And there's also a NTLM encrypted password. And again, that's the one that's used in Microsoft Windows on modern versions. Older versions use the LM encrypted password, but unfortunately, it's very easy to decrypt that using a brute force attack. So modern Windows systems don't use that. It just shows up inside of the database, but it should say no password followed by a bunch of asterisk characters. So what you see in that bluish color or the green color is the NTLM encrypted password. So let's talk about NTLM just for a moment here. It is what we refer to as a challenge response type password, often used when the host is not part of a domain, so we can't connect to a domain manager and be authenticated using a domain manager. We have to use a local account system instead. There are two different protocols that could be used. One is NTLM authentication protocol, and the other one is the LM authentication protocol. As I mentioned before, the LM authentication protocol is not used on modern Windows systems any longer. So let's talk more about how this authentication process works. So we have a client and a server machine, and the client wants to be able to authenticate on the server. So the first thing that happens is the Windows user provides a username, a password, and a domain. Then it sends the username in plain text format over to the server. The server uses that information to determine how to encrypt a random bit of data, a 16-bit random bit of data. It encrypts that information and sends it back over to the client machine. This is referred to as the challenge or annoyance. The client then decrypts that using the password the client has provided with the step here, and then takes that information that gets encrypted and sends it back. It's called a response. So the next thing that has to happen is that has to be converted to something that gets sent to a domain controller. So the username that was provided by the client, the challenge that was provided by the server, and the response that was provided by the client Those are all sent to the domain controller. It encrypts the challenge using the password that's on the domain controller for that username. And then it compares that after it decrypts it with a response. And if those things match up, then the client is authorized to access the server. So let's talk about Kerberos, because Kerberos is going to be in a network environment the most common way that you're going to authenticate users. So with Kerberos, it's the default authentication method, unless, of course, you don't have a network-based environment. It's a component of Active Directory. So Microsoft's Windows Active Directory is a database type environment that also allows for authentication too. It uses something called a ticket-based authorization of services. And we're going to talk more about ticket-based in a few minutes here, but the idea is that your Active Directory server will make use of these tickets that are provided by the Kerberos server. It communicates in port 88, and that's important for security purposes because if you've got firewalls in your environment, you may have to make sure port 88 is open so that the Kerberos environment can actually work. So in this environment, we make use of something called domain controller. The information for the account is stored in Active Directory, and then Kerberos's KDC, or Key Distribution Center, is used to authenticate the user. It also grants these things called tickets. So you often will see with Kerberos something called a ticket granting service, or TGS. Now the way this works is when a client utility wants to authenticate on a server, the first thing that happens is a request from the KDC server the authentication. So it asks for the KDC server to authenticate it. And once that's happened, the access is being granted for the client. But that doesn't actually provide any access to a service. So in order to access a service, we have to request a ticket. So a ticket would be like if you were to go to a movie and you have to actually have a ticket to get into the movie. So in this case, we need a ticket to get into that particular service or that server that we want to connect to. So once we get that ticket from the KDC server, because we've been previously authenticated, we can take that ticket and give it to the service. So whatever machine I'm trying to connect to and log into, we'll provide that ticket to that machine. And then what happens is that server will validate the ticket. So when the server gets the ticket validated, then the access is granted to the client. So that's how authentication works in a Microsoft Windows environment. In this next lesson, we'll talk about how you could defend against password cracking. So first thing that you want to do is have some good password policies. And a lot of these are probably pretty straightforward and fairly common sense, but you want to consider making sure that everyone in your organization makes use of these password policies. One is to use different passwords for different situations. Now what that means is if you have a login for your internal company, but you also have a login for Facebook, don't use the same password in both locations. Don't use the same password for your different bank accounts. If you use the same password for all those environments, then if someone finds out what that one password is, then you're completely vulnerable across the board. You also want to have some kind of password changing policy. So on a regular basis, make sure the passwords are changed. I point out this is actually something that you normally see in corporate environments quite a bit. People need to change their password every 90 days or so. But I recommend that you make a password changing policy for yourself as well. So make sure you change all of your really sensitive data passwords like your bank accounts, your credit card accounts, your social media logins like Facebook and Twitter. Make sure you do that on a regular basis. I know a lot of people don't do that because they're not required to, but once again, once one of those is compromised, that might compromise other ones as well. Obviously, don't share your password. Make sure you use a complicated password. Most environments nowadays require to use numbers and symbols, but it's best to use multiple symbols, multiple numbers, special characters, not just alphanumeric characters. Also want to make sure you use cap and lowercase combination letters as well in your password. Definitely avoid personal data. One of the things we'll talk about in a later video is social engineering hacks. And the idea behind that is just trying to get information from a user to try to determine what their password might be. So don't use things like your dog's name, your wife's name, your husband's name. Your social security number would be a really bad idea as well. Don't use information like your favorite color, what kind of car you drive, where you grew up, your best friend, any of that kind of stuff you don't want to use when you create a password. You also want to avoid system default passwords. A good example of this is a lot of the routers out there come with a built-in password. So like, for example, the account name for that router might be admin, the password might be admin PW. And a lot of people forget to change that to something else. So the problem with that is that information is very easy to determine. Most of the time, the router documentation has the username and password, or you can just do a simple Google search to figure out what that is. And so what happens is you might have your own personal router at home, and that router can be compromised. And once that's compromised, then things like packet sniffing can be done on the router so the attacker can see what's going on as far as your network traffic is concerned, and other information can be gleaned as well. And lastly, don't use any dictionary-based passwords. Now, as far as service policies are concerned, you want to make sure that you monitor logs. So make sure you're looking at the logs on a regular basis to see if there's any kind of unusual activity. In fact, you probably want to make use of some kind of program that monitors the logs for you and then alerts you automatically when something suspicious occurs. You also want to avoid any kind of application that stores passwords. Whenever possible, try to make use of the password that's available on your operating system. That's typically more secure. Each time you have an application that stores passwords, that's another point of vulnerability. If you do have applications that have to store passwords, and a good example would be like maybe your web browser has its own passwords, make sure the passwords are stored at a secure location, so a secure database or some other location. Perform routine audits to make sure that there's nothing wrong as far as your system security is concerned. Make sure you only use encrypted protocols. There are still some systems out there that use plain text passwords. Those are extremely easy for a hacker to connect to and to break, so make sure you use some kind of encrypted policy. Also want to make use of something called SALT. So the idea of SALT is to enhance the encryption by introducing some random data into the password before it encrypts the information. This makes it more difficult for someone to use something referred to as a rainbow table, which is a form of a brute force attack. The idea behind a rainbow table is that someone's taken the time to take all the possible passwords and all the possible encrypted versions of them, and then based upon that, they are able to determine what kind of password you have by just a brute force attack. By using SALT, it makes it a lot more difficult because the resulting encrypted password will be different depending upon the SALT value being used. We'll see an example in more detail about how SALT works in just a few moments. The last thing to do is make use of something called syskey. So syskey is a Microsoft Windows feature that's part of the SAM database. And what it does is it makes use of a 128-bit encryption key. That 128-bit encryption key could also be used as part of the authentication method. So when the user logs in, not only do they provide their username and password, but also that encryption key as well. That makes it a lot more difficult for someone to hack into an account because they need yet one more bit of information. The idea behind this was introduced in Windows NT 4.0, and it is a good extra level of security. However, recently, folks have been using this as a method of attacking a system through a process called ransomware. So you may have seen ransomware before. This is when you download a program accidentally or you click on a link, it installs some kind of malware on your system, and that malware locks you out essentially. You get some kind of message on your screen saying that something like your FBI has locked your machine because of suspicious activity, and then they have a link to go pay to get back into your machine again. So one of the techniques they use is this syskey by actually making use of that 128-bit key. If you don't know what that key is, then they can lock you out of your system. So that's one of the problems of using the syskey feature. So let's talk more about how SALT works. To begin with, here we have a password provided by the user. I know it's too simple. We've got a password here, ABC123, just for this demonstration. And then what happens before it gets converted into a hash password by a hash algorithm, the system will add a random bit of data. In this case right here, let's assume that data is 456. Then this is what gets hashed. So the hash algorithm creates a hash password based upon that. The SALT gets stored in the database because in the future, when we have to compare the passwords, it's going to have to decrypt the password the user provides at login and compare that with the result that we got back from the hash algorithm. So in this case right here, that gets stored in the password database and including the hash password as well. So in this next section, we're going to talk about escalating your privilege. So the idea behind escalation is that when an attacker first tries to hack into a system, they know they normally can't log in through a privileged account like the root account on Linux or Unix or the administrator account in Microsoft Windows. So what they'll try to do is focus on regular user accounts, which we refer to as non-privileged accounts. Those accounts typically have weaker passwords and other vulnerabilities that privileged accounts don't have. Then once the attacker has access to those non-privileged accounts, they'll use that as a launch pad to gain access to other user accounts. So other user accounts, like I said, could be either regular user accounts or also administrative accounts. In fact, there's two different types of escalation type attacks. One is referred to as horizontal. And in this case, we would try to access another regular user account. The point behind that is that an attacker may initially be able to get into, like say, the user account for the user Sue, and then he discovers that possibly another user, like the user Bob, is going to be easier to get authentication to a higher level account. Like for example, in the Linux environment, there's a process called sudo. And with sudo, what you can do is type in the command sudo followed by a command and have that command run as the root account or the administrator on the system. And this is done by setting up something called the etc sudoers file. On Linux systems, this is done on an account-by-account basis. So again, that Bob account may have sudo access, but the Sue account doesn't. So gaining access to different regular user accounts can be advantageous. And then, of course, the goal here is for vertical escalation, which means we are going to try to get access to a root account or to an admin account. So different types of tactics that could be used to escalate. One is called an app init DLL. So in the Microsoft environment, there are certain types of DLLs that are automatically executed whenever an application starts up. A good example of this is one called the user32.dll. So it's referred to as an app init DLL because when the application initializes, that DLL is executed. So that's actually a really good place to put some kind of malware that would escalate the privileges of user to someone that's not the regular user. There's also something called accessibility features. The accessibility features are a pre-login feature that you see in Microsoft Windows particularly, where you could do things like bring up an on-screen keyboard or see the date and time on the system. These accessibility features could be used to open up like a command prompt and escalate to a higher level of privilege. There's also something called Windows User Access Control, and the idea behind this is you may have seen before when you run some kind of program and it says that that program needs administrative access. By bypassing that user access control feature, someone can actually run a program as an administrator. We also have this idea called DLL injection. This is any time that we put some code inside of a DLL that would result in authenticating the privileges of a regular user account. And then software vulnerabilities exist as well. Make sure you keep your software up to date to avoid any kind of escalation issues regarding software vulnerabilities. There are several different tools that you can use out there for escalation. Again, keep in mind that there are a lot more tools than I talk about in this session. This is just a review of some of the tools that are available. For the exam, you want to probably put together a list of all the tools that are available. Some of the tools that you may want to know about: the Stellar Phoenix Windows Pass Recovery Tool is all designed about recovering passwords and hacking into systems. The Lazy Soft Recovery Suite's got the same kind of capabilities. Pinterest Monkey is actually a tool that lets you do several different types of penetration type features, but one of the things it can do is escalate privileges as well. Password Elastic is very similar to the Stellar Phoenix Pass Recovery Tool and Lazy Soft. It actually allows you to access user accounts and compromise the passwords. Same with the Windows Password Rescue Personal. So the Trinity Rescue Kit is a little bit different than the other ones we've seen so far. With this one, what you do is you put an operating system on a removable device like a CD-ROM or a USB drive. You boot off that, and then you can access your hard drive and manipulate Microsoft Windows environment. It's actually used as a technique to fix problems on a Windows-based platform, including recovering the administrative password, but it can also be used as a hacking tool as well. ORFcrack is a Windows password cracking program. It makes use of brute force attacks using rainbow tables. The offline NT password and registry editor is again another tool that allows you to access the password database and make changes to it. Comboot is another password recovery tool. So is the Windows Password Recovery Tool. LPC is also another technique that's very similar to the ORF crack. It does brute force attacking on passwords. And also we have eComSoft's system recovery. This is actually an all-in-one kind of security tool, and it has a variety of different ways of trying to recover a Windows-based system, but again, it can be used for hacking techniques. Next, let's talk about how DLL hijacking works. So we have this user, this innocent user, who's installed some software that unfortunately has replaced the real DLL, the dynamic link library, with a malicious DLL. So when they run the application, that application normally will access the real DLL, but in this case right here, now it's pointed to the mal DLL instead. And that software that was provided by that evil attacker off in the corner there, once that happens, the mal DLL connects to the evil attacker and allows the evil attacker to access the operating system. Let's talk now how we can defend against escalation attacks. One technique here is to always make sure we encrypt data whenever possible. That includes the user password. We also want to limit any type of administrative-based software program. So make sure any software program that you utilizes doesn't require administrative access unless it really needs to have administrative access. On a regular basis, you don't want to log in as an admin account. So if you're working on Linux or Unix, don't log in as root on a regular basis. Log in as a regular user. And then just switch to a root account when you want to perform some kind of sysadmin privilege. Or on a Windows-based system, just log in as a regular user unless you need to perform some administrative tasks. It also helps if you use some kind of multi-factor authentication method. We kind of talked about this on a previous video where we can make use of a system where a user specifies a username, password, and an encryption key in order to be able to log into a system. Make sure you keep all your software up to date. Recall that one of the vulnerabilities that we might have is when certain applications allow for escalation because of some kind of vulnerability that the application has. So for software developers, another thing that you may want to consider is using something called privilege separation methodology. The idea being is that when a software program runs, it may at some point need to have administrative access, but other times it doesn't need that. So what you can do is have some of the code run with regular user access, and then occasionally have part of that software use administrative rights. But when we don't need administrative rights anymore, it goes back to using regular user account rights instead. Always make sure you keep up with security alerts. That would help whenever you find that your application that you have has some kind of software vulnerability. And also restrict interactive login. In this next lesson, we'll talk about executing applications. So remember, this is a step after we've escalated and we now have some type of administrative access to the system. And we want to execute some kind of malicious application, some kind of malware that we want to run on the system. One thing that's really important to realize is typically these are executed remotely. So once we have compromised the system, we should be able to access that remotely, perform some kind of process to run some kind of programs. And these programs are designed to do several different types of things. One thing you could do is gather some more information, which we normally refer to as spyware. We'll talk more about spyware here in a couple slides. It might be used also to create more backdoors. The idea behind a backdoor is that once we've created one hole into the system, we want to be able to make some additional holes in the system so we can get back into it easier later on. We might also launch additional attacks on other systems as well. So the first thing we're going to talk about here are execution tools. These are software programs that you can utilize as an attacker once you've compromised the system in order to be able to perform some type of execution programs. And the first one we'll look at is called psexec. Now the purpose behind this one is it provides a replacement for your typical telnet program that allows IT professionals the ability to access a remote system and perform tasks on it. Another one's really popular and a tool that's used not only for hacking purposes, but for legitimate purposes by IT admins is PDQ deploy. This allows you to add software to the system and deploy patches fairly easily as well. So it's a really good way for attackers to add more software to the system and even patch things with security holes purposely intended for making holes or backdoors into your system. Another similar tool to psexec is called remoteexec. This tool allows you to remotely execute code on the system. And lastly, a tool that's somewhat similar to PDQ deploy is called dameware. Now remember that one of the things that these execution programs will do is introduce spyware. So you should be aware of some of the sources of spyware. Not only can you get them from someone who's placed them directly on your system because they've elevated their access to an admin, but in addition to that, you can download them accidentally yourself. For example, they could come from browser cookies or browser add-ons. Other browser vulnerabilities are quite often used for spyware sources as well. It could be something that you downloaded on your system. You might get an email attachment or a link that would actually end up downloading some spyware. And quite often they masquerade as other software as well. Not only could they masquerade as for other software, but they could also be included in other software. So it might be a process called piggybacking, where you download some valid software, but in that software are some spyware programs as well. So different types of spyware types. This is actually how it's going to record information for your system. One is a video-based spyware. This is where it hooks into your webcam and without your knowledge can actually start recording what you're doing on your system. It can view you and other things around you as well. A very similar technique is audio, where it hooks into your microphone and starts recording the sounds around you. Another tricky one is a USB spyware. Now, you might have gone to a trade show before and then got some information from a vendor on a USB stick. That USB stick, when you insert it into your computer, may launch a program automatically. Unfortunately, that program may have spyware enabled to it. Maybe not necessarily from the vendor at the conference, but you may get this USB key through the mail or some other resource as well. In addition to that, you'll see it's becoming more and more prevalent to see cell phone spyware types and also even GPS spyware types as well. GPS spyware types keep track of where you are, while cell phone spywares are ones that actually keep track of what you do on your cell phone. Now, as far as the spyware defense is concerned, first thing you want to do is make sure you use some kind of trusted anti-spyware application. You also want to be careful whenever you download stuff on the internet. Make sure you're going to the right location, downloading the right software. Also, web browsers have different levels of security. So if you go to preferences in your web browser, you should have different levels of security. And typically they're called like low, medium, high. Look at each one to find out which one has the highest level of security but still gives you the most usability for your particular browser. Definitely always avoid opening email attachments. If you're like me, you probably get tons of spam email, and sometimes it looks like really valid information, but any type of attachment you get from someone that you don't know, don't ever open it. Also, avoid running any kind of application as the administrator. Typically, spyware software prefers you to run as administrator because it has more access to the system and can compromise it better. And also disable auto run. So again, when you plug a USB disk into your drive, you don't want to launch applications automatically. There's a feature in operating systems to disable the auto load feature. And then lastly, try to make use of a firewall. Firewalls that inspect not only the data packet, but the contents of the data can be used to determine whether or not you have some spyware information coming into your system. So in this next lesson, we'll talk about rootkits and how you can protect yourself by using anti-rootkits. So first, let's talk about the purpose of a rootkit. And this is going to be a software-based program that handles several different types of things. First of all, it'll allow you to gain access to an account with administrative privilege access through a backdoor. It'll also be designed to further compromise your system by gathering additional sensitive data. It can also monitor network traffic. And rootkits are also designed to conceal hacker activity. That includes concealing additional software that you may install on your system, some additional malware, for example. And also rootkits can be used to launch attacks on other hosts. So they're very commonly used after a system's been compromised or even in the process of compromising the system in order to be able to perform tasks on that system. So let's talk about how rootkits work, or at least one component of how they work. So typically what happens is you have some kind of application code and that'll try to access some file contents. If a rootkit has established itself on the system and has compromised the file contents, what really happens is the application code will try to access the file contents, but the rootkit takes over that process. And instead of performing whatever action it's supposed to take, it performs whatever the rootkit wants it to do. And then to make it so it doesn't seem like there's anything on the system amiss, it goes back to the file contents, which returns back to the application code. All right, so some typical rootkit actions One thing a rootkit might be used for is either a denial of service attack or a distributed denial of service attack. Again, they might be also used to create backdoors in your system. They might also be used for a remote system probe for packet sniffing, so you can look at the network packets on your system and see what's going on. And also they can be used to delete logs so we can cover tracks. There are several different types of rootkit software programs that you should be aware of. One of them, and probably the least often used one, is called the user mode. IT environment, the user mode is any type of application that runs as a non-privileged or non-system type of account. So we refer to this as application level as well. Typically, rootkits don't run at the user mode very often simply because they just don't have a lot of access to the system. There's not a lot they can do. For example, things like sniffing the network normally requires administrator rights. More common and more dangerous are kernel mode rootkits. The idea behind a kernel mode rootkit is the kernel itself is where the rootkit software is installed as a kernel module or a kernel library. And that'll allow a lot more access to the system and allow the rootkit to do a lot more harm. We also have system library rootkits. So system library would be some type of program that gets called up in the course of running some kind of application. We also have rootkits called bootkit. So a bootkit rootkit is one in which the boot process itself is compromised. So the rootkit will be placed on something like the master boot record or the boot sector or the volume boot record. So this bootkit rootkit will be very difficult for a administrator to figure out that's on the system because of the fact that it's actually part of the boot process itself, not part of the operating system. In addition to this, as virtual machines become more and more popular, you'll start seeing more rootkits for the hypervisor. Remember, the hypervisor is the program that's used to communicate with the host OS and the virtual machine. And lastly, another one that's very difficult to pick up is the firmware or hardware rootkit. So for example, on your system, you have firmware software in your BIOS or other components of your hardware, and software can be installed on that. And those rootkits are very difficult to see because even a system probe of the operating system won't pick those up. Speaking of which, how are we going to detect rootkits? First of all, you don't ever want to trust a system that may be compromised. So you don't want to use any kind of tool or technique on that system to test to see if it has a rootkit. Remember that rootkits are designed not only to compromise the system, but also to hide the fact that the system has been compromised. So what happens is quite often rootkits are aware of different types of techniques to discover them, and they hide themselves from those techniques. So best thing to do is to use a third-party operating system, boot off of like a removable USB drive or CD-ROM that has maybe a Linux-based operating system or some other OS, and do rootkit detection from that instead. Also, it's a good idea to create a baseline for your system right after your install. So the baseline would consist of things about the files on the system, like for example, what type of software you have installed in the system, the checksums for individual files, the size of files, permissions on files, things like that. There's several different tools out there to let you create baselines for your system, and we can use that later to see if anything has been changed in your environment since the rootkit was installed. The other thing you may want to do is look for something called a hook function. So a hook function is something that shows up in your system call table, in which what will happen is instead of actually calling up the right function, it calls up a different function instead. So it hooks it away from the regular function and calls a different function. You also want to compare any executable program to older copies to make sure that they coincide, they're the same size, the checksum's the same, the permissions are the same, the ownership's the same, things like that. And then you also want to look for unusual behavior. So anything on the system that's kind of unusual, like a heavy amount of activity on your system, processes that are running that really shouldn't be running, things like that. You also want to watch any kind of outgoing network packets. One of the things that happens with rootkits is they do tend to send out information to the attacker, letting the attacker know what's going on in the system. By watching network packets, you can see that activity taking place. There are also ways to analyze the kernel memory dumps. So this again will be done through a third-party system. There are tools that will analyze the kernel and see what kind of software is in the kernel. So when the system gets shut down, the memory dump can be used to analyze what was on the system. You can also make use of rootkit detection software as well. So next thing we're going to talk about is rootkit defense. So first thing to point out, and this goes with any type of defense, always avoid untrusted downloads. Make sure you get your software from a trusted location. Also make sure you use firewalls, specifically a firewall that not only will look at the network packet information, but also the contents of the packet as well. Make sure you verify all software before installing it. A lot of software has checksums to make sure that the software is valid, so double check the checksum and make sure the software is actually coming from the right location. Only install software that's necessary for your system. Make sure you install software packages on a regular basis. And also make sure that when you choose an antivirus program, it includes protection from rootkits as well. And if you do use an antivirus program that has the rootkit feature, then make sure you keep that up to date on a regular basis. And lastly, and this goes with any type of software, always try to avoid running programs as the administrator. Last thing we're talking about here is rootkit recovery. So first thing to point out here is if you want to do rootkit recovery, you want to make sure you use an anti-rootkit tool and always run it from a trusted system, so don't run it on the system that might be compromised. You can also recover just by reinstalling the operating system if the problem actually is an operating system-based rootkit, so like a kernel-based rootkit or an application rootkit or a rootkit that's based upon some type of library. This won't really help out with hardware-based rootkits like firmware-based rootkits, but it does actually remove lots of rootkits that are based upon the operating system. You can also replace suspected hardware as well. And that will handle situations where the rootkit's been installed on the firmware, for example. In this next lesson, we're going to talk about NTFS stream manipulation. So first of all, let's talk about what this is all about. Typically, when you try to determine if a file has been compromised, there are two ways of doing that. One is to check to see if the contents of the file has changed. The other way is to see if the file attributes, also known as the metadata, has been changed. The attributes include things like the permissions in the file, the ownership of the file, things like that. So by looking at those attributes, we can determine whether or not a critical file has been changed. The attributes also include the file size. So if the file size has changed, then maybe the contents have changed as well. With NTFS, which stands for New Technology File System, Alternative Data Stream, we can make it so that a file contents is not changed directly, but instead we change the metadata through a process called forking. Now the problem with this is it doesn't show up when you look at the contents of the file or the metadata that there's been any changes. And the process of forking basically is, instead of running a process that you specify, we fork off or we send off to another process to run instead. So this way we can have a valid program run a malicious code instead. So it allows us for the injection of that malicious code. It's also fairly easy to create. There's a command called the type command in a Windows environment that lets you create these forking processes. It does require you to have administrative access, but it's also fairly easy to create. It's also very difficult to detect using standard tools. We have to use tools that are specifically designed for checking for NTFS alternative data streams. So let's talk more about this NTFS stream manipulation. The idea here is we want to make it so that a virus or some other kind of malware can be executed without the knowledge of the person who's executing it and make this hidden so it's not very easy to find. So we've got this malware, which I'm just going to refer to as ABC, and we have some file. It doesn't really matter what this file is. It could be a text document of some sort. But what we want to do is associate that malware with that file. And you can do that in Windows by using a command called type. You say type followed by the file, and then redirect that output into XYZ:ABC. So after we do this, we're going to replace a valid application like this calc program by using a command called mklink. So this will create an association between the calc program, essentially replacing the content that would normally be executed with the content that shows up inside of this file, which remember is now the malware program. So later on when we run the calc program, it doesn't run the regular calc program, it ends up running the malware instead. So if you think that a system has some files that have NTFS ADS, then there's several different ways you can recover these. One is to use a file integrity checker software program. Another technique is to make sure you have regular backups to replace any kind of corrupted files. Another great way of solving this problem is to move the files that have been corrupted to a FAT file system. The reason why NTFS ADS works is because the metadata on a NTFS file system allows for this forking process, but it's not allowed on a FAT file system. So for example, you have a USB thumb drive that has a FAT file system, simply moving the file from the NTFS file system over to the thumb drive and then moving it back again will remove that forking process. And then lastly, there are tools that are specifically designed to detect NTFS ADS. Some of those tools include Streams. There's another one called Stream Explorer. ADS Manager also can be used. ADS Scanner is another tool you can use. Hijack This also detects for NTFS ADS files. ADS Spy and Gamer. In this next lesson, we're going to talk about NTFS stream manipulation. So first of all, let's talk about what this is all about. Typically, when you try to determine if a file has been compromised, there are two ways of doing that. One is to check to see if the contents of the file has changed. The other way is to see if the file attributes, also known as the metadata, has been changed. The attributes include things like the permissions in the file, the ownership of the file, things like that. So by looking at those attributes, we can determine whether or not a critical file has been changed. The attributes also include this file size. So if the file size has changed, then maybe the contents have changed as well. With NTFS, which stands for New Technology File System, Alternative Data Stream, we can make it so that a file contents is not changed directly, but instead we change the metadata through a process called forking. Now the problem with this is it doesn't show up when you look at the contents of the file or the metadata that there's been any changes. And the process of forking basically is, instead of running a process that you specify, we fork off or we send off to another process to run instead. So this way we can have a valid program run a malicious code instead. So it allows us for the injection of that malicious code. It's also fairly easy to create. There's a command called the type command in a Windows environment that lets you create these forking processes. It does require you to have administrative access, but it's also fairly easy to create. It's also very difficult to detect using standard tools. We have to use tools that are specifically designed for checking for NTFS alternative data streams. So let's talk more about this NTFS stream manipulation. The idea here is we want to make it so that a virus or some other kind of malware can be executed without the knowledge of the person who's executing it and make this hidden so it's not very easy to find. So we've got this malware, which I'm just going to refer to as ABC, and we have some file. It doesn't really matter what this file is. It could be a text document of some sort. But what we want to do is associate that malware with that file. And you can do that in Windows by using a command called type. You say type followed by the file, and then redirect that output into XYZ:ABC. So after we do this, we're going to replace a valid application like this calc program by using a command called mklink. So this will create an association between the calc program, essentially replacing the content that would normally be executed with the content that shows up inside of this file, which remember is now the malware program. So later on when we run the calc program, it doesn't run the regular calc program, it ends up running the malware instead. So if you think that a system has some files that have NTFS ADS, then there's several different ways you can recover these. One is to use a file integrity checker software program. Another technique is to make sure you have regular backups to replace any kind of corrupted files. Another great way of solving this problem is to move the files that have been corrupted to a FAT file system. The reason why NTFS ADS works is because the metadata on a NTFS file system allows for this forking process, but it's not allowed on a FAT file system. So for example, you have a USB thumb drive that has a FAT file system, simply moving the file from the NTFS file system over to the thumb drive and then moving it back again will remove that forking process. And then lastly, there are tools that are specifically designed to detect NTFS ADS. Some of those tools include Streams. There's another one called Stream Explorer. ADS Manager also can be used. ADS Scanner is another tool you can use. Hijack This also detects for NTFS ADS files. ADS Spy and Gamer. In this next lesson, we'll talk about steganography and steganalysis methods. First of all, let's talk about steganography. This is the practice of hiding messages or information within other data. Remember we talked about before that once the system's been compromised and malware or software has been installed in the system, it starts gathering this information, and that data's got to be hidden somewhere. The reason why it's important to hide it is because the attacker won't make use of that data right away. We've got to store the information somewhere, and if it's in a really easy to find location like a plain text file, then anyone who discovers that the system's been compromised will delete that information. So by hiding it within other data, it means the data could still be there that's been compromised, and we can recover that data later on. So this other data is referred to as a cover medium. And the cover medium could be different types of things. So for example, it could be a simple text-based document, or it could be a graphic image. You can also hide things in audio files or video files. And there's a bunch of other ones we can utilize as well. In fact, let's talk about different types of steganography cover mediums. The first one that's really commonly used is an image. Now, the idea behind this is that we can make use of several different techniques, either a complicated algorithm, some kind of masking technique, or something called the least significant bit. That last one, by the way, least significant bit, is when we make use of the rightmost bit of a pixel for the image that will be used to store the information that we're trying to hide. There are a couple different tools that are commonly used for this. OpenStego is a really popular one, and GIF Shuffle is a popular one as well. Audio, it can also be used as a cover medium, and this one commonly is used by either the least significant bit, again, just like with an image, or by using inaudible frequencies. So frequencies that you and I can't hear, but a software program could actually understand. That way, any kind of audio file won't include the data that's being covered up, but you just hear the regular data instead. Couple tools you can use for this, BitCrypt and MP4 Stego are really popular. We can also store stuff in documents. Documents have this thing called metadata that contains information about the document. So for example, like a Microsoft Word document would have things like the author of the Microsoft Word document, when the document was last modified, and other bits of information as well. So we can store information in there. And so a couple tools you can utilize are WB Stego and TextHide. So let's talk about how document steganography works. So we have this file, like some file, Microsoft Word document, file.doc, and that file has file contents, but it also has metadata. Remember, the metadata is things like information about the file type, and things like that. So what Steno app does is it takes this data that we want to hide inside of the file.doc, and it places inside the metadata. So the end result is going to be that file.doc with the documentation data that you expect to see when you open up Microsoft Word. But also, in addition to that, it's going to hide that information inside of the metadata. It won't show up when you try to load up Microsoft Word, but using that Stego app, we can retrieve that information at some later time. Another technique we can utilize is white space. It's not a very common technique because there's not a lot of data that could be stored in there. If you've got a large chunk of data, images or audios are a better way to go. But white space actually makes use of white space at the end lines. That's things like spaces and tabs and things like that. So there's a tool called Snow that lets you create white space data in cover mediums. Another technique is video. So just like with audio and images, we can make use of video to hide things. A couple different techniques. One's called a discrete cosine transformation. That's actually when the image is transferred into its most element frequency components. We can also make use of image and audio techniques that we saw earlier as well. Common different tools for this are Steg Secret, OpenPuff, and Stego Stick. And another technique that we can utilize is hiding data inside of folder metadata. So just like with files, folders have this idea of metadata too. The metadata is information about the folder. which includes its permissions and other data as well. You can use a tool like Quick Crypto to store stuff inside of folder metadata. There are a few other cover mediums that you should be aware of as well. Sometimes people will use source code. That's the code for applications before it's been compiled into compile code. We can store things inside of email as a cover medium. DVD-ROMs have metadata and other techniques to store information that's not in a plain, easy-to-read file. We can store things on the web. Operating system has several different places where we can store data that's hidden to a normal media, and also social media techniques as well. Steg analysis is a process of discovering hidden messages and trying to find them. And it's actually kind of challenging because of the fact that you don't always know there's hidden messages in the first place. So trying to find something in a file or an audio image is kind of difficult if you're just guessing there might be something in there. It's typically done by using statistical analysis. And again, it might be difficult to figure that out because there may or may not have hidden data in that cover medium. Also, this idea of lossy compressed data poses a bit of a challenge as well. Lossy compressed data is when you have some type of audio or video file. In order to make it smaller and more compact, it compresses the information, but some information is lost as a result. Some of the information that's not quite as relevant and important gets lost. Things that you won't really notice when the file gets expanded again. You won't notice little gaps in the data or in the video itself. And that makes it really difficult to actually see if there's hidden stuff in there because, some of that stuff actually has been removed during the compression process. So the last thing to point out here are different types of Steg analysis tools that you might utilize. One's called Steg Detect. There's another good one called Steg Studio. You might want to use also Steg Spy, IMG Stego or Image Stego. And the last one we have is Steg Alicer SS. In this next section, we'll talk about how to cover your tracks. So first thing you want to consider doing is deleting log entries. You may also want to consider changing log entries. If you delete log entries, it may indicate that there is a problem in the system because there'll be gaps in the log entries. While changing log entries is going to be a little bit more difficult to determine that a hack took place. You can also disable auditing processing so that the typical auditing steps that take place in the system don't happen at all. And also you can clear command history. So first of all, some of the tactics you should be aware of is firstly, you should know where the log locations are. Windows-based systems, there's an event viewer. You can go edit log files there. And on Linux-based systems, the /var/log directory contains logging information. So to clear the root command history on Linux, the first thing you want to do is delete /root/.bash_history. When a user logs out of the system or closes out a shell in Linux, the .bash_history file is used to store all of the commands that were executed in that shell prior to closing the shell. So this is one way someone could look at if there was any kind of hacking activity that took place is by looking at that file, especially for the root user, which is the admin account on the system. The command we can use in this case here is called shred. It's a little more powerful than the rm command. Rm deletes the file links, but it doesn't actually delete the data itself, so that data could possibly be recovered. Shred actually will delete the links to the file after it overrides the data with other data instead. And then to make sure that none of the current history is stored into the .bash_history file, set the hist size variable equal to a value of 0, and then close out the terminal window. Next time you open up a terminal window, there should be nothing in the history for the root user account. On Windows, we want to remove what we refer to as the MRU, or the most recently used list. You may have seen this before on Windows. When you click on the Start button, you'll see some programs that were recently executed in the Start menu option. That gives an indication to an admin or to a security professional that some programs were run that weren't supposed to be run. So you want to remove those recently used programs. Now, as far as tools are concerned that help you out with these tasks, the first one you should be aware of is clearlogs.exe. Now, that can be run on a Windows-based system to clear out your log entries. We also have MeterPreter. MeterPreter is a tool that actually does several different things. One of the things it does is it allows you to place malware in memory-based DLL injection stages, but it also can be used to cover tracks as well. CCleaner is a Windows-based program that's designed to clean out a PC. It's designed to clear out caches and history lists and things like that. It's a valid program that's used by users to make sure that their system doesn't have any kind of private information on the system left over, but it can also be used to cover tracks by an attacker. To remove your most recently used programs in Windows, you can use a utility called MRU Blaster. BleachBit is another program that's very useful for cleaning out things in your system. And again, it's kind of a privacy guard program that's designed to clean out things in your caches and your history and things like that on a Windows-based platform. Another example of a tool like that is called ClearProg. In this next lesson, we're going to talk about real-world application as far as penetration testing is concerned. And we're going to focus on the system hacking section that we've discussed so far. So first of all, let's talk about cracking passwords. And the first thing that's really important is that you should identify the system that you're trying to crack passwords on. This is because the way that you're going to attack a Microsoft Windows system, for example, is going to be different than a Linux-based system. Then you want to use the social engineering skills that we talked about in this lesson. And lastly, use the attacking skills we talked about. Now, once you've gained access to this system as a regular user, so you've cracked a password, the next thing you want to do is escalate privilege. You want to get access to this system as an administrator account. And again, the first important thing to do is to explore the system to find out where the weaknesses are. For example, if you're on a Linux-based system, you can look at the etc passwd file and see what kind of privileged accounts are on that system. Typically for Linux, the root account is the privileged account, but that could vary. Look for user accounts with the UID number of 0. And then you want to try to execute apps that normally require some type of privileged access to see if you can execute them as a non-privileged account. If you do that, you may be able to access the system using a privilege that you're not supposed to have. And then lastly, use the different types of tools that we talked about in previous lessons on how to escalate to a higher level privilege. Once you gain that higher level privilege, you want to execute the applications that would provide you with additional access and access again in the future. Again, the first thing you want to do is explore the system. So you want to look and see if there's any kind of firewall settings on the system, if there's any type of antivirus software in the system, possibly disable those or modify those. And then you want to enable different types of software programs like keyloggers and spyware. And lastly, you want to make it so you can do remote executions, so install some applications and execute those applications that allow you to have remote execution to the system. After that, you probably want to make it so you can hide files in the system. Again, you want to explore and find where the weak areas are in the file system. For example, if I'm looking at a file system that has a lot of images on it, that would probably be a better place to hide files than in a bunch of text files. So find out what kind of files are typically on that system so you can make use of those to hide all your data. Then you want to install rootkits on the system so you can make it easier to hide that data. And then use the various tools that we talked about for hiding file information. And then lastly, you want to cover your tracks. So for covering tracks, make sure you disable any kind of auditing that might be enabled on the system. You also want to modify or delete the log files. Typically, it's better to modify them because deleting the log files really raises red flags. So modify the entries in the log files, delete the ones that would let someone know that you've hacked into the system. And then lastly, close connections and ports. Welcome to Lesson 7, Malware Threats. The word malware is all over the news lately. This lesson is devoted entirely to malware, what it is, where it comes from, detection and eradication, as well as Trojans and countermeasures. In this next section, we're going to talk about several different types of malware threats. We're going to talk about Trojans, backdoors, viruses, worms, and some other malware threats. So let's first talk about Trojans. The idea behind Trojan is it'll be some kind of malicious software that actually represents itself as valid software. The term comes from the Trojan horse used in the ancient Greek war, where It appears though one army was presenting a gift to another army, but inside that wooden horse were a bunch of soldiers that broke out and caused havoc when the city went to sleep. So the same kind of idea here. We have some kind of software that appears to be some cool software, but once we actually try to run it, it performs some other kind of task instead. And we'll see more of details about Trojans in just a few slides. Then we have a term called a virus. So the idea behind a virus is some kind of malicious program that performs some kind of task, maybe designed to delete stuff on your system or steal sensitive data. But the key thing about a virus is that it's designed to replicate itself. So it attaches itself to a file, and it can replicate to other files in the system as well. A worm is very similar to a virus, but the big difference between a virus and a worm is that a worm not only is some malicious code that performs some kind of malicious attack, but also it replicates itself, but not locally. It does it across the network to other machines. So more machines will be infected by a worm. Another malware type software is called adware. The idea behind this is not necessarily to do any harm to your system, but when you install some software, possibly even free software that you got somewhere, it starts popping up messages on your screen advertising different types of products. So the person that created the adware software, they gave it to you for free because they knew they're going to make money from the advertisers. A backdoor is something that allows you to gain access to a system, again, sometime in the future. Spyware is some type of malware software that records stuff on your system, data and information on your system. Botnet is not just one bit of software. It's actually the same software on multiple machines that is used to perform some kind of coordinated attack on another machine. Cryptor is some malware software, or part of malware software that's designed to hide itself from antivirus programs and anti-worm programs. So you might often see a Cryptor component of software in a virus or a worm or adware or whatever it might be. And it's designed to use encryption technology to prevent a antivirus type program from determining that it is a virus or a worm or whatever. And last thing we have is something called a rootkit. We discussed rootkits in a previous video, but the idea behind them is they provide more access to the system, compromise the system even more, hide the fact that the system's been compromised too. Let's talk for a moment about how these things called exploit kits work. The idea is we've got some poor innocent user that decides to go to a website. At some point in time in the recent past, this website's been compromised. So someone's taken over this website, and instead of actually serving up what the website normally serves up, maybe it might be an application that the user's going to download. Instead, it may go through a series of other websites to get to this evil website. And this evil website actually has a malware package, which it sends back up to the website the user was trying to go to, and sends that information back to the user as if it was the application the user wanted in the first place. The user has no idea that they got the application from this evil website. It appears that it came from this website that they were trying to connect to instead. And the result is the innocent user ends up installing an application that contains some malware. So let's talk about some malware actions. Again, this is actually just a collection of different things that malware might do. It might be used to destroy data on your system, to spy on activity, to steal data. Might also do something with ransomware. The idea of ransomware is to lock down your system until you actually pay a fee to access the system again. Could be used to create backdoors. Malware can also disable services, replace key system files. Might be used to launch additional attacks on other systems. Might be used to download additional malware as well. Perform denial of service attacks on machines. Act as a proxy server, so we can, as attackers, use that to access some other system. For example, maybe I can't access your internal web server, but I can't access another machine in your environment, so I can use that as a proxy server to get to that internal web server. It can also be used to host email spamming solutions as well. Let's get a little more detail about how the Trojans work. Again, it appears to be some kind of normal program, but it does perform some kind of destructive behavior. It also may provide access to a hacker to perform other techniques and tactics as well. The big thing about Trojans is they don't typically reproduce themselves or replicate themselves, and they often come disguised as antivirus programs as well. They're typically spread through social engineering techniques. For example, an email that appears to be from a friend of yours that you would download a file from, and then it launches a Trojan attack. So a couple different types of Trojans you should be aware of. Botnet could be a Trojan type attack. Proxy server could also be a Trojan attack as well. A Trojan also might create a web server on your system. So it might serve as the HTTP or HTTPS server. It could cause destruction on your system. It could block access to your system. It could have an effect on computer performance or network performance. It could also deface, and the idea behind defacement is, particularly for websites, modifying the content that gets displayed on the website so it's not your typical content, it's something else instead. It also may include some fake antivirus software, it may do some ransom, it may provide remote access to a hacker, and it also can be used to host a spam email. Let's talk about some basic information about viruses. Again, the idea is that some type of malicious software code is attached to another program. And the big thing about viruses is they're designed to replicate themselves into other files in your system. The other file could actually be a completely different type of file, or it could be the same type of file as well. For example, an email virus might attach itself to a Word document. It can also not only affect files, but also other sections as well, like your boot sector, possibly even your entire hard drive. And again, they're normally spread by social engineering techniques. There are several different types of viruses you should be aware of. One of the more tricky ones is called a resident virus. This one is stored permanently in RAM, so it's not something that you actually see on the hard drive, it's just in RAM itself. There are also directory-based viruses. Directory-based viruses change the path to where programs are executed. So perhaps, for example, you have a program down in your /Windows /System32 directory, and a virus that's a directory-based virus may redirect that directory location to another place where that program contains more malicious code. We also have this idea of file or file infectors. So that's going to executable programs, that the programs that end in either .exe or .com on Windows-based platforms would have some virus attached to it. There are also network-based viruses, viruses that perform direct actions. So they perform some kind of task that's designed to either damage or harm the system. There's also multi-partate viruses. The purpose behind these viruses are to distribute through some kind of media device, whether it be a USB device or a readable, writable CD-ROM. We have the viruses that affect the boot process. Macro viruses are very common in documents like Microsoft Word documents and Excel documents. In those documents, we have these things called macros that when you perform some kind of keyboard combination strokes like Control F, for example, it runs some kind of mini-based program called a macro. Companion viruses are kind of like file infector viruses or resident or direct action viruses. They're known as companion viruses, though, because once they're in the system, they accompany other files that already exist. Stealth viruses are a component of viruses that are designed to trick antivirus programs into thinking that it's not really a virus. We also have an overriding file type virus. That one's designed to delete information in a file, either all the information or enough of it to make the file completely worthless. And the last type of virus you should be aware of is a polymorphic virus. The idea behind a polymorphic virus is very similar to a stealth virus. It's designed to make it appear as though it's not a virus, so when an antivirus programs run, it doesn't pop up as a positive. But the big difference is that polymorphic viruses use a specific technique. They use some kind of encoding or encryption technique to disguise themselves. They're very hard to actually find through antivirus programs, which makes them really a popular feature for those people that write viruses. Okay, let's talk now about the virus lifecycle. So it starts off with some person creating the virus itself, designing the virus, and then goes through the process of trying to replicate that virus on different systems. At some point in time, after it's been replicated, it launches and performs whatever task it's supposed to perform. Then after a while, that new virus has been detected, and a solution gets created by some kind of antivirus software program. At that point in time, users can now use an elimination tool to remove that virus from the system. But one of the catches behind this is once that solution has been developed or once that virus has been detected, quite often the person who created the virus in the first place will make some subtle redesign changes to make the virus not as detectable again. So it may start the entire process all over again. Last thing we'll talk about is some information about some worm basics. And viruses and worms are very similar in many ways. They're both malicious software programs. The big thing about worms, though, is it doesn't really attach itself to an existing program. What it does instead is it runs in memory and it tries to replicate itself across the network to other machines, so it can work in conjunction with other machines to perform whatever task it's designed to perform. So in this next lesson, we're going to talk about indications of an infection. In other words, how can you tell that your system has some type of malware installed on it? So to begin with, here are some primary indications that you have some kind of a malware infection. One could be that your system appears to be very slow. Now, this could just be a normal part of the system, so maybe your web browser is just chugging along trying to access some data, but it also could indicate that you've got some type of malware on your system. And the reason why is because once some type of virus or other malware program appears in your system, it's going to perform a bunch of tasks on a routine basis, and that could slow it down quite a bit. Another thing that might happen is pop-ups appear, especially for ransomware. Again, for ransomware, if someone were to get access to your machine, they could lock it down and pop up a message saying if you don't pay some money, you can't have access to your system again. You also might indicate that you have a malware if your system crashes, it completely fails to boot, you have some strange boot messages on your system. If your antivirus program, which always seemed to work just fine, suddenly becomes disabled, that could be another indication that you've got some malware, especially if you try to start it back up again and then look 10 minutes later and it's disabled again. That's a very clear indication. There's a lot of malware programs try to disable those antivirus programs. Another reason why you might think that you have malware is you get email from other users that you know about that you're sending strange things to them. Remember, one of the things that malware can do is use your system to spam other organizations or other people. One of the ways it does that is it looks at your contact list and says, hey, here's a whole bunch of emails that trust this person, so we'll just send off some spam email to them. So if you start getting email from your friends saying, why do you send me this link here? That's probably because you've got some kind of malware installed in your system. Another indication might be that your browser's changed, your home page might change, your toolbar might change, your search tool might change. Things like that indicate that you might have some malware. Typically, that was probably installed when you download some software or you added on an add-on to your system. It may have changed your browser and how it works. And another thing that's kind of indication that you've got some malware is programs that you didn't have before automatically get started up. So when you boot your system and log in, now you have some programs running that weren't running before. There are also some secondary indications. One of those is hard drive activity. A lot of times malware will create a lot of hard drive activity because it's storing a bunch of information on your system. So as it's probing the network and gathering information about the network, it starts creating some files, especially if it's using the technique to hide that data. That can actually create a lot of hard drive writes as well. If you have reduced hard drive space, that might be another indication because its space has been taken up with the stolen data. A whole bunch of network activity is a really good indication as well. We're going to talk about later on how you can scan your network and see what kind of activity is being taken place, especially coming from a specific machine that you think has malware stored on it. Another indication might be the system freezes. If the system freezes, that means that some kind of software went wrong on the system. It's more prevalent on a Windows-based platform than on like a Linux or Unix-based platform, but definitely a frozen system indicates something's wrong there. Either it's malware or some programs behaving inappropriately. Missing files can be an indication of some malware, especially viruses designed to damage your file system and delete files. Also, if your files or directories or even your drive label changes the names, that could indicate that you've got some kind of virus or other malware. And then lastly, if you get complaints from third-party organizations. This typically happens when your machine is used as a launching point to perform attacks on other systems, like probing network ports that are open on other machines. You'll start getting complaints from other organizations saying, hey, your machine's probing our environment, and it's probably because of that malware that was created. In this next lesson, we're going to talk about common ports that you should be aware of and what type of malware attacks you can expect on these different ports. So it's really important to know these common ports that are utilized because of the way that a network communication works, it requires two bits of information. One is the IP address of the machine, whether it be IP version 4 or IP version 6. And the second thing would be the network port that we use to communicate with that particular machine.
So services listen to specific network ports. For example, your FTP server is going to listen to port number 20 and 21. SMTP listens on port number 25, and DHCP listens on port number 67 and 68. So malware is aware of these ports and try to utilize the ports to establish connections because they realize that those ports might be something that's up and running and available, and you may have holes in your firewall that allow those ports to go through. Some basic information you know about ports. Ports numbers 0 through 1023 are referred to as well-known ports. These are the original ports in a lot of the basic services that have been around for a long time, like Telnet, Secure Shell, FTP, and other ones use these well-known ports. Port number 1024 through 49151 are called registered ports. The idea about these is they're ports that are supposed to be assigned to specific services, but you could use them for other purposes if you want to as well. And port numbers 49,152 through 66,535 are called private ports or dynamic ports. They're not really assigned to any specific type of software, but they can be used for whatever purpose that you like. To determine what kind of ports are available, you can use port scanning tools. So port scanning tools can be used to probe a host and see what ports their responses are coming back from for services. One thing to keep in mind also is that once the system's been infected, the software on that host can open additional ports. So it's important not only to use port scanning tools to see what network ports you have available now, but if a virus or something like that has attached itself to your system, you want to monitor your network port again and monitor traffic to see additional ports that may have been open. You also want to make sure you use a network-based firewall to protect your system. By blocking down ports in the firewall, you can limit what kind of access malware would have to these specific ports. So one of the things you should also be aware of is what ports are normally used by malware software. So a lot of times you'll find that specific software for viruses or worms, whatever, may use specific ports. There are really too many of these to memorize. You probably want to make use of a resource that lists all the ones that are available. The ones listed on the screen right now, that's antitrojan.org/port_open.html, provides you with a good list of ports that are available. Let's take a look at that resource. So as you can see here, there's a large list of different ports and their corresponding Trojan software programs that make use of those ports. Let me just scroll through so you can see there's a ton of these different ports. So we talked about, for example, port 20 and 21 that are normally for FTP. As you can see, there are a bunch of different types of Trojans that simulate FTP that utilize those ports. But as you can see, there are quite a few of these ports that are available. And you can also see that it's broken down into two different types of protocols. Typically, the TCP protocol, that's part of your TCP/IP protocol stack, and the UDP protocol as well. So in this next section, we're going to talk about how do these malware threats get onto a system in the first place. There are several different techniques that could be used for an attacker to get a malware threat onto your system. One technique that you see quite often is online ads. So the online ad might have you click on a link that ends up installing some software on your system. Another very popular technique is social media. Someone may send you a link through Facebook or through email. You follow that link, install some software, and now you have some malware on your machine. The third common technique is mobile devices. Also, pirated software is very common as well. So you might think you're getting a great deal because you've got that software for free, but it has some virus or something attached to it. Web plugins are also another popular way of putting malware on your system. The reason why these are popular is because a lot of those web plugins are third-party software programs that aren't vetted. In other words, there's no one that actually tests to make sure that there's no malware in those programs. So you may install that without even realizing you're getting some malware. Specifically, you'll see most likely adware added on to those web plugins, but it could be other types of malware as well. One really critical one is any kind of files that you download from the internet. If you're not 100% sure where that file is coming from, definitely don't download and install it because it could have some malware in it. Could also come with some bundled software. Again, this is where you see adware and sometimes spyware appearing in this software package. So it looks like it's a perfectly great software package, but it's got some additional code in there that's still designed to compromise your system. And the last thing here is some type of system hole. We talked about ports, for example, being open. An open port might be a gateway into your system in which an attacker can place some malware on your system. So in this next lesson, we're going to talk about how you can detect malware threats and see if they're on your system. So several different things you probably want to do. First of all, you want to scan for any type of suspicious activity, including open ports that aren't supposed to be open on your system. You also want to look for any kind of processes that are running that should not be there. You look at entries on a Windows-based platform to see if there's any kind of suspicious activity in the registry. Also look to see if there's any new startup programs. Typically, malware tries to have things start up automatically when your system boots up or when you log in, so startup programs are a typical place to look for. You also want to check to see if any services are running that aren't supposed to be running. So for example, do you suddenly have an FTP server that's not supposed to be there? Any additional software drivers, folders, or files on the system? And lastly, definitely pay attention to your network activity. That's a very clear indication of whether or not you have a virus or a worm that's trying to communicate with some other system. So let's talk about different types of tools we can use to check for these suspicious activities. Let's start with port scanners. So a couple of port scanners you should be aware of. One's called Cur ports. Another really popular one that's primarily a Linux-based tool is called Nmap. It'll scan ports to see what's available on a remote system. TCP View is another very popular one as well, and NetScan is one that you want to look into. Now, as far as what processes are up and running, you can always just look at the processes. For example, in a Microsoft Windows machine, you could use a task manager, or you can use the PS command or the top command in Unix or Linux. But that doesn't actually do a good job of determining which of those processes should or should not be there. Instead, you may want to consider using tools like Hijack This, Security Task Manager, Microsoft Process Explorer. Another good one is called Auto Runs, Op Manager, and YAPM. Those are really good scanning tools that not only just list the processes, but also determine which of those processes are suspicious. Again, you can also go look at your Microsoft registry directly, but there are thousands of bits of data in there. So instead of actually trying to look at your registry directly, you may want to use some registry scanner tools. There's one good one called Registry Viewer. Alien Registry Viewer is another good one. Active Registry Monitor and Reg Scanner are both good ones as well. Now, as far as drivers are concerned, we have driver scanners that will look at your drivers and see if there's any kind of suspicious drivers on your system. This includes Driver Reviver, Driver View, My Drivers, and Driver Easy. So for Microsoft Windows, you also may want to see what kind of services are running. Again, you can list all those services and try to determine which ones are suspicious, but it's probably better to use a scanner process. Like you can use Process Hacker, Service Plus, Nagios has some tools for service scanning, Smart, ServiWin, and ServMan. Another concern that you might have is the startup programs. So some scanners that will look for suspicious startup programs include Win Patrol, Startup Manager, Startup Booster, and Active Startup. So one of the tricky things that you may have to do is try to figure out if there's any kind of malware inside of setup programs. So one of the things you first want to check for is the Windows registry. Second thing you want to do is look inside your boot INI file for any kind of suspicious references to programs. You also want to check the device drivers. This is when it's really good to have a benchmark that you can compare against and see if there's any device drivers that should not be there. You also want to check any kind of services that are started up automatically during boot. And lastly, Windows has a startup folder. Look inside that startup folder to see if there's any kind of programs that shouldn't be there. And lastly, you want to be able to scan files and folders to determine if there's any kind of malware on those files or folders. One really good tool for that is called Tripwire. You'll see that used quite often on Unix and Linux systems. There's also another one called FastSum. FCIV is a popular one. SIG Verify, WinMD5, and Verisys.
Hi, this is Nick. I'm going to give a demonstration of creating a backdoor in a Windows 7 system using a removable USB disk and the auto run functionality built into Windows. I'm going to be using this Kali host in VirtualBox as well as this Windows 7 system. And within Kali, I'm going to use the SE toolkit and Metasploit to create that payload and create the backdoor. So let's go ahead and boot up our virtual machines. And we won't need Windows yet, so I'm going to go ahead and minimize that. First thing I want to give you a quick overview is how these machines are talking to each other. So here on Kali, I'm using the internal network on VirtualBox. So these two machines are layer 2 adjacent. So we see 192.168.56.102 with a 24-bit subnet mask. Same over here. So they can actually talk directly to each other, just for simplicity for this lab. And that works fine. All right, we go ahead and minimize that. All right, so what we want to run over here in Kali in the SE toolkit, Social Engineer Toolkit or set. Start that up, and we want to do a social engineering attack. We press 1 and hit enter. Infectious media generator, number 3, and a standard Metasploit executable. Now we select the type of executable we want. We're going to go with number 1, which is a reverse TCP shell. So once this application is executed on the remote host, it's going to connect back to the host that we specify, open a session, and spawn a shell. Let's go ahead and run that. We're going to point it at ourselves, 192.168.56.101, and give it a port of 8080. So now it's creating that payload. This is using Metasploit. It's been created. We can see where it put it in the root.set folder. And it asks us, do we want to create that listener now? I'm going to say yes here. And it starts the console. Now, I'm not going to use an actual USB drive for this, just for the sake of simplicity. I'm going to use web and transfer that file. So we can see this script, meta_config, had several commands that were executed in succession. Use multi-handler, set payload, set lhost, set lport. So it creates a listener on lhost and lport right here. And it's waiting for connections. So over here in the root directory, I'm going to run python-m simple http server. And now we'll come over to Windows. And we will surf to that host. And we can see that all the files are there. But what I want to do is pull them all over. So let me go ahead and kill this, and we will do a zip -r for recursive. We're going to call it exploit.zip. And there's our directory. So now we'll rerun Python, refresh the page, and grab exp.zip. Save it into the downloads folder. And let's head into downloads. And there's our file. Extract them all. So you can see we have the autorun folder. Inside here is autorun.inf and the actual application. So I'm going to execute this application from the command line. Now remember, if autorun was enabled and you take this USB stick, you drop it in a parking lot, some random user at a company picks it up, plugs it into their computer, autorun's enabled, and you can get a shell. So let's run command prompt. We're going to go into downloads. And what was it called? Exploit.set. Go into autorun, and we'll run program.exe. And we saw some text pop up on the screen over here. Command shell session 1 opened from this host. So that's the Windows host. So if we run sessions, we can see we have a session available. The ID is 1. So if I do sessions -i for interactive and the session ID 1, we now have a shell running on that host. Let's go on to the desktop here, and we'll do echo hello there, redirect to file.txt. Let's come back over to here, and we have file.txt, hello there. So we have full access to this system, and the permissions that we have on the system are those of the user that executed it. So in this case, because I'm logged in as an administrator of this local machine, I have administrative access to this system remotely. All I needed to do was get them to plug something into their computer and have auto-run do its job. The exploit vectors for something like this are not just USB removable stuff. Vulnerable PDF files can be used and various other methods that are built into SE Toolkit as well as Metasploit. So take a look at those options and have fun.
So in this next lesson, we're going to talk about anti-malware software. So let's focus first on anti-Trojan tools. And keep in mind, just like anytime I talk about tools, I'm just showing you some of the more popular ones, some of the more highly regarded ones, but you may want to create your own list and test out different types of anti-Trojan tools beyond what I show you. So we have the XOff Spy SE tool. Trojan Remover is another really good one. Anti-Hacker is a program that's designed for Trojan removal. EMSI Soft Anti-Malware, and Trojan Hunter. Now, for antivirus tools, there are definitely a lot of these available on the market. In fact, a lot of these are also going to have some anti-Trojan, anti-worm functionality. They'll do things also like look for rootkits and a whole bunch of other things as well. Some of the most popular ones are Kaspersky Antivirus, Bitdefender, AGV Antivirus, Total Defense Internet Security, Norton Virus, which has been around for a long time, Avast, and McAfee Antivirus. So in this next section, we're going to talk about online malware analysis services. So let's first talk about what we mean by malware analysis. Option number one that you have is to use a technique called reverse engineering. With this technique, what you do is you take that malware and you try to break it down into components, parts to find out what the software is doing. That could be a really time-consuming, painstaking task. Instead of doing that, you could also use an online tool. And the online tool basically provides you with a sandbox environment. So it's a safe place that you can put that malware and dissect it and break it apart. It examines the malware code for you, finds what the malware actually does, and also makes use normally of a database of malware techniques so you can figure out what it's doing. It's normally quicker and safer than performing these steps on your own system because you're in a sandbox environment that won't affect any other system in your environment. Some of the more popular of these online tools include Acana, which is actually designed not for a sandbox for Microsoft Windows or Linux, but specifically for Android app development. So if you have malware on an Android machine, you can upload it into this environment and break it down and figure out what the problem might be. Detux is a Linux malware environment. It's designed specifically for x86-64 ARM CPU environments. Another really popular one is called Joe Sandbox. In fact, this is a collection of different sandboxes. They're designed for looking for malware in PDFs, RTFs, Microsoft Office documents, Microsoft EXE files, so executables, DLLs, dynamically linked libraries, and things like that. Another really cool one to know about is Binary Guard. That's for bare metal malware. And lastly, we have Threat Expert. It's designed to analyze and report the behavior of computer viruses, worms, trojans, adware, spyware, and lots of other security-based risks. It also does it in a fully automated mode as well, which makes it a lot easier. In this next lesson, we're going to talk about countermeasures to malware threats. So there are several different types of things you can do on your system to try to prevent viruses and worms and other forms of malware from getting to your system in the first place. One of those is to have a really strong firewall. And you want to spend some time trying to figure out what firewall works best for your environment. We'll talk about firewalls in a future video, but one of the things that you want to keep track of when you're looking at firewalls is exactly what type of things they protect. Some firewalls can only look at the network packet, for example, which is great if you want to block things based upon IP address or port number. But if you want a firewall that actually will block the malware threats, you probably want one that looks in the packet data itself as well. Obviously, you want to use some kind of anti-malware software. We talked about a few of those previously. Whenever possible, use encrypted email. and also filter your email as much as possible before it actually gets to the user that's the email is intended for. Make sure you back up all your data routinely, so if any malware does come on your system, you can recover your old data easily. Also, make sure you install patches on a regular basis. As we mentioned before, one of the reasons why malware can get into your system is when security holes are discovered in certain software programs, the malware programs may take advantage of that to get into your system. By patching your system on a regular basis, those security holes are closed more quickly. Always avoid installing any untrusted software, and make sure you restrict permissions as much as possible. One of the things that malwares try to do is install or run in administrative mode. If you limit the access to users to install software by limiting permissions, you can eliminate some of those malware viruses. Always make sure you monitor your network traffic for any kind of suspicious activity. So you also want to avoid any email attachments that come from unverified sources. Really big one here is also to educate users. The more users know about how malware works and how it might affect their system, the more likely they are to actually make sure that they don't cause problems on the system, including things like downloading software they're not supposed to or opening up attachments. And lastly, you want to perform routine file system scans.
In this next lesson, we're going to talk about some real-world application when it comes to malware threats. I want to focus on how we can determine if there have been any type of threats to the system and how we can make sure we can handle those properly. So the first thing is, for Trojans and backdoors, what you want to do is scan the system. And there's several different things you want to scan for. Look for any type of open ports in the system, any types of running processes on the system that might indicate that you've got some kind of backdoors or Trojans on your system. If you're on a Windows-based machine, scan for registry entries. You also might want to look at Windows services as well to see if there's any type of service on the Windows machine that's not supposed to be up and running. You can also look at startup programs, scan those to find out what they do and if they're supposed to be on the system. Do a full system scan on all your files and your folders. Carefully watch any type of network activities that take place. Those are different types of things that you want to scan for. Once you determine that those exist on your system or there's problems on your system, what you want to do is isolate that system. So take it offline, make it not available to the network any further, figure out what all the different types of vulnerabilities on the system are, and then once you've done that, resolve the problems. You may actually want to also go to a previous backup of that operating system and use that as the base. Plug all the holes that you have in the system, all those open ports and poor services and things like that, and then resolve all the issues before you bring that machine back up online again. Now, as far as viruses are concerned, the first thing you want to do is focus on your antivirus programs. The antivirus programs should be able to scan for any type of virus you may have in the system. It's really important to make sure that those are not compromised. So when you run the antivirus program on a suspected system, you may want to boot off of a special CD to run that virus program. And also make sure your virus definitions are up to date. Typically, you're going to be a lot more vulnerable for viruses that happen more recently than ones that have been around for a while. So scan your system with that antivirus program, find all the viruses. Sometimes it takes more than one scan. And also keep in mind that if you boot off of an external device like a CD-ROM, then you won't have to be as concerned about viruses that are in resident memory. So it's another good reason to scan using some kind of external media. And then once you find those viruses, isolate the system, just like we talked about for worms and backdoors. Resolve any kind of issues. Again, you may want to use an older version of the operating system that you've backed up in a previous backup that might be more secure.
Welcome to Lesson 8, Sniffing. Seeing traffic on the network and the data that is being transported is invaluable to an attacker. If you're able to see a telnet session from its inception, you can get a valid username and password for the resource being accessed. I wonder if that user uses the same password on other systems. In this lesson, we'll be covering what network sniffing is and the various techniques to get access to the traffic we want to see. All right, let's dig into sniffing, one of my favorite pastimes. Sniffing. So what is sniffing? Sniffing is simply watching traffic flowing around the network. There are legitimate as well as illegitimate uses for sniffing. Legitimate might be that a user complains that the network is slow. You go and do a packet capture, you take a look at those packets, look at the timestamps on those packets, and try to figure out what's going on. An illegitimate use example might be, I capture a telnet session and now I have a username and password for a device on the network. It's used for also information discovery, and there are several different methods to do it, whether it's inline or packet copy. So inline is that the traffic flows through the sniffer, and packet copy is that it's simply passively watching the network and a copy of the packet gets sent to the sniffer. There's a couple different ways to do that, and we'll talk about all of those in this lesson. What is some information we can gather while sniffing? Usernames and passwords, of course, the most important thing. Replay is often useful if you want to replay a session to get a system to redo the thing that it just did, but maybe you modified the username in that session where that person created a user account. We can grab DNS information, log information. So if we can capture syslog messages as they're flowing across the network, we can get a lot of good information there. Websites, if we can watch somebody surf the internet just through sniffing, we can capture a lot of good information such as usernames and passwords. Chat, for an unencrypted chat protocol, we can see the full bidirectional communication between those two people. And I have two examples of protocols here that are unsecured protocols. So sniffing FTP and Telnet will get you the username and password that can be used to impersonate that user. Now, sniffing can also be referred to as wiretapping. And wiretapping, the official term for what sniffing essentially is, as defined by the Cambridge Dictionary, the action of secretly listening to other people's conversations by connecting a listening device to their phone. So you expand this idea to a network, you attach a listening device to the network, and you start listening in on that information. Listening device can be hardware or software. If you're trying to sniff a very high-speed network, there's a chance you might need to look into a hardware sniffing solution because a laptop's not going to be able to keep up with, say, 10 gigabits per second of IP traffic. There are also two different methods for sniffing, active versus passive. With active, you are in the path or actively ensuring that the traffic gets to you so you can see it, and passive is simply sitting there silent and watching traffic flow by. Lawful intercept is an area of wiretapping wherein law enforcement agencies can officially sniff traffic, basically. Several networking vendors offer solutions for lawful intercept. They're built into the software. For Cisco, it's Service Independent Intercept, and Juniper has something called FlowTap. And essentially what this is doing is once they receive the warrant, meaning the law enforcement agency receives that warrant, they can go to that service provider and tell them to turn on lawful intercept. And once it's enabled, then copies of the suspect packets will be sent to that collection device as shown in the picture on the right. Let's take a look at some of the attack types you will see when doing sniffing. Touched on passive sniffing, and that is simply watching traffic flow by. You need a device in order to do that, meaning you need to be plugged into something that will allow you to observe but not participate in the network. The old school hubs, which were devices that would simply take in a packet and replicate it to all other ports, were perfect for doing sniffing because you don't have to manipulate the device in order to get a copy of the traffic. A tap is something that sits in line and has a third port for you to plug into and grab copies of those bits as they're flowing between the two devices. With passive sniffing, the two hosts that are being watched, or all of the hosts, it could be several hosts, if you're able to get access to all of that traffic, they're not aware that you're there. And the sniffer, meaning your device that's doing the sniffing, gathering that information, should be silent. Active sniffing, I mentioned in the previous lesson that active sniffing is doing something to get access to that traffic. So in a switched network, in layer 2 of the OSI model, right, the data link layer, that's where we deal with MAC addresses. And switches, their job is to intelligently switch traffic from source to destination. And it does that by analyzing the source and destination MAC address in the layer 2 header. Now, if you plug into a switch your sniffer and the switch is doing the job it should be doing, you should not see that traffic. So active sniffing will manipulate that switch in order to force it to give you copies of the traffic as it's flowing through. There's several different attacks you can do in order to get switches to send you a copy of traffic that's going between source and destination. In this lesson, we'll be taking a look at those, including MAC flooding, duplication of MACs, spoofing of ARP, as well as DHCP starvation. Here's an example of what passive sniffing looks like. We have our source and destination. That's A on the left, C on the right, and a hub in the middle. I have hub surrounded by asterisks because it's important to make the distinction between hub and switch. Hubs will mirror traffic to all ports except the port the packet was received on. So in the case of this example, A going to C and C going to A, the sniffer will receive a copy of those, even though it doesn't need to see it. So if you have the network interface card on the sniffer in promiscuous mode, which is required in order to sniff, you should see a copy of those packets. Now let's touch on promiscuous mode real quick. So network interface cards, when they receive a layer 2 frame, that layer 2 frame has a destination MAC address in it. If that destination MAC address is not the MAC address of that local NIC, then it will be discarded because the NIC is intelligent enough to know that I received a frame that's not destined for me, so I'm going to ignore it. Promiscuous mode is a method to tell the interface card that it should accept and pass up to the kernel frames that are not destined for this host. So whenever you're sniffing, whatever you're sniffing with, it probably already has this feature built into it, but it will enable promiscuous mode on that NIC so that traffic that's not destined for the local host will be sent up further to whatever applications need access to it. Now, before we talk about active sniffing, wherein we need to get a switch to send us copies, we need to touch on what switching is. I mentioned earlier that switches will intelligently switch traffic from source to destination. And it does this by looking at MAC addresses which operate at the layer 2 of the OSI model, which I'm showing here. So switches and sniffing operate at the data link layer and routers operate at the network layer. So whenever we're sniffing and we want to do some active sniffing, we're going to have to tell the switch that it needs to do something in order to send traffic out of a port where that destination MAC address may not exist. In order for switches to make this intelligent decision, they use something called a CAM table. CAM stands for Content Addressable Memory. Within the switch itself, in this CAM table is a mapping of MAC address to port. So we have host 1 on the left and host 2 on the right, and you see some example MAC addresses there. In the CAM table, it's saying that the host with MAC address 010101 exists out Ethernet 11. Same for host 2, MAC address 222 exists out Ethernet 12. So when the switch receives a frame, it looks at the destination MAC address, consults its CAM table, and then forwards that frame out the port that's specified. Here's an example of how CAM gets populated. Host A comes online and has some traffic that he needs to send to IP address 10.1.1.20. He's going to use Address Resolution Protocol, or ARP, in order to find out the layer 2 MAC address of host 20. So he sends an ARP request. When the switch receives that ARP request, because the source MAC address on the ARP request is host 10, it knows that host 10 exists out Ethernet 11. So it adds an entry into its CAM table. That ARP request is sent to the destination MAC address FFFFFFFF, all Fs, which is the broadcast MAC address. So a switch, when it sees a frame that is destined for the broadcast MAC address, will send it out all ports. One of those ports happens to be Ethernet 1.2, so it will be received by host 20. Host 20 receives the ARP request and sends an ARP reply, which is unicast back to the requester. So it says, hey, I'm 20, 10.1.1.20 is at MAC address 20. So this is the ARP reply. When the switch sees that ARP reply, the source MAC address of that ARP reply is host 20. It puts it in the CAM table, and now we have a populated CAM. So if traffic needs to flow from host 10 to 20 and vice versa, it will only go in and out those two ports, unless we manipulate that switch to send us a copy. Passive sniffing on a switch. In order to accomplish passive sniffing with a switch, we need to configure the switch to send us a copy of the traffic. Most intelligent switches these days, such as those from Cisco or HP or Juniper, have a feature. It may or may not be called Switch Port Analyzer, SPAN. In the Cisco lingo, that's what they call it. And SPAN is a feature of network switches that allows you to copy a packet to a destination port. So for passive sniffing on switches, you can use SPAN. Active sniffing, you need to do some sort of attack, whether it's attacking the switch or attacking the two hosts to get them to send the traffic to you. Cisco Switch Port Analyzer, this is that SPAN feature I was just talking about. It's often used for sending copies of packets to intrusion detection systems. So you have usually between a firewall and a router is a switch. That switch's job is to switch traffic between the firewall and the router and any other hosts that exist in that local area network. As possible, you can plug in an intrusion detection device into that switch, enable SPAN, and now you have a copy of all traffic that's going between the router and the firewall. That router is probably plugged into the internet. So you can see people from the internet coming into your network and the responses that are going back out so that your IDS system can analyze either signature or behavior to alert about an active attack. It's also useful for analyzing traffic flow. If you copy all traffic down those ports, then you can see who's talking to who, how much data they're sending. It's useful for sniffing as well as troubleshooting. So that previous example of the users complaining the network's slow, enable SPAN, plug your laptop in there, grab all the data and take a look at what's going on the network. There could be a large FTP transfer, something like that that's slowing things down. Protocols. Encryption is very important. So here's some examples of very common protocols that are flowing all over the internet today that are not encrypted and can reveal usernames and passwords. Telnet, used for remote command line administration. POP is for email, as well as SMTP and IMAP. NNTP is for news groups. FTP for file transfer. All of these are unencrypted and can reveal sensitive information such as usernames and passwords. Protocol analyzers are devices that are used for capturing traffic and analyzing it so that you can deduce certain things. That's usually a purpose-built device, such as this device by Fluke. So Fluke is a popular vendor for multimeters, things like that. They also make a network analyzer and can be used for analyzing network traffic. They'll have ports built in. So I talked previously about you might need a hardware-based sniffer when you have large amounts of data. So this is an example of a hardware protocol analyzer. The software side of the analyzers like Wireshark or even TCP dump on the command line will get you that data. The graphical tools will provide more of an analysis of that data so you can see charts and things like that. But when it comes down to it, TCP dump on the command line is going to capture all the bits and allow you to analyze it later. There's many single board computers out there these days. They're made for the makers of the world. The Raspberry Pi being one of those makes for a very quick, cheap traffic analyzer sniffer, and it's very small. So for $30, you boot up Linux on the Raspberry Pi, run TCP dump, capture the traffic, bring that device home, take a look at the data. Here on the screen, I'm showing a screenshot of SoftPerfect. It's a network protocol analyzer, a graphical protocol analyzer. Wireshark, I would say, is probably the most popular one. I believe we're going to take a look at Wireshark here in a bit in a demo. It does require promiscuous mode, which I touched on earlier. Actually, all of these would require promiscuous mode. I mentioned in a previous lesson that if you have a switched environment, you may need to manipulate the switch through various attack methods in order to get it to copy traffic to you, you being the sniffer. In the next few lessons, we're going to look at each of those different methods, the first one being MAC flooding. So I talked about CAM tables and how they store MAC address to port mappings. And that CAM table's job is to map MAC addresses to physical ports where those hosts exist. But CAM tables are not of infinite size. They can only grow to a maximum limit. And that limit is usually 64,000 or 128,000 entries. So the question is, what happens if you fill up a CAM table? And the answer is flooding occurs. So if I were to say, send say 130,000 ARP requests, and I randomize the source MAC of all of those, the CAM table is going to fill up real quick, and the result is a switch that's flooding. So in this example here, we have two hosts, 1 and 2, they're talking to each other. The attacker is plugged into Ethernet 1.3 on the bottom, initiates a MAC flood, the CAM table fills up, and now whenever hosts 1 and 2 are talking to each other, because it's flooding, the traffic is going to be sent not just to the intended recipient, host 1, but also the attacker on the bottom. Here's a tool that will do MAC flooding. It's called MACoff. It floods TCP packets on the network and randomizes the source MAC. This gentleman, Doug Song, created it as part of the DSNF package. You can get access to that at monkey.org. And here's a screenshot of MACoff with 10 different packets being sent to the destination 10111. So the switch where I'm sending these packets would add a CAM table entry for each one of these packets as it's sent. Yersinia is another tool that can do MAC flooding. It does a lot more than just MAC flooding, but that is one of the options there. You can see in this screenshot that I'm flooding CDP packets towards the switch, just as an example. It does support many layer 2 protocols such as virtual trunking protocol, hot standby router protocol, dynamic trunking. So a lot of cool stuff you can play with Yersinia. What can we do about MAC flooding? How can we protect ourselves? Now, because MAC flooding occurs at the switch layer, however, it could occur on any port on that switch, you need to protect the ports individually. There's a feature in Cisco called port security, and you can configure that to allow a maximum number of MAC addresses on that port. And once that maximum is reached, you can have a couple different conditions, either shut down the port or just don't allow any more MAC addresses to come in. You can have it generate an SNMP trap. So there are features available from the various vendors out there to protect against MAC flooding. So take a look at implementing those. Again, it's at the port level. So if you have 10,000 switch ports in your organization, that's quite a bit of configuration. So take a look at options that are available for protecting yourself against MAC flooding. Another method we can use to influence a switch to send us traffic, or even influence a host to send their traffic to us, is through manipulating DHCP. DHCP is Dynamic Host Configuration Protocol, and it's used for assigning IP addresses to hosts on a subnet. So when you plug in your computer, plug in the Ethernet cable, your computer, provided it's configured to do so, will send a DHCP discover message. It will receive back an offer. You send the request, and then an acknowledgement. So once this four-way handshake, if you will, is complete, you now have an IP address on your computer and you can surf the internet. However, if you take a look at a large enterprise, because DHCP occurs within the local LAN segment, you're not going to expect to see a DHCP server in every layer 2 broadcast domain. So that's where DHCP relay came about. What happens with DHCP relay is when your host boots up, it sends that DHCP discover. The router is going to proxy that for you. So it will send the DHCP discover as a directed unicast message towards the DHCP server, which will send back an offer. The router will then proxy that offer to the host. The request goes again proxied, and the acknowledgement again is proxied. So as far as the host is concerned, it's talking to a DHCP server locally, and the router is proxying that communication for us. So if you have an environment with 10,000 switch ports out there, you could be able to provide DHCP addresses to the entire network from a single server. So provided you configure DHCP relay on all of your routers and switches. But what if we spoof a DHCP offer before the proxied server does, right? So host 1 sends its discovery message, and we're sniffing the traffic. We see that DHCP discover being sent, and we immediately fire back an offer. Because we're plugged directly into that local segment, we can respond faster than the DHCP server, which may be a country or two away. So that allows us to tell the host, here's what I want your IP address to be. But there's something unique we can do with DHCP, and that is we can tell that host what their default gateway is. So if we can manipulate that host's default gateway, we can get them to send traffic to us, which we can then relay out. So let me use my mouse on this screen here. Normally, when DHCP occurs, the default gateway is going to be set to the inside address of this router here. However, if I can win the race to provide host 1 with a DHCP offer, I can tell host 1 that its default gateway is me. And then when that traffic is sent to me, I can then forward it out the correct path. So in that sense, I can get access to the traffic without manipulating the switch itself. It all comes down to winning the race for the DHCP offer. Another attack you can do on DHCP is to starve the pool. It's essentially a denial of service. If you spoof the source address and request many addresses, so you just keep spoofing and keep requesting addresses, the pool will be starved. You won't have any more addresses. New hosts, as they come online, will not be able to get an address. So this isn't necessarily a sniffing attack. However, it does apply to DHCP as a method that you can restrict hosts from getting addresses and therefore not be able to get any work done. Some tools that can help you do this: Yersinia, again, it's a toolbox for layer 2 attacks, and DHCP Starve, which you can grab at sourceforge.net, will also do the same thing. So how can we protect ourselves from being attacked using the DHCP protocol? In this case, I'm showing an example from Cisco. I touched on port security in the previous lesson. We want that enabled, as well as DHCP snooping. DHCP snooping will watch DHCP messages as they flow through the switch, and it will protect you from somebody providing a DHCP offer that isn't allowed to. So take a look at Cisco, search for DHCP snooping. You get some good information there. Just like the applications that we've been referring to throughout these lessons, for the exam, you need to be aware that these features exist. So protecting against DHCP attacks, take a look at DHCP snooping. Another method we can use to get access to the traffic is to manipulate the ARP cache of hosts on the network. And that's what we're going to talk about in this lesson: ARP spoofing and ARP cache poisoning. ARP is Address Resolution Protocol, and it's used for mapping IP addresses to layer 2 MAC addresses. I have an example of that here. Host 1 wants to talk to host 2. As that data flows down the OSI model and it gets to the point where it needs to encapsulate the data into a layer 2 frame, all it knows is the IP address of where the data needs to go. So its next question is, okay, what's the MAC address to create that layer 2 frame? It uses ARP to determine those MAC addresses. ARP request goes out, who has 10.11.20? ARP reply is sent back, 10.11.20 is at, and the MAC address. That's the basic overview of how Address Resolution Protocol works. One of the interesting features of ARP is that an operating system will accept an unsolicited ARP reply. So think about that for a second. If I'm a host, and in order for me to surf the internet, I need to send traffic to my default gateway. My default gateway, 10.1.1.1, is at MAC address 1, as an example. If I'm an attacker and I send an unsolicited ARP reply saying, I'm 10.1.1.1 and my MAC address is 5, host A is going to receive that and trust it. And from that point forward, when host A wants to surf the internet, that layer 2 frame that we see, the destination MAC, is going to be 5 in our example. Now, the attacker, to avoid suspicion, is going to turn on IP forwarding. And he's going to know the true MAC address of the default gateway. So in that case, he can become a man in the middle. If he spoofs both the victim as well as the default gateway, so he tells host A, the victim, I'm the default gateway, and then he tells the default gateway that I'm host A, all traffic from A through that gateway will be sent through the attacker, which is pretty helpful when you want to get information. What can we do with this information? What's the risk of a poisoned ARP cache? We have some examples here. We can modify traffic in flight. Because we're inserted in the middle and traffic has to come into us before being sent to the intended recipient, we can modify it in flight. Of course, we can sniff it. We can hijack a session. So because we see the sequence numbers with TCP and all the flags, we have the ability to insert ourselves into the middle of the session and actually inject data. We can reset connections as well. If there happens to be a voice over IP phone call from that host going out through that default gateway, we can actually capture the audio for later replay. Here's a tool that's very commonly used for ARP man-in-the-middle attacks EtherCap. It allows you to, through a console session, it uses incurses to show you a text-based user interface, and you can select the victim, the gateway, you can manipulate various parameters in order to insert yourself into the middle. As well, it'll show you data as it's flowing live across the network. It's a very cool tool. For countermeasures, there's this tool XARP that runs on both Windows and Ubuntu, and it will monitor a subnet for MAC address changes. It'll send emails if something changes. And keep in mind that the system you're running this on needs to be per subnet. If you were to deploy this enterprise-wide, you're going to need several instances of it out there running. There are features, again, just like the previous lessons, from the network appliance vendors that will protect you against ARP cache poisoning. From Cisco, we have dynamic ARP inspection, which will watch the ARP requests and replies and ensure that they don't change. And DHCP snooping can work in conjunction with dynamic ARP inspection to protect you from ARP cache poisoning. Next thing we'll cover in sniffing is MAC spoofing. MAC spoofing is simply impersonating another user. So host 1 is sending traffic with the source MAC 01. I sent traffic and use that same source MAC. Whenever it hits the switch, the CAM table is going to be modified, saying 01 is now out this interface. Why would we want to do this? If you do run into a network where they're using MAC filtering, then you can purposefully manipulate your MAC address to bypass that filtering. You'll have to know that they're using filtering, and it's pretty easy to determine if you try to talk and nothing comes back. Impersonating another host on the network can help. How would you find out the MAC address of another host? Start sniffing and look for ARP requests. This tool, which runs on Windows, Technidium MAC Address Changer, can be used to modify the MAC address of a NIC. As you can see here, it's pretty full featured. It shows you all of the network adapters present, allows you to modify the MAC address prior to those frames being transmitted. To protect yourself against MAC spoofing, again, Cisco provides features for that. Your other vendors, if you're using Juniper or HP, whatever the case may be, should have features that allow you to protect against MAC spoofing. In the case of Cisco, IP Source Guard can be used. It works with the DHCP snooping database to ensure that the hosts that are sending traffic are the real hosts by comparing MAC addresses and IP addresses with that snooping database. DNS spoofing is another method we can use to get people to send us traffic. The areas of focus for DNS spoofing are man-in-the-middle, cache poisoning, as well we'll be talking about using proxy servers as the man-in-the-middle. So when it comes to man-in-the-middle with respect to DNS spoofing, the object, very similar to DHCP, is to win the race to get that response back to the host. So if we're sniffing the network and we see a DNS request go out for bank.com, we see that request, it's going to take on the order of, tens to hundreds of milliseconds to get the response. If we can formulate the response and send it back to host A before the DNS server does, we can win that race. We need to ensure we match information so that host A accepts the response. Once we've done that, host A, when it tries to go to bank.com, the new destination IP address is going to be whatever you specify as the attacker. With respect to cache poisoning, this is not necessarily manipulating DNS at the host level, but actually manipulating the cache on a resolver. So when a host inside a network has a request to make, it asks its DNS server. The DNS server isn't going to know the answer. It's going to have to go look it up. And it does this through a process called recursive DNS queries. If you can respond to that recursive DNS query before the authoritative name server does, it's possible that you could taint the cache on that DNS server for the period of the time to live of that zone record. So in this example here, we have host A saying, hey DNS, what's the IP for bank.com? DNS says, I don't know, I'll do a recursive query for you. And then me, the attacker, I'm going to respond to that DNS and say, here's the response. In this case, And this is assuming I have access to that traffic, meaning I can sniff the traffic from the DNS server. I can actually inject information into the cache of that DNS server so that subsequent queries for bank.com resolve to the bad IP address as well. So I'm not just attacking a single user, I'm attacking anyone who's using that DNS server. So it's very dangerous. With proxy server man in the middle, this is more about manipulating a host's proxy server settings to get them to send you traffic. This requires a bit of work on the front because you actually have to get that user's machine to configure the proxy server. And that can be done several ways that use tools covered in other lessons in this course. We're just touching on the fact that if you're able to manipulate the proxy server settings on host A, you can get them to send you traffic, which you would then proxy to the destination. If they're asking for bank.com and they're configured to use you as a proxy server, you can redirect them to the badbank.com website that you want. How do we protect ourselves against DNS spoofing? Use infrastructure ACLs to filter DNS requests and responses. Infrastructure ACLs is a concept in networking wherein you apply an access list to protect the device itself. I mentioned transit ACLs in a previous lesson, so infrastructure ACLs are similar to transit ACLs in that they filter traffic, but where they're filtering is the difference. So infrastructure protects the device, transit protects traffic flowing through a device. Use host protection software, implement intrusion detection systems, intrusion prevention systems. DNS security, I would say it's widely used these days, wherein requests and responses are authenticated. You can trust the response that's coming from a DNSSEC configured DNS server, and use firewalls to filter DNS requests and responses. Let's take a look at some tools that can be used to sniff network traffic. Several different tools available to capture traffic, most popular being Wireshark and TCP dump. Both of these options are free. And there are some commercial options available as well, such as Riverbed Steel Central, CAPSA, OmniPeak, and Observer Analyzer. Wireshark, I have here, de facto standards, very popular, very fully featured, relies on something called libpcap, which is a packet capture library. It's also the same library used by TCP dump. Big difference between the two is that Wireshark is graphical and TCP dump is command line. They both accomplish the same goal of capturing traffic. It's just how they're displayed, and some of the analysis you can do in Wireshark is a bit more than in TCP dump on the command line. We're going to hop into a quick demo of Wireshark and see what it looks like. So I started up Wireshark, and the first thing it shows us is a list of interfaces that are available, as well as spark lines to show you traffic that's actually flowing. So I can tell here that Ethernet 3 is most likely my active network connection. That's a wired Ethernet port on my laptop. I'll double click on that and immediately see some traffic flowing across the network. So let's take a quick look at it. Just by looking at the packets that are flowing, I can tell that I'm connected to a Cisco network. This HSRP is a proprietary protocol used by Cisco. It's Hot Standby Router protocol. That's used for gateway redundancy on a local area network. Let's see what else we can see in here. We see some DNS traffic. There's some TCP traffic. If I apply a filter here, such as UDP port equals 53, then I'll filter in on DNS traffic. So here's some DNS traffic for screammy.name, Google. See what else we can find in here. TCP port equals 80. Looks like we got some web traffic. See if I can get some to show up there. Let's surf to forks.com. Looks like we got some traffic flowing. And what we can do is come up here to analyze. We select one of those packets, follow TCP stream, and it'll narrow in on the actual flow of traffic. We can clear out that filter here and see traffic continue to flow. So looks like there's quite a bit of traffic going on here on port 2253. So if you recall from a previous lesson, I had SSH'd into my home system. So that's what this information is here. I'm actually connected to my home system right now through SSH. So there's quite a bit you can do with Wireshark. As well, you capture voice over IP packets and actually listen to them as they're flowing across the network. So pretty cool stuff. I would definitely recommend taking a look at it. One of the things you could be quizzed on is the actual format of those filters. So if I type in tcp.port equals 80, this is a filter. You need to be aware of the options available for filters. It provides some information as you're typing. tcp.source_port would be another option, equals 80. And it goes from red to green to let you know that what you've typed is valid or not. There's quite a bit of options there. Take a look at it, play around with it. This is something as an ethical hacker you need to be extremely familiar with, capturing traffic, analyzing traffic, and being able to pull information from that data. Next up is TCP dump. This is that command line sniffer I was telling you about. You can download it at tcpdump.org. If you want to run it on Windows, it is possible to do that. However, you need the Windows version of the packet capture library, which can be retrieved from winpcap.org, and windump is the Windows equivalent of tcpdump. It runs in the command prompt and does the same job as tcpdump. Quick look at tcpdump on Linux. So here I'm logged into my Linux computer at home. And first thing I want to do is run tcpdump. I'll give it an interface of Ethernet 0. And I'm running this here to show you this error. You don't have permission to capture on that device. Operation not permitted. So in order to put your network interface card into promiscuous mode, you need to be root. So let's go ahead and get root. Now we can run tcpdump and give it an interface. And we should see quite a bit of traffic. There's several different options available with tcpdump to actually get to the data. So if I do an in, this is to not resolve names or ports. So if you see here, this DNS packet, it says .domain here. That .domain is telling you the port number. So it's actually resolving the port number to a name that's a little bit more easy to understand. So similarly, here's .ssh. The -in tells it to not resolve names or port numbers. So now when I execute it, you'll see no names are flowing in the output here. It's all just numbers. Similarly, if I put a VV on there, this is verbose, and it will provide quite a bit more information, such as the TTL of the packet, the flags that are on TCP segments, checksum numbers, a lot of data to deal with. And we can add even more with the -x, which will actually output the data of the packet itself, which, let me kill that. If we were looking at Telnet, we would see the actual username and password, which could be pretty handy. So let's try to do that now. Let's do tcpdump -i Ethernet 0, and we're going to not resolve names, but I do want to see the data. However, I want to filter it to just Telnet. Here in tcpdump, if I do TCP port 23, so now I am sniffing just for Telnet traffic. Coming over to my other window, I'm going to execute a telnet to 10.1.1.1. It's asking me for my username. I'm going to type in Nick and my password. So as we look through the output, we can actually see the raw text that was entered into that telnet session. Right here is the query for the password, and here is where I actually start typing at that capital H. Scroll down a little bit. HAPP. Yep, it's in there. So there are other tools that will actually give you the data in easy to read format, such as Ettercap, which I mentioned earlier. It'll show you just the raw telnet session and the data going back and forth. If you were to capture this to a file, which is the -w option or command line switch to tcpdump, and you save it to a capture file and then open it with Wireshark, you can, again, there dig into the data and see just the raw telnet traffic going back and forth, and it'll color code it for you so you know which host is which as it's talking. And this exclamation point right here is the final character of the password as it's flowing across. Riverbed Steel Central is a commercial option for sniffing, provides charts. It'll do geolocation of IP addresses, as well as show you which applications are using the most bandwidth. You can get more information at riverbed.com. Another option is CAPSA from Colasoft. Very similar to Riverbed Steel Central. It provides charts, graphs. It'll break it down by protocols so you can see what's going on your network, provided you actually have access to that network. OmniPeak is another commercial sniffer produced by Savius. Also provides charts, graphs, shows you bandwidth utilization, breaks it down by protocols. All good stuff. Observer from Viavi. Again, another commercial option with charts and graphs and bandwidth utilization, protocol breakdowns. Colasoft Packet Builder. This is another product from Colasoft that will actually let you create a packet and put it on the wire. If you don't want to use the command line, such as hping to create a packet, then this would be an option to do graphical packet crafting. There's a couple methods we can use to detect if a host is sniffing traffic on the network: ping, DNS, and ARP. With the ping method, you're going to craft an echo request to the host that you think is the sniffer. This echo request is simply an ICMP ping. However, what you're going to do is modify the destination MAC of the crafted packet. Now, there's a couple things need to fall into place for this to work. One, the switch needs to actually switch this echo request to the sniffer, so you'll need to account for that. But the key here is what actually occurs when a sniffing host receives an echo request that it's not the intended recipient. The network interface card is in promiscuous mode. That echo request will be sent to the operating system, which will send an echo reply, provided the IP address is correct. A non-promiscuous mode NIC would ignore the request. So it's all about modifying the destination MAC so that it gets past that promiscuous mode check of the destination MAC address in the frame header. The detection of a sniffer using DNS, it's kind of an odd method of detecting sniffing in that you have to take a look at the amount of DNS queries that are coming into your DNS server. By default, sniffers such as Wireshark and TSpeedDump are going to do a reverse resolution. They're going to say, I have this IP address, what's the name? And they're going to ask the DNS server for that information. When a sniffer is running, you will see the amount of DNS queries spike as it receives packets because it needs to query for the names of those hosts that are actually sending the packets. So you can monitor your DNS systems for a spike. However, if you have one or two DNS servers for a very large organization, the spike is going to be pretty small if there's a single host out of 10,000 that is capturing traffic. Another method is ARP. If you send a non-broadcast ARP reply to a bogus MAC address and a sniffing host receives that, the promiscuous NIC is going to pass it to the operating system and you'll see an ARP cache entry created. So this detection method assumes you have access to that host's ARP cache. So it's kind of unique. It requires a little bit more access to the host that you think is sniffing so you can get that data. What can you do to protect against sniffing? It's really going to come down to protecting the switch from being manipulated to send the traffic down to that particular host. So look at vendor-specific features such as Cisco port security to prevent the alteration of functionality of the switch, which would result in traffic being copied or flooded out of all ports. Use the detection methods we've talked about to try to find sniffers. If it's a true silent sniffing host that isn't trying to modify the switch, it's just watching for traffic, there's not much you can do to find it. You can do static IPs and static ARPs. However, this is extremely administrative intensive. You have to maintain those tables as the network grows. This is going to be unmanageable. Also, for hosts that maybe sit in a DMZ and do one specific function, the network's not going to change very often. You can do static ARP cache mappings to override any dynamic ARP entries that may be coming in from the network. Let's take a look at the steps you would take when using sniffing in a penetration test. Again, get approval for what you're about to do, and then try the various things that we've discussed in this lesson, such as starving the DHCP address pool. Try to gather all those addresses so the other hosts can't connect, get an address, and access the network. Try deploying a rogue DHCP server. If you're using proxying of those DHCP requests through the routers, it's possible that your rogue DHCP server could hand out addresses faster than the actual DHCP server. If you can do that, you can take over the default gateway functionality for that network. Try poisoning the ARP cache using tools such as Ettercap to send spoofed ARP replies to your target as well as the gateway so that traffic has to flow through you. Try spoofing MAC addresses to get around any sort of MAC filtering that's occurring. DNS spoofing as well. Try to respond to a DNS query before the actual DNS server does. Altering the proxy, this relies on some previous exploit or malware sent to that host to manipulate the proxy settings so that that host uses you as a proxy. And finally, as always, document your findings, report to management, and provide some sort of remediation steps to fix these issues.
Welcome to Lesson 9, Social Engineering. People want to be helpful, and fear of confrontation can often be the weakest link in security. Social engineering is all about psychological manipulation of a person into performing an action or releasing sensitive information. In this lesson, we'll be discussing SE techniques and countermeasures. Next, let's talk about social engineering concepts. And we're going to start by talking about a situation that happened to a company named Leone. Leone is a company with about 75,000 employees in about 32 countries throughout the world, and it's been in business for about 100 years now. It's a fairly recent situation. In August of 2016, one of the top executives in the Romanian factory branch of Leone received an email from some top executives in the German branch. That email had a request for a fairly large transfer of funds. Now, this request was fairly normal for the CEO in the Romanian organization to get, and the way it was actually worded, it sounded like a legitimate email. So as a result, the CEO transferred the money. Soon after that, an investigation discovered that this was not a legitimate email. It was actually a spoof. It was using a social engineering attack referred to as a whaling attack, also called a BEC, a business email compromise, or CEO fraud. Essentially what happened was that some attackers found out the different ways that transfers occurred within a company, discovered who normally requested those transferred, and spoofed the email from those people. So it looked like a legitimate request, but unfortunately it actually came from attackers, and the loss for this entire process ended up being over 40 million euros. So what is social engineering hacking? The idea behind this is to try to compromise security by tricking people into breaking their traditional security policy. This will appeal to either someone's vanity, their carelessness, their fear, or possibly even their greed as well. There's several different impacts of social engineering hacks. They can include financial loss, like the example we just talked about from Leone, physical damage, loss of property, loss of data, a loss of reputation, a loss of privacy, can also result in some lawsuits, and business shutdown. There are several components to a social engineering life cycle. Component number one is gather information. So try to get as much information about that organization or the person that is the victim of the social engineering attack method. Next, you normally try to establish a relationship with that person, then exploit that person, and then execute your plan. So in this next lesson, we're going to talk about who is a target for social engineering attacks. To begin with, let's make clear here that really everyone is a potential target for a social engineering attack. With that said, though, there are some targets that are more common than others. In the business environment, you'll typically see small organizations get attacked more often than larger ones. And this is because typically small organizations don't have the security policies in place that larger ones have. In addition to that, you'll find that small organizations don't have a strong IT structure. A lot of social engineering hacks are actually based on IT attacks as well. Also, in small organizations, individuals tend to wear more than one hat. This results in that person having to handle multiple things, and more things slip through the cracks as a result. The second group that's typically targeted are financial institutions. And this is a pretty obvious reason why. Financial institutions have money. So they're a very popular attack. Obviously, they're going to have a very strong security policy in place,
but that can be circumvented with the right type of social engineering attack. So governments are also a common target in the business world for social engineering hacks. And the primary reason why is because governments have really valuable information that other organizations would want to have, including other governments as well. And lastly, company executives like that CEO in Leone. The company executives typically aren't quite as savvy about these attacks, so they're a little bit more vulnerable. Plus, they also have access to funds and company secrets as well. In the private industry, typically the elderly is a little bit more susceptible to targeting attacks. They're not quite as adept at how social engineering hacks work, so they're a little bit more vulnerable. Same can be said for inexperienced computer users and young users as well. And also people with lower income, even though they don't have as many resources, they're not quite as savvy typically when it comes to social engineering attacks. So in this next lesson, we're going to talk about different techniques for social engineering attacks. There are three primary types: computer-based attacks, human-based attacks, and mobile-based attacks. For computer-based attacks, the first one you should be aware of is one called phishing. The idea behind phishing is to try to defraud someone that has an online account by trying to pretend to be the company that the account's with. So you've seen these before, emails that you get that says, oh, your bank account has been compromised. Click on this link to reset your password. And when you click on the link, it ends up taking you to a rogue web server, not the real bank or credit card website. A similar attack to that's called whaling. The difference between phishing and whaling is really the target, not the technique. With phishing, it's more of a mass target effort. We're just trying to send out email to millions of people, hoping that a handful respond. Whaling is a very specific phishing attack in which we're trying to focus on people that are CEOs or top-level executives in an organization. Vishing is just like phishing, except for we're using a cell phone or a landline-based phone to perform the attacks. So instead of getting an email or getting some information through some kind of social networking site, the information is coming through a phone line instead. Social networks and IMs are also a really hot spot for computer-based attacks. Social networks are great because people are willing to forward on messages that may or may not be true. And of course, you can receive IMs with fake information as well. Web-based pop-ups, especially on sites that aren't mainstream sites, may contain computer-based social engineering attacks. You also may have seen hoax or chain letters that contain social engineering attacks, and of course, spam. For human-based attacks, there are a couple of things you should be aware of. One is the process of impersonation. So the idea behind this is that someone pretends to be someone else, and based upon that, they may glean some information in order to be able to attack a system. Either end users are impersonated. So like, for example, I might call up my security person in my company saying that I forgot my password and try to get that password from the security person. VIP users are quite often used for impersonation as well. Support personnel. So this is kind of the opposite of the first scenario. In this case, I might pretend that I am your security organization within your company, and I might call you and say, something's gone wrong with your account. We need to reset your password. Give me a new password, and I'll reset that for you. And then third-party organizations as well. There's another technique called NLP. It stands for Neuro-Linguistic Programming. It's a psychological tool that's designed for social engineers to manipulate how a person behaves. And when it's done successfully, it's very, very successful in getting the results that someone wants from a person. This is actually using techniques that deal with someone's response to certain stimuli, whether it be a certain type of language or the tone of your language, or even how you move your body when you're talking to someone. It is a valid technique for people in therapy to learn how to adjust their behavior, but it's also used by attackers to try to gain information for someone, gathered new data, possibly even get someone to trust them so they can get some more information as well. Another technique that's human-based is actually more of a physical attack, is called piggybacking or tailgating. This is when a company has some kind of security policy where in order to get into the company, you have to go through some kind of badge-based system to open doors. So with piggybacking, someone will try to come in right behind someone who's opened the door with their badge. Something like, oh, hold the door for me. I've got this stuff in my hand, so I can't open it up myself with my badge. RSE is something we're going to talk about in a few minutes in more detail. It stands for reverse social engineering. And this is a person-to-person attack where the attacker convinces the target that they have some kind of problem that the attacker can fix for them. And then eavesdropping and shoulder surfing is when an attacker gets information by either listening on conversations or looking over your shoulder at your computer screen as you're doing things like typing usernames and password. And the last technique we'll talk about here is a very effective one called dumpster diving. Not a very glamorous way of getting information, but it's a good way for an attacker to get things like financial information, phone records, and contact information, or even an organizational chart that will provide more information about the company. Let's just talk a little about reverse social engineering. It's a kind of interesting way of attackers to gain access to someone's environment. The first thing that happens is a phase called the sabotage phase. So maybe someone will send a whole bunch of emails to people in an organization that have a link to some kind of malware program. And then what they do is they advertise that they have a solution to the problem that is created by that sabotage effort. And then by getting someone to respond to that advertisement, they try to assist that person, but while they're assisting that person, they're also really compromising the system even further. The last type of attack method that you should be aware of is called a mobile-based attack method. This can occur either with the repackaged malicious apps. So you may have gone to your app store for your mobile device and maybe looking for a popular program, maybe something like Clash of Clans, for example, and then accidentally click on a similar sounding one, but it's slightly different that does something else instead, and it ends up having some kind of malware associated with it. Also, SMS, the messages you get, instant messages on your phone, could be a way of creating a mobile-based attack. Quite often, security-based applications on your mobile phone could also include malware. And lastly, ad-based malicious apps as well. So any kind of app that you have that maybe you got for free, but it pops up ads all the time, that may actually be a risk as well. In this next lesson, we're going to talk about social networking sites and how they affect social engineering hacks. First of all, let's talk about different social engineering sites and how they might be used by an attacker to gain access to your system. First of all, we have Facebook, and some of the concerns you should have about Facebook include fake company pages. The reason why that's important is because a social engineering attacker could use a fake company page to do things like misinform the public about your company. It can also be used to gather information about your company as well. People going to the fake company page might provide information to the owners of that page that was really intended to be for you. And that includes even things like the usernames and passwords and things like that. Same kind of problem might occur with fake group pages and also fake user profiles as well. Another thing you want to be concerned about is Twitter. So the idea behind Twitter obviously is to send information to people who are following a Twitter account. And the problem here is that if someone were to try to spoof your company Twitter account, they can misinform your clients. LinkedIn is also another source that you should be concerned about. A lot of your company employees probably have LinkedIn accounts. Attacker can use that to gather information about users. For example, they can get their username possibly, or at least the person's name, and try to deduce the username. Plus also, if your users use information about themselves, for example, maybe their spouse's name or their dog's name as part of their passwords, that information can be gleaned either from LinkedIn or possibly even Facebook as well. Also with LinkedIn, you have to be worried about impersonation. So someone could create a LinkedIn account and claim to be a person that works at your company and then try to contact other people as if they came from your company. A few other social engineering sites you should be aware of. Google Plus is becoming more and more popular. It's a rival to Facebook. And the same kind of concerns you would have for Facebook, you'd probably also have for Google Plus as well. Forums are also a concern, and web apps as well. In this next lesson, we're going to talk about identity theft when it comes to social engineering. So there's a process of identity theft that you should be aware of. First of all, there's the research phase, which includes researching information on social media, web-based searches, and dumpster diving. After you do a little bit of basic research, we want to gather more information. So once we have things like the person's name, maybe their address, and other sensitive information, we can gather more information at like the DMV, possibly through the Social Security Administration, and other government organizations. Now that we've gathered all this information, we can apply for different types of additional identity features that we can utilize. So we can go to banks and apply for loans, credit card companies, maybe in department stores as well. And then the result comes in when the person who really has that identity starts getting all those bills. There'll be the financial damage that goes along with that. Their ability to borrow goes down, and then bankruptcy is a possible solution as well. So how do you minimize the risks of identity theft? First of all, try to keep your personal information as secure as possible. So only carry with you what you need when you go on trips. Hide the stuff from view of others. So when you're trying to make a purchase with your credit card, don't make that so visible to someone so they can read what's on your credit card. Also, try to use some of the advanced security techniques that your bank or credit card companies offer, including a higher level authentication and geographic validation, which means you can make it so your credit cards or your bank cards only work in certain geographic areas, and they'll be automatically declined if you're outside that geographic area. You also want to probably change account verification on a regular basis, so like change your password for your accounts, and also check your credit reports on a regular basis too. Also, you want to probably avoid signing up for any mailing or phone lists. If you do decide you want to sign up for a mailing list or phone list, try to provide an alternate email address. Don't use your company email address or even your primary personal email address. And you also may want to use an alternate phone number. Now, what I mean by that is you can actually get a secondary phone number through organizations like even Google provides you a free secondary phone number if you want. It's like a Google phone number for life. You may not use it for any other purpose besides just signing up for things. And again, try to use some kind of secondary email account, not your company email or even your personal email. You also want to avoid sensitive storage on remote locations. So don't you put things on Dropbox, it's like sensitive data, or other sharing sites like Dropbox. And also try to download your email from your server as soon as possible. Don't leave the email on the server, because if that server gets hacked, then your information could be hacked as well. Always shred documents that contain sensitive information. And lastly, verify all requests for personal or company information to make sure that the individual who requests the information is really valid. So now let's talk about some social engineering countermeasures. First of all, let's talk about some company policies and procedures, including making sure you train your employees really well so they understand the potential threats and risks of social engineering hacks. You'll also want to make sure you have very strong password policies in place. And then physical security is really important as well. Gaining physical access to an environment is one of the primary steps for social engineering hacks. That includes things like dumpster diving techniques, and then getting information to a location so that tools like eavesdropping and shoulder surfing could be used. You also want to limit privileged access, so any kind of access that provides access to secure information, you want to limit that. And also make sure you plan a response to any kind of breach. So if someone were to attack your system, how are you going to respond to that? Also, make sure you perform background checks on anyone within your organization. That includes not only employees, but also contractors that you work with. Assign security personnel to monitor social media sites. That's a pretty big one. You definitely want to know what's publicly available out there, either regarding your company or employees in your company, and again, including contractors as well. You want to develop a plan to classify your information, so how to secure important data. Make sure you use anti-phishing tools like PhishTank and spam blocking software as well. And lastly, make sure you secure data as best you can. So let's talk about some examples as far as training is concerned, because this is really one of the biggest steps. You can make a really solid security policy, but if you have one individual in your company that doesn't follow the policy, then you're going to have problems. So one of the things you could do is demonstrate to employees how information on Facebook and LinkedIn can be used to gather information. So pull them into a training session and show them what their public Facebook profiles look like and LinkedIn profiles, and show how that information could be used to get more information about the company, and not only compromise the company, but maybe even compromise themselves as well. Give a demonstration of a spoofed Facebook page. Show some case studies about how social engineering attacks have worked. You can also show them several different phishing attempt emails, although most likely they already have hundreds of them in their spam box right now that they've seen multiple times. I always try to show them some of the more clever ones, not just the ones that say, oh, I've got $20 million I want to transfer to your bank, but ones that actually really appear to come from a legitimate source, and show how tricky those can actually be. And lastly, you want to demonstrate how piggybacking can cause security problems.
So we've been talking a lot about social engineering attacks and how attackers will use them to gain access to your environment. Now we want to focus on some penetration testing techniques to determine how you can see where the vulnerabilities are in your environment. The first thing that's really important to point out is that you want to define the scope of your testing. This is important because social engineering is a pretty broad range of attacks. So you want to focus on the ones that are really going to be the most important for your organization. And once you've done that, use that scope to define a plan of action. And then really important here, you want to make sure you obtain permission from the powers that be within your organization. You want to make sure that they're aware of the techniques that you're going to use to test to see if there's any vulnerabilities. It's better in this case right here to obtain permission ahead of time than ask for forgiveness after the fact. So for example, let's say we want to test out what type of email social engineering attacks will be successful in the environment. So one thing we could do is send a request for information to people. We can send attachments that would provide some type of false malware information that they can utilize, or use phishing attacks. And the different types of techniques you could use for in-person attacks is you can use a third-party person to be an imposter to try to gain access to the environment. Try to use tailgating techniques to come in behind someone through a secured door and try to make use of their access. And then try to use eavesdropping techniques as well.
Welcome to Module 3, Network Security. In this module, we will be discussing two aspects of security that pertain to the network: denial of service and session hijacking. Welcome to Lesson 10, Denial of Service. If your users cannot access a resource that they need to do their job, money is lost. If your customers cannot access your website to buy your product, money is lost. Denial of service is all about crippling a resource so it cannot provide a service. In this lesson, we will be looking at botnets, denial of service tools, as well as countermeasures. Denial of service has been in the news quite a bit recently. Well, for the past few years. Even just within the past week, there was a massive distributed denial of service against dynamic DNS, or DNS, that service that's sort of wreaking havoc across the internet. And it really points out the vulnerability with denial of service attacks, especially distributed denial of service attacks. So what is a DOS? Purposeful attack on a network or resource to prevent legitimate access. Several different ways to do this, or to accomplish a DOS attack: either system or link flooded with bogus requests. So if you think about the way services are deployed, you have a web server that's plugged into a switch, there's a router, and that's plugged into something, and eventually the internet. If you take one of those links in the chain that gets from user to server and flood it with bogus requests, or you just send a whole bunch of traffic down towards that server, if the smallest link becomes congested, you can actually restrict users from accessing that service. That is essentially a denial of service. And the one that I just described in number 2 there. And the final result, legitimate traffic unable to be serviced. It's usually from the outside in, meaning from the internet towards the resource that the attacker is trying to restrict access to. Here's an example of the system overload method of denial of service, wherein many requests are sent from the attacker or attackers towards the resource, in this case a web server, and that web server, being overwhelmed, is unable to service actual legitimate user traffic. Normally you would see that this web server is sitting in some sort of DMZ or demilitarized zone in the network, but this is just conceptual, showing that sending a whole bunch of requests to the resource, in this case a web server, can result in legitimate requests for that resource being dropped. In the case of link overload, you're simply sending a whole bunch of traffic down that chain I referred to earlier to the point where legitimate traffic cannot be serviced because the link is congested. A distributed denial of service is similar to a DOS. It actually is a DOS, it's just on a massive scale and distributed. So there's many sources. I have Z listed there because they're often zombies that are the sources of these distributed denial of service attacks. Zombies being machines on the internet that have been infected with something that can be remotely controlled so that all of the zombies can talk at once towards the victim in order to accomplish the denial of service. Symptoms of a DOS: the network unavailable, abnormally slow connectivity. In the case of the DNS attack that I mentioned a moment ago, if you deny users access to the DNS service, then they wouldn't be able to resolve names to IP addresses. So attacking DNS is a very effective way to restrict many users from being able to access the resources they want to, because most people aren't going to remember an IP address for twitter.com, but they'll type in twitter.com. If DNS is unavailable, they can't get to twitter.com. What are the effects of a successful denial of service? Financial loss, loss of customers, networks disabled. Financial loss not just from revenue, sales and things like that, but also employee time costs money, and resolving that denial of service costs money in the operational impact. And organization disabled. If you bring down the network, then nobody can work, and of course you're going to lose money from that as well. Several different techniques that can be employed to accomplish a denial of service. We'll be covering each of these in the subsequent slides. SYN floods, service request floods, application level DOS, overloading bandwidth, flooding ICMP, and permanent DOS. For SYN floods, it comes down to spoofing sources and sending a whole bunch of SYN segments to an open port. When a system receives that initial segment of a three-way handshake, they allocate resources to service that connection. If you send a SYN packet or SYN segment to a web server on port 80, it's going to send back the SYN ACK. Now, what if we just ignore it? We receive the SYN ACK, but we just stop right there. Eventually, that web server is going to allocate enough resources to where it cannot service another connection request. In that case, the server is effectively DOSed because it has allocated all of its available half-open connections and it can't provide another one. So this is what's going on with a SYN flood. The server, typically a web server, will not be able to service new connections because of that. With a service request flood, this is actually opening a valid request. However, it's opening a whole bunch of them. In this case, the web server cannot provide a response to a legitimate user because it's too busy servicing requests from what it considers to be valid users. However, it's just an attacker or several attackers requesting that resource. Application level DOS, this is sending a piece of information or a chunk of data towards an application that results in the application crashing. You can find in the lists of vulnerabilities out there where new vulnerabilities are published that denial of service vulnerability, where malformed piece of data is sent towards the application that results in its crash. If the application crashes, then that is denial of service because the application is not running and it can't service clients. Some examples: buffer overflows or malicious SQL. Bandwidth overload is usually done in a distributed fashion because a single computer most likely, depending on the size of the link we're talking about, will not be able to generate enough traffic to saturate the bandwidth. So by having multiple sources of this traffic, you can saturate that link, and then legitimate traffic would not be able to get through the link to the intended resource. ICMP flooding, similar to the previous slide where we're sending an enormous amount of ICMP echo requests, resulting in the CPU of the target being overwhelmed because it has to service so many ICMP echo requests and send out those echo replies. I have here this asterisk next to must. Host must process received ICMP. It's possible to filter this stuff. And if it's an internet accessible resource, that's a good argument for blocking ICMP at some level in the network that is north of the resource. Permanent denial of service, aka flashing. And the reason it's called flashing is because the term flashing with an F is usually used when talking about installing a firmware update, say like a BIOS update, right? The term flashing, sort of a play on spelling with respect to phishing. The intent here is to permanently disable the device so that it can't be recovered. The final note here, this bricking, that really goes back to the flashing comment where you install a firmware update that makes the device unusable. If I try to update the BIOS firmware and it results in the device not booting the next time, that is an example of a permanent DOS or flash. Botnets are primarily used when initiating a distributed denial of service attack. So those zombies we talked about earlier would be the bots in the botnet. It's a network of compromised hosts running software that automates tasks through remote command and control. So on the left side of the screen here, we have our CNC server. This is our command and control server. Its job is to tell the bots or the zombies what they should do. So it sends out a message, I want you to attack xyz.com. And the zombie says, I'm on it, and initiates the attack. So by sending that command out to all of the zombies and they all initiate the attack at the same time, it results in that distributed denial of service. Now remember, the zombies are most likely compromised computers that exist somewhere in the world. So if you have 10,000 of these zombies, you send the command to attack, you have 10,000 devices all attacking at the same time. If xyz.com is not able to service those requests, and then it's possible for legitimate traffic to be dropped. The concept of patient zero when it comes to botnets is that with some of the software used for botnets, it has the ability to spread on its own. So the attacker compromises one host, and then the software that's used for the botnet will attempt to compromise other hosts. So it can grow by itself. So it's very scary, but it has been seen in the wild. Here's an example of the actual use of a botnet. The attacker is sending the command to the command and control server. It tells the zombies to attack xyz.com. And then once the attack has started, services are unavailable from xyz.com. They reach out to xyz.com and say, hey, give us some money and we'll stop what we're doing. xyz.com says, fine, we got to get back to business. Just turn it off. So the attacker tells the command and control, stop doing what you're doing. And then they all go back to standing by. Some other uses of botnets, generating spam email. That spam email can then manipulate the stock market as an example. If you can get enough people to believe what the message says, as well advertising, again, through spam. We're going to take a look at some of the tools that are available for performing denial of service. There's a whole bunch of them that are basically ready-made, and they kind of fall into the script kiddie side of the hat colors we were talking about at the beginning of the course. These are tools that you can go download, execute, and magically you're doing a denial of service. Some examples here on the screen: Loik, Zoik, Hulk, DDoS Sim, Taurus Hammer, PHP DOS. We'll talk about these in the subsequent slides. Another one I want to mention is Slow Loris. It's a pretty neat application for performing denial of service. Also, it's a good point to mention that while these are available for you to use, they are most likely illegal to use if you were to execute it on a live target that particularly you're not in some form of agreement with. So when you talk about ethical hacking and having some sort of contracted pen test agreement with the people that you're working with, even if you have that contract, let them know if you're going to attempt to do a denial of service, because it could actually impact revenue for the group that you are contracted with. First one on the list there, PHP DOS. It's a distributed denial of service script written in PHP. You basically put it on a web server, surf to it, and pass it parameters to initiate the denial of service. So it makes it extremely easy. You can see there all you'd have to do is surf to that web server. You pass in the password that the script requires in order to actually execute. Give it the host you want to target, the port, the amount of time you want to run it for, the number of packets, and the number of bytes you want to send. It's extremely easy to initiate a denial of service just by making one single web call. Now imagine if you had 100 web servers all hosting this same script, and you, from a script on your side, called all 100 of them at the same time. Now you can see you're getting into a distributed scenario where you have 100 web servers generating a massive amount of traffic towards your destination. LOIC, or Low Orbit Ion Cannon, it is advertised as a network stress testing application, and that's essentially what it's doing. However, that stress test can lead to a denial of service if enough traffic is generated to actually restrict access to the service. ZOIC, same sort of thing, generates traffic, though not necessarily as attractively. HULK stands for HTTP Unbearable Load King. It's another application for generating web traffic as fast as possible. You can see in this example here, they're sending thousands of requests and eventually getting that HTTP 500 coming back saying that resources are unavailable. DDoS Sim is a layer 7 simulator in that when you execute it, and this is a Linux tool, when you execute it at the destination, it appears to be a DDoS in that it's randomizing IP addresses, port numbers, things like that, in order to make the end system appear to be under a distributed denial of service. And provided this tool can generate enough traffic, it would denial of service that particular target. Tor's Hammer, similar to the previous tools such as HULK, it'll generate a whole bunch of HTTP requests, and this one does have the ability to send traffic through Tor or the Onion router to anonymize the source. It's a bit more sophisticated in the method of generating the HTTP denial of service. What can we do about detecting that a denial of service is occurring, and what countermeasures can we deploy to protect ourselves or to mitigate an in-progress denial of service? Activity profiling is one method of detecting that a denial of service is occurring. When it does occur, you'll normally see, if you're monitoring the traffic on the network, you'll see a spike in that. So having some form of baseline established as to what the network looks like, and then monitoring that, it's possible to detect the DOS just by seeing the change in the chart that's being generated. The key caveat here is that you need to have a baseline. So whatever you deploy for network monitoring, most likely using SNMP, which we discussed earlier, to gather those interface statistics, you're going to want to generate that baseline so that as you're watching those charts and you see that spike, you can tell that there's possibly a denial of service occurring. Another method for detection with a fancy name, wavelet-based signal analysis. Under the covers, it's using a lot of math and fast Fourier transforms to determine that abnormalities are occurring just by looking at that baseline we were talking about and seeing spikes in the chart. I refer to a research paper by these gentlemen listed at the bottom of the screen, Wang and Tharaha, wavelet-based real-time detection of network traffic anomalies. Take a look at that. It's a very in-depth paper. There's quite a bit of math going on there, but it is some interesting research on detecting denial of service through traffic abnormalities. So what are our countermeasure strategies? A couple different options here. We can absorb it, which is basically just sit and wait, or scale on demand to absorb it. However, we have to think about the fact that we're going to absorb it before the attack occurs, and it costs money to scale on demand. So if we're, for example, deployed in Amazon Web Services, and we have that ability to scale the compute need as required to absorb, it's going to cost money for each of those new instances that we're going to spin up. So we have to be prepared for it, and it's going to cost money to do it. Another option is to degrade the services that we're offering. If we're offering 10 services and they're all under attack, maybe we can bring down a few of those so that the remaining critical services are able to service through the attack. And finally, shut down. This is simply disabling the services under attack for the duration. If your denial of service is so large that you can't service any legitimate traffic, this is a valid option because you're basically accepting defeat. You shut down your services, you wait for the DOS to go away, and then bring it back up, and hopefully you don't get attacked again. However, in that period of time, you are coming up with some form of scaling so that you can absorb it, or talking to your service provider to have them filter the malicious traffic prior to it being sent to you. Protect secondary victims, the zombies. When we look at botnets in the previous section, those computers had to be infected for them to become zombies. If we can prevent them from becoming zombies at all, then we can protect ourselves and the internet as a whole from denial of service. This requires a pretty coordinated effort. However, as the operating system vendors and hardware manufacturers become more and more aware of implementing security by default, then the risk of computers becoming zombies goes down. What can we do to protect them provided they are vulnerable? Antivirus, anti-Trojan software, increase awareness. This really comes just, talking to people, disable unnecessary service, as we've talked about several times in this course, and patch when needed. Neutralize the handlers. So hopefully you have some form of network monitoring deployed on your network and keeping track of what's going on with the baseline so that you can point out those systems that are generating more traffic than they should. Then it's possible to neutralize those devices. If you can find them, you can shut them down. If you can disable the handlers, so the handlers are the ones that are actually telling the zombies what to do. And if your network happens to be hosting the handler, then you should be looking at the traffic that's going on in your network so that you can find it. Oftentimes, botnets will use IRC, Internet Relay Chat, for command and control from zombie to handler. Filtering IRC is one quick and easy step to stop those handlers from being able to communicate. Detect spoofed packets. So oftentimes when a DDoS is triggered, the sources on those packets that are sent is spoofed. And we talked about bogon filtering earlier in this course, and that is filtering traffic as it's leaving your network. You shouldn't see a destination IP address that belongs to you going towards the internet. As well, you shouldn't see RFC 1918 addresses going towards the internet. So filter that stuff on your routers. I just talked about bogon filtering. Bogon filtering deals with both ingress and egress filtering. Also, take a look at detecting attacks using intrusion prevention appliances. They can detect those anomalies and try to shut them down. However, if the attack is large enough to where it's actually filling the pipe or saturating the link, then you're really going to need to talk to your service provider to have them filter it before it saturates the link. The service provider has much more bandwidth than you do, and they may be able to absorb it simply by sending that traffic to the bit bucket. TCP intercept is a feature that's available on Cisco products that will proxy the three-way handshake to avoid the half-open problem that you see with the SYN flood. So if you deploy TCP intercept, it will receive that SYN and complete the three-way handshake and proxy it towards the actual destination. So it allows the router to receive the brunt of the SYN flood, which is probably a bit faster at processing packets than the actual host. Deflect an attack. So honeypots is a concept that was covered by Bo, that wherein you deploy a system that is intentionally supposed to be attacked. Deploying a honeypot in the DMZ could provide a target for a denial of service and protect your other assets from being attacked. IPS and host intrusion prevention can also divert attacks. Again, you have to ensure that the link or the pipe isn't flooded with traffic. In that case, your IPS isn't going to do much for you. You need to get the traffic off of the link, and that's where you call your service provider. As I just mentioned, contact your service provider for bandwidth increase during attack if possible. So if you have a link, it's physically 1 gig, but the provider is offering you, say, 200 megabits per second, it's possible you could call a service provider to have them up the bandwidth so you can get some of that legitimate traffic through. Scale horizontally. I was talking about this earlier, where you absorb an attack simply by spinning up new servers. If you're in an environment where, such as Amazon Web Services, where you can spin up a server very quickly and add it to a load balancer pool, then it's possible to absorb or mitigate through absorption. With throttling, you're using network devices to rate limit connections as they're coming to the servers. So you're really just protecting the servers. You're using the network to slow things down so that the servers themselves don't go down. You're still going to impact legitimate traffic, but you're protecting the servers a bit. When it comes to forensics, and this is post denial of service, take a look at what broke and why it broke, and develop a plan for what you're going to do if it occurs again. Collect logs for law enforcement. I touched on synchronized clocks through NTP in a previous lesson. And it's very important because if those logs need to be used for litigation, you're going to need a coordinated time across all of those logs so that you can correlate logs as they're being analyzed. Take a look at network utilization after the attack and come up with ways to perhaps better engineer the traffic flow so that you're routing around certain areas of the network that may have become the bottleneck. To protect from botnets, egress filter bogons, we've touched on that a bit. Filter traffic as it's leaving your network. Packets that shouldn't be going towards the internet, filter that stuff. That's packets that are destined for your IP blocks, RFC 1918 addresses, things like that. Black hole filtering is using routing protocols on routers themselves to send traffic to what's commonly referred to as a bit bucket, which is basically black holing traffic. So if you see that you're being attacked from IP address 11, then using black hole filtering, you can send that traffic to the bit bucket, as well as using policy routing. This is an example for Cisco devices policy routing, where you match on the source IP and send it to the bit bucket. Again, another option to filter malicious traffic. Check with your service provider or internet service provider for DDoS protection services. I've mentioned this before, where if the link is saturated, you might need to call your service provider to have them filter it. Some service providers do offer services for DDoS protection and protection, where they will redirect traffic that's destined for you, scrub it, and then tunnel it back to you so that it avoids link congestion as well as protecting servers. The service providers most likely have a lot more bandwidth than you do and could possibly absorb the attack. Take a look at IP reputation services. These are services that will look at the IP address the traffic is coming from and provide you with a score as to whether or not it should be trusted. And there are services out there that will validate the reputation of the source IP. When looking at the perimeter, filter ICMP at the internet edge. The network operations folks that are listening to this, we're not saying filter internal ICMP because we understand that has a valid use. This is simply at the internet edge to avoid overwhelming systems and links with ICMP echo response traffic. Application level IPS and IDS, take a look at deploying that stuff either inline or off to the side, at least so you can know that it's occurring. And use that least privilege model for access control and defining access control lists. You can contact your service provider for protection services wherein they redirect, sanitize, and return. I touched on this a few slides ago. As well, there are some cloud-hosted solutions that can be used during an attack. So when we talk about absorbing an attack, if you're already deployed in something that can automatically scale as demand increases, then it could be possible to absorb an attack simply by scaling on demand. There are hardware options out there for DDoS mitigation. I list a few here, such as Cisco Guard. These devices, they usually sit on premise. So that means, again, as we've talked about previously, if the link is saturated, there's not much you can do about it. But if the link is not saturated, then these devices can scrub the traffic before it gets delivered to the actual server. If the link is saturated, call your service provider. If not, you can look at tools like this to scrub traffic prior to it going to your server. So what are some tools that you can use on hosts to protect against denial of service? We list a few here: DDoS Defend, and I have the URLs specified as well. These are either software packages or software that can run on an appliance, such as Defense Pro from Radware. So again, be aware that these tools exist. Go to the websites, read up on them. Not necessarily how to use them, but just be aware that they exist. Now let's look at our real-world application using denial of service in penetration testing. I mentioned earlier in this lesson that if you are in a contracted penetration test, that denial of service is a valid thing to show the client. However, it could impact their actual operation. So be careful when even proposing the denial of service. You wouldn't want them to agree to it, you execute it, and then them to actually, lose revenue as a result. So tread lightly, basically, with a denial of service and approved penetration test. So let's run through our steps here. Get approval, again, as always. Get a window. So this is a scheduled window to actually execute the denial of service. Don't do it at peak times. 2 a.m. when the traffic is low would be a good time. So make sure you notify the Network Operations Center as well that you are about to commence with the denial of service. It is valid to test your environment to see how it would react to a denial of service. Just make sure everyone's aware that it's going to occur. When it comes to the actual servers themselves, establish a baseline and then monitor for heavy loads. With respect to actually executing, take a look at the tools that we've talked about at the beginning of this lesson to actually kick off the denial of service, such as using PHP DOS to simply, through one simple URL call, execute a denial of service. For link starvation, you're going to need several hosts to pull this off. And when you listen to the cloud computing section of this course, I talk about using cloud computing as a source of a penetration test and why I don't necessarily recommend it. So take a look at that before you go to Amazon and spin up 100 servers and start executing denial of services. And finally, document your findings, report back to management with some recommendations on what to do.
Welcome to Lesson 11, Session Hijacking. This lesson provides an overview of TCP sessions and some of the vulnerabilities that can be exploited, such as man-in-the-middle attacks.
In this next lesson, we're going to talk about what session hijacking is. So let's talk about the method of session hijacking. The purpose behind hijacking or spoofing is to compromise a valid session between a web client and a web server. It's also referred to as TCP session hijacking. So what I have normally is the client that has established some kind of connection with the server, and what the attacker or hacker will try to do is take control of that connection, so the client is no longer connected to the server anymore, the hacker is instead. There are many techniques available for this. One technique is referred to as a brute force attack. There's also an application level TCP session hijacking in which the web-based application rather than the web server itself is hijacked. Through a process called sniffing, we can gather information about that TCP session and try to attack that. There's also the idea of a man-in-the-middle attack where the attacker will establish himself between the client and the server so the communication doesn't go directly between the two, it goes through the hacker's machine. There's also a technique called predicting session ID. So the idea here is that when a session is established between a client and a server, there's an associated ID that goes along with that session. It's normally a long alphanumeric sequence of characters. If we can predict what that session ID might be as the attacker, we might be able to hijack that session. There's also a technique called session replay, in which we use an existing session to reestablish a connection. An RST, a technique, is when we request a reset from the server. That typically happens when we have a disconnect between the server and client. We ask for a reset, and that way we get a new session ID. And that's something we may possibly be able to see by using a sniffing tool, or maybe predict by using predict session ID tool. And last thing we have is called a blind injection. The idea behind a blind injection is we can't really see the responses coming from the client or the server, but we may be able to interject some information into that transmission.
So we're soon going to see more details about how session hijacking works, but let's just talk about some of the basics about the concept of how this works. So what we have here is the innocent user who wants to communicate with the web server. And at some point in time, they start off by doing an authentication request, so providing the authentication protocol information like username and password, and the web server confirms that. And then the innocent user is going to try to start up the session process, and the web server is going to respond back with the information needed for that session setup. Unbeknownst to the user, the evil hacker is watching the network and seeing all this communication take place. And what it's able to do is steal the session ID using one of the techniques that we'll talk about later in this lesson, and use that session ID now to replace the innocent user and connect to the web server using that session ID. So why is all this possible? Well, first of all, you should realize that TCP is a very popular protocol, so it's widely used for connections between clients and servers. Also, the authentication process typically only occurs when the connection is established. There are ways of recreating authentication, but users get really frustrated about having to continuously type in their username and password. So normally authentication happens in the very beginning. So once that authentication has happened, hijacking a session can be really advantageous for an attacker because that authentication has already been taken care of. Also, session IDs are sometimes set in plain text format instead of encrypted. The data itself also is often sent as encrypted. Also, some sessions have lengthy expiration times. What that means is, in order to not have the user re-authenticate and recreate a new session, the time might be something really long, like an hour before it times out. On more secure systems, like when you log into your bank account, that session ID has a much shorter period of time. But in some systems, like when you log into your email server, that might be a longer period of time. And lastly, web servers make use of cookies to store information on the client side, and unfortunately those cookies can sometimes be spoofed. In this next section, we're going to talk about some session hacking techniques. There are two general types of session hijacking techniques. One is called the active technique, and the other one is a passive technique. The big difference between the two is an active technique is going to actively take over the session, while in a passive technique, the hacker or attacker will just sit there and watch the transmissions going between the client and server. So with the active technique, the first process is to find that session. In some cases, we'll see later on that might include also establishing the connection for the client. And then we're going to take over that session. By taking over that session, we'll gain active control of the session, and the result of that is the client ends up getting frozen out. Now, the advantage of that is by taking over the session, we can do whatever we want with that session, but now the client's frozen out. That means whoever that client program software is being run by, they know now that there's a problem with their connection, and that may cause them to alert the server and try to reestablish the connection or break the connection. In a passive type, you also have to find a session or steal the session by stealing cookies, for example. But then instead of actually taking over the session is recorded. So we can gain information like, for example, maybe the user's name and their password, or maybe sensitive information about their accounts as well. The client is typically unaware of this because it's a passive-based attack. There's also several different levels of attacks too. We have an attack level where it's an application-based attack where we obtain session IDs. And we also have a network-based attack where we intercept network packets. So for application-based attacks, there's several different techniques that could be used. One's called sniffing. So sniffing actually is watching the network to see what's going on as far as the network packets are concerned. We can also make use of a brute force attack. With a brute force attack, we basically try to use different types of session IDs until we find one that matches. Normally that goes hand in hand with a sniffing attack, because the sniffing attack is going to at least give us an idea of what type of session IDs we're dealing with, whether they be really long alphanumeric strings or maybe short ones. There's also a technique that we'll see later on called a replay attack. The idea behind a replay attack is we've already found a session ID and we're just going to reuse that session ID to establish a connection with the server. That's useful whenever you have servers that don't have short timeouts for their session IDs. And then another application level attack would be the man-in-the-middle attack, where we interject ourselves between the client and the server. For network-based attacks, we can make use of either TCP or UDP hijacking. IP spoofing is another good example where we know that the client has already been accepted as a connection to the server, but the server continuously checks the IP address of the client to make sure it's the right IP address, so we can spoof that.
the concept of blind hijacking, which again is when we send information to the server and a client, but we don't really know if that works or not because we can't see the communication. Maybe it's encrypted, but we might be able to interject some data into the connection and establish a connection based upon that. And also man-in-the-middle attacks could be used by intercepting network packets as well. In this next lesson, we're going to talk about application-level session hijacking. And we're going to focus on understanding how these different types of hijacking attempts could work. So first of all, let's just talk about session IDs in general so you understand what they are and how they could possibly be hijacked. They're designed to establish a stateful connection between the client and the server. And typically, when you're talking about web-based services or a web server, they're either stored in cookies on the client side, passed in URLs, or stored in hidden fields. They're also normally long alphanumeric strings, and they should be randomly generated, but depending upon the software it's being used, they may be sequentially generated. That's actually one of the possible security exploits that could be utilized. Sometimes they're used for authentication and authorization. This allows the avoidance of having to re-enter a password each time that the client tries to connect to the server. Strong encryption of those IDs make them a lot more secure. Sometimes they're sent across in plain text, which makes them obviously a lot less secure. And then if they're compromised, then the attacker can gain access to the session. Since the session normally has already gone through the authentication process, that means the attacker can gain access to the server as if they were an authenticated client. So let's look at some different examples of session IDs. Remember that they could be stored in a cookie. So you can see in this case right here, the session ID shows up on the first line of this cookie. It's that long alpha, in this case, numeric character sequence. They can also be part of the URL. And lastly, they may show up in hidden fields. In this case right here, there is that hidden type, and you can see that the name is session ID, and then the value, in this case, again, a bunch of numeric characters. So one of the attacks could be used is called a session replay. And the idea behind a session replay is to try to reuse a valid session ID to spoof the client. So the idea is normally viewed by some kind of session sniffing. So by watching the network, we can see the IDs being passed back and forth. Again, if it's encrypted, that might not be possible, but if it's set in plain text format, in the URL, for instance, then we can see that ID. So the client at some point in time establishes a connection with the server. And during that process, the server provides a session ID for the client to continue to use. At some point in time, the client stops using that session ID, and the attacker recognizes there's no more communication happening between the two, but is guessing that the server hasn't invalidated that session ID. So by seeing that session ID, the attacker can now use that session ID to reestablish the connection on the server. Another technique that can be used is called session predicting. The idea behind this technique is we'll watch for session IDs and see if there's any kind of pattern associated with those session IDs. Again, they should be randomly generated for security purposes, but sometimes they're not. Sometimes they're actually sequential. So by looking at the session IDs between multiple client and server connections, the attacker can probably predict what the next session ID would be and use that session ID to establish that connection with the server. So another technique that we can use is called session predicting. So for session predicting, there's also a variation that's called a brute force attack. A brute force attack tries as many session IDs based upon known sessions. So instead of actually trying to predict what the next session ID will be, we just try a whole bunch of different session IDs based upon the information that we've gathered from previous sessions. So it could possibly end up that we do thousands of guesses per second. It's a fairly typical thing to do in the hopes that one of those sessions would actually be an accurate one. Another technique is called session fixation. In this case, the connection is not established between the client and the server, but really it's established on the attacker side. So the attacker establishes a connection pre-authentication with the server, and then it sends a link that includes that session ID to the victim. So it could be sent through email, it could be because they went to a web page and there was a link they could click on. But by having that session already established, that means the attacker already knows the ID and it's going to be a pre-authentication ID, which means the user hasn't typed in their username or password yet. So the attacker, after they establish that connection with the server, then passes that session on to the client through some kind of link, and then the client will use that session to connect to the server. And once the connection has been established and the user logs in with the username and password, then the attacker takes over the connection again by using the ID that they're already aware of because they were the ones that established the connection in the first place. Okay, let's talk about some other application level attacks. One attack we've already talked about, and that's man in the middle. And remember, the idea behind this attack is that we, as the attacker, will establish ourselves between the communication that's going from the client to the server. And so by doing this, we can see everything that's going on between the client and the server, and also make changes to the session as well. So we can interject more information. We can find out what kind of username and password is being used to log into the system, things like that. We haven't really talked about man in the browser before, but the idea behind this is to install a proxy Trojan horse on the client side in their web browser. We can do this by taking advantage of vulnerabilities in the web browser itself. The security web browser may allow that to happen either by installing an add-on to the web browser that acts as a proxy, or it could be a situation in which the user clicks on a link that we send to them, and that installs some software in the browser as well. So it's referred to as man in the browser because, again, the malicious software that we put in the browser will act as the in-between between the client and the server. So the next two things we're going to talk about, we'll discuss in more detail later on. This is just to give you an overview of what they're about. The first one's called cross-site script. It's also referred to as XSS. An XSS attack is a type of injection in which some type of malicious script is injected into the website itself. Another type of attack that we should be aware of, and we'll discuss in more detail later on, is a cross-site request forgery, also referred to as a CSRF or XSRF. This is actually known also as a one-click attack or session writing. It's a type of malicious exploit in a website where unauthorized commands are transmitted from the user that the website trusts. So in this next lesson, we'll get a better idea of what a man-in-the-middle attack is. So remember that the man-in-the-middle attack is designed to have the attacker insert himself between the client and the server. It forces all the traffic that's going between the client and the server through the attacker's machine. And then based upon that, now the attacker can view and even control all the network traffic between the client and the server. So it's a pretty easy visual demonstration of how this works. The client and the server has some kind of connection between the two, and the attacker interjects between those two, and the communication no longer goes directly between the client and the server. Remember, we also talked about the man in the browser attack. It seems very similar to the man in the middle attack, but the difference really is that it's not a separate system that the information is going through. It's really a client-based program, some Trojan horse that's been installed in the client system. Typically, it acts as an extension or an add-on application. And there are various approaches that we can use with the man in the browser attack. We can capture form data. Form data is normally when you do an HTTP post request, and it's quite often used for things like authentication where the username and password is required. One really big advantage of the man in the browser attack when it comes to usernames and passwords over a man in the middle attack is that normally the man in the browser attack can see that information before it's been encrypted. One of the problems with a man in the middle attack, if all the data has been encrypted, then it's kind of hard to see what exactly the data contains. But since this is running on the client side and the Trojan horse program can work pre-encryption phase, or actually when data comes back from the server, it can work post-decryption phase. That way the man in the browser has a better chance of getting information from a encrypted-based communication. Can also be used to interject JavaScript into web pages, making the user think a server is requesting data when it's not really requesting data at all. So again, we can prompt the user for a username and a password simply by interjecting some JavaScript in the web page data coming back from the server. That information never gets sent on to the server, it gets sent on to the attacker instead. And we can also use a man in the browser to hijack authentication sessions as well. In this next lesson, we're going to talk about a couple of different cross-site attacks. So remember from before we talked about two different cross-site attacks. One is a cross-site script vulnerability. This one's also referred to as XSS. And what it's going to do is exploit a valid connection that already exists between the client and the server. And the way it does that is on the client side, it'll inject some malicious scripts to execute that will provide access to the attacker, provide the attacker with the session ID so it can start communicating with the server instead of having the client communicate with the server. Another technique is called cross-site request forgery. This one also exploits an existing valid connection between a client and server. But instead of specifying or giving the client a script to execute, the attacker is going to provide a script on a third-party website and does that by sending a malicious link to the client. So let's take a look at these two visually to see how they actually work. So first, let's assume that we already have a connection between the client and the server, so some kind of session ID has been established between the two of them. What the attacker will do is they'll send a link with JavaScript to the client, and that link will contain some code that captures the session ID and sends that session ID to the attacker. And then once the attacker has that session ID, the attacker can then use that to connect to the server and freeze out the client or see information that the server has to provide through that session. That's a little different from a cross-site request forgery. In this case, before the connection is even established, the attacker sets up some malicious link on a website the attacker has access to, some third-party website. So when the client and the server establish a connection, the client is going to be encouraged to go to that website. Could be through an email link or maybe a pop-up that appears when they're browsing through web pages. And by clicking on that link to go to the attacker website, there's going to be code on the attacker website that sends the session ID back to the attacker. And now the attacker can use that session ID to establish a connection with that server. So in this next lesson, we're going to talk about session hijacking, focusing on network level hijacking. So let's talk first about TCP/IP hijacking. This is possible because of a feature called a three-way handshake. So when a client normally establishes a connection with a server, it first starts off by sending something called a SYN or a synchronized package. It's a way to sync up between the client and the server and create a connection status between the two of them. And what the server will do is respond back with 3 bits of information. First of all, that sync request to make sure it matches up with the original client request. Secondly, something called an ACK or acknowledgement request. And the last bit of information it provides is something called an ISN, which is referred to as an initial sequence number. Once all that information gets back to the client sends back the acknowledgement that it got from the server to make sure those two matched, plus also the ISN number +1. So it establishes the next packet, the sequence of packets that are sending back and forth between the client and server. Now, TCP/IP hijacking occurs in between the second and third step. So right after the second step, when the acknowledgement comes back from the server with the initial ISN, what will happen is that the attacker will respond to the server instead of the client. And this is possible because the attacker and the client will be on the same network. So the attacker is probably sniffing the network and watching the transmission of the SYN and ACK packages going back and forth. And as soon as it sees the response back from the server, instead of allowing the client to do the communication, it jumps in with the acknowledgement plus the ISN +1 number. As a result of that, it establishes a connection with the server and the client's frozen out. So the next thing we're going to talk about is something called reset hijacking. It's also referred to as RST hijacking because that's the name of the package that's sent from the server to the client when a reset request occurs. So a reset package is a message that goes from the server to the client to reconnect the session. The attacker can send an RST package using a spoofed IP address from the server. So what it's going to do is it's going to send that information to the client. The client thinks, oh, I need to reset my connection. And so the client resets the connection, which includes providing the username and password to re-authenticate into the server again. But of course, since we're using a spoofed IP address, the information is not going to the real server, it's going to the attacker server instead. There are some additional network level hijacking attacks that you should be aware of. IP spoofing is simply using an IP address of a server to pretend as though your attacking machine is the real server machine. There's another technique called UDP hijacking. It's not technically session hijacking because with UDP, there's no connection established. TCP is a connection-based protocol, while UDP is a connectionless protocol. However, it is a hijacking effort. It just happens to be not session hijacking. It's actually a little easier than TCP because no connection is established between the two, so it's pretty easy for an attacker to interject into a UDP connection. Not many protocols that are security-based use UDP, but one that's really important you should be aware of are DNS lookups. So one of the things that a hacker could do is interject itself between the client and a DNS server and serve up fake IP address and host names with the hopes that it can redirect traffic from the legitimate websites to its own websites. And then based upon that, it could do things like gather user account information, passwords, and things like that. Another technique that you want to know about is called blind hijacking. So blind hijacking typically happens when the client and server are communicating through some type of encrypted protocol. So it's not easy to see that information, or possibly they're not on the same network, so we can't see the communication either. So with blind hijacking, the attacker machine can't really see the results of its efforts, but it can try to interject information into the server and client communication. By doing that, it can disrupt the communication, possibly even encourage the client to go connect to another website instead and gather information from there instead. And then we also have man-in-the-middle network hijacking attempts. This can make use of forged ICMP or ARP spooling. ICMP is the Internet Control Message Protocol. It's mostly an error reporting protocol. You're used to seeing it for things like pings and trace routes and things like that. So quite often used by routers to generate error messages when the source IP address has problems in delivering something. And ARP stands for Address Resolution Protocol. It's used primarily by IP protocol, specifically on IP version 4 networks to map the IP network address to the hardware address. So not a very common way of doing hijacking, but since communication does happen not only via IP, but also sometimes at a lower level using the hardware address or the MAC address of systems, by hijacking ARP's requests, we can modify where the end result packets go to. So let's talk a little bit more about UDP hijacking. Remember that UDP requests could include DNS queries. So here we have our innocent user who wants to perform a DNS query to know what IP address to go to a website. So the UDP request goes to the proper server, and we're querying for that DNS query. In this case right here, before the response gets back, the evil hacker who's watching the network sees that request and quickly sends back a UDP response. The result of that is instead of giving the real web server, he ends up giving the fake web server's IP address, and the innocent user ends up going to the fake web server instead. In this next lesson, we're going to talk about some session hijack tools. So up until now, we've been talking about different ways that you can hijack sessions, but now let's focus on some tools you can use to hijack sessions, including the first one, Surfjack. So Surfjack is a tool that allows you to hijack HTTP connections, primarily designed to steal cookies. Nice thing about Surfjack, it also works on HTTPS sites, so even if it's encrypted using the HTTPS protocol, it'll work. It works both on Wi-Fi, what they refer to as modern mode, and Ethernet. If you want to download that and play around with it, there's the URL for that. The other one is Cookie Catcher. So this one is designed specifically to use attacks that are based upon XSS. And again, if you want to download that and try it out, there's the URL for it. Firesheep we briefly mentioned before. It's a Firefox extension that's designed to demonstrate how HTTP session hijacking attacks work. And again, if you want to download that, there's the link to that location. Another tool that's kind of useful to know about is the WhatUp's Gold Engineering Kit. So What's Up Gold Engineering Kit is a network diagnostic tool. And to test it out, you can download it from www.whatsupgold.com. The next tool comes from OWASP, which is really a website that allows you to see a whole bunch of different types of hacking techniques and how to combat them. They don't just have one tool available, but I'm just going to mention one, the ZA proxy tool. It's a penetration testing tool. What it does is it searches for kind of vulnerabilities that you might have in web applications. So it's specifically designed for web application vulnerability testing. And you download this tool from this URL. And lastly, there are a bunch of additional tools that you may want to consider. Remember, whenever we talk about tools, there are always going to be more than we talk about in these training videos. We're just pointing out some popular ones. So it gives you a starting point where you can go search for additional tools that you might want to be able to use. But some ones that you may want to consider looking into, including Cookie Cager, SSL Strip, Projack, Burp Suite, Hijack, Ettercap, Tamper IE, T-Site, Peros, Achilles, Juggernaut, and Hunt. So in this next lesson, we're going to talk about hijack protection. And one of the things you want to do to protect yourself from hijack attacks is to train your users. Teach them to not follow untrusted links. Also teach them not to visit any unknown websites. You also want to tell them not to open untrusted files or extensions. Make sure they clear out their browser history on a regular basis and also their cache and their cookies. And then also make sure they keep the browser software up to date. So if there's a new version of the software, make sure they download and install it on a regular basis. That last one you can actually handle from the server administrative side, where you can automatically download and install the software on their behalf. Typically on most Windows systems let you do that, and there's some Linux tools you can do that as well. As far as making sure the session IDs themselves are secure as possible, make sure that your web application uses random IDs, not sequentially numbered IDs. Also, try to increase the length of the ID as much as possible. The longer the ID, the more difficult it is for a brute force attack to figure out what that ID is. Make sure you use session timeouts. Also, make sure your web application has a logout function. That way, if the session timeout hasn't reached its maximum and someone logs out, that should disable that session ID. Make sure for every new login, a new session ID is assigned. And definitely make sure you encrypt your session IDs. As far as encrypting session IDs is concerned, there are a couple different protocols that you want to look into to determine which one you want to use. One popular one is called IPsec, that's the Internet Protocol Security. Another very widely used one is SSL, that's Secure Socket Layers. I can even use Secure Shell to encrypt the data transfer. Next thing, let's talk about network security. Make sure you're secure networks with firewalls to block unwanted packets. You want to prevent attackers from logging directly into your network. This can actually eliminate the concern of man-in-the-middle attacks. Also, limit incoming connections and minimize remote access. Use switches and not hubs as they provide higher level of security. And as far as your web server is concerned, make sure you use tools to determine your weaknesses. Make sure you also use a certificate of authority, or a CA. Don't use HTTP protocol if you can avoid it. Anytime that you're going to authenticate users, you should always use HTTPS and send data in encrypted format only. Also, you want to use different accounts for different purposes, and don't provide the session ID in a query string. You also want to make sure you keep your server software and all your web application software up to date.
So now that we talked about different types of session hijacking attempts, let's talk about how you can make use of penetration testing techniques to try to determine whether or not your environment is vulnerable to session hijack attacks. So the first thing you want to do is locate a session. So try to determine by looking at your network environment,
probe those sessions to try to get information about them, gather information from the URLs, from cookies and caches and things like that. And then lastly, you make use of one of the many hijacking session techniques that we talked about in this lesson.
Welcome to Module 4, Web Services Security. Many applications that were traditionally deployed in a thick client fashion are moving to the web. This opens up a whole new world of attack vectors. In this module, we'll be discussing hacking web servers and hacking web applications.
In this next lesson, we'll talk about web server concepts. Let's begin by looking at the market share for different web servers. In this graph by netcraft.com, you'll see that historically, and even today, the Apache web server is one of the most popular web servers. Microsoft also is a fairly popular web server, but its popularity has declined in recent years. In fact, if you look, you can see Apache accounts for at least up to 50% of the current web servers in use today. Now, why this is important is because hackers will go after web servers that are more popular because they have a better chance of getting access to a server if there's a lot of them out there. So it might be advantageous for you to use a lesser known web server such as Google's web server, which is less likely to be attacked. Let's talk about why web servers are attacked in the first place. One of the primary reasons why is because they're available to the internet. That means a hacker doesn't have to go through a firewall or some other type of security structure in order to be able to access the web server. There's also several different attack vectors available. The hacker can attack the server itself, any kind of web application that's running on the server, or even the backend database as well. In addition to that, if you can attack a web server successfully, you may be able to get access to regular user accounts or even the administrative account. Let's talk about some of the web server vulnerabilities. To begin with, the server settings themselves have a lot to do with how strong the security is for the web server. In addition, since they're user accounts for web servers, poor user security like poor passwords, easy to guess passwords, can cause a problem for security as well for web servers. Applications themselves may have their own security holes, and any kind of misconfigured security settings could cause security vulnerabilities as well. In some cases, there's absolutely no authentication required whatsoever to access a web server, and that can cause a security problem. Also, web servers should be routinely patched because as vulnerabilities are discovered, attackers will make use of those vulnerabilities. So the quicker you can install patches on your server, the better off you'll be. In addition to that, sometimes you have unnecessary services or features enabled in a web server. For example, your web server may support Python scripting, but if you're not using any Python scripts, there's no point to having that available. In addition to that, you may have poor file or directory permissions. So what are the results of a successful web attack? One result might be access to sensitive data. Quite often web servers are used as a front end to provide access to information from a database, so that sensitive data could be accessible by the attacker. It may also provide access to user accounts, and that might be a launch pad to provide access to other features in the operating system. Defacement is an issue as well. The idea behind defacement is changing the website so its content is different. That might actually cause embarrassment for the company, or it might actually cause some problems with the users trying to use the website as well. It could also be used to launch secondary attacks. The idea behind this is once you have access to any kind of server, you can launch attacks from that server, possibly get access to the internal servers in the company as well, because there might be a hole opened up through the firewall for that one machine. And lastly, that can result in compromising of other systems. In this next lesson, we'll talk about web server attacks. Let's first talk about DNS attacks. Now, it's important to realize that when someone goes to a website, for example, www.example.com, that website's URL or domain name needs to be translated into an IP address. And the way that works is through DNS, domain name service. So if you can make a DNS server either not respond or respond with a different result, you've effectively hacked the web server. One technique that's used is referred to as DNS server hijacking. In this case,
we're able to redirect web queries to an imposter website. And the way that's done is by having DNS queries come back from a rogue DNS server, not the real DNS server. As a result of this, people are sent to the wrong website, a malicious website that's designed to either gather the information, like the username and password, so we can use that to authenticate on the real web server at some point in time in the future, or it might be used to serve up incorrect information. Another technique that's often used is referred to as a DNS amplification attack. This is a denial of service or distributed denial of service attack, which is designed to make it so that the DNS servers can't respond. If the DNS server can't respond, that means people can't get to their website because they don't know the corresponding IP address. The way this works is that the DNS queries are increased in size, in other words, how big the packet's information is, and the number of DNS queries. The more machines you have doing these DNS queries that are large DNS queries, the more likely the DNS server won't be able to respond to valid requests. That compromises the DNS server, which means, yet again, that the user can't get to their website. Another type of web server attack is referred to as an HTTP-based attack. There are a couple different varieties of this. One variety is an HTTP response splitting attack. In this case, what happens is the attacker inserts content into the HTTP header section, and that content splits the response into two responses. The responses come back, and the attacker has control over one of the responses and could do whatever it wants to with that response, while the other response is just discarded by the web browser. This is made possible quite often when applications don't sanitize the input values from the user. In conjunction with an HTTP response splitting attack, we have something called an HTTP cache poisoning attack. This is when we place invalid data within the browser's cache, and the result is the browser queries a rogue web server instead of a real web server. This HTTP cache poisoning attack is implemented via an HTTP response splitting attack.
So let's talk a little bit about how a directory transversal attack works. First of all, here's a typical Linux file system structure. You see I've got just three of the directories underneath the root directory that you normally see: var, etc, and usr. Now in this case, it's important to understand that our web files are underneath the var directory structure. So we've got the www directory, HTML, and here's where all the code for the HTML files are going to be. Underneath the etc directory, we normally have our configuration files. On the Microsoft Windows machine, this might be your Windows subdirectory. And then we have our binary commands under the USR directory as well. Now typically what happens is that when a web server runs, it limits access to its clients to underneath the directory www. In this case right here, that means the only files that the web client can access should be these files and not the etc directory files or the USR files, which is important because there are config files that we just don't want an attacker to see in the etc directory, and we certainly don't want the attacker to run commands down underneath the user bin directory. But by using a transversal attack, what a hacker could do is use a URL like this. So in this case right here, we're going to this website, which is going to be what this website's for right here. And by using the dot directory notation, which means go up one level and then go up one level, we're trying to actually get over to this directory structure here. So if we were initially down, let's say in this directory, one dot would take us to this directory, another dot would take us to this directory, and we keep working our way up until we get to the root directory. Now, an important thing to point out about this is, obviously, this is somewhat of a guessing game. We may have to guess exactly where those files are. But through trial and error, we may be able to figure out how to get down to the etc directory or the USR directory.
The last thing we want to talk about are some additional web-based attacks. One type of web-based attack is a man-in-the-middle attack. So a man-in-the-middle attack is when an attacker can place itself in between the web client and the web server. That way the attacker can see all the information coming to and from the web browser and the web server. It can gather information and use that information to perform attacks. Another attack is called a phishing attack. You've probably seen these before. You've got an email saying that your account's been hacked, log into the server to fix the problem right now. And the URL that's provided is not the real URL for your particular service. So the idea is to try to gather someone's username and password by using a fake server and then use that information to log into the real server. Typically, it's information from things like bank accounts or credit card accounts. Another technique that could be used is password cracking. So in this type of attack, the attacker will try to guess user account names and passwords on a web server. There are a variety of different techniques that can be used. It could simply just guess the password. It could use a dictionary attack, in which case it's actually using a whole bunch of different words from a dictionary, or just simply a brute force attack. Another type of attack that we'll talk about in more detail later on is called SQL injection. This is when we actually try to hit the back-end database and either gather information from the database that we're not supposed to have access to, or insert more information. There'll be another section later on application-based attacks, so how we can focus on the applications themselves. These are the web applications, and make attacks on those. And there's also attacks based upon misconfiguration of the web server itself. In this next lesson, we'll talk about attack methodology when it comes to hacking web servers. First of all, let's talk about different types of methods in general. When attacking a web server, the important thing to start off with is gathering information. You want to get some basic information about that web server, including who normally goes to that web server and possibly what type of web server it is. In the next phase, you're going to focus on footprinting, which is getting more detailed information about the web server. That'll include things like what kind of applications the web server provides and additional information like that. Another useful method is called mirroring. The idea behind mirroring is to basically duplicate the web server so you can actually test it out and probe for any kind of vulnerabilities. The process of scanning is looking at the web server in more detail to find out what available ports or services there are. Session hijacking is another technique in which the attacker will take over the connection that's been established between a client and the server. And lastly, we can rely upon password hacking to access and to hack into a web server. Let's talk about that first part, information gathering. There's some different tools that you can use that will allow you to get information about a web server. First of all, there's a couple websites. For example, whois.net is a website that can provide some basic information about a web server. In addition to that, alexa.com is a good resource. Let's see an example of alexa.com. So here's alexa.com's main website. If you scroll down, you'll see a section where you can type in a URL and then click on the find button. If you do that, you'll get information about that website. It includes some basic information, for example, how popular that website is. Globally, CNN.com has a ranking of 91. Within the United States, has a ranking of 18. You can also see who normally connects to that website. So you can see that a total of 64% of all network traffic comes from the United States for this particular website. And there's other statistical information you can use to find out information about how that website works. In addition to the general information you get from whois.net and alexa.com, there's other general information you get from news groups that are related to the company whose website that you're trying to attack, and also news site information as well. You also can gather account information either by looking at social media, so search Facebook for people who work at the company that you're trying to attack, or through forums. Next, let's talk about footprinting tools. Remember, the idea behind footprinting is to get more information about this website so we can find the vulnerabilities that we can attack. One tool that's good for providing some basic system information is Telnet. Typically, when you Telnet to a machine, it provides you what they call a banner, which gives you basic information about that machine, possibly the operating system, for example. Another great tool is called Nmap. Nmap will probe for open ports and services on a machine. So you might find the web server itself is not very vulnerable, but there is a service that's running on the web server that is more vulnerable. There's a nice little tool called IDserve, which will examine your web server and provide information about it. Another similar tool called HTTP Recon. It does several different types of footprinting tests. There's even a web-based footprinting tool called Netcraft. Let's take a look at that. So you see here we're at netcraft.com, And let's type in cnn.com as the website that we want to get information about. And if we do this, we can see several bits of information. First of all, it breaks down the web server cnn.com into subsites. For example, we have money.cnn.com, edition.cnn.com, and for each one of these, I can see a site report where I can get more information. I can see how long that's been up and running for. I can even see what type of operating system that we're dealing with as well. So let's just look at money.cnn.com site report. So you see here, we can see basic information about this. We can find out, for example, the IP address. We can find out who owns this web server. So this might be a way of figuring out who I can gather more information about. I can see the hosting history of it, security features. I can even see, if I go down below here, some information about what type of client-side technology it uses. So you can see it uses JavaScript and jQueries. I can see that it has an RSS feed. That might be another possible hole that I can exploit. So there's a lot of good, useful information about this web server that I can get from here. The next thing we're going to talk about is mirroring tools. Remember, this is the idea of taking the contents of the web server and copying it to your own system so you can probe it for vulnerabilities. It's important to also point out that you want to make use of what we learned through our footprinting tools as well. And the idea behind that is making sure that we not only mirror the content of the web server, but we also mirror the web server as well. So try to find out, for example, what type of web server it is, what kind of features it provides, and other things like that as well. So when we create our mirrored web server, it mirrors the original web server as much as possible. As far as copying the content is concerned, there's a great little utility called wget, which is designed to just pull down entire websites. Another one that's good is httrack. rsync is also fairly popular on Unix and Linux systems. Black Widow is another very popular one, and a good one as well is called webcopier. You also may want to try some vulnerability scanning tools, including Scan My Server, Sakura, Detectify, Web Inspector, and Site Guardian. Now there's several different hijacking tools for hijacking a session. We're going to talk more about these in detail in another video, but just to give you a general idea, we have cross-site scripting tools. This is actually when you inject a client-side script to be viewed by other users. Sidejacking, which is stealing session cookies by sniffing the communications between a client and server. Fixation, which is when the attacker sets up a connection between itself and the server and then encourages the user to make use of that connection either through an email or web link. This way the attacker can then take control of the session after the user is authenticated. And then also malware can be used to steal session cookie information as well. Let's talk about a couple of hijacking examples. One's referred to as Firesheep. This is a Firefox extension that's designed to intercept cookies from sites like Facebook and Twitter. There is a tool called the WhatsApp Sniffer. It's not really a web-based tool necessarily, but it is an Android app designed to sniff messages between users that use the WhatsApp application. And then also Cookie Cager. That's a sidejacking tool that can be used for penetration testing as well. Last thing we're going to focus on are different hijacking tools. Again, we'll see more of these in detail when we talk about hijacking sessions in a later video series, but you should be aware of tools like Firesheep, Cookie Catcher, Wireshark, Burp Suite, and JHijack. Now let's talk about countermeasures when it comes to the process of hacking web servers. Now let's talk about maintaining patches. First thing you want to make sure you do when you maintain patches is create a patch schedule and follow it. Also, make sure you research patches before you apply them. Make sure that the patches won't cause problems with other parts of your web server. Always make sure you back up all data before you apply patches. And it's a good idea to test out patches in a non-production environment first. In fact, it's a good idea to test out anything you do on your web server on a machine that's a mirror image of your web server. So if you install new applications, you add more features to your web server, you want to probably do that in a non-production environment. And then once you make sure it works in that environment, then apply that in your production system. And then lastly, make sure you have a backup plan. So if something goes wrong, you want to have some way of easily replacing what you did with something new. Let's talk about some general policies of securing your web server, starting with protocols. You want to make sure, first of all, you block unnecessary ports and services. Definitely avoid using any insecure ports like FTP and Telnet. They're considered insecure because they send data in plain text format, not encrypted. And speaking of which, you probably always want to make sure you use tunneling and encryption protocols as much as possible. In regard to user accounts, disable any unnecessary user account on your system. I'm not just talking about web service accounts, I'm also talking about local user accounts as well. So if your web server resides on a Linux machine, make sure you disable as many of those Linux accounts as you possibly can. Make sure that all the account passwords are strong passwords, not easy to guess or to break with a brute force attack, and only run a process with the least required privileges. In regard to files on your web server, make sure that you disable services that provide directory listings, and also move all files unrelated to web services into a secure directory. Now, as far as monitoring the web server is concerned, you want to make sure you monitor the web server for any change in files, especially configuration files. One of the tools you can use for this is a tool called Website CDS. It's a good tool to see if any files have changed. And on IIS-based web servers, use a tool called URL Scan. URL Scan is a tool that will prevent potentially harmful HTTP requests.
Let's talk about the concept of a DMZ, or a demilitarized zone. The idea here is we have this external network, which is maybe representing the internet, and we want to have people get into things like our web server, our FTP server, or a mail server. In order to be able to do that, we want to have a firewall to block the unsavory elements to the web server, FTP server, and mail server. So the firewall is designed specifically for that. It'll be a less stringent firewall than our internal firewall, which is going to have even further blocks to prevent people coming through the demilitarized zone into our internal network. So we're going to have more strict rules on the external firewall outside of our DMZ zone, and in the inside part of the DMZ zone, we'll have more strict firewall rules to prevent full access into our internal network.
In regard to response splitting and cache poisoning attacks, make sure your software is always up to date. You can use web vulnerability scanning tools to test to make sure that they're not vulnerable to response splitting and cache poisoning. Also, make sure that your applications use unique IP addresses. And when you get user input, so when the client sends data to the server, don't allow any of those carriage return or line feed data. Some general policies on your web server: always pay attention to permissions on your files and directories. Bad permission might allow someone to place a file, for example, on a folder or a directory and start serving up content. And there's a lot of other permission issues that you might get files deleted, for example. Make sure you audit your system. Now, what I mean by auditing is make sure you audit your log files to make sure that there aren't unauthorized accesses to your system. Look very carefully for any type of probing attacks by looking at your log files. Make sure you utilize session ID tracking. Try to make this machine that's your web server as standalone as possible. In other words, don't have your web server also be your FTP server, for example. Make use of access control lists. Also, be really careful when you choose scripting on your web server. Scripting makes your web server more powerful, but also makes it more vulnerable as well. There are a variety of different types of scripting languages you can utilize: Perl, Python, PHP, JavaScript. If you do have to pick a scripting language, I would recommend just trying to pick one and stick with it. It's easier to secure one scripting language versus many scripting languages. And lastly, make sure that you have a secure database as your backend. For this next lesson, we're going to focus on patch management. Let's go through some basic patching policies. First of all, make sure you always apply patches to a test system first. You also probably want to create a patch schedule, so how often you'll implement the patches. Really critical one here is to sign up for notifications. Now, even though you're going to have a patch schedule, there may be some patches that come out that you want to apply right away. There are certain patches that have to do with security that if you don't apply them right away, your website will be vulnerable for a period of time. So if you sign up for notifications for all the software that you're using on your web server, you'll be notified when an emergency patch needs to be implemented. It's also a good idea to use a patch management tool. Instead of trying to manually install the patches, patch management tools make it a lot easier, and they also provide normally ways of backing out of patches so you don't have to try to manually do that yourself. And also, if you get a patch, always make sure you verify the source before installing it. That might actually be a rogue patch that you got from somewhere that would actually cause more security problems than solve. Now, as far as patch tools are concerned, there are several different tools you can use to patch your system. As with all cases when I talk about tools in these video classes, keep in mind there are a lot of tools out there. I'm just showing you some of the more popular and highly regarded tools, but you probably want to do some research on your own, figure out what makes sense for your particular situation, so whatever web server you're using, and probably also whatever software platform you're using as far as the operating system is concerned. Those are going to be key components when you choose a tool. So the following tools are for patch management. There's one called GFI LandGuard, Secura CSI, MAAS 360 Patch Analyzer, Security Manager Plus, Prism Suite, and lastly, Microsoft's Baseline Security Analyzer. In this next section, we're going to talk about different security tools that you may consider using if you want to protect your system from an attacker trying to hack into your web server. Now, first of all, I want to point out that with tools, you always want to be aware of the fact there's multiple tools out there. The best thing to do is explore and find other tools like the ones I'm about to talk about right now. So the first type of tools that you want to know about are scanners. And let's first start talking about one utility called InScan. So for those of you working on a Windows-based platform, InScan is a good tool that does port scanning. Another scanner you may consider is the Saint scanner. It's designed to scan for both TCP and UDP services on a service. It also, once it finds a service open, it has a nice little feature where it launches an additional set of probes to figure out what other kind of vulnerabilities it might find on that service. A good example would be something like if it probed and found an FTP server up and running, it might try to do things like log into the FTP server using anonymous access. Or if it finds a web server port open, it might try to probe and find out what other services the web server provides as well. So it's great for getting sensitive information, not just on what services and ports are open, but what really those services and ports actually provide. Another great tool is InStalker. So InStalker actually will probe a system looking for vulnerabilities, open ports, and features on that web server. So as far as compliance is concerned, there are a couple of interesting tools that you may want to look at. One is called NetID Secure Configuration Manager. It is a configuration assessment and compliance tool. It's an automatic solution that's designed to make sure that there are no issues as far as your policy is concerned regarding security on your web server. Retina CS is another compliance tool. It also can work as a patch management tool and a reporting tool as well. You also may look into some testing tools. One really good testing tool is called HP Web Inspect. It actually looks at not only your web server, but also web applications, looking to see if there's any type of vulnerabilities on that web server. And lastly, another good testing tool is W3AF. It's designed also to look at the web server as a whole, including web applications, and to try to determine if there's any type of security holes or vulnerabilities. Now let's talk about penetration testing when it comes to hacking web servers. The first thing you need to do is identify the type of system that you're trying to hack into. There are several different ways you can go about doing this. You might be able to use some social engineering skills. You may be able to query whois databases. You also might be able to get information from internet user groups, things like that. The next thing you want to do is probe the system, try to find out its weaknesses. So you may want to look to see what type of ports are available on that system.
You may want to do some website crawling using the different tools that we talked about in this lesson. You want to enumerate web directories, perform directory transversal attacks, and then after you gather all the information, you can figure out what type of attacks that you want to perform from that point. So you may want to perform like a man-in-the-middle attack. You may want to use some other type of exploit on that web server. Now that you've gathered all the information, you can figure out what test and what probe and attack will work the best. Now let's talk about penetration testing when it comes to hacking web servers. The first thing you need to do is identify the type of system that you're trying to attack into. There are several different ways you can go about doing this. You might be able to use some social engineering skills. You may be able to query whois databases. You also might be able to get information from internet user groups, things like that. The next thing you want to do is probe the system, try to find out its weaknesses. So you may want to look to see what type of ports are available on that system. You may want to do some website crawling using the different tools that we talked about in this lesson. You want to enumerate web directories, perform directory transversal attacks, and then after you gather all the information, you can figure out what type of attacks that you want to perform from that point. So you may want to perform like a man-in-the-middle attack. You may want to use some other type of exploit on that web server. Now that you've gathered all the information, you can figure out what test and what probe and attack will work the best.
Welcome to Lesson 13, Hacking Web Applications. Applications that users interact with through a web browser can provide a great deal of functionality, and much of the code is exposed, as it needs to be interpreted by the browser. This provides several paths of exploitation. In this lesson, we'll be looking at techniques to find and exploit these vulnerabilities.
In this next section, we're going to talk about attack vectors and threats when it comes to hacking web applications. So let's start talking about the different types of vectors of approach when you want to attack a web application. One vector is unvalidated input. So the idea behind this is when we get data from a client, it's possible that data might be poisoned by the attacker who has added some data in there to perform tasks that we don't want to perform. Another vector of attack is called form tampering. Now this is based upon a manipulation of parameters that are exchanged between the client and the server. So when a server provides a form for the client to fill out, that information could be captured and modified. Usually this information is stored in cookies or hidden form fields or possibly even URL queries as well. Another technique that we've talked about previously is directory transversal. Remember, that's the technique that we can exploit the capability of moving up the directory structure to a location on the file system which normally the web server should not be able to access. Another vector of approach that attackers could use to attack web applications is misconfigure the web application. And lastly, a popular vector of attack is cross-site scripting that we've talked about previously as well. Let's talk about injection. This provides the attacker with access to the back-end part of the web application. This could either be a shell command, or it could be an operating system call, or even more likely, access to a database through a database command. Typically, the attacker is able to do this by introducing data as part of a command or a query. There are several different types of injections that you should be aware of. One popular injection type when it comes to user accounts is something referred to as an LDAP injection. LDAP stands for Lightweight Directory Access Protocol. It's a means typically used on Unix and Linux systems to store user account data and authenticate user account data as well. Sometimes it's connected with a web application so that user accounts don't have to be stored in the web application's location, but instead on a back-end LDAP server instead. We also have the capability of a file injection. In this case, what's going to happen is the attacker will inject a file into the operating system. That file could be used to launch some type of scripting code, whether it be PHP-based or Perl or Python or some other scripting language. XML injection is an attack technique used to manipulate or compromise the logic of XML or an XML application or service. the injection of the unintended XML content into the XML message can alter the intended logic of the application, because applications normally use XML to specify how they run. An XPath injection is related to an XML injection. It's a technique to exploit applications that construct XML path language queries from user-supplied information. So when it tries to query the XML data structure, the XPath injection type could alter the way that the query is performed. An OS command injection is when you have the web application run a command in the operating system that the web server is on. And again, this is something that could provide access to the attacker. They can access the backend and get information about the operating system, possibly even information about user accounts on the operating system as well. HTML injection is an attack that's very similar to cross-site scripting that we've talked about previously. With the cross-site scripting vulnerability, the attacker can interject and execute JavaScript code. With an HTML injection attack, only the injection of a certain HTML tags is utilized. And the last injection type, and one that we're going to spend a lot of time on in future videos, is called SQL injection, often referred to as SQLI. This refers to injecting commands or data into an SQL or database query. There's some additional types of attacks that you should be aware of for web-based applications. For example, there's an attack that we refer to as a CSRF, one that we discussed in previous videos of this course. This is a cross-site request forgery. Web applications can also be vulnerable to denial of service attacks. The idea behind this is that if we can make it so the web application can't respond, then we've effectively prevented someone from using the web application, and that's what a denial of service attack does. Typically, this is a result of multiple machines or multiple queries just hammering away at that web application and just preventing it from responding to any valid query. Another attack that you should be aware of for web applications is called cookie poisoning. Cookie poisoning is a modification of the cookie, that's the data that's stored on the client side, to gain information about the user that's performing the operation on the web server. This can be used to steal the identity of that user and allow the attacker to use the credentials of that user to perform actions on the web application. Another attacking method you should know about is called session poisoning. This is similar to cookie poisoning, but in this case, we exploit input validation by inserting invalid data. We've already discussed session fixation in the topic on web server hacking, but session fixation can also be done with web applications. The idea behind this is the attacker sets up a session between itself and the server or that web application, and then it encourages the client to make use of that session. And the next type we have is one called buffer overflow. So a buffer overflow, the idea is that we might be able to get the web application to accidentally overflow into another memory location and access another program's memory. And that can cause problems with the system and allow unintended access, particularly if the other memory that we're flowing into has elevated privileges, like maybe it's running as a root user, for instance. There are also storage-based attacks. We're trying to access the data storage on the web application. There'll be attacks that are based upon error handling, the transport layer of the web application, trying to redirect the web application to go to another site and not the client site. CAPTCHA, which is what you've seen when you go to a website to verify that you're a human by typing in some characters that you see on the screen. That can also be attacked. And then the authentication process itself of the user can also be attacked when we're talking about web-based applications. In this next lesson, we'll talk about footprinting and specifically focus on how footprinting works when we try to attack or hijack a web application. So the methodology of footprinting when it comes to application hijacking consists first of the footprinting process itself. And again, that's when we gather information about the application to figure out exactly what it does and what its vulnerabilities might be. Then we want to analyze that information, determine where the weaknesses are that we can attack. We also probably want to try to attack the authentication process, and then also possibly attack the session process, the session IDs. The next step is we want to probably try some injection attacks like script injection, SQL injection, XPath injection, things that we've talked about in the past. We can also try to do a database attack to try to access the backend database. Might even try to attack the client-side connection. And then lastly, we may want to attack associated services. So we may find that we really can't get into the web application directly, but that machine also has other services that are available, and maybe through those web services such as SOAP or RDF, we can connect to that system and compromise it. So let's get into footprinting basics a little bit more. First thing we want to do is determine what type of server that we're dealing with. So even though we're going to be attacking the web application, knowing as much as we can about the web server is going to be very useful and important to know. And there are several tools that we've talked about in previous videos. One of them you can use is the Whois lookup. The alexa.com website is a good one as well. So the next step, we want to discover what kind of web services are available. So one way of doing that is by using the tools that are based on DNS interrogation. And then after that, we want to extract any kind of server-based information. And one way of doing that is by using port scanning tools that we've talked about in previous lessons. We also want to focus on hidden content. Hidden content is anything that's not viewable by a visual web link. We can discover this information by brute force probing attacks, by using a utility like, for example, like the Burp Suite utility. We can also make use of a tool called spidering. This parses HTML forms, JavaScript, and the idea behind it is it not only will find the files that are visible, but by spreading out and following links, it can find more information. Those links are inside the HTML forms, the JavaScript, maybe even some XML files as well. And again, we can use Burp Suite for that. There's also a nice tool called the Mozilla Web Agent Builder. In the next lesson, we're going to talk about hacking web servers, which is a discussion we had before, but we're going to focus on the idea of hacking web servers in conjunction with hacking web applications. So recall in the previous video that we talked about the process of hacking methodology, and this included the process of footprinting. And footprinting is not only footprinting the web application, but also footprinting the web server itself. And so there are several tools that you may want to consider when you're trying to footprint the web server for the purpose of attacking a web application on the web server. Some of the tools that you want to be aware of that you can utilize. Nessus is a vulnerability scanning tool. It's also a web application scanner, so it has the benefit of not only probing the web server itself, but also probing the web applications that run on that server. And it's also good for searching for sensitive data on the server as well. Another tool that can be really useful is HP Web Inspect. It's a tool that we've talked about in previous videos, but just realize that it's not just for checking to see if the web server has any vulnerabilities, but it's great for web application security testing as well. One of its features is that it simulates hacking techniques and also provides analysis of web applications and services as well. And a third tool that you should be concerned about when you're trying to footprint the web server is the Web Vulnerability Scanner. It also is a vulnerability scanning tool. It also does web crawling. We talked about that before. That's the idea of just looking at all the possible files on that web server and building up a master list. And it can gather that information either by using hidden field data, links, or JavaScript code. And it also performs a variety of web service testing as well to probe to see if the web services have any kind of flaws or vulnerabilities. So the next lesson, we're going to focus on the next step of hacking web applications, and that'll be trying to hack the authentication and authorization system. So keep in mind that we've already talked about footprinting and analyzing the information that we get from the footprinting step. Now let's talk about the next step, which is trying to hack or attack the authentication protocol. So there's several different types of methods you may want to utilize to find that weak spot in the authentication process. One is user account names. So account names are part of the two-piece puzzle that you need to know in order to be able to authenticate on a web server. The other thing that you need to know is the passwords. So commonly used usernames and poor passwords can make it easier for us to attack a web application. We've also talked about previously that cookies are a place where information is stored, and sometimes that includes user account and passwords or other authentication information. And another technique we can do is attack the sessions themselves. So let's talk about enumeration. Remember, enumeration is the idea of getting more finite information. In this case right here, we want to focus on user account names. And one way we can go about doing this is looking at the contents of error messages. Like for example, if I try to log in through a web application and I get back an error message of user unknown, well, that's one piece of the puzzle that I have now that I didn't have before. So what I could do is use some kind of brute force technique to continually try different usernames until I get messages that don't say user unknown. So as a result of that, I can build up a list of valid user accounts on that system. And again, that's one half of the two pieces of the puzzle we need to hack into a system using authentication. Another one that we might get back as a mirror message is account R exists. So again, this is good for me as the attacker because I can see what accounts exist on the system and which ones don't. This normally appears when you try to create a new account. So when you create a new account and you specify an account name, it comes back and says you can't use that name, it already exists. We also might get a message of invalid email. So emails are normally associated with accounts. In fact, in some cases, they're used in place of accounts on web services. So if I get this message, I know that that's not a valid email, and I can try other emails to see if they actually work. And last thing we have here is the idea of the message that you get new passwords sent to your email. This is what normally shows up when you try to recover a password. So when you ever go to a website and you don't really know what your password is, it says you want to recover that password. You normally type in your email address so it can send you a password recovery technique. In this case, if I get back the message that a new password has been sent to the email, now I know that that email is a valid one for that system, and I could try to start attacking that email by using a brute force password guessing technique. So the other thing that we should be aware of is the fact that the use of common names can also be a possible vulnerability on web applications. The concept behind this is that common names, such as Bob and Ted and admin and user, are very popular to use on web applications. So if I know that as an attacker or hacker, I can test those names out first and not have to worry about really complicated names like Bob 127-said. And that goes hand in hand with the idea of a brute force attack, in which I'm really just trying to guess what kind of usernames are available using a large dictionary of usernames that I've generated. Now, as far as passwords are concerned, there are several different techniques that we can use for enumerating passwords. One is just simply guessing the password. We can also make use of common passwords. For example, I might have an admin account with a password for the admin of admin PW. We can try a brute force attack. Also, we can make use of the feature of change password. So you may have seen this before where you want to change your password and there's a link for that. So you type in your current password and your new password. We might be able to use that to get some information about what the password might be. And lastly, there's a technique that you see in a lot of places called Remember Me, in which when you click on that option, what it does is it stores information inside of a cookie in your browser. So if I'm aware that as an attacker, I might be able to compromise your browser security and get that cookie and then get the user account and password as well. Speaking of which, as far as enumeration of cookies are concerned, we can make use of stolen cookies for not only gathering user and password information, but also script injection, eavesdropping so we can watch the kind of traffic that's going between the web application and the web client. We can make use of tools like Burp Suite to do this. There's another one called Z Attack Proxy that could be really useful as well. So in this next lesson, we're going to talk about session management attacks. So again, remember we've already gone through footprinting, analyzing the data that we get from footprinting. We've talked about attacking the authentication protocol. So now we're going to talk about the session attacking method. So there's a couple different methods you should be aware of. One method is called token generation. For this, we can use prediction, which requires us to sniff the network and determine what the possible next token will be. We're going to also make use of a feature called tampering. The idea behind tampering is we're going to modify the token to force a reset and then steal that new token to access the system. In addition to token generation, there's another method referred to as token handling. In this one, we can make use of session replay. We've talked about this before, where with session replay, that means that we've already seen an established session and we wanted to make use of that session again. Maybe the client's no longer using it anymore, but us as the attacker can take over that session. Session hijacking, when we literally steal an active session between the client and the server. And then lastly, a possible man-in-the-middle attack. In this next lesson, we'll talk about database connectivity attacks. So again, a reminder, we've already gone through the footprinting and analyzing phases. We've talked about attacking the authentication process and also session and injection techniques. Next, we're going to focus on the data or the database section. So just an overview to begin with here. Web applications often connect to a back-end database software. The information provided by that software may be sensitive. It may include information about an application, including user account information and password information or other sensitive data. And the purpose of attacking the data connectivity is to steal the data, block access to the data, or to modify the data. First thing you should be aware of is different types of database software. While they all communicate in a similar fashion, they do have different commands that you may want to be aware of. So you may want to look into how Microsoft SQL works. MySQL is another popular database software. IBM's DB2. Oracle has an extremely popular software. The SAP Sybase software program and the ADA BAS software program. Let's just mention a few different methods. We will have an entire video lesson later about SQL injection and other types of database attacking ideas, but one thing you should be aware of, very common technique, is something called a connection pool DOS. So as a denial of service attack, the purpose behind a connection pool DOS is really to block access to the database, not necessarily to steal information or modified information. The way this works is that a connection pool is a cache of database connections maintained so that connections can be reused when future requests for the database are required. The problem with this is often there are a limited number of connection pools, and so a denial of service attack is when a large number of SQL queries are performed, taking up all the possible connection pools. When that occurs, there's no way that we can connect to that pool as a valid user. Another technique you should be aware of is called connection string injection. The purpose behind connection strings is to pass in information into the database in order to be able to authenticate the user to be able to access the database. So when it connects to the server, it may connect using some kind of information like the server, the database that we want to connect to, the user ID number, the password. And with connection string injection, additional information could be added on. For example, we could add on that it's a trusted connection. This typically happens when the information that's coming from the client side is not validated and sanitized, and so we can perform an injection and add some more data in there. Or we can also make use of something called a connection string parameter pollution. This is similar to connection string injection, but instead of injecting new parameters, what we do instead is just modify existing parameters. Like in this case, I'm trying to access a database called my database, but we could inject or pollute that information with a different database name, and so we can connect some other information instead.
Hi, this is Nick. I'm going to give a demonstration of using the Metasploit framework to exploit a vulnerability on Windows XP. So I have these two virtual machines running, WinXP and Kali. They are right here, and they are on the same network so they can talk directly to each other. So let's go ahead and verify that. We see 192.168.56.102 for Windows, and over here in Kali, we see 56.101. So they should be able to talk to each other, and they can. That's good. So from our previous network scanning, we should have discovered this host and saw that it was a Windows XP host. But let me go ahead and run that here. I'm going to scan 102, that Windows host. And what we're looking for is something that might be vulnerable. So from the output that we're going to get from Nmap, we see that the SMB service is available and open, and this is Windows XP. There's a well-known vulnerability in SMB on Windows XP, so let's go ahead and try to exploit that. We'll start up the MSF console. That's Metasploit Framework console. The first thing we need to do is specify which exploit we're going to use. So we're going to use exploit Windows SMB MS08 Net API. You can use the tab key to autocomplete so you can type a little bit faster. Show options. Let's see what's available to us. So we have rhost, rport, and SMB pipe. The last two already have settings as default. So we need to specify rhost. So let's set rhost 192.168.56.101. That's the Kali computer. Now we want to specify the payload that's going to be delivered to the Windows machine. Set payload Windows Meterpreter reverse TCP. Show options again. Now we see our payload options is missing the lhost option. So let's set lhost to 192.168.56.101, the Kali machine, and let's set lport to 8080. And take a look at those again. We can see that they're now specified. We have the remote host is 56.101, localhost 56.101. Our host is incorrect, so let me go ahead and change that. 192.168.56.102. All right, now we're looking good. So we have remote host 102, localhost 101, local port 8080. Now we simply do exploit, and it'll connect to that remote host, try to exploit the vulnerability, and we see session 1 was opened. So now we're connected to that machine and we can do a lot of stuff. So let's go ahead and hit question mark and take a look at some of the commands that are available to us. Come up here towards the top. So there's several core commands we can execute. Load is for Meterpreter, run is also for Meterpreter, and we'll take a look at run here in just a moment. Some file system commands, networking commands, we can take a look at the interfaces on the machine. System commands, we can execute stuff, we can run a shell, get desktop, we can get a screenshot of the desktop. If there's a webcam available, we can record what that webcam sees. A lot of cool stuff. See hash dump here, so let's go ahead and run hash dump. So we can get a dump of the SAM database, run this through oafcrack, and get the passwords for these accounts listed on the left. Let's run sysinfo. You can see it's Windows XP Service Pack 2. It's in workgroup. ipconfig. We can get all the interfaces on the machine. Now let's run a shell, and we can see that we have shell access. Let's go ahead and go to Documents and Settings, NIC, Desktop. Looks like there's a file error, type file.txt. It says hello, echo, back at ya, redirect to file.txt. Come over here on Windows, take a look at it, back at ya. Let's hop out of the shell. There's one more thing I want to show you, and that is you can actually run VNC on that remote host and get access to the desktop. If I do run VNC, VNC stands for Virtual Network Computing. So it's actually going to start up VNC on that remote host and then open a VNC viewer to that remote host, which is pretty handy. Now with the mouse emulation that's going on here in VirtualBox, I can't move the mouse. A little defect, but if you were running this on a proper laptop, booting to native Kali and Windows was running where you would expect it to, then you'd be able to interact here. You can see that it's reflecting what I do on the right over here in Kali. So that's Metasploit and exploiting Windows XP. It's very quick and easy to do. There's a whole bunch of exploits available in Metasploit, so take a look around and have some fun.
So now that we learned about some techniques that are used to hack web applications, let's talk about some security tools to enhance the security of your web application. First of all, you should be aware of these vulnerability scanners. One really popular one to utilize is NetBrute. It is a port scanner, but can also include techniques to do brute force attacks on username and passwords on an HTTP authentication server that's using basic authentication. There's also Secure Bat, which is a generic and modular web vulnerability scanner. It's kind of similar to a port scanner, but it automatically analyzes websites with the aim of trying to find any kind of exploitable SQL injections or XSS vulnerabilities. And we also have the OWASP, which is really an online community, stands for Open Web Application Security Project. And not only does it have great content as far as how you can make your web applications more secure, but also contains some tools and techniques that you can use to secure your system as well. There are several different tools you can download and install on your system to test out the security of your web applications. Now, as far as full auditing and testing is concerned, one great tool to utilize is Watcher Web. It's a penetration tester that passively finds web-based application vulnerabilities. Another one you might want to be aware of is NetSparkler. They claim to be the only false positive free web application scanner. All you have to do is point it to your website and it'll automatically discover any kind of flaws that will leave you seriously exposed. And another one you should be aware of is Skipfish. It's an active web application security reconnaissance tool. It's designed to prepare an interactive sitemap of the targeted site. It does a recursive crawl and dictionary-based probes. And it provides a map for you when you're all finished so you can see the possible points of weaknesses. Some additional tools that you want to be aware of: X5S is a good tool, Spike Proxy, Rat Proxy, the Website Security Audit Tool, Vampire Scan, and InStalker, a tool that we've seen in the past. So one more thing you should consider is the idea of using web application firewalls. Now, I want to point out this is a little bit different than your typical firewall. A web application firewall is an appliance or server plugin that filters incoming connections based upon rules that are designed to protect any type of HTTP connection. Typically, these rules cover common attacks such as cross-site scripting and SQL injection. So if you customize these rules to your application's needs, you may be able to block a lot of these incoming connections. Some other ones you want to be aware of include WAF Red. And by the way, WAF stands for Web Application Firewall, so you'll see that term used in a lot of these tools. Vultr Web Application Firewall, Mod Security, Shadow Daemon, Cloudflare, EasyWAF, Dot Defender, the Barracuda Web Application Firewall, Armitize Smart WF, FortiWeb Web Security Appliance, Mycona Security Application, and the Cisco AC Web Application Firewall.
In this next section, we're going to talk about some penetration testing techniques for hacking web applications. The first thing you want to do when you're testing this out is probe the system. So use different techniques to get information about the system from the outside world. Things like search engine probing, looking and seeing what types of web apps are available on that system. That could include things like probing for open ports. Could also include looking for error codes that you might get back when you try to access those web applications. You may also want to probe the files and directories that are available on that machine. Look closely at the source code. So when it serves up code, you can actually look at the source code and get more useful information there. And also, most web-based servers have a robots.txt file that might provide some useful information as well. Once you probe the system and gathered all that information, the next thing you want to do is do some more in-depth testing of the system. This could include things like TSL/SSL attacks, looking again at the source code for more useful information. You may want to determine what types of file extensions that web application utilizes. There might be some weaknesses there. You also may want to probe for some old files. It's not uncommon for web servers to have older files from older versions of the website, and they may have some vulnerabilities that the newer files don't have. You may want to try to gain administrative access, not just to the web server itself, but to web applications running on the web server. Often a new web server will have an application that has a default username and password for the admin account, so you may be able to test those out. And then also try different types of HTTP methods to test the system out. The next thing you want to do is probe the authentication process itself. So obviously, if we can gain access and authenticate ourselves to the system, we can gain
more useful information and probably even bypass any type of security protocols for that particular web application. So you can focus first on using a cache. Also, a lot of times CAPTCHAs will allow you to gain access to your system. And then certainly a type of password reset might cause an access breach. Next thing we want to do is focus on session management. If we can take over someone's session, that will actually allow us to have more access to the environment. So take a look at the cookies, make use of session fixation techniques, and also make use of the session variables as well. The last thing we want to do is test data validation. This could include any type of cross-site scripting attacks, any SQL injection attacks. We can also do HTML-based attacks, XML-based attacks, CGI-based attacks, and any type of back-end type of attack as well.
Welcome to Lesson 14, SQL Injection. Most web applications use some form of database on the back end to store user data. Through crafty manipulation of the web application, we can sometimes interact with that data directly. This lesson will dig into the most common methods of injecting our own malicious SQL code into our database. In this next lesson, we'll go through an overview of SQL injection. Let's first talk about what SQLI, or SQL injection, is. The purpose of SQLI is to have the attacker execute some type of malicious SQL statement on your database. These statements are often referred to as malicious payload, and they're used quite often to either bypass user authentication, retrieve data from the database, modify the contents of the database. Sometimes they're also used to deface the website because the database often contains data that's displayed on the website. Or they also might be used to gain access to the operating system or even the file system on the machine that the database is being stored. There are several different types of data that are vulnerable when SQL injection is used. Basically, any type of data that's inside of your database could be accessed if the SQL injection technique is valid and it works the way the attacker planned on it working. For example, your database typically has some account information, usernames and passwords that are used either by your web server or possibly by web applications. It's also possible that you might have some private information, some trade secrets that are stored in your databases. Especially if you have a database that's really designed to be used internally within a company. Keep in mind that those databases could be a target for an attacker. If they gain access to your internal organization, they should be able to attack your internal web servers as well. The same kind of idea goes for customer information. The customer information may not be available on an external-facing website, but an internal website, you may use some type of web-based application to keep track of customer information. So that information could be vulnerable as well. Sometimes you'll have in your databases some personally identifiable information or some intellectual property that also might be vulnerable. And of course, you have other sensitive data that might be vulnerable as well. In this next lesson, we're going to focus on attacks that make use of SQL injection. And we'll begin by talking about different categories of SQL attacks. There are 3 categories in total. The first category is referred to as a first-order attack. And in this attack, the intent is to directly insert the payroll into an SQL-based command. And by doing that, the code that we add is automatically executed instead of having to be stored for a future date inside the database. And that's the purpose behind a second-order attack, is the code or the payload is inserted into the database and not executed immediately. And the purpose behind this is we have some kind of application we want to execute that code, maybe some type of web application, or maybe even something that the web server itself does. So that code is going to be placed in the database for that other application to execute. And the third type of category we have is called a lateral injection. With a lateral injection, we're going to make use of an implicit call to a function called toChar. The idea behind the tochar function is it'll convert data into a text format. It's a very commonly called function whenever someone has some user-based data that they want to convert into text. And by using a lateral injection technique, we can have some data manipulated by the tochar function that wasn't intended to be manipulated. Let's talk about different types of SQL attacks, starting with pseudonomy. The idea behind this type of attack is to inject parameters into conditional statements. And the goal behind this is to evaluate the conditional statement as true, even though that wasn't the intended result of the statement based upon the original data being sent in. This is often used to bypass authentication methods. So for example, maybe the user is provided with a dialog box where they're supposed to type in their username and their password. And maybe they type in for a username Bob and a password of Bob Pass. If that's what they type in, then the resulting SQL statement may look like this. We're going to do a select star from users where user ID equals Bob and password equals Bob Pass. The idea behind this is we're going to try to select any record in the user's table where the parameter of user ID is equal to the value of Bob and the parameter of password is equal to Bob Pass. And that should only work if there really is a entry in the user's database that has a user ID of Bob and a password of Bob Pass. If instead of typing the username and password of Bob and Bob Pass, the attacker types in the following: A quote or quote 1 equals 1. They type that in for the username and for the password, then the resulting statement is changed now. So instead of actually looking for a user ID of Bob, we're looking for a user ID of A or 1 equals 1. And instead of looking for a password of Bob Pass, we're looking for now A or 1 equals 1. And the key behind this is the statement A or 1 equals 1 is a valid statement. It means true. So that means it'll match every single record in the user's table and return back all the results. So we're basically saying where user ID is some kind of true value and password is a true value, that's going to select every single record inside of that user's database and return back all that information. By using that return information, we can now find out individuals' usernames and passwords. Another technique that can be used is an illegal or logically incorrect query. This is not really designed to get direct information or to immediately attack the database, but more to get information about what type of database it is. So we're going to use that information for some kind of future attack because, again, knowing the different type of databases that we're dealing with is going to be really useful. Different databases accept different types of commands. So we're going to inject an illegal query, and the resulting error that we get should indicate to me what type of database we're dealing with. So if we get some kind of prompt or dialog box like this, and then we provide some illegal information. This is illegal information because it has a quote, the double quote at the very end that doesn't have a matching value. So if we provide that information, we may get an error message like this: incorrect syntax near AAA, unclosed quotation mark. And then based upon how that error message appears in the return page, I may be able to figure out what kind of database that I'm dealing with, because the different databases have different ways of responding to these illegal or incorrect queries. Another type of SQL injection that we can do is called a union query. In this case, what we're going to do is interject in a union select statement some code. And the result is that we want to return additional data from a second table. So the data is going to be merged together with the code that we provide with the union select statement. So here's an example where we have a simple select statement. We say select the date value from the results table, whatever title equals trees. So basically just finding any kind of records where title equals tree and returning back the value of date. If we insert into that a union select statement where we're asking for all of the usernames for the account where name equals Bob, we're going to get back information about that system, including the user and name that matches Bob. Another technique that you should be aware of is called a stored procedure. The idea behind this is that there are some procedures or some code that's built into the database. This is often provided by the software or database vendors. Typically, it requires knowing the database type, but we just talked about a few moments ago a way we can determine what type of database we're dealing with by providing some illegal or logically incorrect code. So once we have that information, What we could do is add on to a valid SQL statement some kind of procedure that we want to call. In this case right here, we'd have to know the name of the procedure, but again, we can figure that out based upon what type of database software engineer we're dealing with. There are a few other methods that you want to be aware of. These are quite often used in conjunction with the methods I've gone through so far. One of the methods is called an end-of-line comment. The purpose behind this one is at the end of our malicious code, we don't want to add or allow any additional code that might mess up our code. So what we can do in this case right here is add a dash at the end of our malicious code. That'll disable any legitimate code that follows afterwards. Another technique we can use is called a time-based method. With a time-based method, we're making use of an inference SQL attack. So remember, the inference SQL attack uses the tochar function that's built into SQL. We can do multiple branches with something called a wait for statement. A wait for statement actually pauses or waits for an operation to finish before it continues on to the next operation. So we can determine based upon the response time what's successful in our SQL injected code and what's not successful. And the last technique we have is called Boolean exploitation. This is also an inference SQL attack, taking advantage of the tochar function that we talked about earlier. We're injecting some statements that are designed to be returning back either a value of false or true. And then based upon that, we'll be able to tell if the injection itself was successful. In this next lesson, we're going to talk about the methodology that's used by attackers during SQL injection attacks. Let's first focus on the attack steps. The first step, and in some cases the most important, is to gather information. It's really important here that we find out several bits of information before we try to do any kind of SQL attacks. Included in this would be to find out what type of web server that the database is hosted on. Different web server types will make a difference as far as how I perform the attacks. And keep in mind the web server itself might be the one that's communicating with the SQL server. So it's important to understand what web server we're working with, whether it be Apache, the Google web server, Microsoft's web server, or whatever. In addition to that, we want to gather information about what kind of web applications are using the SQL server. And then, of course, really important to find out what sort of SQL server we're working with. Then we want to launch some simple attacks. The simple attacks are designed to gather additional information. We may be able to gather information about user accounts that are available on the database. We also might be able to find out things like what kind of commands are accepted by the database and which commands aren't accepted. And then lastly, we launch our advanced attacks. This is when we actually do the harm that we intend to the SQL database or get all the nitty-gritty information that we want from the database as well. So as far as gathering information is concerned, that first step, the first thing we want to do is probe the web application or the web server to determine what type of database connection we're dealing with. Second thing we want to do is list SQL-based fields, and then also try to use SQLi to generate some errors. We talked about some of those techniques in the previous video and how we can generate errors to determine what type of database we're dealing with. We also want to inject string data where numeric data is requested. The reason behind this is really twofold. Number one, we want to find out whether or not the database server is going to accept string data in numeric situations in the first place. If it does, it provides yet another way we can hack the database server. The second thing is we want to see what kind of error message we get back if it does have a problem with string data in numeric fields. That error message might give us some idea on how we can further attack the SQL database. Next thing we want to do is try to attempt to use a union operator and then make use of all the gathered information that we have to plan our next attack. Let's talk about error messages for a moment here. The error messages are designed for several purposes. One is to determine what type of database engine or database software we're dealing with. We also can use this to determine what functions are available. Not all functions will be available in all databases. And then what type of acceptable commands we can utilize as well. We can use this to determine the data types and also the data structure of the tables in the database as well. Next thing is going to focus on simple attacks. Simple attacks can include union statements that we talked about previously. Making use of stored procedures to do a stored procedure injection attack. Again, we talked about that previously as well. We might be able to bypass logins by using techniques that we had previously discussed. And we also might make use of something called a blind SQL injection. A blind SQL injection is really just any kind of regular attack that you have, but it's blind in the sense you can't actually see the return error messages, because instead of actually using the return error messages that the SQL server provides by default, the SQL administrator has changed it so it provides some custom information as well. So the custom information may not be as useful for me, so I consider this to be a blind SQL injection because I'm not really getting back the output I'm hoping to get. But if you use this in conjunction with a timed attack, it can be useful to find out what's going on in the database, even if you can't really see the result of your SQL queries. And last thing we have here are those advanced attacks. We can use attacks that provide data enumeration. Remember, data enumeration is just basically getting as much information as we can from the database. We can use an advanced attack to create accounts, to gather passwords of existing accounts. We might also be able to execute operating system commands, and then possibly even access the file system and make changes to files on the file system. Now let's turn our focus to some SQL injection tools. So with all tools that I talk about in this course, remember, I'm just showing you some of the basic tools that you should be aware of. There are literally dozens of tools that you could use, but if you get started with the tools that I provide you and then explore some additional tools, you should be just fine for the Certified Ethical Hacker exam. The first tool we're going to talk about is called SQL Map. So SQL Map is a Python-based utility. It's an automated tool that's designed to insert injection flaws. Nice thing about it is it supports multiple different types of databases. In fact, most of the tools that I go through do support multiple database types. Another useful tool is called SQL Ninja. This is a command line based tool. It's designed to gain you remote access to the database. As you can see by the menu that you see on the right hand side, it's got different functionality like enumerate user information. You can also get information about your tables and rows and columns and the data inside the table. It can also be integrated with another tool called Mega-Exploit. Another useful tool is Safe3 SQL Injector. This tool has the advantage of being a graphical-based tool. I know some people are not as comfortable with the command line tools like the last two were. But this graphical-based tool can be used to automate the process of hacking into an SQL-based database. One of the nice features is it supports both HTTP and HTTPS sites. So if you're going through a more secured site, you're more likely to be able to get information using the Safe3 SQL injector. And it does support multiple authentication methods as well. So some additional tools that you may want to spend some time looking into include SQL Pat, SQL Git, BSQL Hacker, Dart Jumper, HaviJ, SQL Brute's a very popular one, Pangolin, SQL Power Injector, and lastly, Marathon. So now that we've learned different types of SQL injection attacking methods, let's now turn our focus to SQL injection defense methods. To begin with, let's just focus on some general policies. We'll focus on first a really important one, which is how to handle error messages. The best thing to do is just turn off the default error messages. As we talked about before, error messages are a key way that someone using SQLi attack methods can determine what type of database that they're trying to hack into. So you definitely want to turn off the error messages or possibly even use customized error messages instead. Another thing that you want to be concerned about are the authentication policies. Start off by making sure you filter any kind of input data. As we talked about before, a lot of times people will use additional data or data that actually is designed to trick the SQL commands whenever they're requested for a username or password. So we want to filter that data really carefully, remove any invalid data before running SQL commands, and also monitor all access attempts. So obviously, if we see someone trying to log in using the same username and different passwords over and over again, that's going to be a problem. I should also point out before we go on to accounts that a lot of times the web applications will have some kind of technique to limit the number of login attempts. If you don't have that feature enabled, you should probably enable it. It's a really good one to have to make sure someone can't use a brute force attack to try to access your web server or your database server. The next thing we want to talk about are the accounts themselves. So we want to make sure we limit database access for the accounts. Make sure you only provide the access that's really required for those accounts. Also make sure that you run operations as much as possible with non-privileged users. Don't have a lot of operations run as the SQL database administrator. Disable any unnecessary access to the operating system. That's one big vulnerability is if you have your database run a bunch of operating system commands, those could be hijacked and taken advantage of. And also avoid any calls to the file system. All the data should be stored inside the database itself. It's extremely rare that you'd have to grab some data from an external data file, so just try to avoid making calls to the file system. Now, as far as handling the SQL data itself, so when you get data either based upon user input or from other source, first thing we want to do is make sure we verify all the data for the size of the data and the type as well. Reject any type of comments. Remember, the comments are the ones that are --, any binary data, and also any escape characters. Escape characters can cause confusion in the commands that are executed, and they may result in things like displaying error messages or running unintended commands as well. Make sure you properly test all the string values that are passed in through the string variables. Make sure they are strings, and also make sure that they don't contain any kind of weird character sequences. Also, don't use application data to create transact SQL commands. Now, the last thing we want to talk about is how to secure web applications themselves. Obviously, we can only do so much with our database. We also want to make sure the web application or the web server is not performing operations that we don't intend to perform. So to begin with is in the configuration files or settings, there are different security settings normally for web applications. Make sure you use the really strict settings if at all possible. Obviously, you need to balance this with the access on the database that you require. So it may require a little trial and error and testing to make sure that the settings work the way you need to and are the most secure as possible. We also want to limit access to application-specific accounts. Perform regular penetration testing, and ensure access to sensitive data is limited. This actually goes back to making sure that different user accounts are used to access different sets of data. Always use hash passwords, for example, SHA-256 password, and also use data access extraction layer and type safe parameters. In this next lesson, we're going to focus on SQL injection detection tools. Let's start with a really popular one called .defender. Some of the features of the .defender program include the fact that it supports multiple platforms. It also designed to find not only SQL issues, but also vulnerabilities in the web applications themselves. And on top of that, it works really well as a web application firewall. So it's a multi-purpose tool. You can see it's a nice graphical-based tool as well. Another really popular utility that can be used not only for SQL injection testing, but also other types of penetration testing is called Snort. Some of the features behind it, it's a very easy to use program. It does real-time intrusion detection, and it can also be configured to display SQL injection attempts. Another tool that you may want to be aware of is SQLi X project. This is a Perl-based program. It scans for SQLi injection vectors. It also can be used to identify the back-end. It discovers a bunch of different types of SQL injection vulnerabilities. And yes, I know it's an older tool, but it actually still is pretty functional. So again, whenever we talk about tools in this class, there are a bunch of tools that are available besides the ones we talk about. You may want to explore some additional tools, including the SQL Block Monitor, SQL DICT, InStalker, which is a tool we talked about in several different places in the class so far, the Web Vulnerability Tool, IBM Security App Scan, NGS Squirrel, WSSA, another tool that we've seen in previous parts of this class, HP Web Inspect, and then also Green SQL.
In this next section, we're going to talk about penetration testing as it relates to SQL injection. So the first and most important thing for SQL injection testing is to identify what type of database that you're dealing with. Once you do that, you can try different types of injection techniques. And then once you determine whether or not those provide any kind of useful information, you could take those results, review the information, and determine how you can further compromise the database.
Welcome to Module 5, Wireless and Internet Security. This module will be covering 802.11 wireless attacks, as well as Internet perimeter security with firewalls, intrusion detection systems and honeypots, cloud computing, and cryptography. Welcome to Lesson 15, Hacking Wireless. Wireless Internet access is everywhere these days, in both homes and coffee shops, restaurants, libraries, etc. Many users will hop on any wireless network they can to avoid cellular data charges. This module digs into attack techniques and vulnerabilities that exist in today's wireless LANs. All right, a quick overview of wireless LANs in general. WLAN, or wireless LAN, is Wireless Local Area Network. It's an IEEE standard. It's the 802.11 standard. It's been around for quite a while, since the late 90s, starting with 802.11b in 1999. As prices have come down, the prevalence of wireless access points, not just in homes, but also coffee shops, restaurants, things like that, has increased quite a bit. There's options there for small office, home office, as well as enterprise scale solutions. So the majority of enterprises these days are deploying wireless networks, even to the point where they're preferring it over wired Ethernet just to save cost. So there's quite a big footprint of wireless out there, and quite a bit of opportunity for exploitation. Here's a quick diagram of what wireless looks like as far as SOHO versus the common enterprise type. On the left here, what you'll normally see with these SOHO wireless access points is that they act as a router, in that the wireless side of the device is a layer 2 bridge domain, with the default gateway for that bridge domain, that layer 2 network, being the access point itself. So usually what you'll see is it'll have a few LAN ports, as well as a typically labeled WAN port, where you would plug it in the WAN port towards the internet, and then those other 2 or 4 wired Ethernet interfaces are actually part of that same layer 2 network that is being offered on the wireless LAN side of things. And then on the enterprise side, what you typically see is that they are true wireless access points that simply act as bridges from the air or the RF space into the layer 2 broadcast domain. So those wireless access points are an extension of that layer 2 switched VLAN, with the default gateway being provided by some sort of routing device, whether it's the switch itself, if it's a multi-layer switch, or a purpose-built router plugged into that switch to provide access upstream, not necessarily towards the internet, but up north. And in the end, it's still IP. So once we get onto the network, we have true access to the network, then it's still just IP. We can still launch the same attacks. We have access to the same devices. It's just like a wire, assuming we can actually get onto the network. So in this lesson, really what we're talking about is how to get access to these wireless networks. Several different common standards are out there. There's much more than this, but these are the common ones that vendors have adopted and put into products. 802.11b was that original one back in 1999, offers 11 megabits of bandwidth. BGN are typically what you'll see in routers that are sold today, in that they provide the functionality of B, but they also support G and N. 802.11a, it only runs in the 5.8 gig band, so you don't see that as often, but laptop manufacturers that have integrated wireless are now more commonly supporting 802.11a. And 802.11ac, up and coming, very high speed, all in the 5 gigahertz band. Some terms you need to be aware of when looking at wireless LANs. The SSID is the Service Set Identifier, and that's simply the name of the wireless LAN. So when you click on available wireless networks on your laptop, whether it's Mac, Windows, Linux, whatever the case may be, you're going to see a set of names there. Those are the SSIDs for various wireless LANs in the area, whatever your laptop can see in the air around it. It's the method of distinguishing wireless LANs in the same space. It's a 32-byte field, and it's often human readable, but it doesn't have to be, which is interesting. So you could put, if you were able to configure a wireless access point to have non-printable characters, as long as it's still 32 bytes, then it'll work. You're going to have some frustration for your users, but the capability is there. Basic service set, this is the BSSID that you'll often hear referred to. It's basically the MAC address of the access point itself. So if you have a wireless LAN with several access points, maybe on different channels, then the BSSID would refer to an access point within that same wireless network. Graphical representation of what we just covered, wireless LAN SSID down at the bottom refers to the wireless LAN, and then the BSSID is the access point's MAC address environment. A couple different modes for wireless networks, infrastructure mode versus ad hoc mode. Infrastructure is what you commonly use when you're getting on the internet with your Soho wireless router. You are connecting to that access point with infrastructure mode, and other clients can connect to that. Ad hoc mode is a peer-to-peer method of connecting two devices that aren't necessarily routing that traffic. So if you have, say, two MacBooks and you need to transfer a file between them, ad hoc mode could be used, and they would both join that same ad hoc network and be able to talk to each other. Security algorithms are where we typically target attacks on wireless networks, because the vulnerabilities that exist in these algorithms allow us to, if we are able to break the encryption or get access to the key, then we can join the network. And from that point, like I said earlier, it's still just IP. So once we get access to the network, once we get past any web encryption or WPA, then we have access to the network and we can launch our attacks on devices either on the same wireless LAN or past the access point. Some antenna types to be aware of. You'll typically see omnidirectional antennas on the SOHO access points. And if you look at the actual radiation pattern of the RF for an omnidirectional, it looks kind of like a donut with the antenna vertically in the middle of it. Typically with the dipole antennas, you won't see them look like what you see on the screen here. But what they'll do is they'll take the dipole antenna and put it into that rubber casing that you see in the omnidirectional example. For directional antennas, there's a couple different options there, parabolic and Yagi. Both of these are pointing towards something. So you'll have much greater signal coming in from the front of the antenna and much less at the back and sides of the antenna. So if you're sitting on a boat in San Francisco Bay and you point a directional antenna at downtown San Francisco, and that antenna has some amount of gain, then you'll be able to see a whole bunch of networks. Whereas with omnidirectional in the middle of SS Bay, maybe not so many. Now we're going to get into some of the options for encryption on wireless networks. Several different acronyms out there, and we're going to touch on most of these in this presentation. WEP, WPA, WPA2, and then the protocols you see at the bottom half of the screen are being used by these other protocols, WEP, WPA, and WPA2. Starting off with WEP, it was in the original 802.11 standard in 1997. It's a stream cipher, so when we get into encryption or cryptography at the end of this course, we'll talk about the difference between stream ciphers and block ciphers. Just understand here that WEP uses the RC4 stream cipher. There's this thing called an initialization vector that is sent in every packet that flows across the network. And capturing these initialization vectors, if you were to find a reused IV, then having two of them together increases the probability of you being able to actually crack that WEP key. The folks that did the statistical analysis of these IVs and when they actually found the vulnerability, they realized that there's a 50% chance that you'll see duplicate IVs within 4,000 frames flowing across the network. So if you're trying to capture traffic for a WEP network so that you can get those duplicate IVs, it's possible to actually inject traffic. so that you can capture it and get the key using some of the common tools that are out there. There's two different flavors here, WEP40, also called WEP64, and WEP128, also called WEP104. And it really comes down to the size of the key. Both of them use a 24-bit initialization vector, and then WEP40 has a 40-bit key, and WEP104 has a 104-bit key. So you might remember the days of having to type in those 26 hex digits when you were joining a WEP network. That was using WEP104, also called WEP128. I'm not going to run through this process here, but I wanted to bring it up just to show you, as well as point to this reference document from NIST.gov that shows how WEP works. This document also talks about the vulnerabilities associated with WEP and provides some really good information on the inner workings of WEP. The vulnerabilities in WEP were found pretty early on after its release. WPA was created in 2003. It was created because the prevalence of WEP was making those wireless networks vulnerable. WPA was created as a stopgap, basically, until WPA could be ratified in 2004 as IEEE 802.11i. WPA, the original version, uses TKIP, that's Temporal Key Integrity Protocol. It's still RC4, but they put a much longer initialization vector in there. WPA2, it's an IEEE standard, and it uses Advanced Encryption Standard. The encryption protocol AES uses something called counter-mode cipher block chaining, and WPA certification is required for new devices that are certified as Wi-Fi compliant. This means if you want to call your device Wi-Fi compliant, it has to be certified, and you have to conform to WPA2 in order to get that trademarked name applied to the box of your product. A couple different methods for WPA. There's personal and enterprise. Personal uses a pre-shared key. There's no user authentication, so the wireless LAN itself will know what that pre-shared key is. When you join that network, you have to provide that shared key, and then they will exchange temporary keys, and off you go. The enterprise mode for WPA will do user authentication, where you type in a username and password, and that uses extensible authentication protocol. EAP authentication uses Radius on the back end in order to provide that actual user authentication. The protocol used from client to server could be several different flavors of EAP. But what I'm showing here on the screen is the process that's going on underneath the covers when you type in that username and password. You can see that it's pretty in-depth just to get the client onto the wireless LAN. It's quite a bit more secure having to go through this various steps in order to get on the network rather than sharing a key with all of your users. As I mentioned, there are many flavors of EAP out there. LEAP is one of the more popular ones, that's lightweight EAP. And then we have several other options that you can go take a look at, including one that uses pre-shared key. Here's a comparison of the various Wi-Fi standards out there. WEP, again, RC4, Stream Cipher. WPA adopted that, WPA being that stopgap to WPA2. You'll notice in the upper left, I have a legend there. Red is bad, green is good. So WPA has AES as its encryption, which is very strong. We have dynamic session keys with WPA and WPA2. Key distribution can be done automatically. And then for authentication, we have 802.1x and EAP to provide true user password authentication. So what's wrong with WEP? There's a few things that are wrong with it. Everyone uses the same key. It's a complicated key. You have to remember either 10 or 26 different hex characters, and that has to be entered. So if someone leaves the company, what do? If you have a large company, then you have to redistribute a new key. Everyone has to type that in. It's very annoying. The initialization vector size is only 24 bits, so that it gives us 16 million possibilities for that single WEP key. It has this underlying problem of reusing initialization vectors. Once enough packets have passed, as the IV gets reused, that's when things become vulnerable to cracking the actual WEP key. And there are some initialization vector values that are considered weak. The ability to inject frames to make the initialization vectors collide is possible. So let's talk about actually breaking WEP. At the bottom of each of these blue boxes, I have a command. These are all part of the AirCrack suite of tools, which is kind of the de facto standard for breaking into wireless networks. So first off, we're going to put our Wi-Fi interface on our system, the actual NIC, into monitor mode using AirMon NG. We'll capture frames. We'll filter on the SSID that we care about with AeroDump. And I talked about injecting frames in order to cause an IV collision. We can do that by flooding ARP requests using AI replay or air replay, however you prefer to pronounce it. And then finally, once we've captured enough data, then we can use AirCrackNG to actually look for those IV collisions and crack the key. For cracking WPA, there's something called a pairwise master key that is known to both the client and the access point. And in order to get into a WPA network, you have to capture this handshake that occurs that includes this message integrity check. That MIC value can be brute forced. So you're not going to see the same IV collision and very quick cracking of a WPA network. But what you can do is if you can sniff that network and you can capture that MIC, then you can brute force it using a dictionary file or true brute force where you're actually going through each value that could possibly exist. Now, there is also the possibility that you're watching the network and nobody's joining the network, but there are existing clients there. There is a functionality called deauth that can be used to kick a user off of a wireless network. So if we send a deauth to get that user off the network, they have to then rejoin, which will require that handshake to exchange between the user and the access point. So then we can capture it. So we can force that authentication to occur so we can capture the MIC. I have some commands here on the bottom of the screen on how to actually crack that WPA password, capture the handshake with Wi-Fi, remove some excess data, convert it to an HC cap file. This is a hashcat capture file using AirCrack, and then crack it with CUDA hashcat. So what can we do to protect ourselves on the wireless network? Don't use WEP. This has been a standard best practice for many years now. Probably 10 to 12 years has been the recommendation not to use WEP. Go with WPA2. It's been around for quite a while. Everyone supports it. You might as well use it. Use complex passphrases because in order to crack WPA, you have to capture that exchange of information and then brute force that message integrity check. The longer the passphrase is, the longer it will take to brute force and the more secure you are. Only use AES CCNP, don't use TKIP, simply for the higher security that you get with CCNP. This is often recommended not just for wireless networks, but for any network where you have sensitive data, you can move up to a higher level of encryption, such as IPsec, to secure the actual data itself from host to destination. Let's take a look at some of the threats that exist in today's wireless networks. Really what the attacker is trying to do is to evade access control, whatever that method of access control may be. Several different options for doing that, such as spoofing your MAC address. Misconfigured access point, this is where we're taking advantage of an access point that's been deployed to provide wireless services, but the administrator of that device may have configured it incorrectly or just used it straight out of the box. Ad hoc networking is taking advantage of a device that has created an ad hoc network, maybe on purpose or maybe not, and you're able to join that and maybe access the device that's running that ad hoc network. And rogue access points, we'll touch on that as far as putting in an access point where it doesn't belong, basically. With respect to threats to integrity, this is all about forging controller data frames to get access to the network. These common methods we see on the screen here, such as initialization vector replay, injecting frames into WEP, replaying data that we've previously captured. Radius replay, this is replaying authentication so that we can get access to the network. Injection of data frames, and replaying EAP, again, to get access to the network. Threats to confidentiality. So we're talking about the CIA triad here, if you're familiar with the CISSP certification. Confidentiality, integrity, and availability. When it comes to the confidentiality side of that triangle, these threats are there. Man in the middle, a honeypot access point, the cracking of WEP to get access to the encrypted data, session hijacking, evil twin, which is basically creating another access point that looks like a valid access point, and just simply eavesdropping the network. If it's an open network that's not using encryption, and simply capturing that traffic, you'll be able to see the data and maybe get some good info out of it. On the availability side of the triangle, that CIA triad, several different threats exist. Denial of service, deauth, which I touched on in the previous section, where we can kick somebody off of a wireless network that would remove availability from that user. Disassociation attacks, similar to deauth. flooding of beacons, or even the physical threat of somebody stealing an access point is a threat to availability. So what is a rogue access point? I put it into picture here because it's a lot easier to understand what's going on. You see the rogue device over there on the left. It's plugged into the same switched network that those other access points are connected to. The point here is to get a valid client to connect to your rogue access point. If you're able to get them to do that, then you can see their traffic post-encryption. So as it's coming out of the wireless access point, you can actually see it after it's been decrypted. So that's what rogue access point is all about. I have a note here at the bottom of the slide. Strict enforcement of access port access control policies can prevent this. So if your switch administrators are very strict about what's going on the network and what can be plugged in, you can avoid this from occurring. Also, we touched on port security in a previous lesson and the max number of MAC addresses that could exist out of a switch port. Because this is a true bridged wireless access point, then you would see multiple MAC addresses coming into that switch port, which shouldn't happen unless there's a valid access point plugged in there. So that switch port security maximum MAC address option can give you some protection against rogue access points. I mentioned misconfigured access points. Often when people are deploying wireless networks and maybe they're not very deep into the information technology field, they will make some assumption that the SSID of that wireless network is the password and then not apply any encryption to it. So when we talk about misconfigured APs, we're talking about that as well as the deployment of a device and not understanding what it does. Because access points broadcast SSIDs usually by default in those beacon frames, then it's very easy to determine what an SSID is. And if you find one that doesn't have encryption applied, you can hop on and get access to the data that's flowing across the air. Ad hoc connection attack. This is joining an ad hoc network that another device has created. If you are able to join it and it's not using any sort of encryption, or rather if you have already broken that encryption, then this is all about getting access to the device that is creating that wireless network and then using it as your point into whatever other networks it happens to be plugged into. So I have the word infected here, and this is just an example of perhaps we joined the ad hoc network, we were able to exploit some vulnerability on that wired client that had the ad hoc network created, and from that point we get access to the rest of the network. The honey spot attack, I won't say it's common, but it's very easy to do. Just an example of this would be taking a wireless access point, just a SOHO wireless router type device, and configuring it with an SSID of, say, McDonald's. And then we drive to a McDonald's parking lot, and we sit there and we wait for people to connect to us. Several different restaurants and coffee shops today are offering free Wi-Fi so they can keep people in the store. A lot of people, they want to avoid cellular data charges, so if they see an open wireless network, are more than happy to join it. So just by very simply putting the same SSID on an off-the-shelf access point can lead to some divulgence of user data. MAC spoofing. If you've ever flown on a flight with Wi-Fi that's charging $30 for an hour to use it, you might have considered this. Simply sniffing the air for somebody who's already paid for it and then impersonating them by using their MAC address. It's a pretty simple thing to do, but if there's timeouts on the user authentication or if they're using it at the same time, you might run into issues with two MAC addresses on the network. So wait for them to take a nap, use that MAC address that you captured earlier, and off you go. The deauth that I've been referring to previously is this deauthentication packet. This is where we can actually kick somebody off of a network in order to capture that MIC exchange or that message integrity check value from the authentication exchange. And I have an example here of using Air Replay to do that. The -01 switch will say, Air Replay, I want to do a deauth attack. Here's the access point I'm targeting, and here's the client I want to deauthenticate. And then ensure that you're actually dumping the packets from the air at the same time so you can capture that exchange of information. The deauth flood here. So previously, this one that I have above deauthentication attack is a single deauth. If I put a 0 in there, then it will just consistently flood. So this is an attack on availability. I'm kicking a user off consistently, or several users in this case. Jamming. This is kind of hard to do in the United States because you need to get access to a device that's purpose-built to do jamming. And what it's really doing is flooding the air with RF to disrupt the valid Wi-Fi RF in the area. And it is very much illegal. If you are a contracted penetration tester or even not, don't do this, basically. This screenshot I have on the right, this is an actual screenshot of me surfing the internet. And so these devices do exist out there, however, they are illegal. Let's take a look at some of the methods used to attack wireless networks. So first let's touch on wireless footprinting. It falls into two different buckets. First being passive. This is where we're simply sniffing the air. It's just like passive sniffing. You're just listening. You're not actively talking on the network. For active footprinting, you're sending probe requests with an empty SSID to try to find networks that are in the area. Several different tools exist to do this, and it's very easily done with a laptop. It's good to use some form of external antenna, and even better to use a directional antenna that has some amount of gain so you can see more. And of course, you'll need some software to actually get the job done. AeroDump NG, running on Linux, part of the AirCrack suite, available at aircrack-ng.org. Swiss Army knife of wireless attacks. Another tool on the right, this is a commercial tool called Insider or NSSIDer, available from metageek.com. It's a graphical tool for looking at the air that's around you for that footprinting. NetStumbler also is a tool that's been around for quite a long time. It'll scan through the available Wi-Fi channels and look for SSIDs, provide you with the MAC address, SSID name, the channel they're on. This visual stumbler on the right, VI Stumbler, will overlay these things on a map, as well as showing you all the same information that the rest of these tools do. Now what about using the device in your pocket? There's several different apps these days that will sniff the air and show you what's available, such as Wi-Fi Manager and Network Signal Info, both for Android. Wiggle is a tool that's been around for quite a while. You run an application on your device, such as Android or a laptop running any form of Wi-Fi capture utility, and you submit that information. You need valid latitude and longitude tied to those SSIDs so that they can correlate all the data and display these maps such as you see on the screen here. It's a good place to go if you're not in the area but you want to have an open access point. When you get there, you can go and research and find one available. So when you land, you can immediately hop on. With passive sniffing, you can still get a lot of good information even though you're not on the network itself. You can get names of SSIDs, the protocols that are being used, the methods of authentication. If there's multiple APs with the same SSID on different channels, then you can be aware of that information. And going back to our information database that we were talking about, all of this information should be going into that database. Tools for wireless traffic analysis. Wireshark will get the job done. It can actually interpret 802.11 frames and provide information on them. OmniPeak from Savius also has some wireless capabilities. ComView over at Tamos.com or AirMagnet at Netscout.com. Both of these will also passively gather information from the network, as well as allow you to dig into the actual data of the frames. One of the problems that you'll run into if you're using Linux for wireless attacking is the compatibility of the hardware that you're using with the actual operating system itself. So commonly you'll use a USB Wi-Fi device to interface with Linux to provide that wireless interface. But you run into compatibility issues. Drivers may not be available and you have to go buy some new hardware to make it work. This AirPCAP device, it's a commercial device offered by Riverbed. It's USB connected and it's purpose-built Wi-Fi traffic capture. It integrates with Wireshark as well as Steel Central, runs on Windows, so you can actually inject frames from a Windows device. It's a pretty neat piece of hardware. This is what it looks like. This is just a screenshot from riverbed.com. They have a couple different hardware options. AirPCAP NX, TX, do different things, but basically get to that same end goal of getting access to the data in the traffic. AirCrack NG, I've mentioned a few times. It's a suite of applications that does some really cool stuff. I've highlighted the two most important ones on here, AeroDump and AirCrack. AirDump basically grabs the raw frames from the air, saves them to disk for later cracking with AirCrack. AirMon NG on the right is also a pretty important command. because you need to put the wireless interface into monitor mode before you can actually get access to the data. Otherwise, the interface is going to filter frames that are not destined for itself. Here's an example of using airmon ng to enable monitor mode on a Linux system. This screenshot here is from Backtrack 5, also available in Kali today, straight out of the disk basically. Airmon is installed for you as part of aircrack ng. What I'm demonstrating here is that you enable monitor mode and then you start looking at the traffic. So airmon ng start WLAN 0. WLAN 0 is the name of the network interface card as far as Linux is concerned. So this enables monitor mode, and then you point an application such as aerodump ng at that monitor interface to actually take a look at the frames that are being received. MAC spoofing attack, if you recall, this is using somebody else's MAC address that's already authenticated. This is not much to do with wireless here, but these are the Linux command to modify the MAC address of the local system. Bring down the interface, change the hardware address, and then bring it back up. And now you are that person's MAC address. Again, wait for them to take a nap, and off you go. Deauthentication attack, this is the same example I showed in the previous subsection. Grouping it here because these are all wireless attacks. This is the deauthentication attack. Start monitor mode, look for an SSID, wait for a client to connect so you can get their MAC address, and then run AI replay or air replay to send the deauth. The evil twin attack, we have this laptop that's labeled as the evil twin on the side there that is going to impersonate the access point, wait for a client to connect, and then proxy the traffic for them so that they can get access to that data. First off, you enable monitor mode, look for an SSID, wait for a connection, and then you can also use aircrack ng suite to create a soft access point with the SSID that you specify as well as the channel that you specify. So this is creating a true software-based access point using the wireless card in your laptop. Once you have that soft AP running, deauth that client that you saw connect previously, bump up the transmit power so that your access point is preferred over the other one, wait for them to rejoin, and then launch an attack such as man in the middle with Ettercap, where you can actually take a look at their data as it's flowing across the network. You'll need to make sure that you're bridging their traffic to the intended destination, otherwise they'll just jump off thinking that the network's not working. Rogue access point, very simple to do. You simply plug in an access point to the network and wait for someone to connect and start watching the traffic. I do have a note here that you can use a soft access point as well, using the command we saw on the previous slide with airbase ng to create that rogue access point. Cracking WEP, enable monitor mode, look for an SSID, capture a whole bunch of frames off the network. Once you've captured enough packets, feed it into aircrack ng. Aircrack ng will look through the entire capture and try. If it can't, it'll tell you to keep gathering data and try again later, basically. If we want to speed things up, if there's not enough traffic on the network, we can do that. I purposefully chose the text size that you see on the screen here because steps 1 through 3 and 7 are the same as the previous slide. We're injecting these 3 steps in the middle where we actually inject traffic into the wireless network in order to cause more initialization vectors to be captured. For cracking WPA, we have a couple options. Wi-Fi is kind of an all-in-one solution. You simply run Wi-Fi, it's included in Kali, select your wireless device, and hit enter. What it's going to do is it's going to start listening and looking for a handshake. If it sees that handshake that includes the MIC, if you have a dictionary file specified, it will try to crack that password to join that network. Aircrack can also be used to crack WPA passwords to get you into that network. Starting off, as always, enable monitor mode, look for an SSID that you want to target, capture the packets to file, the --write WLAN.cap on the right-hand side of the screen will actually write the contents of those frames to disk. While you're capturing those frames, send a deauth, and then use aircrack and feed in your capture file to look for the captured handshake. Provided it's found, you can run that capture file against a word list to try to determine the passphrase used to join that network. I'm going to give a quick demonstration of cracking WEP using aircrack. So up on the screen here, I have 2 windows. These are logged into my Ubuntu system at home. Inserted into that Linux system is a little USB wireless adapter. I think I got it for about 10 bucks. It's not expensive to get this job done. The tools that I'm using here are all part of aircrack. If you use the Kali Linux distribution, they're pre-installed. I've installed them here prior to this demonstration. So I have two windows up because I'm going to be doing some things simultaneously. First thing I want to do is take a look and make sure that the card is there. Here it is, wireless LAN 0. That's the interface I'm going to be dealing with. Airmon NG, if you run it without any options, it'll show you that interface just so that you can know what you're going to be interacting with. So the first thing I want to do is enable monitor mode on the interface itself. I do that with Airmon NG start wireless LAN 0. And we see this output right here, monitor mode enabled on Mon 0. So now if I rerun that previous command without any options, we can see we now have two interfaces. Mon 0 is the one that I'm going to care about. If we now rerun iwconfig, we can see that for our original interface WLAN 0, mode is managed, and for Mon 0 up here, we have mode monitor. The monitor mode is what we need to actually capture the traffic. So that's good. Next thing I want to do is take a look at the air currently, and I can do that with aerodump-ng mon 0. This is that monitor interface that we just created. Let me make this a little bit bigger so we can take a look at what's going on. You'll see up in the upper left that it's cycling through channels, grabbing frames, parsing them, and continuing the process. If you hit spacebar, it'll pause the output. The one that we're going to care about for this demonstration is the only WEP-enabled device out here. So I created this purposefully for this example. You'll notice that everyone else is using WPA. This is quite a bit more common these days, but WEP networks do still exist. So this is going to be the target of our attack, this wireless access point called NIC test, using the SSID NIC test. So let's grab this information and keep it. All right, we'll resume our output. So now we know what we're going to be trying to attack. So let's go ahead and start with that. So if we take a look at the information that we saved from that output, this column right here is the channel. Now, the way monitor mode normally works is that it's going to keep cycling through those channels. What we'd like to do is lock it in on channel 1 because that's the channel that our access point is using. And we want to see all of the frames that are flowing across channel 1. So in order to do that, we're going to stop our previously created monitor mode with airmon ng stop mon 0. And we just have our single device there. And I can run airmon ng start WLAN 0 and say 1, which is channel 1. So now we have monitor 0 created and it's locked into channel 1. So the next thing I want to do is test injection. I know that this is the MAC address of the access point that I'm going to be working with. So I'm going to test injection to that MAC with this command here. Air replay -9 to test injection. E, this is the ESSID or NIC test. A, this is the MAC address of the access point I'm going to be attacking, and this is the interface that we'll be using to send the traffic. And very simply, we see that injection is working right here. So everything's working great. Next step is to start capturing traffic. And we do that with aerodump on channel 1. BSSID, this is the MAC address of the access point. The write command, that was that -- write that I showed in the previous example. We'll say NIC test 2. And finally, the interface that we're going to use. So here we are. We have just a single access point is found because this is what we told it to do. We're on channel 1. A whole bunch of beacons are flowing, and here's the SSID that we care about. Next up, we want to associate with the access point. And we associate with it so that it will accept the frames that we're going to inject. So we're going to fake authentication so that we don't get denied. I have this command previously saved. I will copy that. We want to keep our dump running. That's why I have two windows up here. And here's the command we're going to use. You have to ensure that the MAC address that you use as the source is the correct MAC address. So this EC1A, we have to take a step first in that we find out our local MAC address. If config WLAN 0, this is our local MAC address of our wireless interface. So this needs to be used in the next command that we're going to run. So air replay -1 0. This is the fake authentication. This is the SSID we're connecting to, the access point's MAC address, our MAC address, and the interface that we'll be using. So we have successful authentication, and you can see that 3 data packets were captured, now 4. So that's good. We're seeing some data, we're authenticated, and eventually when this number hits about 5,000, then we can run it against AirCrack. So because it's going up so slow, let's start injecting some traffic with AI replay. This is the command we'll be using. The -3 is ARP replay. This is the MAC address of our access point. This is our MAC address, and this should be mon0. So what it's doing is listening for ARP requests. When it sees a valid ARP request, it's going to replay that ARP. I don't have any devices connected to this network right now, but I did when I was testing this previously. So what I did was I captured this same example last night with several devices connected to this same wireless network NIC test. I'm going to show you the results of a previous test. So I'm going to stop this dump right here. If we take a look in the local directory for files, we can see several files are created. So this write command that I did here, it'll create 4 files for you. Those 4 files are these 2 and these 2. The capture file is the actual capture of the frames that were captured as part of AeroDump. This capture file right here is my example from last night. So once this number here in pound data reads about 5,000, then you should have enough frames to try to get to the actual WEP key. And this capture file has enough in it. So let's go ahead and run aircrack ng nic test 01.cap. It'll run through, test a bunch of possible keys, and there we go. So this is the WEP key for that SSID NIC test, 01, 2, 3, 4, 5, 6, 7, 8, 9. So the tools do work, and that is how you crack a WEP using AirCrack suite of tools. Now we're going to talk about Bluetooth and some of the attacks you may see out there in the wild. Bluetooth is a specification. It was created in 1994. Shortly after that, the Bluetooth Special Interest Group was formed in May of 1998 in order to create the standards that would surround Bluetooth. Ericsson, IBM, Intel, Toshiba, and Nokia were the initial members of the Bluetooth SIG, and now there's about 19,000 companies worldwide. The majority of mobile devices these days include Bluetooth capabilities. So what are some of the attacks that you may see out there with Bluetooth? While these do exist, I would say that they're not very common, particularly the first one, bluejacking, which is simply a method of sending a message to a person using Bluetooth. You're not going to get access to their data, but you can elicit a response. So if you want to know who somebody is, doing this bluejacking attack can let you know who is actually holding this device that you're seeing talking Bluetooth. Blue sniffing is similar to war driving with Wi-Fi, where you're driving around watching the air for Bluetooth devices. But most of the time, Bluetooth devices are portable and are moving around a lot. So creating some sort of database of Bluetooth devices may not be that useful. Blue snarfing is the actual theft of information from a device through Bluetooth. This would require Bluetooth file transfer to actually occur. Blue smacking, another term for a Bluetooth attack, is the denial of service by sending random packets to a device or just even in the air around the device to make Bluetooth stop working. Bluejacking, as I mentioned, was simply eliciting a response from somebody. You create a contact on your device. In the name field of that contact, you put the message you want to send to that person. Save it, click send by Bluetooth, pick the device you want to send it to, hit the button, shows up on the other side with the message that you wanted to tell that person. As far as what's the point that I have down here, I mentioned response solicitation. Guerrilla marketing, I personally have never seen that occur, where somebody sends a message via bluejacking just to get me to buy something. I don't think that would really make me want to purchase anything, but that is one of the possible uses of it. Some tools for Bluetooth. BT Browser. The majority of these are all about just looking at the air to see Bluetooth devices. BT Browser, Bluever, BT Audit, Blue Snarfer, BT Crawler, and Blue Diving can all be used to take a look at the air around you for Bluetooth devices. Keep in mind, as I've mentioned several times, You need to be aware that tools exist, not necessarily how to use each one of them. What can we do to defend ourselves against wireless attacks? When it comes to rogue access points, take a proactive stance. Look at the air around you for access points that shouldn't be there. Don't forget, if you're in a multi-level building and you don't occupy all floors of that building, your neighbors above and below probably have wireless networks as well. So if you're looking for rogue APs and your intent is to kick them off the network by constantly flooding them with traffic so that they can't be used, you don't want to do that to your neighbor. So be aware of what's above and below. Check the CAM tables of your switches for the organizational identifier of known wireless access point vendors. There are actually tools out there that will do this for you. They will log into the device, grab the CAM table, look at those first 6 bytes of the MAC address for OUIs of AP vendors to identify access points that shouldn't be there. Several of the wireless solution providers out there offer rogue detection capabilities, wherein you can deploy an access point that's either an access point or a rogue detection device. Some of them actually even do both at the same time. And then they report all of that back to some form of central management. So look for those enterprise solutions if you are concerned about rogues. If you do find a rogue AP and you can't necessarily find it on the floor, shut down that switch port. That'll stop people from using it, at least for the time being, while you go find it. Wireless IDS and IPS do exist. They watch the air for intrusions and can prevent if needed. Best practices for using wireless: change the SSID from the default. Don't deploy that Netgear AP with an SSID of Netgear. And remember that the SSID isn't a password. It should not be used for authentication of people, as that information is freely out there on the air. Change default username and passwords from those things. That you can go to websites on the internet to find default usernames and passwords. So if somebody does happen to get onto your network, you want to make sure that at least they can't log into the router and change settings. Disable SSID broadcast. This isn't necessarily protection. However, if there's nobody using the network, then those SSIDs aren't going to be sent out as broadcasts. There is a little bit of security that you can get from that, simply as a means of obscuring the fact that it exists. Disable remote administration from the WAN side. So if you are using one of those router access point combination devices like the Soho device, and you have that WAN port plugged into the internet to where it has an actual internet routable address on it, disable administration from that side of the device so that you don't have someone changing the settings on your access point from the internet. Filter MAC addresses if administratively feasible. So management of MAC addresses on a per device basis is extremely complicated and tedious in a large network. But if it's just you, just your house, and you know what should exist on your network, you can put some MAC address filtering there. Use WPA2, disable WEP, only use WPA2. And again, if you want to be certified Wi-Fi, your device has to support WPA2. So the majority of devices and routers out there today will support it, so please use it. Don't use identifying information in your SSID. Don't put your street address in your SSID, for example, because then people will know where that thing is located. Use firewalls, intrusion detection. Consider IPsec for encryption of the actual data that's flowing across wireless. And again, wireless intrusion detection does exist, so take a look at it. I mentioned wireless intrusion detection and prevention in the previous section. I just want to call out a couple of those options that are available. Cisco provides one called Adaptive Wireless Intrusion Prevention System, or Adaptive WIPS. It runs on their wireless LAN solution that uses controllers and access points that tunnel traffic to those controllers. It does do vulnerability assessments, over-the-air threat detection, supports Cisco access points, and also provides some compliance reporting to whatever standards you have in place. It does also include rogue detection and mitigation, which is pretty important. The mitigation part is actually shutting down the rogue device remotely. Aruba is another popular wireless vendor out there. They also offer a wireless intrusion prevention system called RF Protect that has 2 different licensing options here. I'm simply calling out the features on the left-hand column. They have rogue containment, scanning, spectrum analysis, intrusion detection, threat management, all that good stuff. So if you're looking for an IPS, IDS for your wireless infrastructure, take a look at the vendor that is supplying your wireless. They probably have a solution for you. Our real-world application penetration test of wireless networks. Again, as always, get approval from management. Let them know what you're going to be doing. Discover the networks that you might want to attack. Determine the encryption and authentication methods that they're using. Do some deauthentication with AirCrack NG so that you can capture that message integrity check that's flowing from WPA clients to access points. Use AeroDump to capture those frames and then crack WEP, crack WPA with AirCrack NG or Wi-Fi. Once you're on the network, you get access to that WEP key or WPA passphrase. Then remember, it's just IP at that point, so attack higher level protocols, other systems on the network as far as you can get to try to get to that sensitive data. And finally, document and make recommendations to management.
Welcome to Lesson 16, IDS, Firewalls and Honeypots. We spent a lot of time looking at how to attack systems, but what if those systems are behind a firewall? What if there's a silent intrusion detection system watching everything that you do? In this lesson, we'll take a look at how to deal with hosts behind firewalls, as well as some techniques to sidestep IDS systems. In this next lesson, we'll talk about the concepts behind IDS, firewalls, and honeypots. First of all, let's focus on what IDS is all about. IDS stands for Intrusion Detection System, and it's designed to analyze network traffic to discover intruders on the network or on a local system. It's used to monitor the activities of users and the system as well. And what's going to happen is it's going to flag any type of abnormal activity, and most IDS are designed to send you a message in some way to let you know about the abnormal activity. There are three components of an IDS that could be utilized. One is a network intrusion detection system, referred to as an NIDS. An NIDS will parse network traffic. Typically, it's going to be installed in the same subnet as your firewall. And what it's going to do is try to match the traffic to known attacks. And then once that happens, it should alert any type of administrators within the organization when a possible attack is recognized. Another component of IDS, very similar to NIDS, is referred to as Network Node Intrusion Detection System, or NNIDS. So it parses network traffic very similar to the NIDS, but the idea is it just monitors the traffic that a single host is getting, not the entire subnet. So the concept's the same as the NIDS, just has a different focus. The third component of an IDS is the Host Intrusion Detection System, or HIDS. So the idea behind this is really to focus on the file system structure itself, not network traffic per se. And the way it works is a snapshot is taken of the file system, and then at some time in the future, another snapshot is taken and the two are compared. So it's typically used on systems in which configuration files are not often changed, but not only can it be used to look for suspicious changes in configuration files, but also any changes to binary or executable commands. So let's talk about what intrusion detection system software looks for. First of all, it'll do scans of open ports to determine which ports might have vulnerabilities for your environment. It also looks for any types of probes from the same remote hosts repeatedly. It looks for repeated login attempts. IDS software can be used to look for missing or truncated log files. Those are indications that someone's compromised your system and are trying to hide their tracks. An IDS software can be configured to look for new files or commands on the system that might indicate that someone's compromised your system and then trying to create some backdoors. It can also be configured to look for missing files, especially key binary commands. An IDS software can also be used to monitor the system performance and report when the performance is lagging. Obviously, this might not necessarily be the effort of an attacker that's causing the system performance to lag, but that is an indication that might be attacker on the system. It'll also probe log entries to see if there's any type of unusual log entries in the log files, and it can be configured to look for changes in the sizes of binary files. Next, let's talk about firewalls. So firewalls can either be hardware-based or software-based. Hardware-based firewalls are devices that only have really one function, and that's to act as a firewall on your environment. Software-based firewalls are installed on an operating system that may have other functions as well. Hardware-based firewalls are typically a faster solution than software-based firewalls. Hardware-based firewalls may not have the flexibility as some of the software-based firewalls do. The design behind a firewall is either to allow or disallow access to a network or a port. Also, they can be configured to log attempts to access a network or a host. They can filter by any information inside the network packet header. A network packet is broken down into a header, which contains information like where the packet's destined for, where it's coming from, what ports it's using, things like that. There's also a section where the contents of the packet, which is the actual thing that's being sent to the machine that it's trying to be sent to. And some firewalls can filter based upon the packet content, but some cannot. And there's a key term that you should be aware of for firewalls, and that's the idea of a demilitarized zone or a DMZ. Basically, the DMZ is going to be a subnet within an organization, and it's going to be designed to protect an internal network from an external network. It's typically where you place your firewalls inside of your DMZ subnet. Let's talk about different types of firewalls. First of all, there's a firewall type called a packet filtering firewall. And this type of firewall just examines the packet content or can examine the packet content. It uses rules to determine what actions to take based upon the contents of the packet. A circuit level firewall doesn't examine the packet content, but really monitors those TCP/IP handshaking that we talked about to determine whether or not the connection is valid or not. A stateful inspection firewall looks at packets, but one of the things that's kind of interesting about how it looks at packets is it remembers packets that are related to an established connection. So in other words, you may have a firewall rule that blocks FTP access, which is normally on port 20 and 21. So you don't want anyone trying to access your internal network through those ports. But the problem with that is someone in your network is trying to FTP out of your network, then the response from the FTP servers may not get through your firewall. So a stateful inspection firewall can keep track of the fact that, oh, this packet is actually a response to the request from the internal request. So that way it can actually allow those packets in. The only drawback about that is it may impact the performance of not only your firewall, but also your network as well. An application level firewall does some packet filtering and some circuit level features. It can also filter on services and other properties as well. And it's pretty good security, but it has some impact possibly on the network performance. And lastly, we have something called a multi-layer firewall. It also does packet filtering and circuit level filtering, but it also allows for direct connections between local and remote hosts. And again, it's pretty good security, but it does have some impact on your network performance. The last thing we're going to talk about is a honeypot. The purpose behind a honeypot is to trap someone who's trying to hack into your system. It shouldn't have access to any other systems or data. A honeypot system should be a standalone machine that has nothing important on it whatsoever. And again, it's used to record login attempts to free up resources on a live system. By having the honeypot on a separate system, we don't have to worry about it taking up valuable RAM or CPU. It also should help limit exposures to sensitive data. And more important than anything else, hopefully confuse and discourage attackers. If they hit the honeypot, they won't get anything really important or relevant, and it might really confuse them as far as what kind of things are available on your environment. You should also be aware of a term called a honey net. This is when you have multiple honeypots that work on the same network. And in fact, one of the advantages behind a honey net is that it can further confuse and discourage attackers because you could have one honeypot that acts as a web server, for example, and then maybe another honeypot that acts as if it's a mail server that provides multiple targets for these attackers to try to attack. And of course, when they try to access those, there's really no relevant data that can be had, so they don't gain anything from it, but it discourages them and confuses them even more as far as your real internal web server or mail server. Now let's turn our focus to different firewall tools that are available. To begin with, let's talk about choosing a firewall. One thing you want to consider is whether you want a hardware-based firewall or a software-based firewall. Now, there are several pros and cons between each one. A hardware-based firewall is nice because the only thing it really does is act as a firewall. So it's a very specific type of hardware design that you don't have to worry about other processes running on the system that will affect your firewall. Is purely focused on the firewall features. The drawback about a hardware-based firewall is since it is a physical machine that you're buying, over time it may not have the flexibility that you'd want to have that a software-based firewall provides. Software-based firewalls can be more easily updated, although hardware-based firewalls, depending upon the vendor, may allow you to install some updates as well. You might want to consider also something called an application-based firewall. It's a firewall that is designed to control the data that's going to or from an application or service. It's designed to block the input and output of that service based upon rules that you set up within the firewall. It's typically also built to control any type of network traffic on the OSI levels up to the application level. When you choose a firewall, you also want to consider the background of the vendor, how long the organization has been in business for, what its reputation is as far as how strong the firewall is, and how flexible it is as well. Included in that, you may want to consider what type of support the vendor provides. Some firewalls are just free open source with only community support, while others will provide professional level support for a fee, of course. And also, how often is a firewall updated? As new features come available for firewalls, how often can you get those new features installed in your system? You also want to consider the type of firewall. In fact, this is actually probably one of the biggest things you want to consider. Is going to be a packet-based firewall, a circuit-based firewall, stateful firewall. These are all things that you really have to consider when you choose that firewall. Also, you want to focus on what type of logging the firewall provides. Obviously, you may want to look at those logs to determine what type of hacks are coming into your system. And also, those logs are really useful only when you look at them or when you get some kind of notification. So notification features can be a big issue as well. And then lastly, you may want to consider trying to find a firewall that has a good failover feature. So if something goes wrong with that firewall, do I have a way of switching to some kind of backup? Let's talk about some highly rated firewalls. Again, whenever we talk about software or devices in this class, keep in mind, we're just talking about some of the ones that are commonly used out there. You definitely want to spend some time looking into other alternatives, but this gives you a good idea of what's available out there for hardware-based firewalls as well as software-based firewalls. So the first one we'll look at is Fortinet FortiGate. It's a hardware-based firewall. You also may want to look into the Cisco firewalls, including ASA. There's a software-based firewall that you may want to look at called pfSense, and another hardware-based firewall called CyberRoam UTM. FireEye is another popular firewall utility. WatchGuard XTM is another hardware-based firewall. Sohos UTM, again another hardware-based firewall you should look at. Checkpoint VSX. And lastly, Juniper provides a really good firewall, the Juniper SRX. In this next section, we're going to talk about honeypot tools. First of all, when you choose your honeypot, there are several things that you want to consider. To begin with, determine the purpose of your honeypot. So what's your honeypot designed to do? What type of people are you trying to attract to your honeypot? Also, really pay attention to the source of the honeypot. Now, what I mean by that is there are some honeypots out there that are really not designed for your benefit. They actually might be used by a malicious attacker hoping to gain some information about your organization by providing you a tool that pretends to be a honeypot. Also, see what kind of features the honeypot provides as well. Some of the more highly rated and popular honeypots include Honeybot. This is a Windows-based honeypot, so that's another consideration you should take as well if you're primarily a Linux-based environment, then it's kind of odd to make use of a Windows-based honeypot. So consider that when you're actually choosing your honeypots as well. It's designed to simulate several different types of network ports, and it also includes an early warning IDS intrusion detection system. There's also a honeypot called the La Brea honeypot. It works on multiple platforms, and good, that's an advantage because if you're mostly a Linux environment or mostly a Windows environment, it can work on either platforms. It's called La Brea because it acts kind of like a tar pit. It's designed to attract hackers and attackers and also pull them in and stick them to your system so you can get as much information as you possibly can about it. It also watches for ARP requests as well. Google has a honeypot called the Google Hack honeypot. It works on multiple platforms. It has an interesting little focus that most honeypots don't do, and it really designed to protect against search engine hacks and attacks. It also limits the attack vectors as well. You might be interested in the Kojani honeypot. It works on multiple platforms, and it simulates an SSH server. So if that's your focus, is to try to attract people that are trying to connect to SSH servers, this is actually a really good tool for that. Happens to be written in Python, which personally I like because anything that's written in a scripting language typically is something I can go in and see exactly how it works and probably even modify it if I know how to program it in Python. I can change the way the behavior of that program works. And then lastly, there is a tool called Conpot. It works on multiple platforms. It's designed for complete protocol stack, so it's a pretty wide-ranging honeypot. And it also is Python-based, so I can go look at the code and see how it works, possibly make adjustments to it, enhance it if I want to as well. In this next lesson, we're going to focus on IDS tools. When you're choosing an IDS, there are several things that you want to consider. First of all, try to identify your security needs. Obviously, not all the IDS software is going to work for your situation, so you want to figure out what exactly it is that you're trying to monitor. Determine that the purpose of the IDS that you're considering installing actually does, and also consider whether or not it's a network-based IDS or host-based. So network-based IDSs focus on monitoring things like network traffic. It doesn't really have as much overhead as a host-based network monitor. Host-based network monitor things like local activity, not only network traffic, but also things like file system utilization, processes running on the system. So it can take a lot more time and CPU cycles as well as memory from your system. So it could have an impact as far as that's concerned. You also may want to consider an application-based IDS. They are pre-packaged solutions. They may cost more and be less flexible, but they're a very simple way of plopping down an IDS environment into your system. Also, you probably want to research the different features that the IDSs provide. As I said before, not all IDSs are equal. Some of them actually provide more features that will be useful for you. Make sure you also don't have it monitor features that you don't care about because that'll have an impact on performance as well. And then also determine what type of support is available for IDS. There's some great open source IDS tools out there, but if you're looking for support, those tools are probably not going to be the best choices simply because they don't normally have the support that you would expect from a commercial-based IDS. And lastly, this is a really important one I think that a lot of companies don't consider, and that's think about deploying more than one IDS. So different IDSs have different features and capabilities. There's no reason why you're required just to deploy one. You might deploy multiple IDSs that may all have their own weaknesses and advantages, and overall, collectively, that might provide you a better level of security than just a single IDS. Not to mention the fact that when a hacker tries to attack a system and recognizes an IDS on the system, that attacker or hacker may try to disable that IDS or circumvent it. That technique they use might work on one IDS, but not all the IDSs in your environment. So it is kind of useful to have multiple IDSs. May cause a little bit more administrative work on your point of view, but it has a higher level of security overall. So let's talk about a couple of different highly rated IDS software programs. I recommend playing around with these and testing them out, but also looking to other IDS software programs as well. One really popular one is the Cisco Secure IDS. It is a network-based IDS. Not only can it be used to scan for connections, but it can also terminate connections automatically that appear to be suspicious. We've talked about Snort a few times in this class already. It is a host-based intrusion detection system, but it's also very, very flexible. It has a lot of cool features to it. Another popular one, particularly on Linux environments, is called AID. It is a host-based and directory integrity checker. OSSec, which is a Unix-based system checker, is a popular IDS software tool. And lastly, Checkpoint provides several different IDS tools. You may want to take a look at them because they're actually probably one of the top vendors as far as IDS software is concerned. And again, they have several different types of tools that may meet different needs that you have within your organization. In this next lesson, we're going to talk about how we can invade IDSs and firewalls. So first of all, let's talk about different types of evasion techniques. To begin with, let's talk about payload obfuscation. Now, you may have heard the term obfuscation in other contexts before. For example, to create an obfuscated program is to create one that does something very simplistic, but it's kind of hard to follow the code. The code is actually quite confusing. When it comes to obfuscation for network communication, the purpose behind this is to hide the intended meaning of the communication. This could be done through encoding methods to make it look like the payload that's trying to be transported is actually just some innocuous information. Another combination of techniques that could be used are insertion or evasion. Insertion is when the end system that the packets are designed for are rejected, but the IDS the packets are being sent through are accepted. That makes it look like the end result of all the packets together are actually something different than what the end system actually receives. Evasion is kind of the opposite. The idea behind the evasion technique is that the IDS system ends up rejecting certain packages, but the packages are accepted by the end user. So the end system actually receives the full packet payload, while the IDS does not, making it seem as though some of the data is not part of the package itself. And then in other words, that information gets to evade the IDS. The third technique we have here is a denial of service attack. So we've seen DOS attacks for other purposes, like DNS DOSs, but in this case, we're talking about a denial of service that just really brings the IDS system to its knees. It just can't handle a huge, massive influx of packages, and as a result, some of the packages get through anyway. So let's talk about some payload obfuscation techniques. One thing to keep in mind is the purpose behind obfuscation is to confuse or bewilder the IDS system. So we're trying to hide the payload, and one way we could do this is through a method of encoding. This is going to be a service-dependent method, so each service may have its own method of encoding data. For example, it could be encoded in hex format, octa format, or Unicode format. And those formats themselves serve to confuse the IDS. It can't really understand what it is that it's trying to look at. An encryption technique would be any kind of secure protocol. So for example, you're using SSH or HTTPS. In those cases, the data is going to be encrypted by some technique like RSA or Blowfish, and unfortunately the IDS is not going to be able to look at those packets and see what they contain because it doesn't know how to decrypt that data. We also have a technique called polymorphism. This is providing unique attack patterns. IDSs work by looking at the network packets and trying to match a signature that has in their database, but by using a polymorphic method, which basically means a changing method. Those patterns are unique each time the attack occurs, and the IDS is not able to actually understand them, so the data is actually obfuscated. Now, as far as insertion and evasion techniques, the idea again is the IDS system won't recognize the packets as malware packets, and a couple different techniques can be used. One is protocol ambiguities, and that's setting packets that are handled differently on different hosts. So in other words, your IDS might be working on a Linux-based system, but the end system the packets are being sent to might be a Microsoft Windows system. And the way the protocol data is being handled could be different than on the IDS than on the host that the packets are actually designed to go to. So the IDS may not recognize them as a malicious payload, but they actually is when it gets to the end system. The other technique that can be used is one referred to as low bandwidth. This is actually sending data over a long period of time. And the reason why this might work as an evasion technique is because the IDS may not recognize the packets are related to one another, but the host actually does. This is also referred to as a time-to-live technique. Another one that you should be aware of is called fragmentation. This is when we break the payload into smaller separate packages. In order for this to be recognized by the IDS, the packages have to be reassembled in the correct order, and that doesn't always happen. This is also referred to as session splicing. And another technique you should know about is something called overlapping fragments. Now, this is taking data and duplicating some of the data in different packages, which make it look like to the IDS that the packages aren't related to one another and the data is actually not malicious. But then when they get reassembled by the end system, it ends up being some kind of malicious payload. And now let's talk about denial of service techniques. So if we know there is an IDS system and we're trying to send some malicious payload to some end system in that environment, we can use a denial of service technique to prevent it from doing its job. There's a couple different types we can use. One is referred to as an operator denial of service. This is when the operator, a human being, is actively working to determine what type of attacks are occurring on the system. We can overwhelm them with too many errors and alerts and a lot of false positives. This is also referred to as false positive generation, in fact. Another technique we can use is called CPU denial of service. And in this one, we just overwhelm the CPU buffer with just too many packets for it to handle. Some of the packets may not be parsed, which means the IDS doesn't get a full picture of the payload and it makes it appear to be a harmless payload. And then the last one we have is memory DOS. This is to overwhelm RAM with too many connections. Each of those connections requires some RAM. And if we overload it too much, again, the IDS may not see all of the packets coming in. And therefore, something that might normally recognize as malicious payload may seem to be harmless payload. Now, as far as firewall evasion is concerned, one really important thing to point out is know your firewall really well. Different firewalls behave differently, so it's nice to know what kind of firewall that you're dealing with to figure out how you may be able to circumvent it. So knowing that firewall can help you evade it. Each firewall, again, has different features and techniques. Some techniques you can use to identify the firewall type is first port scanning. Another technique you can use is firewalking. This is an interesting technique which uses trace route and time to live values. And what it does is analyze the responses from the IP packets in order to determine what kind of access control list the gateway has. It's actually an interesting way to actively probe the network to determine what type of firewall that might have. And another technique you might be able to use is banner output. Some firewalls, if you connect to them through something simple, even like a telnet session, may respond with some kind of banner that tells you what type of firewall it is. A good example is like software-based firewalls typically have some kind of banner when you connect to them. And it could either be through Telnet or SSH or some other kind of media like FTP. The banner you get when you connect to it can indicate what type of OS you're on, and that might clue you into what kind of firewall is being used. Some techniques you can use to evade firewall include a process called tunneling. So the idea behind tunneling is to go through another protocol or service to be able to communicate with something on the end. So one technique that you can use is ACK tunneling. ACK is the acknowledgement for TCP segments. Typically, firewalls do not have rules set on that, so if you can tunnel through ACK statements, that may be a way to get to the back end. Another thing that's not normally firewall blocked is ICMP. ICMP is for status checking. This is what things like the traceroute command, your ping commands use as a protocol to determine if a remote system's up. If the firewall is not blocking those, you may be able to tunnel through those protocols. A more standard way of doing this is through SSH. So if the firewall allows SSH connections, you may be able to remotely log into that server and then open up a tunnel to that server through SSH to send other data. And also you could do the same thing in some cases with HTTP as well. Another way you can evade firewalls is to change the source. That means where you're coming from. One way you could do that is to access an authorized external system. So maybe you can't get in through your machine or your network, but if you go to another machine network, you can access through the firewall in that case. You can also pick a proxy server. In fact, there's a lot of free proxy servers available on the internet, including some anonymous web servers that act as proxy servers as well. You also can use a technique called source routing. This is also referred to as path addressing. This is a technique of specifying the route that you want to go through to point A to point B, instead of using the default routers that are typically set up for different networks. And the last thing you might be able to do is IP spoofing. If your IP address doesn't allow you access through the firewall, but you know of one that does, you may be able to spoof that IP address, assign your system to that IP address, and get through the firewall. There's a few other techniques that you might be able to use to evade firewalls, some that we've already seen before, like you can use a man-in-the-middle attack. You can also have the user-initiated connection. This is actually a clever technique because most of the times firewalls are set up to allow anyone internally to send packets out through the firewall. And also firewalls typically have a state connection where they remember those internally defined connections and allow returning connections to come back through there as well. So if we get the user to initiate a connection, maybe we can send them a web link or something like that, then we can get through the firewall. And then, of course, we just use old-fashioned techniques of probing the firewall, looking for holes, and once we find one, exploiting that hole. In this next lesson, we're going to talk about different tools you can use to evade IDS and firewalls. So first of all, let's just talk about some port scanners. And keep in mind, we've actually talked about port scanners in other sections of the course. So this is a review of just a few of the port scanners that really you should already be aware of. One really popular port scanner is Nmap. It's used to scan either a single host or even an entire network of hosts. We can also use a tool called SuperScan. One of my favorite ones is the Angry IP Scanner. And then we can also use Unicorn Scan. And in addition to that, any of the port scanners that we talked about throughout the entire class would be sufficient for scanning a firewall to see what ports are open. Now, as far as tunneling is concerned, there are a few different tools that you can use for different circumstances. For example, HTTP port or HTTP port is a tool that allows you to open up a tunnel through HTTP protocol. Super Network Tunnel is another popular tunneling tool. HTTP-tunnel, again, can open up a tunnel on HTTP protocol. Bitvise is a technique that you can use to open up a tunnel through SSH connections. ACK command can open up tunnels that use the ACK protocol. And if you want to open up an ICMP tunnel, the Loki ICMP tunneling software package is a good one. The last thing we're going to talk about is packet fragmentation tools. So remember, the idea behind packet fragmentation is we have some payload that we want to deliver, but we don't want the intrusion detection system to pick it up as payload. So we can actually fragment the packages in a way that the IDS system won't recognize them as malware. So one tool you can use is one called NetScan tool. fping is another popular one. pktgen, the mgen utility. hping3. Another one that's good is the packet generator. So in this next lesson, we're going to talk about some techniques that you can use to detect honeypots. To begin with, let's just talk about the fact that honeypots, by their very nature, are going to be difficult to discover. When you connect to a honeypot, it's going to look and feel like a real system. That's the purpose behind them, is they're designed to draw you in and not make it really clear to you that you've actually been captured in a honeypot. It should look like the operating system you're trying to hack into. So if it's an operating system that has a web server, that should look like a valid web server is running on that system. One of the things that you might use to determine if it's actually a honeypot is, since they're designed to be exploited, they're really designed to be easy to break into as well. So if you find a system really easy to break into, that might mean that it's a honeypot. Of course, it could mean it's really a poorly configured system as well, so that's not a 100% guarantee. Also, if it's a honeypot, after you break in the system, you'll probably find there's really not much there useful. Not any real data, real user accounts. That kind of stuff will be seen to be missing in the honeypot. Also, it's helpful if you're aware of how different honeypot software works. So if you're aware of how to install a honeypot and configure it, it may make it easier for you to figure out when you've gotten onto a honeypot. You can also use honeypot detection tools, and you can probe for running services on the system and look for any type of unusual responses. An unusual response would be something like an open port that refuses to accept any type of three-way handshake connections. Also, if you see too many ports and services running on that, that's highly suspicious. Typically, an admin will only have ports open and services open on the system that really need to be there. So if you're looking at the ports, you find out the FTP, Telnet, SSH, your email ports, the web ports, all those things are open. That's kind of an indication that's really not a valid system, and it's probably a honeypot instead. Now, as far as tools are concerned, there's a few out there that might help you out. One tool that's kind of useful is the Send Safe Honeypot Hunter. It checks for a list of proxies, HTTP, and SOC space. So you can see an example of what that tool looks like. Another tool that we've actually mentioned before is the Nexus Vulnerability Scanner, but by its very nature, it's actually pretty good for testing for honeypots as well.
In this next section, we're going to talk about penetration testing. We're going to focus on IDS firewalls and honeypots. So first of all, let's talk about firewall testing. The first thing that's probably going to be the most important and useful thing is to try to scan the firewall, determine what types of ports are allowed through the firewall, which ones are blocked. That scanning probably should be done from several different environments because while a port might be blocked from one IP address or one network, it may not be blocked from another IP address or network. Once you find out which kind of holes are possible, you may want to try to use IP spoofing to further penetrate the firewall. You can use IP fragmentation. That was one of the techniques that we talked about earlier, where we can actually fragment our IP packets so they appear to not be malicious payload, but can get through the firewall. We can also make use of tunneling technique through like SSH tunneling, for example. We can make use of proxy servers to get past the firewall, and then also try a man-in-the-middle attack as well. Now, when it comes to IDS, and to some extent honeypots as well, the most important thing you need to do is identify that there is an IDS, an intrusion detection system, on that platform. Try to use different techniques that we referred to in class to evade the IDS. And then lastly, we want to attack the IDS and make use of its vulnerabilities to bypass the IDS.
Welcome to Lesson 17, Cloud Computing. This lesson will give a brief overview of cloud computing, what it is, detection of a host being in a public cloud, and securing a cloud. Let's take a look at an overview of cloud computing. So, as I mentioned, we're not going to be discussing attacking cloud computing providers. It is possible that the target of an ethical hack could be hosted in the cloud, but those are just systems that you would be attacking as if they weren't in the cloud. So the purpose of this lesson is to give you a general overview of what cloud computing is, the different types of clouds there are, as well detecting if something is running in the cloud. So what is cloud computing? It is really the commoditization of compute in that the actual servers are hosted off-premise in some data center somewhere on the internet and easily provisioned so that you can go click on a website, boot up a server, get access to it, load your software, and off you go. The elasticity point here is to point out the fact that you can scale on demand. So as the need for access to that application rises, the cloud itself can bring on board or provision more servers as needed in order to fulfill the demand, and scale down as needed if the resources are not needed any longer. And they are pay-as-you-go, and it's extremely granular. If you take a look at Amazon, it gets down to the compute hour where they're charging you for actual CPU utilization rather than renting an entire server as you would with co-location services. This really comes down to extreme virtualization and very granular resource billing. Several different types of cloud computing. The one on the left here, on-premise IT, this is not cloud computing per se. This is within your data center, within your environment. You are responsible for everything listed here from network to applications. With infrastructure as a service, what you are really utilizing there is from networking up to virtualization is the responsibility of the provider, and then you're responsible for the operating system, the data, as well as the applications. Platform as a service brings it up a few steps higher in that the provider goes from network to runtime, and then you're responsible for the data and the applications. Software as a service is at the other extreme end, wherein you are utilizing an application that is provided by that provider. You're not responsible for maintenance of the application. You are simply a user of it in a private fashion. There's a few different models for cloud computing. Public cloud computing is simply the cloud provider data center connected to the internet is hosting your environments. Private is replicating the public cloud concept within your data center. So that's same virtualization of resources, but completely contained within your data center. So looking back at the previous slide for types, on-premise IT goes hand in hand with private cloud in that because you are replicating that cloud, you are still responsible from the network on up. But the virtualization of servers as well as applications is much easier in the private cloud environment. Hybrid cloud is a combination of the two, wherein you have your own private cloud within your data center, and then you have some form of communication to a public cloud, such as Amazon Web Services. In this picture here, I'm showing that red line. That could be, for example, an IPsec tunnel going across the internet, which would basically extend your data center into that cloud service provider. Amazon Web Services is one of the most popular cloud computing platforms out there. They have a concept of virtual private cloud. And you can think of virtual private cloud as a self-contained environment. Within a virtual private cloud, you will have subnets. Inside subnets, you have instances. EC2 instances are elastic compute instances. It's simply a server. If you really define what it is, when you go onto the website and you say provision instance, you are booting up a server. It may be virtual, may be physical. It's completely abstracted to you. All that really matters is the resources you are requesting, whether it's, say, 2, 4, 8 cores, CPU cores, this much memory, this much disk space. It's provisioned for you and you have access to that. What it looks like on the underneath isn't really your business. It doesn't matter. It's provided to you. Let's take a look at some of the providers that are available to you as the cloud user. Some of the common features that you'll see across all of these options that I'm about to run through are hourly pay-as-you-go billing. So for the resources you utilize, you'll be billed per hour. All of them have some form of web interface to actually do the management. All of them have an API you can access to do management. So if you wanted to script the provisioning of an instance in the cloud, it is possible with these APIs. Auto scaling as demands increase, as well as decrease and pulling back that scaling. Imaging is, if you're familiar with VMware, the snapshot functionality. All of these providers provide some form of snapshotting or imaging of systems so you can revert if you need to. First one on the list is Amazon Web Services at aws.amazon.com. They have a free tier that you can utilize just to test out the service. So if you've never used Amazon, you can head over to this URL, click on Create Account, and sign up for the free trial and provision some servers, deploy some stuff. If you're not familiar with Linux as well, you can go into AWS and boot up Linux systems just for testing to get familiar with the command line. Microsoft Azure, it's azure.microsoft.com. Same concept as AWS, but running in Microsoft's data centers. They do provide not just Windows, they do provide Linux as well on their cloud platform. Google Compute Engine, another alternative cloud provider at cloud.google.com/compute. IBM has the cloud available to you at ibm.com/cloud computing. DigitalOcean, this is another one that's a little bit more low level in that you can get full servers if you wanted to and have out-of-band access to them. And finally, VMware vCloud, just another option for cloud services. This one is highly integrated with VMware's product offering. So if you're an existing VMware user, you might be more comfortable using VMware's vCloud. If we're contracted to analyze the security of something, how would we know if that something is in a public cloud? The security methods that are used in cloud providers are different, whether it's filtering at the virtual machine level, filtering at the subnet level, the VPC level. There could be load balancers in front of it, virtualized firewalls. There's a lot of different vectors to consider when looking at a device that's in the cloud or trying to penetration test a device that's in a public cloud. Cloud services, as far as users are concerned, should be transparent. If I'm surfing to, say, twitter.com and it happens to be in Amazon Web Services, it doesn't matter to me as the user. All I care about is getting access to Twitter. Whether that's provided from Twitter's data center or Amazon Web Services, doesn't really matter. It should be transparent. So how do we detect if a host is in, say, for example, Amazon Web Services? The easy way to do it is to take a look at DNS. In this example here, I'm using Dig, the Linux command line utility for doing DNS queries. I'm querying the SOA record, which is start of authority, for Netflix.com. And we can see here in the SOA that the authoritative name server is ns81.awsdns-10.com. This is Amazon Web Services DNS server. So I can tell just by running the simple command that Netflix.com is being served from Amazon Web Services. Since I have, from the previous example, determined the IP address of Netflix.com, I can then go to one of those regional registrars, do a query through their Whois services for that IP address, find the block, and see who it's associated with. In this example, Netflix.com had the address 52.37.56.128. Searching for that in ARIN tells me that it is a direct allocation to Amazon. I mentioned in the previous lesson that security could be applied at several different areas in a public cloud. Let's take a look at some of those for Amazon Web Services. Anywhere I have a lock on the screen here is somewhere that the administrator can apply access rules. You can apply it at the entrance to the virtual private cloud. You can stick it in front of a load balancer and then in front of an EC2 instance if you wanted to. Creation of a VPC access list. I have a screenshot here of me modifying an access list in Amazon. And it's very much like a firewall in that you define the source of the traffic, whether or not it's permitted or denied, the protocols and port ranges, if there is a port associated with that particular protocol. Similarly, with load balancers, you can apply an access list, or as they're called in Amazon, there are security groups. And normally what you'll see with, say, a load balancer, the security group on a load balancer will permit the ports and protocols that are necessary for the load balancer to balance the traffic amongst hosts within the pool that the load balancer is sending traffic to. Whereas on the EC2 instance, you will permit those protocols as well as other protocols. For example, on a load balancer, you may permit TCP port 80 to get to the instance named web server. But then on the web server, you apply a security group that allows port 80 as well as SSH. So you can log into the web server to manage it. Here's a security group for an instance. So the first one we looked at VPC security groups, then load balancers, and now an instance. So as I mentioned, the security groups for instances versus load balancers are going to be different, and they're usually more restrictive or less restrictive depending on where they're placed. This is our last sub-lesson or subsection within lesson 17. We're not going to have a real-world application here because we're not talking about attacking cloud computing providers. But one thing I wanted to touch on before we wrap up this lesson is using the cloud as a pen testing source. So it's kind of enticing if you, say, wanted to send a denial of service to a company that you are contracted with to do a pen test, it's kind of enticing to go to Amazon Web Services, spin up 200 hosts, and just send out as much traffic as you can. And why might you want to do that? There's a lot of resources there. If you're running it from home, then you have that single external IP address from your internet service provider. With Amazon, if you were to, say, source an attack from Amazon, you can get hundreds of addresses, provided you're willing to pay for it. It's also cost effective in that you're only paying per hour. So if you wanted to spin up 200 instances, fire off an attack, and then spin those down, you're paying for that period of time. Also, there's a whole bunch of bandwidth available to you, as well as direct access to the internet. So it sounds like a really good idea. However, you shouldn't do it. Amazon actually has a webpage you can go to authorize penetration testing. This is in both directions, either sourcing it from Amazon or targeting an Amazon hosted service, meaning something that you control within Amazon. So check out this webpage. You can go there and submit a form to request permission to do this. And don't do it without asking them first. Welcome to Lesson 18, Cryptography. Given the number of compromises that come about due to credential disclosure while using unencrypted protocols, it's not a surprise that encrypting communications is becoming more popular. Even Google ranks a page higher that uses SSL when providing search results. This lesson will take a look at common encryption algorithms and methods of attack. Quick overview of cryptography. It is simply the practice of securing messages, not necessarily data, but cryptography, 1,000 years ago was securing of information that's going between two parties. The underlying principle is that the contents of the message should not be readable by a third party. We see here in this example, Alice is sending some information to Bob. It goes through an encryption process, and now data looks like *K and 2. As it's flowing from sender to receiver, it's encrypted. Bob is able to decrypt it and see the actual data, where Eve has no idea what's going on. CIA triad: confidentiality, integrity, and authentication. These are the three tenets of cryptography. Confidentiality is that only the intended recipients can read it. So the encapsulated data, the encapsulated information is confidential. Authentication is that the sender is who that they say they are. In our previous example, Alice, when she sends that, then authentication is going to tell Bob that Alice is the actual person that sent it. Integrity is simply that the contents of the message has not been modified. Two types of encryption: symmetric and asymmetric key. With symmetric key, there is a single encryption and decryption key. In the previous example, Alice and Bob both know the key, and the same key is used to encrypt and decrypt. With asymmetric key cryptography, there's two keys, a public key and a private key, and it's a one-way sort of thing. In our previous example with Alice and Bob, with public key cryptography or asymmetric key cryptography, Alice has a message to send to Bob. She would encrypt it with Bob's public key, and he can decrypt it with his private key. A response from Bob to Alice, Bob would encrypt with Alice's public key, and she could decrypt with her private key. So cryptography operates by using algorithms to take the original data and turn it into encrypted data or ciphertext. An algorithm is simply a step-by-step set of operations. When applied to cryptography, when the algorithm is executed step by step, it will result in encrypted, hopefully secure data. So we take the data, we do some math, we do some more math, receive an encrypted result. The math in the case of cryptography is extremely complicated. We won't be getting into that math here in this presentation, but just be aware that the people that create these algorithms, these are PhDs in math the majority of the time. Ciphers, when we talk about cryptography, a cipher is just an algorithm for performing the encryption and decryption. A couple different types of these. Substitution cipher is replacing a piece of plain text with a piece of ciphertext. And if you've ever heard of Rot 13 or the Caesar cipher, that's an example of a substitution cipher. Transposition cipher is the rearrangement of plain text, and using a key you can unarrange it or bring it back to its original plain text. I just mentioned the Caesar cipher, or ROT13. This is a shifting of the alphabet, 26 letters, shifting it basically to the right 13 characters. So in this example here, the substitution cipher would take hello and turn it into URYYB simply by shifting to the right 13 times. Transposition will take the letters and rearrange them to create that ciphertext. I touched on private key and public key crypto in the previous section. Private key is the same key for both sides of the conversation. Public key uses two keys, one for encryption and the other for decryption. Typically, the public key is used for encryption and the private key is used for decryption. Ciphers can be categorized into two different types, block ciphers and stream ciphers. Block ciphers will take a chunk of data, perform the encryption, and apply it to the resulting ciphertext in the same order. Stream ciphers will operate on a stream of data as it's flowing through. It will be encrypted byte by byte there. Data encryption standard, one of the most popular encryption standards of the day, 30, 40 years ago. Created in 1997, it operates on 64-bit blocks and it uses a 56-bit key. The original DES standard is considered insecure today as it can be quickly cracked. It's a symmetric key algorithm as well, so it's using the same key for both encryption and decryption. Picture on the right, courtesy of Dave Rudolph. Triple DES, it's an evolution of DES, wherein once they realized that DES was insecure, they said, okay, let's do it 3 times with different keys. And this makes it quite a bit more secure because you would have to reverse the process 3 times, or rather crack the key 3 times. AES came about in 2001. It stands for Advanced Encryption Standard, also known as Ringdahl. Also a symmetric key algorithm, uses 128-bit blocks. You have several different key links, and it is still considered secure today. This is widely used around the internet for encryption, and it is approved today for top secret classified data as far as the NSA is concerned. RC, or Rivest cipher. If you recall, WEP uses RC4. It's a stream cipher for encryption. And this was a proprietary thing when it was originally created in 1987, and it was sold by RSA Security. It was leaked in 1994 and uses variable length keys. RC5 and 6 are evolutions to RC4, both patented and available from RSA Security. When the NSA put out the request for proposals for the next encryption standard, RC6 was considered one of the finalists in that process. AES eventually won, but RC6 was in the running. RSA algorithm by these gentlemen, Rivest, Shamir, and Edelman. It's an asymmetric key algorithm. So with symmetric keys, remember you have the same key on both sides. RSA is using public-private keys, and you encrypt with the public key, decrypt with the private key, as I'm showing in this example here. You keep the private key to yourself. You don't share that. Public key you can give out to anyone because you can't decrypt the data with the public key. Hash functions are another concept of cryptography where you take data of an arbitrary size and it turns into a fixed size chunk of data. So MD5, Message Digest 5, is a good example of this. If you run MD5 sum and give it a file, whatever the length of the file, the output of the MD5 function is going to be the same length every time. The idea here is that 2 files of different data should not have the same digest value. So it's a method of ensuring that the data that you receive passes an integrity check. Usually when people publish large files, they'll give you the MD5 sum of that file so that once you download it, you can validate the MD5 sum and know that the contents of the file that you have are the intended contents that the original publisher put out. Here's an example of doing MD5 on the command line. Command MD5 sum, I'm pointing it at a large file. This is an image for an ISR router from Cisco. And we can see that it results in this MD5 value pointed out in red here. It's been around for quite a while, and collision attacks have been demonstrated where 2 files with different contents resulted in the same MD5 value. Secure hash algorithm is another method of ensuring the contents of a file are what they should be. It is SHA-1 is now considered to be insecure. SHA-2 and 3 do exist and are still considered secure. Here's an example of getting the actual SHA sum. In this case, I'm using 256-bit digest size to get the SHA sum of that same file we saw earlier. Some tools we can use for cryptography, we'll cover those now. The Advanced Encryption Package 2016 offered by AEP Pro. So Windows set of tools that allows you to both encrypt, decrypt data, as well as manage public-private keys that can be used for, say, sending email, as you see on the right here. Some more tools, GNU or GNU Privacy Guard, that's commonly referred to as GPG, can be used for public-private key cryptography. WinAES, Encrypt, and CryptoForge, some more tools to be aware of that can provide some form of cryptography function. For hash calculation, I mentioned in the previous section, MD5 and SHA can be used to generate message digests to ensure that the contents of files are as expected once you've downloaded them, meaning that the integrity has been preserved. Public key infrastructure is really a set of roles, policies, and procedures that, as the slide shows, create, manage, distribute, use, store, revoke digital certificates and manage public-private key encryption. So it's the creation, management, and distribution of those public and private keys, as well as certificates that can be used for encryption. Some of the components you'll encounter when talking about PKI: certificate authority. The job of the CA is to issue certificates. The RA, or registration authority, will accept certificate requests, also called CSRs, and validate the identity of the requester. So if I generate a certificate request and I send that to a registration authority, they're going to call me up and say, hey, are you the person that requested this? What's your name, social security number, things like that. The actual certificate itself, issued by that certificate authority, and the authenticity has been validated by that registration authority. It's tied to a public-private key pair and used for encryption and decryption. The users of PKI are simply the holders of the actual certificate itself. Here's the cycle you can expect when dealing with PKI. Step 1, we generate keys. Step 2, we create and submit that certificate signing request that goes to that authority that validates the authenticity. The CA will issue that certificate, and then the user will receive that signed certificate saying that you are who you say you are, and here's your public-private key authenticated. There's several different public certificate authorities out there, primarily used for creation and issuance of SSL certificates for websites. Comodo, VeriSign, DigiCert, GlobalSign, all fine options for creating SSL certificates and validating the authenticity of the person requesting the certificate. Now we're going to talk about encryption and email, but before we do that, I want to touch on TLS and SSL. SSL is Secure Sockets Layer. TLS is Transport Layer Security. TLS is the successor to SSL. Essentially, TLS 1.0 is equivalent to SSL 3.1. So when you surf to a website like https://google.com, that's using TLS in order to provide security of the data flowing between the client and the server, the client being your web browser. The process that occurs when you make that initial request is shown on the right here and detailed in the bottom left, where your client will offer to the server the version of TLS that you're using, what cipher and what compression you're willing to accept. The first step of this process, the client is going to send a hello to the server, as well as offer several different options for encryption, which will include TLS version, the cipher, and compression. From the available offers, the server is going to choose one of them and encrypt its certificate back to the client. The client is going to receive that certificate and validate that it's from an authorized CA. So it's an authentication step to ensure that the server that is sending the certificate back to the client is who they say they are. Once the client has validated that certificate, a key is exchanged with the server. It's usually what's called a pre-master key, or PMK. that key is going to be used for subsequent encryption and decryption between the two hosts, client and server. The client sends that PMK to the server will verify that it can decrypt data with it, tell the client that it can, and from that point forward, they'll use that pre-master key or PMK for communication between the two systems. Now let's talk about cryptography and encryption with respect to email. Traditional email flows across the internet in plain text using SMTP or Simple Message Transport Protocol. You may recall from a previous lesson I was talking about SMTP verbs such as verify and expand. Early on in the days of the internet, they realized that information could be disclosed simply by watching the traffic that was flowing between email systems. So a couple things occurred. One was the creation of something called opportunistic TLS. And this is the ability for a plain text protocol to basically upgrade a connection to encrypted using TLS. If you connect to a plain text protocol's port, such as IMAP, which uses port 143, and you execute the command start TLS, then it's possible, if the server supports it, that it can upgrade the connection to use encryption through TLS. So IMAP and POP3 as well as SMTP have options to find in RFCs for start TLS. The other thing that occurred around the same time was that SSL TLS versions of these protocols were also created. So there is an SSL TLS version of IMAP on port 993, same for POP3 on 995, and SMTP has a SSL TLS option on port 465. So there's two options available. And opportunistic TLS came about because they realized they had two ports to do one job. One was encrypted, one wasn't. So let's just put them together and you connect to that same port, you run start TLS, and you upgrade the connection to TLS. And then they ran into a problem that certain software had already been created for the other port numbers. So it's kind of a mishmash of protocols out there today. As an example, if you connect to, say, Google Mail, Gmail, using SSL IMAP or TLS IMAP, it's going to use those other ports, the 993 ports. I don't believe that it supports opportunistic TLS. So just be aware that these options are available. There's SSL TLS versions of protocols, and then there's opportunistic TLS RFC specifications for those same protocols. There's several software applications available for encryption and decryption of email content. GNU Privacy Guard, GPG Mail, is an option. Symantec Desktop Email Encryption was formerly called PGP, or Pretty Good Privacy. It was very popular in the late 90s and early noughts to use PGP. That was acquired by Symantec, and now it's called Desktop Email Encryption. Other options, Enigmail, Proton, Hushmail, and Tutanota. The Hushmail option is an online service, like Gmail or Hotmail, Yahoo Mail, that provides encryption of emails. Now let's talk about encrypting data on disk and the tools that you can use to do that. If I head to my local swap meet and I see somebody selling a 100 gig disk that they're no longer using, and I take that home, there's a possibility I'm going to find some data on that disk, and to a slight extent, some possibility that might have some personal information in it. If we were to encrypt that data on the disk, then if the disk is ever stolen, then we don't have to worry about data being released. So disk encryption tools, what do? They, of course, encrypt data on disk. They ensure confidentiality when you turn that host off. And I called that out on purpose because when you turn the host on and you enter the key to decrypt the data, that key has to exist in memory to access the data. So if you're accessing a file while the system is booted, then it's possible that an attacker, if the system is online, can access the data because that key exists in memory to actually decrypt it for use by the operating system or the user. A couple options for disk encryption. You can do the whole disk or just the home directory. When encrypting a whole disk, you might need to enter a key to boot the system up. So in the example of Linux, when you're, say, installing Ubuntu, it'll ask you, do you want to encrypt the disk? If you do, you have to enter a key. You have to type in the key that's going to be required to boot the system. And the next time you reboot, you have to type in that key to boot. But otherwise, when the system is turned off, the entire disk is encrypted. For home directory encryption, it's usually using the user's login password to do that encryption. so the user doesn't have to remember 2 passwords in order to accomplish some form of disk encryption. The operating system and its associated files on the rest of the disk would not be encrypted, but the home directory is. So anything you put in that home directory, your home directory, is secure. A couple different states to be aware of when it comes to disk encryption. There's at rest, in use, and in motion. At rest data is simply data that's stored on disk. In use is sitting in memory, maybe in somewhere in the CPU, whether it's a cache or a register. It's in a non-persistent state. In motion is data that is flowing. It's in transit from source to destination. Options for disk encryption on Windows, there's something called BitLocker. This is built into the Windows operating system. You can encrypt a disk with BitLocker. OS X has File Vault that can encrypt the entire disk for offline protection. In Linux, built into the kernel is something called dmcrypt. In this example here, I'm showing the creation of an encrypted disk image. It looks like a file on disk, but the contents of that file are encrypted. dmcrypt can also encrypt an entire disk if needed. Some more options for Linux: Scramdisk for Linux, Cipher Shed, as well as Symantec endpoint encryption. The Symantec option is cross-platform. They have Windows, Mac, and Linux options for Symantec endpoint encryption. I called out this link on the bottom to Wikipedia. This isn't a reference to the content that's on the slide, but I wanted to call this out because it has a nice comparison of several different, when I say several, I mean tens of disk encryption softwares and which do what. So it's basically a large table or matrix of capabilities of these different software packages. So take a look at that. There's several different options available to you for disk encryption. Attacks against cryptography. So in this section of this lesson, we're not going to be talking or demonstrating actually attacking cryptography. What we're going to be talking about is methods to attack cryptography. The terms that you'll see here, you could possibly see on the exam. I'm going to run through each one and explain the differences between the several options here. Ciphertext-only attack is an attack on encrypted data where the attacker has that encrypted data, and the goal here is to recover the encryption key that created that encrypted data. A known plaintext attack is where the attacker knows part of the plaintext data. Using that plaintext data as well as some ciphertext, they attempt to deduce the key with that information. Chosen plaintext. The plaintext data is passed through a cipher, and then you use the encrypted data to try to determine what the plaintext was. It's using the known plaintext and known ciphertext to try to deduce the key that was used to create it. Chosen ciphertext is where the attacker obtains the plaintext from arbitrary ciphertext, meaning some portion of the ciphertext is used to determine the plaintext. A chosen key attack is where key data is passed through the cipher, meaning you use this key and then analyze the data that results from that cipher. Adaptive chosen plaintext attack is an iterative encryption with slight modification to the plaintext. So we have this chunk of plaintext, we slightly modify it, run it through the cipher, and look at the differences that are coming out of that cipher. Timing attack is where an attacker attempts to compromise encryption by looking at the time taken to execute the algorithm itself. Pretty complicated. And rubber hose attack, this is the actual name of it, and this is the threat of violence or actual torture to get access to a key. And finally, brute force. Brute force is commonly used to try to get access to the key. The problem, though, is the size of the key increases the amount of time it takes to crack that key exponentially. So if we look at the key space table on the right, if we had a 4-bit key, there's only 16 possible values of that. But if we had a 256-bit key, such as the example with AES 256, the number of possible combinations in a key size of 256 is enormous, 1.1 times 10 to the 77th power. So it would take quite a long time to crack the key in this example, AES 256. I will take a look at a few tools that are available to analyze data that's been encrypted. CryptTool 2, it's an open source program, and I call this out individually because it's extremely interesting in its user interface, because it actually shows you what's occurring with bits and bytes as they flow through algorithms. So CryptTool 2, it's open source. It basically allows you to visualize and experiment with algorithms and data that's flowing through algorithms. Pretty neat. In this example here, the Enigma machine is shown and data is fed in, and it shows you how it flows through the various portions of the encryption algorithm, or in this case, the Enigma machine, to result in ciphertext. Some more tools to be aware of: CryptoBench, Alpha Peeler, Medigo, and Crank. Take a look at all of these. Again, be aware these tools exist and what they do. Just for fun, download them, play with them, and become familiar with what's possible with cryptanalysis tools.
Thank you for watching the Certified Ethical Hacker video course. We cover a lot of material, including footprinting, enumeration, host and session attacks, web server and application attacks, SQL injection, wireless, and cryptography.
There could be a question about any of these items during your CEH exam. We wish you luck in your studies and look forward to seeing CEH in your signature soon. Thank you.
Thank you.